everyone and welcome to the Machine Learning with Python full course. In this course, you will start by building a solid foundation in Python and its essential libraries like NumPy, Pandas and Matplotlib, which every data scientist and ML engineer relies on. From there, we will dive into the world of machine learning, beginning with the basics what machine learning is, the different types of models and the core mathematics behind them. Next, you will explore popular algorithms step by step, starting with linear and logistic regression, moving through decision trees, random forest, KNN, naive-Bayes and support vector machines. Along the way, you will learn how to choose the right predictive techniques for different problems. And finally, we will wrap up with the interview question and answers to help you prepare for real-world opportunities in machine learning. And by the end of this course, you will not only understand the theory but also know how to apply Python to solve practical machine learning problems confidently. So before we get started, please like, share and subscribe to Edureka's YouTube channel and hit the bell icon to stay updated on the latest tech content from Edureka. Also, do check out Edureka's postgraduate program in Generative AI and Machine Learning in collaboration with Illinois Tech. It offers a unique opportunity to explore the cutting-edge world of Generative AI and develop advanced AI-powered solutions. This program covers in-demand topics including machine learning, deep learning, natural language processing, prompt engineering, generative AI, LLMs, RAG, agentic AI, and much more. And learn from industry experts through a curriculum built around real-world hands-on use cases designed to equip you with the practical and job-ready skills. So check out the course link given in the description box below. And now, let's get started with our first topic, that is machine learning with Python.
So to understand machine learning, we must understand the need for machine learning first. So ever since the technical revolution, we have been generating an immeasurable amount of data. Now, everybody must be aware of this term that is being thrown at every instance of any achievement or anything. There is always data involved in it because data has become the new fuel. And as per research, we are generating around 2.5 quintillion bytes of data every single day. Now, it is also estimated that by 2025, 1.7 MB of data will be created every second for every person on Earth. So now, considering we are more than 7 billion people on Earth, that's a lot of data. And with the availability of so much data, it is finally possible to build models, the machine learning models that can study and analyze complex data to find useful insights and also deliver pretty more accurate results. The top tier companies such as Amazon, and then there is streaming platforms like Netflix, they build such machine learning models by using tons of data in order to identify the profitable opportunities. For example, let's say for Netflix, they analyze the patterns into whatever you're watching on their platform, and then they build a recommendation system based on your interest and your activities. They are feeding you the similar data that you will be interested in and eventually watch. That is going to increase their profit margin, of course, and same goes for any e-commerce business as well. They quantify their revenue generation based on recommendations, which eventually helps their sales as well. And not even just trying to scale up the business, machine learning also helps in avoiding unwanted risk as well. So I'll just tell you quickly a few reasons why machine learning is so important right now. So first of all, since the data is generated in numbers, due to the excessive production of data, we need a method that can be used to construct or structure and analyze and also draw in useful insights from that data. So this is exactly where machine learning comes in, and it uses data to solve problems and find solutions to the most complex task faced by any organization. And it can be any organization, government, or as simple as a simple small scale business owner who has a lot of data of their customer base, and he has structured that data so you can use that for quantifying on or scaling up their business using machine learning models. Then machine learning improves decision making, guys. I'll tell you how. By making use of various algorithms that machine learning comes with, it can be used to make better business decisions. And for example, machine learning is used to forecast sales, predict downfalls of the stock market, and the stock market prediction, where you can just predict a stock price for a particular date. Although I would not suggest you to do that, because that requires immense amount of statistical knowledge and inferential statistics. So that is one thing that you should not directly go for when you're beginning with machine learning. And there are other things like identifying risk and anomalies in data, and then spam detection, etc. These are some domains where machine learning helps in improving decision making. Now, machine learning can also help you uncover patterns and trends in data, guys. So machine learning will help you finding out hidden patterns and extracting key insight from data, and which is going to be the most essential part of machine learning, guys, because by building predictive models and using statistical techniques, machine learning actually allows you to dig beneath the surface and explore the data at a very minute scale. So understanding the data and extracting patterns manually will take days, guys. So let's say if I'm giving you a data and I want you to identify a pattern in that data, it will take you a lot of time. I mean, this is pretty obvious that it's going to take a lot of time. But with machine learning, you have all these algorithms that can compute, all these calculations in a second, and they can identify the distribution of data. And by doing that, you will be able to find patterns very easily. And last but not the least, machine learning actually solves a very complex problem in a matter of minutes. And from detecting genes linked to the deadly ALS disease to building self-driving cars even, machine learning can be used to solve most complex problems, guys. And if you really want to know how object detection in moving cars work, there is a session on object detection on our YouTube channel, guys. You can check that out, and if you want, I can give you the link in the description as well, or in the chat. All right, so now these are a few reasons why we need machine learning. So now let's go ahead and take a look at what exactly is machine learning, guys. So the term machine learning was first coined by Arthur Samuel in 1959, and looking back, that year was probably the most significant in terms of any technological advancement. So if you browse through the net and if you search on Google like what is machine learning, you'll get at least 100 different definitions, because there is no specific definition for machine learning yet. Everybody has their own perspective when it comes to machine learning, and the point here is there are a lot of definitions to learn from, but the point should come across where, I mean, the first formal definition was given by Tom M. Mitchell, who said a computer program is said to learn from experience E with respect to some class of task T and performance measure P if its performance at task in T as measured by P improves with experience E. Sounds quite complicated right now, so I'll just tell you in simple terms. Machine learning is a subset of artificial intelligence. Yes, artificial intelligence, you heard me, which provides machines the ability to learn automatically and improve from experience without being explicitly programmed to do so. Now, in the sense, it is the practice of getting machines to solve problems by gaining the ability to somewhat think. You must be worried about how a machine can think or make decisions, right? But if you feed a machine a good amount of data, which is also known as training the model or training the machine, it will learn how to interpret, process, and also analyze this data by using machine learning algorithms. And also it will lead to solving real world problems as well. So this is machine learning, guys. So you have a machine, you give it an ample amount of data, it learns on itself, analyzes the data, identifies pattern based on the algorithm that you have provided, and after that it evaluates itself. After the evaluation, we put it to a real world data and see if it works as efficiently as we programmed it to be. Now there are a few things that you must know about when working in machine learning. There are algorithms. So algorithm is basically going to be a machine learning algorithm, which is a set of rules and statistical techniques used to learn patterns from the data and draw significant information from them. So an algorithm is basically the logic behind a machine learning model. And an example of a machine learning model is linear regression algorithm. That's one algorithm that I'm just telling you. There are also a lot of algorithms that you can use for machine learning. And then we have another term which is model. So when we say model, it is the main component of machine learning. It is the model that we train with the data using the machine learning algorithm, and the algorithm is going to map all the decisions that a model is supposed to take based on the given input in order to get the correct output. Then there is input variables, there is output variables, also known as dependent and independent data. And then we have the training data, the testing data. So these are a few terms that you must be familiar with when you're working in machine learning. Now let me just talk about the machine learning process as well, guys. The machine learning process involves building a model that can be used to find a solution for any problem statement. So when I say problem statement, it is the very first task that is given to you where you want to implement a model. So to understand the machine learning process, let's just assume that you have given a problem statement that needs to be solved using machine learning. So let's say you have a lot of data, or let's say you don't have that data yet. So you have a problem, you're gonna identify the problem and see how you can use that data. So for that, you have to gather the data. After that, you have to prepare that data, remove out all the redundancies, you clean it out, and after that you explore the data to find out trends. Then you make use of visualization, you do the feature engineering and feature sampling, and then after that you feed the model, build it, and if you do the evaluation, if it's up to the mark that you imagine or that is suitable for your problem statement to solve, you use it for your problem statement. And that is how you create any machine learning model. So that is the process that we actually use for machine learning, guys, and that is how it goes. Okay, tell me in the comments, guys, what you thought machine learning was when you first heard it and you had no idea what it actually was. Also, now let me just talk about a few machine learning types as well. So a machine can learn to solve a problem by following one of the three approaches, which is basically supervised learning, unsupervised learning, and reinforcement learning. So let's talk about supervised learning first. So supervised learning is a technique in which we teach or train the machine using the data which is well labeled. So we have labeled data. Now to understand supervised learning, let's consider an example. So as kids, we all needed guidance to solve math problems, right? So whenever you wanted to solve a complex mathematical problem, there was an assistance needed from your teachers, or it could have been your guide as well. So our teachers helped us understand what exactly that problem was and how it was done. So similarly, you can think of supervised learning as a type of machine learning that involves a guide. So basically the labeled data set or the labeled data is going to be the teacher that will train the model to understand patterns in the data. And the labeled data set is nothing but the training data set, guys. We basically feed the machine the labeled data, and the goal is for the machine to identify and classify it into whatever we need it as. The training data set that is fed to the model is labeled. So we're basically telling the machine this is how the data looks and this is how you identify the data. And by doing that, you're just training the machine by using labeled data. So that is supervised learning, guys, and it is a well-defined training phase done with the help of labeled data. Then again, we have unsupervised learning, which involves training by using unlabeled data and allowing the model to act on that information without guidance. So one of the examples is generative adversarial networks, but that is way ahead of this topic, guys. It's a very advanced topic. I'm just telling you because it's a very nice thing to know about GANs, and if you have free time, you should research about it. And it's a very cool topic, or it's quite revolutionary in terms of machine learning. So think of unsupervised learning as a smart kid that learns without any guidance. All right. So in this type of machine learning, the model is not fed with the labeled data. Okay, I'll just tell you what it means. The model has no clue that whatever data that you're feeding it, they do not have any idea what that data actually is because they do not have labels. So it basically figures out patterns and the differences between the data, and it takes its own time and builds upon it using the algorithms. For example, let's say we have these images of Tom and Jerry that we want to train the model with. So it identifies the prominent features of Tom, such as the pointy ears, the biggest eyes, and etc., to understand that this image is of type 1. And similarly, it finds such features in Jerry that knows that this image is of type 2. Therefore, it classifies the images into two different classes without knowing who is what. So without the labels, it is able to classify the images or any data. So based on that, you can use it for classification problems, guys. Unsupervised learning is quite good for classification problems. And then we have reinforcement learning, guys, which is a part of machine learning where an agent is put in an environment and he learns to behave in this environment by performing certain tasks, actions, and observing the rewards which it gets from those actions. This type of machine learning is comparatively different. So imagine that you are dropped off at an isolated island. So what exactly would you do? First thing that you would do is panic, of course. But initially, what we all would, as the time passes, you will learn how to live on the island. And if you ask me how you do that, I don't know, but you will eventually learn how to live on that island because we have a survival instinct as human beings. But you will explore the environment, understand the climate condition if you can, and the type of food that grows there. And eventually you will also take into account the dangers of that particular island. The dangers of the island can include poisonous plants. There could be insects, animals as well. So this is exactly how reinforcement learning works, guys. It involves an agent, which is basically you stuck on that island. You are the agent that is put in an unknown environment, which is the island, where he must learn by observing and performing actions that results in rewards. And your reward as stuck on the island was maybe food or surviving a day. That's a reward. First you observe and then you learn and then you perform some actions. So that is how reinforcement learning works, and it is mainly used in advanced machine learning areas such as self-driving cars and AlphaGo, etc. Now, to better understand the difference between supervised, unsupervised, and reinforcement learning, there is a session on our YouTube channel, guys. You can head there and learn about it in detail. And last but not least, I want to talk about a few types of machine learning problems, guys. Okay, let's take a look at this image, guys. There are three main types of problems that can be solved in machine learning, guys. First is regression, then there is classification and clustering, guys. In this type of problem, the outcome, or when we talk about regression, the outcome is continuous quantity. So for example, if you want to predict the speed of a car given the distance, it is regression problem. Regression problems can be solved by using supervised learning algorithm like linear regression and other supervised learning algorithms. Then again, we have classification, guys. So in this type, the output is a categorical value. When I say categorical, it's either true or false, or high or low, which only has two values, like a Boolean. And classifying emails in two classes, let's say spam or non-spam. So this is how classification problem works, guys. And it can be solved by using machine learning classification algorithms. And these algorithms are support vector machines, naive Bayes, logistic regression, K-NN neighbor, etc. And then we have clustering problems, guys. So this type of problem involves assigning the input into two or more clusters based on feature similarity. And for example, clustering viewers into similar groups based on their interests, their age or geography can be seen as a clustering problem, guys. And this can be done by using unsupervised learning algorithms like K-means clustering. So we can just identify these problems like this, guys. So for regression, we need supervised learning. For classification, we need supervised learning. For clustering, we have to make sure there is unsupervised learning involved. For regression, the output is a continuous quantity. For classification, it's categorical. And for clustering, it assigns data points into clusters. Then we have, for regression, the main aim is to forecast, or we are using it to predict something. And for classification, we are using it to compute the category of the data. So we will have different categories. We just want to find out what the input belongs to. And then the main aim of clustering is to group similar items together or into clusters. And after that, one example of regression would be, predicting stock market price. And for classification, an example would be classifying emails into spam or non-spam. Or for our example that we are going to use is predicting if somebody has survived on a ship or not in case of a wreckage. Clustering, for example, we can find all the transactions which are fraudulent in nature because we can make a cluster of all the frauds transactions. Some of the algorithms that are used for these problems, for let's say regression, is linear regression. For classification, we have logistic regression, and for clustering, K-means, I mean, these are the common algorithms that are used for these problems. And now comes the part where I will tell you why we choose Python for machine learning, guys. So what exactly makes Python the best programming language for machine learning? There are various features of Python that actually tells you that it is the best bet for machine learning, but there are a few that stands out. So first of all is Python is simple and very consistent. Python offers you a very simple readable code that has comparatively lot less lines of data that you can use inside your program, which makes it very less complex. And whenever you're working on a bigger problem as well, you will be able to read the data, you will be able to debug it because it's very easy to read. It's like writing code in simple English language. So that is why Python is quite the very first choice when it comes to machine learning. Then again, we have a lot of libraries and frameworks at our bay, which we can use for machine learning easily to implement any machine learning task. For example, let's say if we want to analyze or explore the data, we have Pandas library, which gives us data frames. It can transform the data into different formats like a CSV format or any other JSON format. You can change it but by just one line of code. And then there is visualization libraries. For example, we have 𝐶born library and we have Matplotlib, which helps us in descriptive statistics, guys. So we can look around and see or identify the patterns and look at the features which will help us best identify the feature that will help our model. So that is how machine learning is actually getting benefited from Python. And then we have sklearn or scikit-learn library, which is also a very good thing, guys. It helps you in providing you like a framework, you can say, or a very structure of machine learning where you fit the data, you can split the data, and then you can train the data easily. You can use fit and predict model to get the outputs as well. So that is how Python actually helps a lot. And then again, where for advanced machine learning, we have Keras, we have TensorFlow, and NumPy, of course, for high performance. Then we have scientific Python as well for making scientific computations. And I've already told you about Pandas and 𝐶born. And of course, we have Matplotlib as well. So these are the basic advantages of using Python over any other programming language, and that is why we use Python for machine learning as well. And also, since Python is open source, there is no worry to look for detailed answers and anything, and the community is so big. For each error that you come across as a beginner, if you find it on the community, you will find a very suitable and a very precise answer to the matter, where you can just there is a lot to do with Python when it comes to machine learning. And community and popularity is one thing. There's one more thing that stands out, which is the documentation part, guys. Every documentation written for every Python library or anything that Python has is such a world-class thing, guys. You don't have to even go to any tutorial or anywhere to learn Python. The documentation is pretty much the summation of everything that you need to learn. But some people find it difficult to understand from the documentation because it's not as interesting as somebody teaching you would look like.
Python has been ranked the #1 programming language in TOB Index and has been used by some of the largest companies in the tech industry like Pinterest, Spotify, YouTube, Instagram, etc. So you looking to learn Python might just be the best decision you've ever made. Since this video caters Python for beginners, I think it is important that we start with what is Python. Python is an easy to learn, powerful programming language. It has efficient high-level data structures and a simple but effective approach to object-oriented programming. Python's elegant syntax and dynamic typing, together with its interpreted nature, make it an ideal language for scripting and rapid application development in many areas on most platforms. And with that, we can see why we use Python, right? The #1 point would be the applications. Python is a very versatile programming language ranging from application development to web design, game design, UI/UX development, data science, machine learning, automation, etc. There's also the point of simplified syntax. If you usually work with languages like Java, C++, etc., you'll get me. Python is one of the simplest languages you can learn. And this fact doesn't impact any of the features. It is just as good as all the other options that you have. And the only thing is, it's a lot simpler. The third point is well-built packages. Now don't worry if you don't know what packages are. I'll cover that later. The only thing that you need to know right now is that packages have the ability to replace hundreds of lines of code with just a single line of code. I'll show you how to do that later in this video. And the fourth point that I want to stress on is the highly supportive community. Look, I get it. Programming is not always easy and you get stuck sometimes. But with Python's community, you get a lot of support for the issues that you face, and I'm telling you, it's one of the most engaging and interactive communities that I've ever come across. Now, I think it's about time that we get started. I do want you to know that this video will be a hands-on session, and I want you to keep your computer ready and follow along with this tutorial. To get started with Python, you will need two things. The first thing is Python itself, which is an application that you install in your computer so that your computer knows how to interact and understand Python. The second thing you will need is a code editor or an IDE. There are a lot of code editors that you can come across, like Vim, VS Code, Sublime Text, Eclipse, Spyder, PyCharm, etc. In this video, we will be working with the Anaconda distribution. Now, I have chosen this because it's the easiest one with which you can set up your Python ecosystem. To install Anaconda distribution, all you need to do is open up your browser and then type download Anaconda. Now once you are here, just follow the first link. If you are not able to find this link, then just follow the URL given above, anaconda.com/products/distribution. The installation procedure doesn't really change for any operating system. You can follow the same procedure for Windows, Mac, Linux, etc. So once you're here, just click download and save. Now once downloaded, just click on the file and open it up. Now once you are here, just follow the steps given by the application itself. You don't really need to do any other settings, just follow what's given in the application. I recommend that you install Anaconda to the path provided by the software itself because this makes it easier for the files to interact with each other. You can just follow along the steps and just make sure that this checkbox is always checked. Register Anaconda 3 as my default Python 3.9. What this does is that when you install any other code editors or IDEs, they will be able to recognize the Python that is installed by Anaconda in your system. After all this, you just need to click install and then it will start installing Anaconda to your system. Now the installation might take some time, but once this is done, just finish this up and then open up the start menu and type Anaconda Navigator. Once you have it, open it up and there you have it, Anaconda Navigator for Windows. Over here, you can see the collection of IDEs and code editors that you get with Anaconda Navigator. You also have your environments where you can manage your packages, your educational videos, and also a community to support your growth. In this video, we will be using Jupyter Notebook. And to use that, all you need to do is click Launch over here. Now you can think of this view as a file directory where you can create files, navigate through files, and even delete files. So right now, what I'm doing is going to the desktop folder, and then I'm clicking on New and Python 3. So what this does is that it creates a new file in my desktop folder to run my Python code. After that, I just want you to do a simple program. It's just one line, alright? Simply type print, all in small letters, and then open brackets, round brackets, and then single or double quotes, and then type some message. I'm typing hello world, and then we can run it by clicking on this button over here, or you can do Shift plus enter and it will show you your message. If you've gotten till here, then congratulations because you just created your first Python project. In this section, we will see what variables and data types are in Python. Variables are nothing but values that are temporarily stored in your computer's memory. Let me show you how to do this. To begin with a variable, you first type the variable's name, like for example, say age. And then what you do is, you assign it a value, like 40. So in the statement, what you're doing is you are assigning the value 40 to a variable name called age. Now, if you run this, again with the run button or shift plus enter, then you can see in the left hand side that this statement has been executed. And now, if you want to access the value of age anywhere in your code in the future, you can just type age and it will give you the result. Now, while you have declared a value for your variable, you should also remember that this value can be updated in the future. For example, say now I say age equals to 50 and I execute the statement. Then if I come back to our second statement, just age, you can see that the execution gives me the result 50. This means that age has been updated. So it's a good idea to always keep track of all the updated variables in your code. Let us continue by declaring a few more variables. Let's say temperature equal to 35.8. In Python, you can declare floating point variables, which is nothing but numbers with a decimal point, and also whole numbers. You can also type something like name equal to Edureka, and you can see over here that I have surrounded it with quotes. The reason why I do this is because whenever you write string values or sequence of characters, Python requires you to surround it with quotes, either double or single. This will help Python recognize the entire sequence of characters as a single entity. You also have some other kinds of data types like Boolean values. Now, Boolean values are nothing but, for example, you can say is offline equal to false. Now, one thing that you should know is that Python is case sensitive. Notice what happens if I replace the capital F with a small. See, it is not being highlighted anymore. This is because Python doesn't recognize this as a keyword anymore. It thinks of this as a name. So always remember to be aware of the case-sensitive keywords while coding in Python. You might also notice that I have used an underscore while declaring the keyword. This is just to make the code more readable. Notice what happens if I take off this underscore. It's not that readable, right? So whenever you code in Python, always make sure that you enhance readability for anyone else who might access your code. Now, there are three types of values in Python. You have numbers, you have strings, and you have Boolean. Now, there are times where you will need to convert one type of data to another. Let me show you how. So you can see from our previous declarations, we have age equal to 50, which is a whole number. We have temp equal to 35.8, which is a decimal point number. You have a string, which is a collection of characters, and then you have a Boolean value over here. If you want to check the data type of all these variables, what you will need to do is say type, open brackets, and then type the variable name. If you execute this statement, then you will see that age is an integer data type. You can do the same for temp, and you can see that it returns float, which is a floating point variable. This just means that there is a decimal point in that number. You can also type name, which returns string. Now, string is represented as str or str in Python, and then you have your final variable, which is offline, which is a Boolean data type. Let's just get this out of the way now and try a few things. What if I want to convert age into a floating point variable? Doing this is very simple. What you need to do is type the name of the data type you want to convert it into, and then you open brackets, and then you type the variable name. So now you have converted age into a floating point value. You can see the decimal point over here. This concept is helpful in many situations. For example, if I want to say print age of XYZ is plus age and execute the statement, you will see a type error. Can only concatenate str, not int to str. What this means is the data type string can be only concatenated or connected to another string, Python doesn't understand how to connect numbers with strings. Solving this is super easy. All you need to do is go over here and then say stir of age. This will convert age into string and will allow Python to connect these two strings. Now, if we execute this statement, you can see that it is successfully executed. Now, with this, I have an exercise for you. I want you to collect the birth year of a particular individual, and using that information, I want you to find out his age. You can pause the video over here, take a few minutes, and then come back and see what the solution is. Now, you must have gotten stuck while receiving input, right? Doing this is super easy in Python. What you need to do is type input and then open brackets, and inside those brackets, you can give any message to your user. For example, enter your birth year. Now, obviously, you will need to store this in a variable, right? So let's just save it under birth year. Now, if we run this statement, Python will ask you to enter the input for your birth year variable. Now, I was born in 1998, so let me just type that, and then I'll press enter. After this, we will need to subtract the current year with the birth year, right? Now, the current year is 2023 minus the birth year. Now, let's just execute this. And oops, we've got a type error. Unsupported operand types for int and stir. Now, let's try to break down this error. Let's check the data type of birth year. Type birth year. You can see over here that birth year has been declared as a string, right? That's what's causing the problem. You're trying to subtract integer with strings. Now, we can currently understand that birth year is a number, but Python isn't able to do that. So what you need to do is tell Python that this is an integer. And then if you execute this and type in the same values again, you will be able to get your answer. Now let's try to make this a bit more readable. First thing we need to do is assign this to a variable. So let's just say age equal to this expression, and we'll execute this again. And after that, we can say print age of XYZ plus age. Now if we execute this statement, we again get an error. This is again a type error and can concatenate strings with strings, not int with strings, right? So again, we will need to convert this into a string data type so Python is able to correctly read the data. So let's execute this, and then you can see age of XYZ is 25. In this tutorial, I will teach you how to do some cool operations using strings in Python. To do this, the first thing we will need to do is declare a string variable called title equal to Python for beginners. Now, after executing the statement, I want you to remember a few things. The first thing is that when you declare a string in Python, it is treated as an object. You can think of objects like real-world objects. Think of a car. A car is an object, and this object has a few functionalities to it, right? It can go forward, it can go backward, it can go sideways, it can honk, it can turn on the lights, etc. Strings are also the same. If you type title dot and press your tab button, you can see a list of functions. These functions are similar to like print, input, etc. The only difference is that print, input, etc. are general purpose functions, meaning that they don't belong to a particular object. And these functions belong to the object called string. Now, calling them functions isn't really the right terminology. When a function belongs to a particular object, you refer to them as methods. So all these methods that are listed over here belong to the object string. Now let us just pick an option called isLower over here. And if you execute this, you can see that it returns false. This means that our string is not completely in the lower case. So you have another method to do that. You can type title dot lower. And if you execute this now, you can see that all the characters, all the individual characters have been converted to the smaller case letters. Now, if you type dot is lower continuing this, then you can see that it returns true. You also have other methods like title dot upper, which returns all of the characters in uppercase letters. You also have other interesting methods for strings in Python like title dot find, which will help you find a particular character or a sequence of characters in your string. Like say if I say y in quotes, then it will return the value 1. You see 1 over here is the index of the first occurrence of this character. Now, the way indexing works in Python is simple. You start from 0 and then you continue with the numbers 1, 2, 3, 4, 5, 6, 7, etc. So when I say find the first occurrence of y, what it means is that the index that is returned is number 1. Now, you can also find the index for a sequence of characters like say for, and you can see that it has returned 7 over here. If you go back over here, you can see the f character starts at 7, and that is where the sequence of characters start from. There's also some other interesting methods that you can use over here. For example, you can try replace to replace one word for another, like say for example for with 4, and then you can see that the string has changed right now. Python for beginners. You should remember that these statements don't really make any changes to your original string. So if you go ahead and type title again, then the result of it would be your original string. If you want to save your modifications, then you will need to save your edits into a new variable. Now for the find expression that we talked about earlier, there is another replacement for it. For example, you can type print for in title, and this will show you the boolean value of your result. Like this sequence of characters does not exist in your variable. But if I change this to the small case, and now if I change it into something that is in the variable, then obviously it will return true. This kind of result is desirable in a lot of cases. Now, in this tutorial, we will be seeing the arithmetic operators in Python. Now, these are the same arithmetic operators that you find in math. For example, you can add numbers, subtract them, multiply them, and so on. So, let's just quickly do 10 plus 3, and you can see that the result is 13. This operator over here is called the addition operator, which adds two numbers. You also have the subtraction, which subtracts 3 from 10. You have the multiply, which is an asterisk, which multiplies 10 by 3, 30. And then you have the division. And technically, there's two types of division. One is a single slash, and the other one is a double slash. Notice what happens. When we did the single slash, we got a floating point value, right? But if you try a double slash, it will give you a whole number. After that, we have the modulus operator, which gives you the remainder of 10 divided by 3, which is 1. So we also have the option to make powers of something. For example, if you want to say 10 to the power 3, then you can put in 2 asterisks, and then if you execute it, you will get the result of 10 to the power 3. Now, for all these operators that you saw, we also have something called as augmented assignment. Let me show you what that means. So up until now, if you had to do something with arithmetic operators, you would have done something like this, right? X equal to 10, x equal to x plus 3, and then you would type print x. Now, there's nothing wrong with you executing your code like this, but you are taking a bit more memory when you do it like this. Because in this statement over here, you are loading x 2 times, right? So a simpler way to do this would be to say x equal to plus equal to 3. Now, this new statement is exactly the same as the old statement. Only difference is it's a lot simpler to write and it's faster. Alright, now let me ask you a question. Suppose I set x equal to 10 plus 5 into 2. What is the answer? Unfortunately, a lot of people get this wrong. The answer to this is 20. The reason for this is because mathematics has something called as operator precedence, where operators like multiplication and division has a higher priority than addition or subtraction. So when you evaluate this statement, you will first evaluate 5 into 2, which is 10, and then you will say 10 plus 10, which is 20. Let's execute to verify this. Now, operator precedence in Python also works the same way as it does in math. The only thing is that you can change this using brackets. So for example, if you want to execute 10 plus 5 first, you can just put this in brackets and then 10 plus 5 will be executed first, after which it will be multiplied by 2. So let's just verify this again and you can see that it has been done. Now, you've already learned what arithmetic operators are in Python. Up next, we have another set of operators called as comparison operators. Let us see what it does. Suppose I write 3 greater than 2. If I execute this, it will produce a Boolean result, which means it will tell you whether 3 is greater than 2 or not. This operator that we have over here is called the greater than operator, and this belongs to a set of operators called as comparison operators. You also have greater than or equal to, you have less than or equal to, you have equals. Now don't compare this with the assignment operator, alright? This thing is checking for equality. It is checking if 3 is equal to 2 or not. So if I execute this, it will tell you it is false. Now one more operator that we have over here is the not equal to. This will check if something is not equal to something. Now 3 is not equal to 2, and that is why this will return the Boolean value true. So to summarize, we have the greater than, we have greater than or equal to, we have less than or equal to, we have equality, and not equal. These operators combined make up the comparison operators. Now that we are done with comparison operators, we have another set of operators called as logical operators. Now to demonstrate this, let me first declare a variable, age equal to 25. Now let's apply some logical operators to it. We'll first say age greater than 10 and age less than 30. Make note that the AND word over here is the logical operator. So now we have age 25 must be greater than 10 and age must be less than 30. So if you execute this, you will get this as true. The thing with AND operator is that both the left side of the operator and the right side of the operator must be satisfied. Another thing we have is the OR operator. Now for this operator, either the left side of the operator or the right side of the operator or the entire equation must be true. Let us demonstrate this. We can have age equal to 5, and then if we say this, and then if we come to the equation, you have age greater than 10, which is false, or you have age less than 30. Now, age is definitely less than 30, right? So this equation must be true. There we go. The last thing is the NOT operator. Let's just put it like this. If you use the NOT operator, it will give you the inverse of the result that you were going to get. So let's just say this. Age equal to 5 and age is greater than 10. So this is false, right? But if you use the NOT operator over here, the result will still be true. Now, you can obviously inverse this and test the result again. So to summarize this, you first have the AND operator where both sides must be true. Then you have the OR operator where at least one side must be true. And then you have the NOT operator, which will give you the inverse of your result. Now let's look at if statements. We use if statements whenever we want to make a decision in our program. For example, if we have something like, say, temperature, based on the value of that temperature, we can make certain actions. Let me show you. Let us first declare a variable called temperature equal to, say, 40. Now, based on this value, I can take certain actions. For this, I will start with writing if, which is a keyword, and then you write temperature greater than 30, and then a colon, and then you type enter. You see over here, if you observe what you have done, you have first written an if statement and then used a conditional statement to check if the temperature is above 30. Now, a colon in Python is used to segment a block of code. If you see our text cursor over here, you can see that there are a few spaces behind it, right? This is what we call an indentation. In Python, if you indent a particular piece of code, it will belong to the previous statement. This is similar to using curly brackets in languages like C, Java, etc. So be very careful as to not put unnecessary indents in your code. Now, for our condition, let us say if temperature is greater than 30, we'll print, say, it's a hot day. You can see that I have written this string in double quotes. This is because I have a single quote in the word it's. So if I put single quotes over here also, then Python will think that you are just making a mistake while writing. So double quotes over here, and let's continue. As I told you before, since you put a colon over here, everything below that colon is treated as a block of code. So as long as this indent remains, this block of code will be executed only if this condition is true. Let's add another statement over here. Let's say print, it's time for cola. After this, we can come out, and if we execute this statement, you can see that it's hot day and it's time for cola. Now, know that you can add as many conditions as you want to. Now, what if this value was less than 30? Let's say 29. What would happen then? Nothing happened, right? This is because the condition was proved false, and that is why these statements didn't get executed. Remember that you can add as many conditions as you want, and all you have to do that is type elif, and then you can come up with another statement. Say if temperature is less than 30, then print it's a nice day. You can also go ahead and write if temperature is less than 10, then print that it's a cold day. You can also add a statement saying print done over here. You should remember that this statement doesn't belong to any condition, so it will be executed no matter what happens. So if you execute it now, you can say it's a nice day and done. Great, right? Now let me ask you a question. What if I asked you to print the numbers 1 to 5? How would you go about by doing that? Obviously, you'd say print 1, and then print 2, print 3, print 4, and then print 5. But I'm telling you that this approach is wrong. The reason is because I asked you to just print from 1 to 5. But what if I asked you to print from 1 to 100, or 1 to 1000, million, billion perhaps? Would you go about the same way, writing it down individually? Obviously not, right? That's a very time-consuming task. So to handle that, we have something called as loops. And the first kind of loop that I want to talk about is the while loop. Let me show you how you can start using it. The first thing that you do is start with a variable and assign it the initial value of the sequence that you have. For example, I have given I equal to 1. After that, I will type the while keyword, and then I have my conditional statement. While I is less than or equal to 5, and then colon, after which I get a block. Over here, the first thing is I have to print the number, right? So print I, and then we will need to start increasing the value of I by 1. So let's say I plus equal to 1. This will start incrementing the value of I by 1 every iteration. If you don't put the statement, then it will print the initial number until your computer runs out of memory. So now let's just run this, and you can see that your output has been printed over here. Now, you can also change this into, say, 1 to 100 or even 1000. Remember that if you want to increase readability of your numbers, you can always separate it by an underscore. So this is like 1,000. So now we have the output 1 to 1000. You can also print interesting patterns using this. Let me show you. If you type the same thing and then say I multiplied by a string, you can give it any value that you want. And then if you execute this, you can get patterns. You can see that you've got a triangle over here. What this is a string operation. Basically, you can multiply strings in Python. So if you say I equal to string and then I has the value 1, then this will be printed once. And if I equal to 2, it will be printed twice. I equal to 3, then it will be printed thrice, and so on. Earlier in the video, I introduced you to the data types in Python. This included numbers like integers, floating point variables, strings, and boolean. Now these data types are something that we call as basic data types in Python. There are also some complex data types, and one of them is called lists. A list is nothing but a group of objects. Let me show you how you can do this. First, you will start with the variable name. Let's just say we are doing a collection of names. So our variable name is names, and then equal to, and then we have square brackets. These square brackets represent a list. And now inside this list, you can write down a bunch of names. So let's say Elton, and then you have Sam, Bob, and Emma. You can use either single quotes or double quotes. It doesn't really matter. Now, if you execute the statement and then you call out the variable, you can get a list of all those objects. The interesting thing happens from now. While you call out the variable, you can also call out individual variables. Like say you want the name of the second index. So you have 0, 1, and 2, right? So second index, and you can get Bob directly. You can also give a negative value. Now, what do you think happens if I give a negative 1? So this is 0, and then a negative value would be the last element of your list. So if you execute this, you must get Emma. And if you do a negative 2, then it will be the second last element. Now, this is not it. You can also go ahead and get a range of values, say from 0 to 2. What this means is that you will start from 0 and you will print all the elements until you reach 2. Remember that if you execute this, the last value, like the ending parameter, won't be printed. So for example, over here, I have 0, 1, and this 2 won't be printed. See, there you go. Now this is what we mean by list operations. You should also remember that a list doesn't really need to be just a single data type. You can also include numbers, like integers, floating point variables, and even boolean. And if you execute that, you will still get the same result. Early in this video, I told you how to use string methods, right? This was because strings was an object and objects have methods. Well, the thing is, list is also an object, and list also has many methods associated with it. The functionalities of this include adding an element, removing an element, modifying an element, etc. Let us see how to do this. Let me first and declare a list of numbers. Say numbers equal to 1, 2, 3, 4, 5, etc. Now we have a list called numbers. Let's see what methods this numbers list has. So we'll type numbers dot and tab, and you can see over here append, clear, copy, count, extend, index, etc. So let us start with, say, append. Now, append is a method that is used to add numbers to the end of the list. So if I say append 6, then my list would be 1, 2, 3, 4, 5, 6. Now, if you type down numbers again and check its values, you can see that you have 6 at the end. See, there you go. We also have another method called as insert. Now, the problem with append is that you can only add numbers at the end, right? But with insert, you can add it anywhere in the list. To use this method, you need to give two values. First thing is the index, second thing is the value of the element itself. So say I want to add a value at index 0 and the value would be 0. Then if I execute the statement and execute it, you can see that 0 has been added. We have 0, 1, 2, 3, 4, 5 and 6. Now sometimes there will be situations where you would like to know whether a certain element exists in a given list or not. So to do that, you can use the in operator. For say, you can write 1 in numbers, and then if you execute the statement, you can see it gives you a boolean value of true. You also have other methods like numbers dot clear, and this will clear the entire numbers list for you. So if you want to know more about list methods or anything in general, then you can head over to the description given below, and I have pasted a blog link over there. This blog lists down all the keywords, methods, syntax errors, etc. And it can give you an approach as to how you can learn Python. Now I want to cover another looping method called as for loops. You see, sometimes in Python, you will come across situations where you would like to iterate over a list of numbers individually. This is where for loops come into picture. Let me show you. Suppose we have a list of numbers 1, 2, 3, 4, 5. Now what if you want to print them out? You would obviously write print and then numbers, right? That will give you the entire result. But now, what if I asked you to print each of these out separately? This is where you can use for loops. What you will do is start by writing the for keyword, and then you will mention the iterator. The iterator is just another variable name. You can keep it anything. I will keep it as items. In, and now the variable name, numbers, and then colon. And after this, you have a separate code block. And over here, you can see print items. Now, if you execute this, you will have 1, 2, 3, 4, 5, all in separate rows. You can also do this with while loops, but it will just be a bit longer. Let me show you. You'll start with I equal to 0 because that's your initial iterator. After which, you'll say while I is less than len of numbers and then colon. Now, if you're wondering what len of numbers is, len is just a method that will give you the length of your list. After this, you can say print numbers and then give the index. You will also need to increase the value of your iterator for every iteration. You can get the same results, but compare and see which one is more simpler. This is why most of us use for loops for iterations. Now, in this section of the video, we will see at a function called range. So, range is a function that will give you a range of values. Let me show you. You type range, and then you pass a value to it. Now, if you execute this, you will see range 0, 5, which means that this range function contains the values 0 to 5. You won't get the actual values itself because this is the default representation of the range function, but you can iterate through this function by using a loop. For example, say for number in range 5 print number, and if we execute this, you will get the number 0 to 4. Note that the index starts from 0, so you won't get the written value over here, but the written value minus 1. Now we can also give two values over here, say 5 to 10. This will return a value from 5 to 10, 10 excluded. So it will be 5 to 9. There you go. You have the values 5, 6, 7, 8, and 9. You can also add a third value over here, like say 2. This is the number of steps it will take per iteration. The default over here is 1. That is why you can get a difference of 1 over here, right? But if you say 2, then it will go from 5 to 7 to 9. If I execute this, there you go, 5, 7, and 9. In this section of the video, we will be looking at tuples. Now, tuples are kind of like lists, but tuples are immutable. What this means is that once you declare a tuple, it can't be changed. Let us see how to do that. You'll first start with the variable name as always. Let's say numbers equal to 1, 2, and 3. Now, till now, you've been using lists, right? And when you do lists, you use a square bracket. But with tuples, you will use round brackets. And once you execute this, you can check for the methods. And you won't find anything like append, remove, etc. You have count and you have index. Now, what count does is, suppose you have two elements of some sort, and you say numbers.count 3. Now you can see that numbers.count has given you an output of 2. What this means is that 3 occurs twice in your tuple. The other method is the index. The index will just return you the first occurrence of a particular element that you ask for. Now, why do you need tuples? Well, I agree that we will be working with lists most of the time, but there are certain situations where you wouldn't want someone or yourself to accidentally change the data in your list, right? That is where you will use tuples.
So what is NumPy? NumPy is basically a module, or you can say a library, that is available in Python for scientific computing. Now it contains a lot of things. It contains a powerful n-dimensional array object, then tools for integrating with C, C++. It is also very useful in linear algebra, Fourier transform, and random number capabilities. Now let me tell you guys, NumPy can also be used as an efficient multi-dimensional container for data, for generic data. Now let me tell you what exactly is multi-dimensional array. Now over here, this picture actually depicts multi-dimensional array. So we have various elements that are stored in their respective memory locations. So we have 1, 2, 3 in their own memory locations. Now why is it two-dimensional? It is two-dimensional because it has rows as well as columns. So you can see we have 3 columns and we have 4 rows available. So that is the reason why it becomes a two-dimensional array. So if I would have had only one row, then I would have said that it is a one-dimensional array. But since it contains rows as well as columns, that is, it is represented in a matrix form. That is why we call this as a two-dimensional array. So let me open my PyCharm and I'll tell you practically how to actually create a NumPy array. So this is my PyCharm, guys. Over here, the first thing that you need to do is first install the NumPy module. And how you are going to do that, click on File, go to Settings tab, and you'll see the Project Interpreter option. And on the right hand side, you'll see a plus symbol. Just go on and type the module that you want to install. So I'm going to install NumPy. Just go there, click on it, and install package. I've already done that, so I'm not going to repeat it. So this is my PyCharm. So first thing that I need to do is import NumPy as NP. Now after that, I need to create a NumPy array. So for that, I'm going to define a variable, let it be A, and I'm going to type in here np.array and certain elements inside it. So I'm going to put in 1, 2, 3 and print it. That's all. So this will actually print a single dimensional array. So 1, 2, 3 has appeared. Now if I want to convert this to a 2D array. So for that, I'll keep this in parentheses. And after a comma, I'll add one more element, and I'm going to give certain values inside that. So I can give, say, 4, 5, and 6. Now go ahead and print this. So as you can see that it is now a two-dimensional array. So this is how you actually create arrays using NumPy module. If you have any questions or doubts, you can ask me. Dave says he's clear. So does Theon, Anando, Ayushi, Jagati, fine. Alright, so we have no questions. So now I'm going to open my slides and we'll move forward and see what is our next topic. Now let us see why are we using NumPy instead of a list. Alright, so many of you might be thinking, why are we using NumPy when we have lists? Alright. So basically we use NumPy because of three main reasons. The first thing is it occupies less memory when compared to lists. Then it is actually pretty fast when you compare it with list, and at the same time it is very convenient to work with NumPy. So these are the three major advantages that NumPy has over lists, and that is the reason why we use NumPy instead of lists. Now don't worry, I'm actually going to prove it to you practically by opening my PyCharm. So guys, this is my PyCharm again. So first thing that I need to do is import NumPy as NP, and now what I'm going to do is I'm going to import a couple of more modules. I'm going to import time and I'm going to import sys. Alright, done. So our first step is to actually define a list, and the name that I'm going to give to my list is, say, S, and I'll type in here range 1000. So what this will actually do, it'll actually take all the integer values between 0 to 1000 and it will give it to a variable S. So this list will contain the integer values between 0 to 1000, but it won't include 1000. It will be only there till 999, that is 999. And now I'm going to print the space occupied by this particular list. So for that, what I need to do is I need to type in print sys.getSize of any one element. Okay, so you can give 3, 4, 5, anything. I'm going to give it as 5, any one element, and multiply that with the length of my list. That's all. So this will actually give me the space that has been occupied by the list, because sys.getSize of will actually give me the memory occupied by one element, and when I multiply that with length of my list, I get the entire memory that has been occupied by my list. Now the same I'm going to do with my NumPy array as well. Let me give a name to that. I'm going to type in d np.a range, and the range will be 1000. Now a range function is pretty much similar to the range which is there. So the same thing will happen here. The integer values between 0 to 1000, but it won't include 1000, will be present in my variable d. So we have created a NumPy array. Now let us print the space occupied by it. So the first thing is I'm going to type in here d.size. So this will actually give me the space occupied by one single element, and when I multiply that with the length of my NumPy array, I get the entire memory that is occupied by the NumPy array. So I'm going to type in here d.item size. That's all. Now go ahead and print this. So this actually shows the memory that has been occupied by my list, and this shows the memory that has been occupied by my NumPy array. So as you can see, there is quite a lot of difference between both of them. So we have proved our first point that it actually occupies less memory. Now when I talk about NumPy array is faster and more convenient than a list. So the next step is I'm going to prove it to you that NumPy array is actually faster and more convenient than list. So I'll remove all of this, and so now I'm going to show you that NumPy arrays are faster than lists. And at the same time, it is easier and more convenient in order to work with NumPy arrays when compared to lists. Let me show you practically. So first what I'm going to do is I'm going to define a variable, say size, which is equal to, say, 1000, and then I'm going to define two lists. Now what I'm going to do is I'm going to add those two lists, as well as I'm going to add two NumPy arrays, which I'm going to define now. And then I'm going to compare the time taken in order to find the sum for list and the sum for NumPy arrays. So first let me define two lists and two arrays. So my first list will be equal to range size. Same goes for my second list as well. Just change the name to L2. And now I'm going to define two NumPy arrays. A1 equal to np.a range size Go ahead and do the same for the second numpy array as well and change the name as A2. So we have two lists and two arrays, and we need to compute the sum of both of these lists as well as arrays. Now before that, I'm going to define a variable, say start, which is equals to time, and now I'm going to calculate the sum. So I'm going to save that in result, and first I'm going to calculate the sum of list, that is L1 and L2. So for that, what I need to do is I need to run a for loop, because if I directly write L1 plus L2, it is going to give me a result which is nothing but the concatenation of both the lists. So in order to calculate the sum, I need to use for loop. Let me show you how to do that. First, I'm going to type in x comma y, and we have already studied loops in detail. For x comma y in zip, and the name of the two lists, that is L1 comma L2. That's all. So what will happen here, it'll first take the first element of list L1, and then it'll take the first element of list L2. It'll calculate the sum, and it'll store in result, and it'll keep on repeating until the range has been exceeded. Now this is how you calculate sum in lists. But when you talk about arrays, what you need to do is you need to just write in A1 plus A2. That's all. That's why I'm saying that it is more convenient in order to work with numpy arrays when compared to lists. Now our next step is to define the same variable start and initialize it with time.time. And now I'm going to find the sum of my two numpy arrays, which is nothing but A1 plus A2. That's all. And now print the time taken. So print time.time minus start, and then multiply it with 1000. Because by default it will take it in seconds, and I need to convert it into milliseconds. Now I forgot to actually print the same thing for my list, so I'm going to do it over here. So this will actually give me the time taken by my list in order to compute the sum, and this statement will give me the time taken by my numpy array in order to compute the sum. So are we all clear till here? If you have any doubts or questions, you can ask me. Any questions, guys? Alright, so we have no questions, so let us go ahead and execute this and we'll see what happens. So it gives me 0 milliseconds because the size is small. Let me just add a couple more zeros. Let's make it 1,000,000. Now go ahead and execute this. Now you can notice the difference, that there is a significant change. Lists took 208 milliseconds, whereas numpy array took almost 67 milliseconds. So there's a huge difference between the compute time of a list as well as numpy array. That's why I say that numpy array are faster, convenient, and at the same time they occupy less space when compared to list. So that is the reason why we choose numpy arrays over list. So now is the time to see various operations that you can perform with the numpy arrays. So you can find the dimension of your array, whether it is a two-dimensional or a single-dimensional array. Then you can even calculate the byte size of each element. It is pretty easy. I'm going to tell you that practically. You don't need to worry about that. And you can even find the data types of the elements that are stored in your array. So if you want to know what is the data type of the elements, you can do that as well. So let me show you these three operations first, and then we'll move forward to the other operations. I'm going to open my PyCharm once more, guys. Let me remove all of this. So we have imported the numpy module. Now what I'm going to do is I'm going to define a numpy array. I'm going to name it as A, and I'll write here np.array 1, 2, 3. Put that in parentheses. Now add one more element, say 2, 3, 4. Alright, so it's a two-dimensional array. Now if I want to know whether it's a two-dimensional or a single-dimensional array, so I'm just going to type in print a.ndim, and it'll give me the dimension. So let me show you that, and I'm going to run this. So it says 2, that means it is a two-dimensional array. So what if I move this part and make it as a single-dimensional array? It should give us the result as 1. Let's see if it does that or not, and yep, it gives us 1 as a result. So this is how you actually calculate the dimension of your array. Now if you want to find the byte size of each of the elements, so what you need to do is, instead of ndim, you can call a function called item size. Go ahead, execute this, and you'll get, so each element occupies 4 bytes. After that, if you want to know the data type that is stored in the array, so you can just type in here dtype. Go ahead, execute this. It should give us integers 32-bit. All right. So this is how you can actually perform these three functions that I've told you in my slides. It's pretty basic. If you have any questions or doubts, you can ask me. All right, so we have no questions. So let us proceed with the presentation. Now let us move forward and see what are the other operations that you can perform with NumPy module. So by using NumPy array, you can actually find the size of your array. How you can do that I'll show you practically. You don't need to worry about that. So when I say size of the array, that means the total number of elements that are present in the array. So if this is an array, so the total number of elements become 4. 1, 2, 3, and 4. Now you can even find the shape of your array. Now what do you mean by shape? So basically the total number of columns and rows. Now over here we have 3 columns and 4 rows. So our shape is actually 3 columns and 4 rows. Now let me show you practically how you can do that. Again, I'm going to open my PyCharm and show you. Let me remove this print statement from here. Now if I want to find the size of my NumPy array, I just need to type in print a.size. That's all you have to do, and it'll give the size of your array. So there are 3 elements. So if I go on and add some more elements, say 4, 5, 6, 7, then if I execute this, you'll see that 7 elements have appeared. That means the total number of elements in my array is 7. Then comes the shape part that I was talking about. So in order to find the shape, what you can do is you can just type in here a.shape and it'll give you the shape. So let us see what happens. So it has 7 columns, but there are no rows. So it has given 7 comma blank. So what I can do is I can close this in parentheses and I can define one more element, say 8, 9, 10, 11, 12, 13, 14. Go ahead and execute this and you can see 2 comma 7 because we have 2 rows and 7 columns available with us. So this is how you can actually find the size of your array as well as you can find the shape of your array. Now let us move forward and see what are the other operations that you can perform with NumPy module. So we saw how to find the size and the shape of an array. So we can perform reshape as well as slicing operation using NumPy array. So now over here there is an example. So we have 3 columns and 2 rows, which we have converted to 2 columns and 3 rows. Now let me show you that practically how you can do it. In a variable, and I'm going to start a NumPy array and I'll have 2 elements in that. My first element will be 1, 2, 3, 4, and my other element will be say 3, 4, 5, 6. So I have a 2-dimensional array that contains 2 rows and 4 columns. Now I can convert that to 4 rows and 2 columns. Let me show you how to do that. You're just going to type in a is equal to a.reshape, and I want to convert it to say 4 rows and 2 columns. Go ahead and print this. So it has converted that to 4 rows and 2 columns as you can see it in front of your screen. Now let me show you that earlier this is not the case. I'm going to type in a print statement here as well in order to show you that how it has reshaped. So earlier we had 4 columns as well as 2 rows, but now we have 2 columns and 4 rows. So this is how you can perform the reshape operation. Now let us talk about slicing. So slicing is basically extracting a particular set of elements from your array. And the slicing operation that happens here is pretty much similar to the one which is there in list as well. So suppose if I want only this particular element, that is 3. So for that what I need to print, I'll show you, print a and the index value of 3 which is present at 0, comma, and the index is 2. Let me tell you how indexing happened. So this element will be 0, this element will be 1. Now if I want 3 from here, so from the 0th element I want the index 2. Indexing starts from 0, 1 and 2. So that's why I've written 0, 2 and it should print 3 for me. Let us see if it does that or not. And yep, it prints 3. Now say if I want to print 4 and 6. Now for that what I need to do is I need to remove this 2 here and I'm going to put a colon that says all the rows including 0, and in that row I want only index 3. So we have only 2 rows, so if I would have written 0, 1, then it wouldn't have included this particular row. So if I have one more element here, so I can actually write here 2, so that won't actually include the element which is present at the second index. So when I say 0, this actually means all the rows that includes 0 as well. So we have only 2 rows. It will include both the rows, and at the same time it'll actually going to print the third index from both of these rows. So let me show you if that happens or not, and yep, it happens. We have 4 and 6 available with us. Now just to remove confusion, what I'm going to do is I'm going to add one more element, and I'm going to give values to it, say 7, 8, 9 and 10. So now if I want 4 and 6, I can't just write 0 colon, because if I do that it'll print 10 as well. Let me show you that. Yep, it has printed 10. Now in order to avoid that, what I can do is I can write in here 2. So as I've told you, this is the 0th element, first element and the second element. So when I write 0 colon 2, it won't include the second element. It'll only include 0th as well as the first element. Now inside that we have index 3 from both of these rows. That is why we'll actually get 4 and 6. Let us see if that happens or not. And you can see 4 and 6 is now available. So this is how you can perform slicing when we in NumPy arrays. Now what I'm going to do is I'm going to type in a equal to np dot line space, and now over here first I'll write 1 comma say 3, and I want say 5 values between 1 comma 3. What this will do is it'll actually print the 5 values which are equally spaced between 1 to 3. So let me print this first. I'm going to type in print a and go ahead, execute this, and you can see that we have 1, then we have 1.5, then we have 2, 2.5 as well as 3. So if I would have written here 10, it will actually give me 10 values between 1 to 3. And yep, you can see we have the 10 values between 1 to 3. So this is how you can perform line spacing as well. So we saw how to perform reshaping and slicing. Now let us see what are the other operations. So we are now going to find out the minimum, maximum as well as the sum of our NumPy arrays. So let us go ahead and execute that practically. Let me remove all of this, and now I'm going to define one more NumPy array, np.array, and I want elements in it, say 1, 2, 3. Now if I want to find the element which has the maximum value, so what I can do is I can just type in here print a.max, that's all, and it'll give me the maximum value in my a NumPy array, which is 3 obviously. If I want to find minimum value, so I'm just going to type in here min, and it'll print the same for me, which is 1. Now if I want to calculate sum, it is pretty easy. Just go on and type sum and it'll give you the sum. That's all guys, it's that simple. I'm pretty sure there won't be any doubts here. If there are, you can just ask me. Fine, so there are no doubts. So Janice has a question. She's asking me, is it that simple to work with NumPy? Alright Janice, so let me tell you that whatever I'm telling you, these are all the basics that you require. After that, whatever your requirement is there, on that basis, you need to use those basic knowledge that you have and implement it. Now, the best way to do that, the best way to understand any programming language is to play around with it. So you know the basics. With the help of those basics, just install PyCharm first, then try out new things like how should I get that, how should I get this, and if I'm not getting it, what is the reason behind it. So go on and try to discover new things. So the conclusion is you need to actually perform things practically. You need to make sure that you are not only getting the theoretical knowledge, you need to perform it practically. That's why I always say that side by side when I'm executing these practicals, you need to do that as well. Although you might find it pretty basic, but with the help of this knowledge, you can perform a lot bigger tasks as well. Alright, so Janice looks happy now. So let us move forward with our slides. So now comes the axis concept here guys. It is pretty similar. We have a NumPy array which looks like this, and the rows are called axis 1 and columns are called axis 0. Now you must be thinking, what is the use of this axis? Suppose if you want to calculate the sum of all the rows, then you can actually use these axes and you can do that. Now let me show you practically how it happens. I'm going to open my PyCharm again and I'm going to show it to you. Let me remove this and let me add one more element here. 3, 4, 5. Alright. So if I want to find the sum of axis 0, it's very easy. Just go on and type print a.sum and type in axis equal to 0. Go ahead and print this, and you can see 4, 6 and 8. 1 plus 3 is 4. 2 plus 4 is 6. Similarly 3 plus 5 is 8. If I make this as axis 1 and print this, so it gives me 6 and 12, because 3 plus 2 plus 1 is 6. Similarly 4 plus 5 plus 3 is 12. So this is pretty easy, I know. Now let us go back to our slides and see what are the other operations. So there are many mathematical functions that you can perform with NumPy. That is to find the square root of each element. You can even find the standard deviation. So these two operations can be performed with the help of NumPy. You can find the square root, you can find the standard deviation. Now let me show you that how you can do it. This is my PyCharm again. So now I'm going to remove this print statement here, and I want to print the square root of each of the elements that are there in my NumPy array, which is actually assigned to a variable a. So I'm going to type in here print np.sqrt, that is square root of my NumPy array a. Go ahead and execute this, and it has actually printed the square root of each of the elements. So the square root of 1 is 1, for 2 it is 1.414, for 3 it is 1.73, again for 3 it is 1.73, then for 4 it is 2, then for 5 it is 2.23. This is how you can find the square root of each of the element. Now when I talk about standard deviation, so you can find that by typing here. So now if I want to find the standard deviation, what I need to do is, instead of sqrt, I'll just type in here std, and it'll give me the standard deviation, that is how much each element varies from the mean value of my NumPy array. And this is the standard deviation, guys. It's that simple. So this is how you find standard deviation. Now let us go back to our slides and see what are the other operations that are still left. Now these are the basic mathematical functions that you can perform with NumPy arrays, like addition, multiplication, subtraction, and division, and that will actually happen element wise. So basically you are performing matrix addition, matrix multiplication, matrix division, as well as matrix subtraction. Let me go ahead and show it to you practically. It is very, very simple, guys. So similarly, I'm going to define one more array, and let me name it as B. Let me remove this print statement. Now if I want to calculate the sum, so what I need to do is I need to type in print A plus B. That's all you need to do. But when I talk about list, again I'm telling you that when I talk about list, if I do that, it will concatenate both the lists. So if I want to print list, that is the addition of two lists, I need to use for loop. So that is where NumPy array stands apart, and it is pretty convenient. Go ahead and execute this, and you'll see that element wise addition has happened. 1 plus 1 is 2, 2 plus 2 is 4, 3 plus 3 is 6, similarly 3 plus 3 is 6, then 4 plus 4 is 8, 5 plus 5 is 10. Alright, so this is how you can perform addition. You can perform subtraction by using the subtraction operator. Go ahead, execute this, and you'll find all zeros, because 1 minus 1, 2 minus 2, 3 minus 3, 3 minus 3, 4 minus 4, 5 minus 5 will be 0 only, right? No rocket science. Now go ahead and multiply it as well and see what happens. So you have 1 into 1 is 1, 2 into 2 is 4, 3 into 3 is 9, again 3 into 3 is 9, 4 into 4 is 16, 5 into 5 is 25. If I go ahead and divide this, it'll give me all ones, and yep, it does. So this is how you can actually perform addition, subtraction, multiplication, and division using a NumPy arrays. Now let me go back to my slides and see what are the other operations present. So now guys, let me tell you one more thing. If I actually want to concatenate two arrays, I don't just want to add those two arrays. You can say that if my one array is a box, then I want another array on top of it. So let me show you how you can do that. Actually, there are two ways to do that. One is called vertical stacking and another is called horizontal stacking. Let me show it to you one by one. First, I'm going to show you vertical stacking. For that, what I need to do is print np.vstack and a comma b. Let us see what happens when I run this. So we have 1, 2, 3, 3, 4, 5. Then again we have 1, 2, 3 and 3, 4, 5. So this is called vertical stacking. If I want that horizontally, I'll just write in here ℏstack, and I'm going to run this now, and you can see that we have 1, 2, 3, then again 1, 2, 3. That means these two are present added horizontally, and we have 3, 4, 5. Again we have 3, 4, 5. So this is how you can perform stacking as well. Now there's one more thing that I want to show you. If I actually want to convert this particular NumPy array, that is A, to say a single column, so how I can do that? Just type in here print a.revel. That's all you have to do. Go ahead and execute this. So you'll have 1, 2, 3, 3, 4, 5. So you have 1, 2, 3, 3, 4, 5. Let me go back to my slides and see what are the other topics that we are going to cover. Now come certain NumPy special functions. Now I'm going to talk about sine function and cosine function first. So what I'm going to do is I'm going to use this cosine and sine function, and I'm going to plot sine and a cosine graph. So for that I'm going to import a module called Matplotlib. So for that I'll open my PyCharm, And let me remove this and import matplotlib dot pyplot as plt. Now we are going to define two coordinates, that is x and y. First, x is equal to np dot arange 0, 3 into np dot pi, 0.1. Now I'm going to define y. So for that I'll type y np dot sin x. Now I'm going to use plt in order to plot the graph x comma y. Now finally show the plot. For that I'll type plot dot show. You must plot dot show to make a graphics appear. So plot dot show, and here we go. Go ahead and execute this and you might be able to see a graph, and yep, it is here. Similarly, what if I change the sign to cos and should give me the cosine graph? Go ahead and run this and you can see we have a cosine graph as well. Similarly, if I write in here tan, that is any other trigonometric function, and I print this, so I get the graph for tan as well. So I'll open my presentation once more and we are going to see what are the other special functions that we can use with NumPy. Now NumPy comes with two very good functionalities, I would say, that is called exponential function and logarithmic functions. Now exponential, this e value is somewhere equal to 2.7 and we all know log. So when I talk about log, it is actually log base 10. And when I'm talking about natural log, that is log base e, I will write it as ln. So instead of that, I've written log, that means log base 10. So you can perform these operations with the help of NumPy. Let me show you how you can do that. So I'll open my PyCharm. Let me remove this. And I'm going to define a NumPy array. Let it be AR equal to np dot array 1, 2, 3. Now I want to calculate the exponential value. I'm going to throw in a print statement and I'm going to write in here np dot exp ar, and this will calculate the exponential value for me, and let us see if it does that or not. So yep, as I've told you earlier as well, value of e is 2.71. So e to the power of 1 is actually equal to e, so it has returned the e value, but e to the power of 2 will be somewhere equal to 7.38. E to the power of 3 will be somewhere equal to 20.0855. Now in order to calculate log, what you can do is you can just type in here log. Now this will give you natural log. So when I talk about natural log, it is nothing but ln, or you can say log base e. But if I want to calculate log base 10, so I need to type in here 10. First let me show you how you can find the natural log. Just go ahead and execute this. Alright, so when I talk about 1, so e to the power of 0 will be equal to 1, right? So log or ln ar equals to 0. Similarly, the other values as well. Now if I want log base 10 instead of ln, or you can say natural log, I can just write in 10 and go ahead and execute this and you'll find log base 10 values. So obviously when answer is 1, that means anything to the power of 0 is equal to 1. So the answer will be 0 here, and similarly we have other answers as well. If you're unsure about it, you can open your calculators and do that.
What exactly is Pandas? So Pandas is a Python library which is used for data manipulation, analysis, and cleaning. And Python Pandas is well suited for different kinds of data, such as we can work on tabular data with heterogeneously typed columns. We can work on ordered and unordered time series data, arbitrary matrix data with rows and column labels. We can work on unlabeled data, and we can also work on any other form of observational or statistical data sets. Now I'm going to tell you how you can install Pandas on your systems, guys. It's very easy to install Python Pandas. You just go to your command line or terminal and just type pip install Pandas, or if you're working on an IDE such as PyCharm, you can just simply type in pip install Pandas in your terminal over there, or you can just open the project interpreter and add the library over there. Since we are going to work on Jupyter Notebook, I'm going to tell you how you can install Python Pandas on Anaconda. So you just have to do one thing. So I'll just show you guys how you install Python Pandas on your system. You open the Anaconda prompt. We'll wait for the prompt to set up. So you type conda install It's already there in my system because I've already installed Pandas since I've already worked on various data analysis projects, and it's a very integral part of it. Because to work on a data set, to read a data set, you require Pandas, and it's just that you cannot work without Pandas if you're working with any data related project. So this is how important Python Pandas actually is. I'm going to tell you a few applications of Pandas as well. So first of all, you can just say that Python Pandas is an integral part of data, whichever project you're working on. So you can work on economics, you can use Python Pandas for stock prediction, you can use it for recommendation systems, then you can use it on neuroscience and statistics also you can use it for. And then there is advertising, so many data coming from different platforms. You can just analyze the data using Pandas, clean the data for irrelevant inconsistencies in your data. You can do that using Pandas, and then you can use it for analytics as well. That's the very basic use of Python Pandas that I can think of. So right now that we know how Pandas actually is in Python programming and what it is used for, let's go ahead and take a look at the very integral part of Pandas, that is data frames and series. We'll wait for this to install, guys. Meanwhile, I'll just tell you what are data frames and series, guys. So data frame is a two-dimensional, and the size of the data frame is mutable, potentially heterogeneous data, or we can call it heterogeneous tabular data. So the data structure, which is data frame, also contain labeled axes, which is rows and columns, and arithmetic operations align on both rows and column labels. It can be thought as a dictionary-like container for series objects. Now, what exactly is a series, guys? So a series or a Pandas series is a one-dimensional labeled array capable of holding data of any type, which is integer, can be string, float, Python objects, etc. And the axis labels are collectively called index, and Pandas series is nothing but a column in an Excel sheet. So let's just take a look at a few examples, and then you'll be able to understand this better, what I'm talking about, like Pandas and series, what exactly they are. We'll be working on an example now. So I'll just take it to Jupyter Notebook, guys. So we have already created a Jupyter Notebook. If you are not familiar with Jupyter Notebook, guys, we have a full tutorial on how to use Jupyter Notebook, all the cheat sheet and everything. So you can just refer to those in our Edureka YouTube channel. And make sure you subscribe to Edureka for more exciting tutorials, because we have a lot of content on Python, guys. So if you want to learn Python inside out, or any other technology for that matter, we have a lot of content on YouTube you can refer. Also, if you are at it, be sure to check out our courses on edureka.co, and we have a full Python programming certification program that you should also check out. So since I have already installed Python Pandas, I'm just going to import Pandas as PD, run this. I'm not going to face any problem running this command because I have already installed Pandas. Okay. So what this command will do over here, it's going to install the package, the latest release of Pandas for me. I think that's why it's not running. Okay, we have our first statement over here, and we have successfully imported Pandas as PD. So I'm using the alias as PD. I hope you guys know what alias is. So let's just say I'm importing this library. So alias is going to be this one, that is PD. So for importing, I'll tell you why I'm using this. Now if I want to create a data frame, I'll just use df as my variable name for data frame. So I'm going to use the alias. Now when I type tab over here, okay, so this is how I can use my alias to create a data frame. So this is just to tell you how you use an alias. Now I'm going to show you how you can create a series and a data frame. So first I'm going to, I'll have to import NumPy as well, because I'm going to use it to create a null value. All right. So df is equal to, I'm going to make a series, so I'll just write it as s. All right. Series, and I'm going to pass a list of values. Let's say 1, 2, 3, 4, 5, 6. And I'm going to use my NumPy now to create a null value like 8, 9, and one more value, let's say 10. So it's going to create a series. Now when I print s, so we have a series which has indexes which are already there, and all these values that I passed inside a list. So this is how you create a series in Python, guys, using Pandas. After this, I'm going to tell you how you create a data frame. So for that also, I'm going to tell you how you create a data frame using a dictionary object and how you can create a data frame using series as well. So now what we are going to do is we are going to create a data frame by passing a NumPy array with the datetime index and label columns. So I'll take one variable, let's say date or dates. I'll just type it as D, and I'm going to take pd dot. So we're going to take the date range, and after this I'm going to pass a few values, let's say 2020, and I'm going to pass values like we're in the month of March, so I'll just write it as March. And after this I'm going to take periods, which is equal to, let's say 10. So this is my date range, guys. Okay, I have an invalid syntax, right? Should work fine now. So when I print D over here, so I have all these values in a date range format. After this, what I'm going to do is I am going to take one data frame, which I am going to take as df for obvious reasons to make it clearer. And I'm going to take data frame, and inside this I'm going to pass a few values. So first of all, I'm going to take a few random values. So I'm going to use np.random number, and inside this I'm going to pass 10, let's say 4. Now I'm going to get the index values as D, and I'm going to have to pass a few more values, which is columns. So I'll pass the columns as a list, and I'm going to take, let's say 4 columns. So I'm just going to take, okay, wait a minute, A, B, C, D. All right, do we have any errors? No. So now I'm going to print my data frame. So I have a data frame, guys, which I've created using, passing a NumPy array, and I have a datetime index with labeled columns, which are A, B, C, and D. This is my index, guys, and I have all these random values using NP array. So this is how you create a data frame, guys. Just a simple example, and I'm going to show you how you can create a data frame by passing a dictionary of objects that can be, converted into a series also. So I'll take, let's say again, df is equal to pd dot data frame, and I'm going to pass a dictionary over here now. So I'm going to take a few values first of all. So first value is, let's say A. Now after this I have to pass something, right? Okay, I'm going to write, let's say a list of 1, 2, 3, and 4. After this my next value is going to be, let's say B, and I'm going to pass a timestamp, let's say. And for timestamp I'm going to use the same I have used over here, 2020 0301. I have to use the right, and after this I'm going to pass one more value, let's say C, and I'm going to use a series now, a series object, and inside this I'm going to pass 1, and the index is going to be, let's say a range. All right, index is equal to a list with a range of 4, because we have only 4 values over here, we don't want any null values. And after this I have to type in the data type as well, the data type of the series, guys. So for that I use dtype is equal to, let's say float 32. All right, after this I provide my next value, which is D. Now for D I'm going to use an NumPy array, and for this I'm going to pass a value, let's say not 3, let's say 5 multiplied by 4, and let's take the D type is equal to integer 32. Yes. All right, now I take my final value, which is going to be E, and inside this I'm going to pass a data frame, or we're going to use the categorical object, guys. We're going to talk about this later on in the session, so don't worry. I'm just showing you how you can create a data frame using all these objects that we have at our disposal, guys. Now instead of test and train, we can just call it as true or false. doesn't matter. We are taking categorical object, so it has to be either true or false, or it can be 0 or 1, but it has to be decisive in a way that there are only two values. So I take another value, and for this, let's just say I give the value Edureka. Alright, so our dictionary is done over here. So we have created our data frame, guys. There's no error. Now when I print this, so we have our data frame, guys. So A, B, C, D, E, and F. So we have all these values using different data types, or we can call it objects as well. So for that also we can check the data frame, and we just write D types, and it's going to give us all the data types that we have. So we have date timestamps over here, integer, float, integer, category, and an object, because I have used a string over here. That's why it is giving us an object. But in the new release, that is Python 1.0.0, it's not going to be an object. It's going to show you it is a string. So don't worry, guys. And we have already made a video on Python Pandas 1.0.0 with all the features that have come with the new release, the new stable release released last month. You can check that out as well to check for the new features that we have come across. So now that we have done this, let us take a look at the next topic that we have, which is how to view data. So viewing data is basically, how you actually look at the data, or how you're going to look at the data using Pandas library. So we'll just jump right to Jupyter Notebook, guys, and I'll tell you what kind of functions or all those things you have at our bay that we can use to view our data. So we'll do one thing. First of all, we have data frames already that we have over here. So I'll do one thing. I'll just change it to df1 so that we have different data types, or I'm sorry, different data frames, guys. I'll run this, and this as well. Now when I check for df.d types, it should be different, guys, because we have already made a data frame using that. All right, it's not. So I'll run all the wait. So I'll do one thing. I'll restart and run all the cells so that we have two different data frames. So first of all, the first very basic thing that you can do for your data frame is to use, I'll just tell you guys, you write df.head. So what this function is going to do is give you the first 5 values inside your data frame, or the first 5 rows. And similarly, for the last rows, you can use the tail method. So this is how you get the first and last values inside your data frame. So it's going to display all the 5 values that you have at your beginning and the end of your data set. After this, we have df.index. So what this will do is it will give you all the values from your index. And similarly, we have df.columns, which is going to give you all the columns from your data frame. So this is how you view your data, guys. And then we have data frame.toNumPy, which is going to give you a NumPy representation of the data. So I'll just tell you how you can do that. So I'll just write df.toNumPy. Wait a second, guys. Yes. So I'm going to create a NumPy array using this. I actually created a NumPy array. And for df, our data frame of all floating point values, data frame.toNumPy is actually fast and does not require copying the data. So it is a very best deal for we have. And then, okay, I'll just remove this. I don't want this. And then we have data frame.describe, which is going to give you somewhat like this, which is going to give you the count, the mean, the standard deviation, minimum, 25%, 50%, 70%, and maximum. So these all values using the describe you can have, which is going to give you an idea or a perspective of how your data actually is and what kind of calculations are already there that you can think of. Then we have sorting by an axis. We can sort our data using an axis. So for that, you have to just write, okay, I'll just show you guys. You just have to write df.sort by index, and inside this you have to give the value of the axis. I'll just give 1. And then let's say ascending, you want it to be ascending. No, I'll just write it as false. So it has given me the data frame by sorting the index. Similarly, I can sort it by the columns as well, or I'm sorry, sort it by values. So I'll write it as values, and I want to give the value as, say, values, and I'm going to give the value as, let's say, by. I want to sort it by C. It has sorted the values depending on C. So this is how you sort your data frame, guys. And now that we know how we can actually look at our data, I'm going to tell you how you select particular values inside your data, guys. I'm going to show you how you select a single column from your data frame. So we'll write df. It's very simple, guys. To get a value from your data frame using only a single column, you can write A or let's say C. So it's going to give all the values from C over here. It has actually given you frequency. It has given you name, data type as well. So this is how you actually get a single column from your data frame. Now let me show you how you can slice the rows as well. So for that, we're going to use the slicing. If you have actually worked on list comprehension, so we have slicing the data over here. We are going to follow the same principle here as well. So I'll just write df. Now I want my first, starting from my first value to third value. So it has given me only 3 rows, starting from the 0th row, and it has given me third row. And it does not actually include the third row because it starts from 0. So I'm giving 3 values. If I write 6 over here, I'm going to get the 6th value, but it's not going to be at the 6th row because the first row over here is going to be 0th row. I hope you understand this, guys. So I have shown you how you can slice your data, to get particular number of rows. Now let me tell you how you can select the data using the labels, guys. So for that you have to use df dot, there has to be location, loc, and inside this you're gonna pass the values by labels, guys. All right, so let's pass d, that is, and 0. So let's see what the output is, guys. All right, so we have got all the values using the label, that is d over here, which we have passed over there in our previous section where we have declared the data frame. And I'm sure this is visible to you guys. Now the next thing is selecting data on a multi-axis by label. So what we'll do is we'll write df.loc, and after this we write hyphen, and we're gonna create, let's say, A, and we're gonna pass C, right? So it's gonna give me the values accordingly, which I passed over here. So instead of A, I can write B, or I can write D. So this is how you can select multi-axis using labels, guys. And I have written this over here, so I can just write, let's say, 0 to 3. Let's see what happens. Oh, we have an error, guys. You cannot do this. So we'll now move on to the next topic that we have, is showing label slicing. Both endpoints are actually included. So how do we do that? So instead of this, we can just, let's say, copy this, paste it over here, and copy this, paste it over here, remove this. So this is just to show you guys how you can work with it. I'm very certain that the data that you work on is not going to be like this. It's going to be very complicated. So this is just to give you a perspective as a beginner how you can work with pandas. Now I'm gonna tell you how you can reduce the dimensions of the returned object as well. So for that, you just type one thing, guys. You remove all this, get just one value, and this is gonna give you the column number at over there. And this is how you get the values inside a data frame. So moving on, let's say we want to get a scalar value. So for that, we just write, okay, let's say D0. Right, let's see if it works. We're getting the same values, guys, only from the 0th row. For getting the fast access to a scalar, you can just write as df, instead of loc, we can just write at. Okay, we have an error, guys. I'll just remove this, and let's see if it works. Yes, so I'm getting the exact value at the 0th row at the column number C. Now I'm going to tell you how you select a value from using the position inside your data frame. So for that, we use df.iloc. All right, so let's say 3. Okay, so I'm getting all the values from third column. And similarly, we can slice the data. You can just get it like 3 to 5. All right, we can add more values to this, like 0 to 2. So this is how you select the values from your data frame, guys. Now we have Boolean indexing as well inside our data frames. So I'll just tell you quickly what it is. So for that, you just write df. Now I'm going to check if df column number A, let's say this is interesting, guys. So it has given me all the values inside A where A is greater than 0. If I write here, let's say 2, I have no values because none of the values are greater than 2. So this is how you can get the Boolean indexing. This is actually important when you're applying functions to your data frame, guys. So moving on, let's take a look at another method, which is isIn method. I'll just tell you how it works, guys. So it's basically is to check if the particular value inside your data frame is in there or not. Now there's one more thing. We can set new values inside our data frame. We can set a new column which automatically aligns the data by the indexes. So for that, we can make the series, and we can set the values by label, we can set the values by position, and we can set the assigning with a NumPy array as well. And the result of the settings will actually align with the data frame, where a new operation with the setting can be followed, where you can simply align the data frame with the existing data frame. Now let's go ahead and take a look at the next topic that we have, which is handling the missing data inside your data frame. So let's jump right to it, guys. We'll go to Jupyter Notebook and we'll work with our missing values now. So Pandas primarily use the value np.nan to represent missing data. It is by default not included in the computations, and we're going to see the missing value right now. So first of all, you have to reindex. You have to do reindexing, which is going to allow you to change, add, delete the index on a specified axis, so which is going to return a copy of the data as well. All right, I'll just take df2 is equal to df dot reindex. So this is how I'm going to do the reindexing, guys. So index is equal to, let's say, d 0 to 4. Yes, I'm going to get the columns after the reindexing, which is going to be equal to list of df dot columns, and I'm going to add one more column, which is going to be, let's say, e. All right, now what I'm going to do is I'll do loc. I'm going to check a few values. So instead of dates, I've taken d, guys. So d of 0 and d of 1 at e is equal to 1. Now let's check what is df2, guys. We have two null values over here. So this is how I'm going to show you how to handle missing values inside your data frame. So we have done reindexing. So first of all, I'm going to check for null values. So we have true over here, and we can get the count as well, is null, and we count these null values. All right, right now we are going to drop a few columns. So we are going to drop the NA, that is the NA values. So as you can see from our data frame, all the values that had null values are dropped. Actually, the whole column has been dropped. Or we can do one thing, fill in the missing data, guys. Just do one thing. Okay, check df2 we have. So we can do one thing, we can fill the missing values, and we are going to provide some value. Let's say value is equal to 2, right? So we have actually filled the value with some other value. Wherever there is a missing value, we have given a value that is going to fill over there. So this is how you get, or check for all these missing values inside your data frame. After this, you can now actually get a Boolean mask where values are nan, which is null. So for that, you do pd dot is na df2. So this is going to get you a Boolean mask, which I've already told you how you can check using df dot is null. Same thing, but different processes to run this. Now let us move ahead and to the next topic that we have, which is Pandas operations, guys. Pandas operations are nothing but a few operations that you can apply on the data frame or any other Pandas object. So we have descriptive statistics that we can apply. We can apply functions, histogramming is there, and string methods is also there. So I'll tell you what histogramming is when we are talking about it. So let's take it up to Jupyter Notebook again, guys. I'll tell you how you can actually work with Pandas operations. So first of all, I'm going to tell you a basic operation, which is that is a descriptive statistics. So it's going to give us all the mean values. Similarly, we can get one value like df dot mean, provide one value over there. So this is how you get it, guys, or we can write it as 2, right? All right, so this is how operating with objects that have different dimensionality and need alignment. In addition, Pandas automatically broadcasts along the specified dimension. So for that, let's make a series. I'll tell you just how it works. pd dot series, give it a few values, let's say 1 2 3, np dot nan 5, I'm sorry 4 5, and then give the index value. The index is going to be dates, and let's just shift all this 2 places, right? We have made an error, guys. Length of pass value is 6 and index implies 10. So we have to actually put more values. So write 6 7 8 9. Yes, now when I print s over here, we have all these values. Now we can do one more thing. So we write it as df dot sub, and we pass the s over here, which is our series, and we make an axis, write it as index. So we have operated with objects that have different dimensionality and needed alignment. So in addition, Pandas actually helped us automatically broadcast the specified dimension. So now I'm going to talk about applying functions to the data. So we already have data frame. Let's see what we have. So we have this data frame, guys. So what I'm going to do is I'm going to apply a few functions. So first of all, I'm going to use the apply method over here, and let's see what all do I have. Let's just check. We have absolute import, all close, a max, a minimum, angle, any append, all these functions that I can apply on this. So let's say we have 𝐂𝐝𝐿𝐿. Let's see what this does, guys. All right, so this is how it works. Now let's apply a few more functions, guys. So I'll write lambda x. So we are talking about lambda functions here. I'm sure most of you must be aware of the lambda functions that we have in Python. If you don't have any prior knowledge on lambda function, guys, there is a full tutorial on how lambda function works in Python, guys. So this is how we applied lambda function to get the subtraction between the x max and x minimum. All right, for all the columns we have the subtraction between all these values. So this is how we apply functions to our data, guys. Now I'm going to talk about histogramming. So histogram is a representation of the distribution of data. So this function we have, which is matplotlib.pyplot.hist, on each series in the data frame, resulting in one histogram per column. So what we'll do is we'll make a series, and it's going to give us value counts for histogramming. How do we do that actually? So we can just write as s dot value counts, right? Let's see if it works. Right, we have one value for each. So this is how we get or do the histogramming with our data, guys. Now I'm going to talk about the string methods. So series actually is equipped with string processing methods in the string attribute that actually makes it easy to operate on each element of the array. So let's just move ahead with the example. So I'll make a series, guys, pd dot, let's say series, and inside this I'm going to pass a few string values. So I'm going to start with Edureka, write Python next. Let's write Jupyter, give it a few null values as well. to make it a little or slightly different from perfect. All right, so give it a few values, let's say football. And looking at the current scenario, let's write world. So we have a series over here, guys. Now what we'll do, we'll take or use the string methods. So I'm gonna make it all to lower, which are already lower. So I'll make it to upper, guys, upper letter words. So everything we have changed using the string methods inside our Pandas series. These are all the operations that you can perform on Pandas, guys. So let's move ahead to the next topic that we have, which is merging. So in merging, we are basically going to merge two data frames together. So we have two functions, which is concat and join. So concat Pandas objects along a particular axis with optional set logic along the other axis. It can also add a layer of hierarchical indexing on the concatenation axis, which may be useful if the labels are the same or overlapping on the past axis number. So let's take a look at the example for this. So we have our data frame. I'm going to use pd dot data frame. Give it a few values, let's say np dot random number from, let's say, 10 and 4. All right, so we have all these values. Now what I'll do is I'll break it into the pieces. So how to do that? So let's say I write it as df2 is equal to df from first to third row. The next one is df from third to, let's say, seventh row, and then we have df from seventh to the end of the data. So this is how I am going to break it into the pieces. Now when I write it as df2, we have 3 data sets. Now I'm going to use the concatenation function using concat. All right, I'm gonna concatenate df2. So this is how I've concatenated the missing pieces, not the missing pieces, the several other pieces together using the pandas concat function. Now let's talk about the join function that we have. So for this, basically I'm gonna tell you how you can do the left and right join. So for the left join, I'll write left is equal to pd dot data frame, and let's see, first value, let's say a, give it a few values, let's say 1 2, and then say b, we have 3 4. All right, we make the for the right as well. So I'm just gonna copy all this, paste it over here. Okay, I'm just going to write it as D. This is going to be, let's say, C, and change a few values. So we have left and right, and I'm going to just type left, and then we get the output for right. So I'm going to join all these two using the join function. So for that, I'm going to use the merge function, and inside this, let's say left, we have right, and on is equal to, I'm going to join it at let's say A. Let's see how it works. Okay, it doesn't. So we have a key error, which is A. So I'll change it to A, guys. So we actually joined using the merge function over here. And another example that I can think of is, let's say we have left and right. We can change the values differently, and we can just group them together. Now what I'm going to talk about is grouping, guys. So how you do the grouping of different data inside your data frame using pandas. So first of all, for that, you have to split the data into groups based on some criteria that you have, and then after that you apply some functions on them, and then later on you can combine the results into a data structure. So first of all, you have to get a data frame, guys. So let's see, we have a data frame over here. So we can actually group it by, let's say, right, I'll just write group by, say, A, and I'm just gonna sum. Right, we have an error, guys. So we have a key error, that is A, because we don't have over there. So I'll write it as, let's say, 2. All right, we don't have 2 as well. We have a key error. We don't have 2 over there because it's not a string value, it's an integer value. So we have our values right over here. So we have grouped the data using the column that is number 2. Now we can actually group the data by multiple columns and form a hierarchical index. So for that, I'll just copy this, guys, or over here only I'll just do one thing, 2 and let's say 3. So this is how you actually combine multiple columns to form a hierarchical index. But here again, we don't have actually categorical values for these columns. If we had, we'd be able to do that. If we had, like, let's say true and false, it is going to have created a hierarchical index which will have different values for true columns and for false columns. So that's how you do the grouping, or that's where you actually need grouping using pandas. Now let's move ahead and take a look at the next topic that we have. Okay, we have already talked about operations, then I have talked about merge, where we have talked about concat and join, and then I've talked about splitting the data, how you apply the functions, and then combining the results together. Merging, we have talked about grouping. Now I'm going to talk about stack and pivot table. So what exactly is a stack, guys, in pandas? I'm sure most of you must have heard about some of the definitions of stack. So I'm going to tell you about this with perspective of pandas library here. So the stack function is used to stack the prescribed levels from columns to index, and it returns a reshaped data frame or a series having a multi-level index with one or more new innermost levels compared to the current data frame. So you're going to understand this with an example. So I'm just going to take let's say my tuple is equal to, I'm just gonna take a list, and inside this, let's see, we have values, and we provide, or we get 2 lists over here, a list inside a list, guys. So let's take a few values, take 1, 2, 3, 4, 5, and then again, let's say 6, 7, 8, 9, and 10. Or we'll add a few more values, guys. Let's say 11, 12, and 13. Over here I will add a few more values, let's say 17, 18, and 19. So we have our tuple. I'm going to create one more variable index. So we'll have multi-index. So from tuples, and inside this I'm going to pass my tuple, pass the names as well. So the names are going to be, let's say, first and second. So we have our index. Now I'm going to create the data frame, guys. So for this we write pd dot data frame, and inside this I'm going to pass a few values, np dot, let's say, random dot random number. So we have 8 values and 2 columns. All right, so and the index is going to be index, and columns is equal to A and B. All right, we have an attribute error, guys. I made a mistake. So there's no error now, and I'm going to make one more data frame. So inside this I'm going to pass this value. Now I check my data frame. So I have reshaped my data frame with this. first and second and all these values. Now we're going to talk about the stack method, guys, so which compresses a level in the data frames columns. So we're going to do one thing. We're just going to do df2 dot stack, right? This an attribute arrow. So this is how we stack or compress a level in the data frames column, guys. And with a stack data frame or series having a multi-index as the index, inverse operation of stack is unstack, by which default it's gonna unstack whatever you have done with using stack. So we'll do df2 dot stack, and this is how you unstack. Now we'll talk about the pivot tables, guys. Oh wait, let's put it inside a variable, let's say a. Alright, so this is how you unstack, guys. We're getting different values there. Now we're going to talk about the pivot tables that we have in Pandas. So it is nothing but the levels in the pivot table will be stored in multi-index objects. On the index are columns of the result data frame. So we'll take a look at one example, guys, which is going to be pretty clear. So we'll take df again, pd dot data frame, and inside this we're going to take a few values, or we're going to take a list inside a dictionary. So let's go with a few values. Let's say 1, or let's say a. Alright, so we write a, b, c, d, we'll remove a few values over here, multiply it to 3. Now we take another value, which is going to be b, and for this we're going to take a list again. So let's say multiply it to 4, take another value, let's say c now, and inside this we're going to pass a few values again. So we're going to pass 6 values. So let's write p, p, and p, q, q, and q. Multiply it to 2 because we want the number to be 12. And now d is going to be np dot random number, and the number we want is 12. And we take one more value e, and we take the same values for this as well, random number 12. No errors, I guess. So we have an invalid syntax, guys. So we forgot to add a comma over here and here and here. Right, so I think it should work fine now without any errors. So we have printed the data frame over here, guys. So this is how it looks. Now we can produce pivot tables from this data very easily, guys. The very reason of creating this data frame was to get the pivot tables. Now what I'll do is I'll just write pd dot pivot table, and I'm going to pass df over here. Alright, df, and the values is going to be, let's say, d, and index is equal to a and b, and columns, let's say, is equal to c. So this is how you create a pivot table, guys. Now that we're done with pivot tables, let me talk about the next topic that we have, which is time series and categoricals. So we have done reshaping, merging, grouping as well. Now we're going to talk about the time series and categoricals. So Pandas has simple, powerful, and efficient functionality for performing resampling operations during frequency conversion, which is, for example, converting secondly data into 5-minutely data, And this is extremely common in, but not limited to, financial applications. So we're going to take a look at a few examples. And for categorical data, data that you collect can be either categorical or numerical. So numbers often don't make sense unless you assign meaning to those numbers. So for categorical data is when numbers are collected in groups or categories. And categorical data is also the data that is collected in an either or yes or no situation. For example, we have 0 or 1, we have true or false. So that's going to be the category over there. So let's take a look at a few examples to understand this, guys, the time series and categoricals. So we'll take a look at a few examples for time series. So first of all, what I'm going to do is I am going to make a time series, guys. So first of all, what we'll do is we'll convert the data into 5-minutely data. So it's very common, guys. So I'll just take the range first of all. So we'll take the dates. All right, I made a mistake. I'll just cut this. So I'll just run this again. We'll get one more column. And now what I'll do is I'll make one variable using the pd.date range. Yes, and I'm going to provide the range as, let's say, 2020 01 or 03 01. We want the periods is equal to 100, and let's say frequency is equal to s. All right, let's print dates. Okay, so we have dates over here. I'll just remove this for now. So now we take one more variable. Let's say ts is equal to pd dot, I'm going to take a time series, and inside this I'm going to use np dot random and random integer, which is going to be 0 to 500, and the length is of dates, and then we have index is equal to dates. So we have, okay, we have NumPy attribute, no random random. All right, so we have an unsupported date time, so I'm going to have to change this over here. So we'll write it as, let's say, 3 1, or we're going to write 3 3 2020. Right, so let's see if it works now. It doesn't. So we are getting the unsupported d type. Okay, so we just mention a few more stuff over here. So we'll write it as 0000. So I think I figured out the problem over here. So I've changed this to this format, and now I'm going to add one more parenthesis here and remove this one, and now I'm not getting any errors, guys. So I'll run it again. Right, so now what I have to do is I will have to make a few changes to that ts, which is time series I've made. So I'll write it as ts dot resample, and I want to make it to 5 minutes, right? And I have to sum this, so no errors there, guys. So now I'm going to do the time zone representation. So for that I'm gonna get one more. Okay, I'll just copy this, guys, this little change to this only. So I'll just copy this, paste it over here, and here I have to make a few changes. That is 0 0, the rest everything is going to be fine, and we'll change this to 5. All right, so now we make another timestamp, and we just use pd dot series, and inside this I'm going to use np dot random dot random number, and the random number is going to be the length of dates, and dates over here. All right, so now when I print timestamp, I'm getting the output as something like this. So this is how you get the time zone representation, guys. So you're getting the date, the time, and everything, and the data type is float 64. And then you can also get the UTC as well. So for that, I'll just write TS UTC, and we just write timestamp dot TZ localize, and we get UTC, right? It's UTC. Now I'm gonna print this, so we get the UTC as well. So this is how you create the time zone representation. And now after this, I want to show you how we can convert to another time zone. So for that, we don't have to do anything. We just write TS dot, all right, TS UTC dot TZ, which is time zone convert, and we write US Eastern. So we have converted into the US time zone. And converting between time span representations also, we can do that. Let's just say that's your exercise. So you have to convert between the time spans representations so that you'll be able to understand this better. For that, you don't have to do anything. You just have to take the date range. The period is going to be 5, and then you write the frequency instead of S, you write it as M. The rest all is going to be the same, guys. Okay, I'll just do it here as well. Just copy this, paste it over here. Instead of S, it's going to be M, where I have to remove this. All right, now I make the timestamp, which is going to be the same, guys. Now print the timestamp. This is how we convert. Or after this, we take one more variable, let's say PS, and I'm going to do period. All right, now when I print PS over here, this is the output I get. So the frequency is M. I've changed the frequency, and now I can just convert it to timestamp, guys. Let's see where it is. This is how you create it into a timestamp. Now converting between period and timestamp enables some convenient arithmetic functions to be used. So for that, we have period, range, and all those things that you can add. Now moving on to the next topic, that is categoricals. So for that, let me just take one more data frame, guys. So I'll write it as df is equal to pd dot data frame. Now I'm going to take a few values inside this dictionary. The first is going to be, let's say, ID. And now I'm going to pass a list with a few values, precisely 6. So I'm going to use 6 values over here. Now my next topic is, or the next key is, let's say raw grade, or just grade we'll write. So we're going to write A, B, C. Let's say again the guy is getting B and this one's getting A. So we have 5 and one more. Let's say one guy has failed. So we have our data frame. Let's print this. Okay, so we have our data frame. What I'm going to do is I am going to get the grade, right? So we'll get the grade is equal to df grade. Now this is going to be the category I'm going to make. All right, now we print df grade. So we have grades like A, B, C, B, A, E. Now I'm going to rename the categories to more meaningful names. So what I'll do is I'll make the change over here only. So I'll write cat dot categories, and I'm going to write the categories as, let's say, good. Instead of pass fail, I'm just going to write very good, and then there is excellent. All right, So we have very good, very bad, and excellent. Alright, we have an error, guys. There's something we have done. So we have new categories needs to have the same number of items as the old categories. So how many categories do we have over there? Let's just copy this. So we have categories 4. So we're gonna have to make 4 categories, guys. So I'm just going to add good as well. There shouldn't be any errors. Now what I'll do is I'll just set the categories. So I'm going to set the categories now. Let's say here I'm going to have to give 6 values, guys. So right, very good. Let's say bad, very bad, medium good, very good. Any sort of categories I have to give over here. So I'll just write very bad, good, and let's say medium. Alright, so after this I have set the categories as well. Now I'll just write df. Great. Okay, so we have good, very bad, then we have very good, very bad, and good, and then we have NaN because we have not given any other category for that. And we have the 5 objects, so we are getting very good, bad, very bad, good, medium. So that's how you use the categoricals in Pandas, guys. Now I'm going to talk about plotting using Pandas. So that's going to be very simple, guys. For that I'm going to have to import one more library, that is Matplotlib dot pyplot. I'm going to use it as PLT. All right. Same thing goes with this as well. All right, this is going to be pyplot. All right, so there should not be any errors now. Okay, so I will close all. Now I'm going to make one series, guys, and inside the series I'm going to provide a few random values like np dot random number until, let's say, 1000, or let's say 500, or yes, 500, and the index is equal to pd dot date range. I'm going to take the date range as 1/3/2020, and let's take the periods is equal to 1000. Wait, we have to take it as 500 because we have 500 values over there. I hope no errors. Yes. Now I'm going to take the timestamp and we're going to get the sum. All right, now ts dot plot. So we have a plot over here using Pandas, guys. This is how we have created one series using the random numbers from NumPy library, and using the pyplot we have plotted a graph for random values which we have taken from 0 to 500 and the random range as well. So this is how you take or get a plot using Pandas, guys. Now last but not the least, we have another topic which is reading and writing to files. So inside this, I'm going to show you how you can read from a file and how you can actually create a file over there. So we have our data frame, guys, or we have our TS. This is our TS, guys. So I can just, convert it to a CSV file, guys. Make it or give it a file name as, let's say, ts.csv, and it's going to save the ts.csv file somewhere in my directory. And similarly, I can read from a CSV file. So for that, I can just write pd.read CSV, and I'm going to have to give the file location for that. So I'll just copy one file location from one of my data sets. So this is one data set that I have. So I'm going to check for the properties, or wait, I'm going to copy this, paste it over here. Okay, we have an Unicode error, so I'll just write R over here, and I'm able to read from the CSV file, guys. Look at this. Instead of CSV, I can write Excel, and it's going to create a Excel file or a CSV file it's going to read from. So that's how we actually read and write from files, like a CSV file, which is a comma separated file basically, or we read from a file.
So why we need data visualization? Now let us take an example. Suppose you work in an organization as an analyst and you have made certain analysis. Now you need to show that analysis to your boss or your CEO or whatever. Now you can understand it by just looking at the Excel sheet and the numbers. But the other person is not an analyst. He's not that technically sound as you are. So what do you need to do? You need to present your analysis or your data in such a way that the other person can understand. And how you can do that? You can do that by representing it in the form of a graph. And it is a well-known fact that human brain can process information easily when it is in pictorial or graphical form. So that is one of the key reasons why we use a data visualization in order to understand the trend better and make better decisions. So let us move forward and understand one more reason why we need data visualization. Now basically it allows us to quickly interpret the data, like whatever the trend the data is showing us. Now basically it allows us to quickly interpret the data. So just by looking at the graph, we can understand what the data is about and what is the trend. But if you are not from an analytics background and you see just the Excel sheet, then it is very tough for you to understand it. So if it is there in the graphical form, you'll quickly understand it and you can experiment as well. Now what happens if you want to change certain variables and see what will be the outcome? So with the help of the graphical representation of your data, that will give you a very good idea as to what all variables are useful for you and what all variables are useless. You don't need to include in your analysis. In order to perform that experiment in an efficient and a quick way, you need data visualization. So guys, these were the two key reasons why we need data visualization. So we'll move forward and understand what exactly is data visualization. So what is data visualization? So data visualization is nothing but the presentation of your data in a pictorial or a graphical format. Now why we do that? We do that in order to enable the decision makers of an organization to see the analytics presented visually so that they can grasp some difficult concepts or identify new patterns. Where I can use data visualization in an organization. You can use it to identify the areas that need attention or improvement in the organization. You can even use it in order to clarify which factors influence customer behavior. Now, it might depend on the season or anything else basically. Now, you can even use it to understand which products to place where. Now, this is very important, guys. Obviously, you won't be selling jackets or sweaters in summers, right? You won't be selling shaving cream to kids. So you should know what are your target audience and where you are selling your product and to whom are you selling your product. So that is one very important field where we need data visualization, and you can even use it to predict sales volume as well. Fine guys, so we have looked at a lot of examples for data visualization. Now let us understand the diagram that is there in front of your screen. So it basically tells you about how to find insights from your data. Now for that we need data visualization. It plays a very, very important role, and it is one of the major applications of data visualization in order to find insights in data. Now there's a process that has to be followed in order to do that. So it starts with visualize. The first step is visualize. So basically you understand what your data is. You visualize it in a form of a graph and you understand what that data is actually talking about. Now we'll take an example. Suppose you have a data set that tells you about the youth percentage of unemployed youth country-wise from 2010 to 2014. Alright, so you have that data, then you visualize it. The moment you visualize it, you'll get to know that, okay, it's fine. This country has a lot of unemployed youth, whereas this country is doing pretty good. So accordingly, you just grasp it pretty easily when you visualize it. After that, you make certain analysis. Now, what sort of analysis? Suppose if I take the same example forward, if I want to find out the change in the percentage of unemployed youth between 2011 to 2010, so that will come under analysis phase. So I'll analyze it. After that, what comes is document insight. Now you have done that analysis, but what is the outcome of that analysis? Now I'll see what all countries are doing good. I mean, the percentage of unemployed youth have gone up and which country it has gone down, and from what all countries it is stable. There's no change. So we'll see that and make a document. After that, we transform our data set. Now there might be certain fields in my data that I don't need. So at that time, what I'll do, I'll transform my data set, I'll remove those fields, or there might be certain fields that I need and which is not there. So I'll add those fields. So accordingly, I'll transform my data set. And once I've done that, I'll again visualize it in order to understand what my data is now talking about. And this process will keep on repeating. So this is how you find insights in data, where visualization plays a very, very important role, guys. So I hope you have understood this flow. So we have understood what exactly is data visualization. So we'll move forward and understand what exactly is Matplotlib. Now it is very important for us to understand as to how Matplotlib works fundamentally. Now it is pretty easy and pretty basic. You have some data, then your computer will draw that data to a canvas of some sort, but it is only in the computer's memory. Now once your computer has drawn that data, you can show that data. So this is so the computer can first draw everything and then perform the more laborious task of showing it on the screen. Very basic. I know you might find it pretty lame, but it is very important for us to understand how fundamentally Matplotlib works. So you have an example in front of your screen. So again, we have that data in which we have country-wise percentage of unemployed youth. And I've done some analysis and I've shown it graphically, the percentage change in the unemployed youth country-wise between 2010 to 2011. So this is how that plot looks like. It is nothing but a bar plot. Now there are various types of plots available. We'll have a look at few of those in the next slide. So we'll move forward and see what are the various types of plots. So I've listed down 6 types of plots. First is the bar graph, then histograms, scatter plot, pie plot, hexagonal bin plot, and area plot. We are going to plot all these things in today's session with the help of Matplotlib module. So we'll move forward and we'll get started with it. We'll write our first Matplotlib code. So here's the most basic code in order to generate one of the most simple graph. So let me explain to you this code. First of all, what I've done, I have imported PyPlot from Matplotlib as PLT. Then I'll use this PyPlot in order to plot the graph in the canvas. And then finally, I'll use this PLT, which is nothing but PyPlot, in order to show what we have got. All right. So pretty basic, guys. So what I'll do, I'll open my PyCharm and execute this practically. So this is my PyCharm, guys. So over here, I'll first create a Python file with .py extension, and I'm going to name it as first code. Now over here, I'll first import PyPlot from Matplotlib. So for that, I'll type from Matplotlib import PyPlot as PLT. Now this PLT is pretty much similar to NP that we were using in NumPy array, if you can recall. So it is not mandatory to use PLT only. You can use whatever you want, but a lot of people use it as PLT, and I'll keep it that way. Now our next step is to plot our graph to the canvas. So for that, what I'll do, I'll type in plt.plot, and I'll write in here my x and y axis values. So for x-axis, I'll keep it as 1, 2, 3. Then for y-axis, I'm gonna add values such as 4, 5, and 1. So this will plot our graph in the canvas. Now final step is to show that plot. How we'll do that? I'll just type in here plt.show, and we'll execute this and see what happens. Run first code, and yep, this is how our first basic graph looks like. So with 3 lines of code, you have got this graph. So we'll move forward and we'll see how to actually add title labels to our graph. For that, I'll open my slides once more. So now, of course, there are some problems with our graph. First off, we have actually learned in school that we are supposed to put labels on each axis. And we need to also add a title to our graph. It actually doesn't make sense. Our graph doesn't make sense if there are no x and y axis labels and a title. So you don't know what is axis, You don't know what is x-axis, you don't know what is y-axis, and what is the graph about. Plus, in terms of programming, it is very unlikely that you'll be actually filling in data to the plt.plot function. Now over here, you can notice that we are actually filling in data like 1, 2, 3, 4, 5, 1. Instead, you will be passing variables into it. All right. So it should be something like plt.plot, and you can say x comma y if you have defined variables x comma y. All right. So now let us show plotting variables as well as adding some descriptive labels and a good title. How does that sound, guys? All right, so I can see a lot of people are pretty excited. So we'll move forward and see how to add title, labels, and plotting variables. Now the code is pretty much similar to the previous one, but it has few extra fields. Let me explain you that. So of course I've imported the pyplot from Matplotlib. After that, what I've done, I've defined two variables, x and y, and I have certain values in it, like 5, 8, 10, and 12, 16, 6. You can put whatever values you want, and this can even contain a data frame, a pandas data frame that has a data set. After that, what I've done, I've defined plt.plot function in which I have x and y. Instead of filling the data, I'm putting in variables that actually contain data. After that, I've added a title, which is info, then y label, which is nothing but y-axis, and x label, which is nothing but x-axis. After that, I need to show my plot. So for that, I've done plt.show. And the result is there in front of your screen. We have a title, we have labels for x-axis and y-axis. Now let me open my PyCharm and execute this practically. This is my PyCharm again, guys. So I'll remove till here, and obviously I need pyplot function from Matplotlib. So now I will define x and y variable. So in x, it'll have a list of numbers, say 5, 8, and 10. And now I'll define one more variable, y, which again has a list of numbers 12, 16, and 6. 12, 16, and 6. Yep. So I'll write in here plt.plot, and instead of filling in data, I'll be passing variables. All right. And now our next step is to add title and x label as well as y label. So in order to add title, I will write here plt.title and the title of my graph. So I can just write here info. And now I'm going to define x and y labels. For that, I'll type in plt.y label, and I'm going to name it as y-axis. Similarly, for x label, I'm going to do the same thing, x-axis. All right. Now finally, I'll type in plt.show. Now go ahead and run this. So you can see that we have a graph that contains the title info, y-axis as a y label, as well as x-axis as the x label. Now I'll again open my slides and we'll see what next are we going to see. Now this graph is pretty much incomplete or ugly, I would say, because what if I want to change the width of this particular line? What if I want to add some grid lines? What if I want to change the color? So all those things, how will I do that? Don't worry, the next slide will actually tell you the same, how to add style to your graph. So how to add style to your graph? For that, first thing that you need to do is import the style function from Matplotlib module. After that, you need to call it style.use_ggplot. So whatever plot that you want to use, I'm using ggplot right now. Then again, I've defined 4 variables, x, y, x2, and y2. And all of these contains a list of numbers. Again, I'm telling you, it can be a data frame as well, which contains a data set. Then what I've done, again, I have used plt.plot function. But over here, apart from x and y, there are many other fields. So don't get confused. I'll explain it to you. It's very, very easy. So this thing G actually tells me that the color of my line should be green. Then this is label. So this label is not for your x-axis or y-axis. It is for your curve, which is line 1. You can give whatever name you want. Then we have line width. I want the width of my line to be 5. So I've put in here 5. Similarly, I've done for the next plot as well. Then I've added title, which you know how to do that. Similarly, y label and x label. Now after that, I'm using this legend function in order to add a legend to my graph. Over here, you can notice that we have it present in our graph where I'm pointing with my highlighter right now. So we have line 1 and line 2. After that, what I've done, I've added grid lines to my graph, which is of the color K, which is nothing but black. So you can see it in my graph as well. We have grid lines available. And finally, plt.show. All right, so we have no questions. So I'll open my PyCharm again and I'll show you how you can do that practically. So this is my PyCharm again. Guys. Let me first remove all of this.
and I need to import the style function. So for that I'll type from Matplotlib import style. That's it. Style.use ggplot. Now define the variables. First will be x, add certain values to it. I'll add in 5, 8, 10, 5, 8, 10. Then y, I'm going to add a list of numbers 12, 16, 6. Now one more variable x2, again it will have list of numbers which will be 6, 9, 11. Then I'm going to use y2 variable and I'll add some numbers to it 6, 15 and 7. Alright, so now I'm going to use plt.plot function, and over here first I write x comma y. Then now given a color to it, I'm going to give it as green. Next label line 1. Now line width which is equal to 5. Now again for x2 and y2 I'm going to type in plt.plot x2 comma y2 comma the color, then label. So I'm going to type in line 2, then comes line width. Alright, so now our next step is to add title to our plot. So plot plt.title, and the title that I'm going to give is info again. Then x and y labels, plt.y label, y axis, then plt.x label, x axis, plt.show. Now go ahead and run this. So over here I've not added any grid lines. I can do that as well. So for that let me first close it. Fine, so I've defined title, x label as well as y label. Now our last task is to actually add grid lines. So for that I'll type plt.grid and just write in here true comma give a color. I want it black, so I'll keep it that way. Finally show your plot, so plt.show. That's all. Go ahead and run this. So you can see that this is our graph. So we have changed the default line width, we have added grid lines, we have added labels, titles, plus we can add legend as well. So let me show you how you can add a legend. So for that I'll go back to my code once more. Just write in here plt.legend. Go ahead and run this again and you'll see that legend has been added. So here we have line 1 and line 2 as our legend, and we have changed the default line width, title, y-axis, x-axis labels, plus we have grid lines. So this is how you can customize and add style to your graph. So what I'll do, I'll open my slides again and we are going to look at how to plot various types of graphs. For example, a bar graph or a histogram, all those things. Fine, so first we'll look at how to plot a bar graph. So these are all the linear graphs that we have seen till now. Now we'll see how to plot a bar graph. So before I tell you how to plot a bar graph using Matplotlib, let us understand why we actually use a bar graph. So bar graphs are basically used to compare things between different groups. And when we are trying to measure changes over time, bar graphs are very well suited when changes are larger. So this is why we use bar graph. Now let us understand how we can do that using Matplotlib. Now since we know why we use bar graph, let me explain you the code and how you can do that using Matplotlib. So first import pyplot like we do every time. After that, instead of plt.plot, I'll use plt.bar, and I have filled in data here. You can fill in variables as well that contains data. Then I have defined a label example1. After that, I have one more plot in which I have filled in data plus a label, and I've given a color as well. I don't want the default color, I want some change. So I've written it as green. After that, I have plotted the legend. After that comes legend and then X label and Y label that you have seen in the previous graphs as well. Then I've added a title and then finally show it. Don't worry guys, I'll execute this practically in my PyCharm now. So this is my PyCharm guys. So over here what I have done, first of all, I have imported the pyplot function.
Then instead of plt.plot, I'm using plt.bar, and inside that I have data filled in. Instead of that, I can even have variables that contains data. Then comes label, in which I am using example1. Then comes label. For this instance, it is example1. Then again, for one more plot, I have plt.bar. Inside that, I have data filled in, then label, and then in order to differentiate between both of them, I'm using a color green for this particular bar graph. Then comes legend, and then after that I've defined X label as well as Y label. After that, I have title, and then finally show it. Now go ahead and run this and see if it works or not. And yes, it does. So we have legend here, we have X label, we have Y label as well as X label, and we have a title for our graph. Alright, so let us move forward and focus on the code that you have in front of your screen. So let me explain you this code. So over here we have population ages. So we have defined a list in which we have multiple numbers. After that, we have defined one more list or a variable, bins, in which we have multiple numbers again. Now instead of using plt.bar for bar plot, for histogram we use hist, plt.hist. Then comes population ages. Instead of data, I am filling in here variables that contains data. Then bins. Then hist type, I want it to be a bar type. Now when I talk about hist type, I want it to be bar. Then the width should be 0.8. That's all. The rest all you can understand. It is X label, Y label, title, legend, and finally show the plot. Now I'll go ahead and execute this practically in my PyCharm. So this is my PyCharm, guys, and just to save time, what I've done, I've actually copied it already. So over here you can see we have imported the Matplotlib module. Then we have a variable population ages and bins. Now instead of using plt.bar, I'm using plt.hist for histograms. Then comes the two variables, and then hist type is equals to bar, and then I've defined width. Similarly, I've defined X label, Y label, and title like the previous examples. Then comes legend, and then finally show the plot. So let us go ahead and execute this and see if it works or not. Yep, it does. So we'll move forward and understand scatter plot as well. Now before we understand how to plot a scatter graph, we need to understand why we actually use scatter plots. Usually we use scatter plots in order to compare two variables, or three if you're plotting in 3 dimensions, looking for a correlation or groups. So basically you try to find out how much 2 or 3 variables related to each other. So over here, as you can see, there is one point here and there's another point here. So these two are pretty much dissimilar to each other, right? Now when I talk about these 2 points, they're pretty close to each other. So you can say that these two are pretty much similar. And basically what we are doing here, we're trying to find the relationship between the 2 variables. And that is actually called your correlation. Now let us understand the code. Now let me explain you the code. So first of all, we have imported the pyplot function from the Matplotlib module. Then we have 2 variables X and Y, which contains a certain set of values. Now instead of calling plt.plot or plt.bar or plt.hist, I'm using scatter because I'm doing it for a scatter plot, right? Now inside the parenthesis, I have X and Y variables. These variables contain data, and I can even write the data instead of just writing the variables as well. Now I've defined a label and then color. Then rest of the things, you know, we have X label, Y label, the title, then legend, and then show. That's all. Now let's go ahead and execute this practically in my PyCharm. Now this is my PyCharm, and over here I've already pasted the code. So I'll just go and run this and we'll see what happens. So this is how our scatter plot looks like. So here we have our legend, then we have the title, then we have our Y-axis, then X-axis. These two are the labels for that. So let me close it and see what is the other plot that we are going to focus on. Now once scatter plot is done, we'll have a look at the area plot, or you can even call it as a stack plot. So basically these area graphs are very similar to the line graphs, okay? They can be used to track changes over time for one or more groups. Area graphs are good to use when you are tracking the changes in 2 or more related groups that make up one whole category. You can take an example of, say, public and private groups, okay? So before I explain you the code, let me tell you one thing, guys. The problem here is with polygons, we cannot actually have labels for our data. In order to solve that problem, all we did here was plot some empty lines, giving them the same color and the correct labels in accordance with our stack plot. We also gave them a line width of 5, as you can notice here, to make the lines a bit thicker in the legend. Now we can easily see that we are spending our day sleeping, eating, working, and playing. So this is how the code works. Now let me execute that practically in my PyCharm. So I've copied the code already just to save time again. Now this is our code. Over here I've already explained to you why are we defining these empty lines, just to add labels. Now Let us go ahead and execute this and see what happens. So this is our graph, guys, and again we have legends, title to our graph, and Y label as well as X label. So we'll move forward and look at various other plots. This is called a pie plot. So let me tell you about pie charts a bit. So pie charts are pretty much similar to stack plots, only they are for a certain point in time. Typically a pie chart is used to show parts to the whole and often a percentage share. You can consider the example of percentage of market share and things like that, right? Now let me tell you guys, Matplotlib handles the sizes of the slices and everything. So all we need to do is just feed it the numbers. That's what we have done here. So let me explain you the code here. So over here we use plt.pie to plot a pie chart. We have slices. We have specified slices. Now slices, which are nothing but the relevant sizes for each part. Then we specify the labels and then the color list for the corresponding slices. Next, we can optionally specify the start angle for the graph. This lets you start the line where you want. In our case, we chose a 90-degree angle for the pie chart, which means the first division will be a vertical line. Next, we can optionally add a shadow as well. And after that, we can even use explode to pull out a slice a bit. So we have explode that says 0, 0.1, 0, 0. So because of that, you can see that eating has been pulled out a bit. Now basically we have 4 total slices. So with explode, if we didn't want to pull out any slice at all, we would have just written here 0, 0, 0, 0. Now if we want to pull out the first slice a bit, we would do 0.1, 0, 0, 0. And if we want to pull out the second slice a bit, what we can do is 0, 0.1, 0, 0, like in our case. Now finally we do an auto pact. Now this auto pact overlay the percentages on the graph itself. So you can see that we have 8.3, 29.2%, 54.2%, all those things written on the graph itself. And then finally add a title and then show it. Now let me execute this practically, guys. Now just to save time, I've already written the code. So I'm just going to go ahead and execute this and we'll see if it comes or not. Yep, here is our pie chart. So we have seen multiple types of plots. We have seen pie plot, bar plot, histograms, area plot. Now what we need to understand is how to handle multiple plots. So at that time, what will you do? Let me open my slides again and we'll move forward with that. So this slide actually tells you how to deal with multiple plots. Now you can notice in the figure as well, we have 2 plots available. Now let me help you out with the code that is there in front of your screen. So in the beginning, we are importing a couple of modules. One is matplotlib.pyplot, which you are already familiar with. After that, there is a NumPy module as well. So we have covered NumPy modules in the previous sessions. If you have any doubts, you can go through it. Now after that, you might find this part confusing if you're not familiar with NumPy. Now let me just tell you what it does. It will create a NumPy array that will have elements between 0 till 5 in the steps of 0.1. Now similarly, T2 will also be a NumPy array that will have elements ranging from 0 till 5 and in the steps of 0.02. Now after that, the code is pretty much similar to the previous examples that we have seen. But there is one new concept that is called subplot. Now let me tell you what this subplot does. It helps us to plot multiple plots, alright? So when we write subplot 211, this means that we have 2 plots. Horizontally, we have only 1 plot present and vertically we have 2 plots. And in that vertical position, this plot will be our first graph. Now you can notice that we have one more subplot that is 212. So vertically we have 2 plots, horizontally we have 1, and this is the second plot. So what I'll do, I'll open my PyCharm and I'll play around with it a bit so that you'll be able to understand it better. So now this is the code, guys. First I'll go ahead and execute this and we'll see the result. So we have a graph, something which is like this, right? We have 2 plots which are aligned vertically. Now what I'm going to do is I'm going to just minimize this and I'm going to change the subplot value so that you'll be able to understand better how we are dealing with multiple plots. Now over here, if I make this as 2 and this one as well as 2, so let us see what we get. So we have got the same graph, but it is aligned horizontally, if you can notice. This is our another graph and this is our first graph. So you can notice the difference between both of these graphs, right? So this is why we use subplots.
Introduction to Data Science and ML. So when I started my research on data science and ML, there was always this question that bothered me the most, right? It was what led to the buzz around machine learning and data science. Now this buzz has a lot to do with the amount of data that we are generating. So data is the fuel that is needed to drive machine learning models, and since we are in the era of big data, it is clear why data science is considered the most important and the most promising job role of the era. I would say that data science and ML are skills, and they are not just any technologies. They are the skills that are needed to derive useful insights from data and to solve problems by building predictive models. Formally speaking, this is how data science and machine learning is defined. Data science is the process of extracting useful information from data in order to solve real-world complex problems. Machine learning, on the other hand, is the process of making a machine learn how to solve problems by feeding it lots of data. Now, these two domains are heavily interconnected. So, machine learning is basically a part of data science that uses machine learning algorithms and other statistical techniques to understand how data is affecting and growing a business. So, this is a small description of data science and ML. If you want to learn more about these technologies, I'll leave a couple of links in the description box. You can go through those links. Now, let's understand where Python libraries fit into data science and ML. Now, the first question is why you should use Python for AI or machine learning or data science. Now, Python is ranked at #1 for the most popular programming language used to implement machine learning and data science. Let's understand why so many data scientists and machine learning engineers prefer Python over any other programming language. Now, the first and the foremost reason is that it's ease of learning. Python uses a very simple syntax that can be used to implement simple computations like the addition of two strings to complex processes such as building complex machine learning models. Another reason is less code. Now, implementing data science and machine learning involves tons and tons of algorithms. Thanks to Python's support for predefined packages and libraries, we don't have to code algorithms. And to make things easier, Python provides this functionality called check as you code that reduces the burden of testing the code. Now, the main reason behind Python for data science and ML is the pre-built libraries provided by Python. So it has hundreds of pre-built libraries to implement various machine learning and deep learning algorithms. So every time you want to run an algorithm on a data set, all you have to do is install and load the necessary packages with a single command. Examples of pre-built libraries include NumPy, Keras, TensorFlow, PyTorch, and so on. We'll be discussing all these libraries in the upcoming slides. Another reason is platform independent. So Python can basically run on multiple platforms, including Windows, Mac operating systems, Linux, Unix, and so on. So while transferring code from one platform to the other, you can make use of packages like PyInstaller that will take care of any dependency issues. So another major reason is platform independence. Another reason is massive community support. So apart from a huge fan following, I think Python has multiple communities. It has a lot of groups and forums where programmers post their errors and they help each other out. Right? So the community is very vast. And if you have any doubts or if you're facing any problems with your code, then there are a lot of people out there who can help you with this problem. Now that you know why Python is considered to be one of the best programming languages for data science and ML, let's understand the different Python libraries for data science and machine learning. Now, the single most important reason for the popularity of Python in the field of data science, ML, or AI is the fact that Python provides thousands of inbuilt libraries that have inbuilt functions and methods to easily carry out data analysis, data processing, wrangling, modeling, and so on. Now, in the upcoming slides, we'll discuss the data science and machine learning libraries for each of the tasks. Right? So first, we'll start with Python libraries that are specifically for statistical analysis. Like most of you might know that statistics is one of the most basic fundamentals of data science and ML. So all machine learning and all the deep learning algorithms or the techniques are built on basic principles and concepts of statistics. Before moving any further, if you all want to know more about statistics and probability, I'll leave a couple of links in the description. You can go through those links and study a little bit more about statistics. Now, Python comes with tons of libraries for the sole purpose of statistical analysis. So now we'll be focusing on the top statistical packages that provide inbuilt functions to perform the most complex statistical computations. Right, we'll be covering 4 libraries specifically for statistical analysis, which is NumPy, SciPy, Pandas, and stats models. Right, so starting with NumPy. NumPy, also known as numerical Python, is one of the most commonly used and one of the most basic Python libraries. The main feature of this library is its support for multi-dimensional arrays for mathematical and any sort of logical operations that you want to perform. So functions provided by NumPy can be used for indexing, they can be used for sorting, reshaping, and conveying images and sound waves as an array of real numbers in multi-dimension. Now, some of the important features of Python include that it helps you perform simple to complex mathematical and scientific computations. It has strong support for multi-dimensional array objects and a collection of functions and a collection of methods to process these array elements. Apart from that, Fourier transformations and routines for data manipulation is also taken care by NumPy. So if you want to perform linear algebra computations, which are necessary for machine learning algorithms like linear regression, logistic regression, naive Bayes, and so on, then NumPy is the perfect library. It's the most basic mathematical computation library in Python. So this is a must know if you want to get started with ML and data science. Right, you'll see that in every code or in every project that involves data science ML, there is the use of NumPy. This is the most basic library. Moving on to our next library, which is SciPy. Now, SciPy is built on top of NumPy. This library is a collective of sub-packages which help in solving the most basic problems which are related to statistical analysis. Now, this library is used to process the array of elements defined using the NumPy library. So it is often used to compute mathematical equations that cannot be done by using NumPy. So to make things more clear, let's look at a couple of features of SciPy. The first feature is that it works along with NumPy arrays to provide a platform that helps in numerous mathematical methods like numerical integration and optimization. Right? Another important feature is that it has a collection of sub-packages that can be used for vector quantization, Fourier transformations, integration, interpolation, and so on. It also provides a full-fledged stack of linear algebra functions, which are used for more advanced computations such as for clustering, right? It can be used in the K-means algorithm and so on. Also, it provides support for signal processing, data structures, and numerical algorithms, and it also helps in creating sparse matrices. Right, so guys, these things are very important when it comes to ML and data science because these are the fundamental and the most basic parts of ML. The algebra, the math behind ML is the most basic and it's also the most important part, I'd say, of ML. If you want to know how a machine learning algorithm works or the math or the why behind the machine learning algorithm, it is all about statistics, right? It's all about linear algebra, the basic math that is involved in these algorithms. Right? And thanks to these libraries, you can easily implement all of this. Moving on, we have the Pandas library. Now, I would say that this is one of the must-know libraries, right? It is another important statistical library, which is mainly used in a wide range of fields, including statistics. It's used in finance, it is used in economics, data analysis, and all of that. Now, just like SciPy, Pandas also depends on the NumPy array for the purpose of processing Pandas data objects. So generally speaking, NumPy, Pandas, and SciPy are heavily dependent on each other for performing scientific computations, for performing any sort of data manipulation. Now, the question is, I'm often asked to choose the best among Pandas or among NumPy and SciPy. Now, what I'd say is I prefer using all of them because they are heavily dependent on each other, right? So Pandas is one of the best libraries for processing huge chunks of data, whereas NumPy has excellent support for multi-dimensional arrays, and SciPy, on the other hand, provides a set of sub-packages that perform a majority of the statistical analysis tasks. So combined, these three packages are very effective. So let's focus a little more on Pandas. Let me tell you a couple of features. The first feature is that it creates fast and effective data frame objects with predefined and customized indexing. Right? So data frame objects are easily created through Pandas. All you have to do is you have to import the library and use it. Another feature is that it can be used to manipulate large data sets and perform subsetting or perform data slicing, indexing, and all of that. It also provides inbuilt features for creating Excel charts and performing any sort of complex data analysis tasks such as descriptive statistical analysis data wrangling, transformation, manipulation, visualization, and so on. It provides support for manipulating time series data as well. So Pandas is one of the must-know libraries when it comes to statistical analysis, or when it even comes to the entire ML workflow. The next library I'm going to discuss is stats models. Now, this library is built on top of NumPy and SciPy. The package is best known for creating statistical models for data handling and for model evaluation. So along with using NumPy arrays and scientific models from SciPy library, it also integrates with Pandas for effective data handling. Stats models is famously known for statistical computations, for any sort of statistical testing and data exploration. Right, to list a couple of features, the first feature is that it is the best known library to perform statistical tests and hypothesis testing, which are not found in NumPy or in the SciPy libraries. It also provides the implementation of R-style formulas for better statistical analysis. So you can assume that it is more affiliated to the R language, which is often used by statisticians. Right? For those of you who don't know R, it is one of the best languages for statistical analysis. Right? It's mainly used for statistical analysis. Apart from that, you can also use the stats model to implement generalized linear models and ordinary least square linear regression models because of its vast support for statistical computation. So guys, generalized linear models, all of these include linear regression, logistic regression, and all of that. Now, using stats models, you can perform statistical testing, you can perform hypothesis testing, null theory, and all of that. So these are a couple of features of stats models. So guys, so far we discussed the most commonly used and the most effective Python libraries for statistical analysis. Now let's get into the data visualization part in data science and ML. So we've all heard of that saying that a picture speaks more than 1,000 words. However, it holds very true for data science and ML. So a lot of reputed data scientists and machine learning engineers know the power of data visualization. Right? That's why Python provides tons of libraries for the sole purpose of visualization. So guys, data visualization is all about expressing the key insights from data effectively through graphical representations. Right? It includes the use of graphs, charts, mind maps, heat maps, histograms, density plots, and so on to study the correlations between the various data features. Under data visualization, I'm going to cover 4 Python libraries, which is Matplotlib, Seaborn, Plotly, and Bokeh. Right? These are the 4 commonly used and I would say the most effective libraries for data visualization. So let's understand the Matplotlib library. Now, this is one of the most famous library for data visualization in Python. Right? It is the most basic data visualization package. It provides support for a wide variety of graphs, like you can plot histograms, you can plot bar charts, power spectra, error charts, and all of that. So it is basically a 2D graphical library which produces very clear and you can say very concise graphs that are very important for exploratory data analysis. So coming to a list of features of Matplotlib, it makes it very easy to plot graphs by providing functions to choose appropriate line styles. You can choose the different font styles. You can change your axes. You can format all the axes and all of that. Now, the graphs that you create using this library will help you get a very clear understanding of the trends, the patterns, and all the correlations in your data. They're basically instruments for reasoning about quantitative information. So the graphs that you create using this library help you get a very clear understanding of the different trends or a series of patterns or any sort of correlations in your data. Apart from that, it also contains the PyPlot module that provides a basic interface which is very similar to MATLAB user interface. So those of you who are aware of MATLAB, this library provides a module called PyPlot, which is very similar to the MATLAB UI. Right? This is one of the best features of the Matplot library. Also, it provides a object-oriented API module that will help you integrate your graphs into a lot of applications or a lot of tools, including WX, Python, Qt, and so on. So guys, personally, I feel like Matplotlib is the most used library when it comes to visualization. Majority of the projects that I've done on data science, I've used Matplotlib for plotting basic graphs, for plotting scattered plots and all of that. Moving on, let's discuss the Seaborn library. Now, the Matplotlib library forms the base of the 𝐶born library. Now, in comparison to Matplotlib, 𝐶born can be used to create more appealing and you can say that they're used to create more descriptive statistical graphs. So along with a lot of support for data visualization, 𝐶born also comes with an inbuilt data science API for studying the relationship between multiple variables. Let's discuss a few features of the 𝐶born library. First of all, it provides options for analyzing and for visualizing univariate and bivariate data points, and it is also useful for comparing the data with other subsets of data. So it has support for a lot of data formats. It also has support for automated statistical estimation and graphical representation of linear regression models for different kinds of target variables, right? Whether it is a continuous target variable or whether it is a categorical variable. It also builds complex visualizations for structuring multi-plot grids by using functions that perform high-level abstraction. Right? So you can say that it can build complex visualizations with n number of variables. It also comes with built-in themes for styling and for creating Matplotlib graphs. Right, so it's fully integrated with Matplotlib. It can build beautiful graphs with different themes. Right, so 𝐶born is again one of the most important libraries when it comes to data visualization. Moving on, we'll discuss the Plotly library. Now, Plotly is one of the well-known graphical Python libraries. Right, it provides interactive graphs for understanding the dependencies between your target variable and between your predictor variable. Apart from statistical analysis, it can also be used to visualize financial, commerce, and scientific data to produce clear and very crisp graphs and subplots. You can also plot a lot of heat maps. 3D charts are also supported by Plotly. Now let's discuss a few features of Plotly. The first feature is that it comes with more than 30 chart types, which includes all the 3D charts. So if you want to draw three-dimensional charts, Plotly provides support for that. It also provides support for scientific and statistical graphs, for SVG maps, and so on. Right? So it performs a very good sort of visualization because it provides a varied set of chart types that you can plot. Now with this library, you can also create public or private dashboards using the API, and it'll basically contain a lot of plots, a lot of graphs, texts, and web images. Right? So you can create your own dashboard by using this library. Now, whatever visualization that you create using this library, they're stored in the JSON format. Now, because of this, you can easily access these visualizations on different platforms, like for example, on R, on MATLAB, and even on Julia. Then it also comes with an inbuilt API called the Plotly Grid, which allows you to directly import data into the Plotly environment. So everything is imported. All you have to do is write a couple of lines of code and visualize your variables to understand which variable is important. Next, we have another library called Bokeh. This is one of the most interactive libraries, I would say. Right? It is used to build descriptive graphical representations mainly for web browsers. It can easily process humongous and very huge data sets. Right? It provides the most well-defined functionality to build interactive plots, to build dashboards, and to build any sort of data applications. Right? So Bokeh is known for its interactivity. And to list a few features, is the first feature is that it helps you create complex statistical graphs quickly with the use of simple commands. This library is quite simple actually. All you have to do is write a couple of lines of code and you can import whatever you want, create whatever visualizations you want. Now this is true actually for all the libraries in Python. All you have to do is import the library and then just code a couple of lines and perform all sort of data analysis, data visualization, statistical analysis, and all of that. It supports a varied format of output. For example, in the form of HTML or notebook or even on the server, it supports all these outputs. It also provides support for multiple language bindings, which include R, obviously, and there's Python, and there's Julia, and so on. Another feature is that Flask and Django are easily integrated with Bokeh, so you can express visualizations on these apps as well. It also provides support to transform visualizations which are written in other libraries like Matplotlib, 𝐶born, ggplot, and so on. So guys, these were the most useful Python libraries for data visualization. Now let's discuss the top Python libraries for implementing the whole machine learning process. So creating machine learning models that can accurately predict the outcome or that can solve a certain problem is the most important part of any data science project, right? I'm sure we can all agree on that. ML and EDA, all of that is a very important part of data science. So implementing machine learning, deep learning, and all of that, it involves writing thousands of lines of code. And this can become very tiresome when you want to create models that can solve complex problems. So there's a lot of coding that goes into ML and data science. But thankfully, we don't have to code any algorithms because Python comes with several packages just for the purpose of implementing machine learning techniques and algorithms. So I'll be discussing three of the most important Python libraries. I'll discuss the scikit-learn, the XGBoost library, and ELI5. Now, I'm sure all of you have heard of these three libraries. These are the most important, I would say the most effective Python libraries for machine learning. Right, so let's move ahead and look at scikit-learn first. I'd say that easily scikit-learn is one of the most famous libraries in Python. It is the best library for data modeling and model evaluation. It comes with tons and tons of functions only for the purpose of creating a model. It contains all the supervised and the unsupervised machine learning algorithms. And it also comes with good functions and well-defined functions for ensemble learning and boosting machine learning. So let's discuss a few features about scikit-learn. First feature is that it provides a set of standard data sets to help you get started with machine learning. For example, I'm sure a lot of you have heard of the IRIS dataset, right? IRIS dataset or the Boston House Prizes dataset. All of these are a part of the scikit-learn library. Now, another feature is that it has inbuilt functions to carry out both supervised and unsupervised learning. Right, so basically this includes clustering, classification, regression, anomaly detection, data mining, and all of that. It also comes with functions for feature extraction and feature selection, which help in identifying significant attributes or the significant features and variables in your data. It also comes with functions for cross-validation so that you can estimate the performance of the model. And it also comes with parameter tuning in order to improve your model performance. Right, so it takes care of the entire process end to end. I feel like scikit-learn is one of the best libraries for machine learning. Now let's move on and discuss another library, which is XGBoost. Now XGBoost basically stands for Extreme Gradient Boosting. Right? It is one of the best Python packages for performing boosting machine learning. Now XGBoost is also an algorithm, right? This library is named after that algorithm. Now, libraries like LightGBM and CatBoost are equally equipped with such functions and methods. So when I'm talking about XGBoost, you can also relate these features to LightGBM and CatBoost. These two libraries are also really good for machine learning. Now let's discuss a few features of XGBoost. So this library was actually written in C++ and it is considered to be one of the most fastest and the most effective libraries to improve the performance of a machine learning model. The core XGBoost algorithm is parallelizable and it can use the power of multi-core computers. Right, this makes the library strong enough to process very huge data sets and to work across a network of data sets. It also provides internal parameters for performing cross-validation, for performing parameter tuning, regularization, handling missing values, and also it provides scikit-learn compatible API for this. Apart from building such effective and such precise models, this library is very oftenly used in data science hackathons or in data science competitions because it's known for creating models which are more precise and which have a very quick response time. Right? So it quickly builds algorithms and it makes sure that these algorithms are more precise and give out a more better output. Right? That's what boosting machine learning is all about. It's all about improving the performance of a model. Right, so that can be easily done through XGBoost library. Now let's move on and discuss the next library, which is ELI5. Now this library is another Python package which is mainly focused on improving the performance of a model. And now this library is relatively new and it is usually used along with XGBoost, LightGBM, and CatBoost. Basically, what it does is it boosts the accuracy of your machine learning models. And now some features of ELI5 include that it provides full integration with scikit-learn package in order to express feature importance and in order to explain predictions of decision trees and tree-based ensembles. So it's mainly used in ensemble models. It also helps in explaining the prediction that is made by XGB classifier, regressor, LGBM classifier, LGBM regressor, catboot classifier, regressor, and so on. Right? So it majorly supports all these three libraries. It also lets you create several algorithms and implement a lot of algorithms in order to inspect black box models. Now, these black box models basically include text explainer models that allow you to explain predictions made by any text classifier. So it also has a good support for text classification. Not only this, it helps in analyzing weights and predictions of the scikit-learn general linear models. Right? This basically includes your linear regression and your classifiers. So these were a couple of libraries for machine learning. Now let's move on and look at the Python libraries for deep learning. So the biggest advancements in machine learning and data science is been through deep learning. So with the introduction of deep learning, it is finally possible to build complex models and process humongous data sets which have like hundreds of variables in them. Right? So thankfully, Python provides the best deep learning packages that help in building effective neural networks. Right? In this session, we'll be focusing on the top deep learning packages, which includes TensorFlow, PyTorch, and Keras. Right? These are the three libraries that I'll be covering for deep learning itself. Coming to TensorFlow, I'm sure all of you have heard of TensorFlow. It's one of the best libraries for deep learning. Now, basically, TensorFlow is a math library that is used for building strong and very precise neural networks. So let's discuss a couple of features of TensorFlow. Now, TensorFlow allows you to build and train multiple neural networks which help to accommodate large-scale projects and data sets. Right? So you can have massive data sets run on this library. Along with its support for neural network, it also provides functions and methods that perform basic statistical analysis. For example, it comes with a lot of inbuilt functions for creating probabilistic models and Bayesian networks such as Bernoulli, Chai2, Uniform, Gamma, and so on. It also provides layered components that perform layered operations on weights and biases, and it also improves the performance of the model by using all the regularization techniques such as batch normalization, dropout technique, and so on. So guys, these dropout and regularization techniques all come under deep learning. Right? These are a few of the ways in which you can improve the performance of your neural network. TensorFlow really helps in that sort of thing. It helps in increasing the performance of your model. It helps in making the model a little more robust so that your predictions are as accurate as possible. Apart from this, TensorFlow also comes with a visualizer, which is called the tensor board, and it helps in creating interactive graphs and visuals to understand any dependencies in your dataset. Now let's move on and discuss Keras. Now, Keras provides full support for creating, analyzing, evaluating, and improving your neural networks. Right? It is built on top of Theano and TensorFlow Python libraries, which provide additional features to build complex and large-scale deep learning models. So Theano is another Python package for deep learning itself. That is also a really good package. I won't be discussing that here, but you all can check out that package as well. So some of the features of Keras is that it provides support for building all type of neural networks. So whether you want to create fully connected or you want to create convolutional neural networks or recurrent neural networks, all of this can be done using Keras. And also for large data sets and for complex problems, all these neural networks can be further combined to create a more advanced neural network. Another feature is that it has inbuilt functions to perform neural network computations, such as, you can define layers, objectives, activation functions, optimizers, and a host of tools to make working with image and text data very easy. So it has a lot of support for image data and text data as well. Then again, it comes with several pre-processed datasets and trained models, including MNIST, which is one of the most popular datasets for deep learning. You open up Google and look for practical demos on deep learning, there's a 100% guarantee that you're going to get MNIST. Right? MNIST is one of the most simplest and one of the most basic deep learning data sets, I would say. Also, it is very easily extensible and it provides support to add new modules which include functions and methods for a more in-depth deep learning process. So that was about Keras. Now let's move on and look at PyTorch. PyTorch is again an open source Python-based scientific computing package that is mainly used to implement deep learning techniques and neural networks on large data sets. This library is actually currently used by Facebook to develop neural networks that help in a lot of tasks such as face recognition and auto tagging. Right? So if you go on Facebook and you start typing somebody's name and you can immediately find their name in the suggested list so that you can tag them in some images, all of this is done through deep learning. And right now, Facebook is making use of PyTorch to do this. So PyTorch is actually one of the best libraries for deep learning. And let me discuss a few features of PyTorch. The first feature is that it provides easy to use APIs that will help you integrate with other data science and ML frameworks. Apart from that, like NumPy, PyTorch also provides multi-dimensional arrays called tensors that, unlike NumPy, can even be used on a GPU, right? So it has support to work on a GPU as well. Not only can it be used to model large-scale neural networks, it also provides an interface which has more than 200 plus mathematical operations for statistical analysis. Right, so PyTorch is also used for statistical analysis. One important feature is that it creates dynamic computation graphs that will build up dynamic graphs at every point of code execution. So let's say you're executing a time series code and you need graphs on real-time basis. And for that, you can use PyTorch because it creates dynamic computation graphs. So these were a couple of libraries specifically for deep learning. Now let's move on and look at our last module, which is Python libraries for natural language processing. So guys, have you ever wondered how Google so precisely predicts what you're searching for? The technology behind all of these Alexa or behind Siri and other chatbots is natural language processing. So NLP has played a very huge role in designing AI-based systems that help in describing the interaction between human language and computers. So in this session, we'll be focusing on the three top libraries for NLP, which is NLTK, Spacy, and Genism. So let's get started with NLTK. So NLTK basically stands for Natural Language Toolkit, right? It is considered to be the best Python package for analyzing human language and behavior. Now, this language is preferred by most of the data scientists and it provides easy to use interface. If I'm not wrong, it contains over 50 corpora and lexical resources that help in describing human interactions, and it'll also help you in creating AI-based systems such as recommendation engines, right? It plays a huge role. Basically, NLP plays a very huge role in recommendation engines. And when you're implementing NLP, I think the first library that comes into my head is Natural Language Toolkit. And this is the best library, I would say, for natural language processing. However, recently they've also introduced a lot of chatbot libraries. I think there is a library which is specifically for chatbots itself. It has everything built in. All you have to do is run your data and all of that. There are a lot of advancements in the field of NLP when it comes to the Python packages that are there. So focusing more about NLP and NLTK, let me tell you a few features of NLTK library. So the first one is that it provides a huge set of data and text processing methods for classification, for tokenization, stemming, tagging, parsing, and semantic reasoning. Right? So text analysis is very strong using NLTK. It contains wrappers for industrial strength NLP libraries to build very complex systems that help in text classification and in finding behavioral trends and patterns in human speech. Along with that, my most favorite features of the NLTK library is that it comes with a very detailed guide that describes the implementation of all your computational linguistics, and it has a complete API documentation that helps all the newbies to get started with NLP. Right? It has huge amount of resources on NLP. So that is one of the major reasons why this library is very famous and it is preferred by a lot of beginners as well as a lot of data scientists. So speaking about its community, it has a very massive community of users and professionals. And also these users provide comprehensive tutorials and quick guides to learn the entire process of NLP and how it can be implemented through this library. So guys, that was about NLTK. Now let's move on and discuss the Spacie library. Now Spacie again is a free open source Python library for implementing advanced natural language processing. Right. So when you're working with a lot of text, it is very important that you understand the morphological meaning of the text. Right. You understand the grammar or the meaning behind the text. How you can use this to classify and understand human language. These tasks can be easily achieved using Spacie. So some of the features of this library include that along with linguistic computation, Spacie provides separate modules to build and to train and test statistical models that will better help you understand the meaning of a word. So it understands the numbers or the quantitative reasoning behind each word. It also comes with built-in function and methods for grammatical structuring and for understanding the grammar behind a sentence. Now, this will not only help in understanding the text, it'll also help in finding the relations between the different words in a text or in a sentence. It can be used to apply tokenization on complex and nested tokens that contain a lot of abbreviations or that contain, let's say, punctuation marks. And so it can be used to apply tokenization on such complex sentences. So along with being extremely robust and fast, Spacie also provides support for around 51 plus languages, right? Which is a really good thing, I would say. So again, Spacie comes with a lot of methods and tools that will help you in lemmatization, that will help you in parsing, that will help you in tokenization, and breaking down your sentences and studying each word one by one. Right? So Spacie again is a very easy to use and a very important library for NLP. Coming to the last library, 𝐤𝐻𝐿 is an open source Python package which is mainly used to extract all the semantic topics from your large documents, right? It basically helps you in processing, analyzing, and predicting human behavior through a statistical models and all of that. Now let's look at a few features of 𝐤𝐻𝐿. First feature is that it can be used to build models that help in classifying documents by understanding the statistical semantic of each word. Right, so considering importance of each and every word and the significance of each word in a sentence, it helps you understand how you can classify different documents. It comes with text processing algorithms like word-to-vec, fast text, latent semantic analysis, and so on. And these help in studying the statistical co-occurrence patterns in a document. Not only can you understand the significant words, you can also filter out any unnecessary word and you can build a model with just the significant features. Another feature is that it provides input-output wrappers and readers which can import and support a very huge range of data formats. So it can easily access a lot of different data formats. And along with this, it comes with a very simple and I'd say a very easy to use interface that can be easily used by any beginner. So if you're a beginner, this tool is very easy to use. Right? The API learning curve is also quite low, which explains why a lot of developers like this library. So guys, those were a list of libraries which can be used for natural language processing.
As you know, we are living in a world of humans and machines. The humans have been evolving and learning from the past experience since millions of years. On the other hand, the era of machines and robots have just begun. In today's world, these machines or the robots are like they need to be programmed before they actually follow your instructions. But what if the machines started to learn on their own? And this is where machine learning comes into picture. Machine learning is the core of many futuristic technological advancement in our world. Today you can see various examples or implementation of machine learning around us, such as Tesla's self-driving car, Apple Siri, Sophia AI robot, and many more are there. So what exactly is machine learning? Well, machine learning is a subfield of artificial intelligence that focuses on the design of systems that can learn from and make decisions and predictions based on the experience, which is data in the case of machines. Machine learning enables computer to act and make data-driven decisions rather than being explicitly programmed to carry out a certain task. These programs are designed to learn and improve over time when exposed to new data. Let's move on and discuss one of the biggest confusion of the people in the world. They think that all the three of them, the AI, the machine learning, and the deep learning, all are same. You know what? They are wrong. Let me clarify things for you. Artificial intelligence is a broader concept of machines being able to carry out tasks in a smarter way. It covers anything which enables the computer to behave like humans. Think of a famous Turing test to determine whether a computer is capable of thinking like a human being or not. If you're talking to Siri on your phone and you get an answer, you're already very close to it. So this was about the artificial intelligence. Now coming to the machine learning part. So as I already said, machine learning is a subset or a current application of AI. It is based on the idea that we should be able to give machine the access to data and let them learn from themselves. It's a subset of artificial intelligence that deals with the extraction of pattern from dataset. This means that the machine can not only find the rules for optimal behavior, but also can adapt to the changes in the world. Many of the algorithms involved have been known for decades, centuries even. Thanks to the advances in the computer science and parallel computing, they can now scale up to massive data volumes. So this was about the machine learning part. Now coming over to deep learning. Deep learning is a subset of machine learning where similar machine learning algorithms are used to train deep neural networks so as to achieve better accuracy in those cases where former was not performing up to the mark. Right. I hope now you understood that machine learning, AI, and deep learning, all three are different. Okay, moving on ahead. Let's see, in general, how a machine learning works. One of the approaches is where the machine learning algorithm is trained using a labeled or unlabeled training dataset to produce a model. New input data is introduced to the machine learning algorithm and it makes prediction based on the model. The prediction is evaluated for accuracy, and if the accuracy is acceptable, the machine learning algorithm is deployed. Now, if the accuracy is not acceptable, the machine learning algorithm is trained again and again with an augmented training dataset. This was just a high-level example, as there are many more factors and other steps involved in it. Now let's move on and subcategorize the machine learning into three different types: the supervised learning, unsupervised learning, and reinforcement learning. And let's see what each of them are, how they work, and how each of them is used in the field of banking, healthcare, retail, and other domains. Don't worry, I'll make sure that I use enough examples and implementation of all three of them to give you a proper understanding of it. So starting with supervised learning. What is it? So let's see a mathematical definition of supervised learning. Supervised learning is where you have input variables x and an output variable y. And you use an algorithm to learn the mapping function from the input to the output. That is y equal fx. The goal is to approximate the mapping function so well that whenever you have a new input data x, you could predict the output variable that is y for that data. Right. I think this was confusing for you. Let me simplify the definition of supervised learning. So we can rephrase the understanding of the mathematical definition as a machine learning method where each instances of a training dataset is composed of different input attribute and an expected output. The input attributes of a training dataset can be of any kind of data. It can be a pixel of image, it can be a value of a database row, or it can even be an audio frequency histogram, right? For each input instance, an expected output value is associated. The value can be discrete, representing a category, or can be a real or continuous value. In either case, the algorithm learns the input pattern that generates the expected output. Now, once the algorithm is trained, it can be used to predict the correct output of a never seen input. You can see an image on your screen, right? In this image, you can see that we are feeding raw inputs as image of apple to the algorithm. As a part of the algorithm, we have a supervisor who keeps on correcting the machine or who keeps on training the machine. It keeps on telling him that, yes, it is an apple. And no, it is not an apple. Things like that. So this process keeps on repeating until we get a final trained model. Once the model is ready, it can easily predict the correct output of a never seen input. In this slide, you can see that we are giving an image of a green apple to the machine, and the machine can easily identify it as yes, it is an apple and it is giving the correct result, right? Let me make things more clearer to you. Let's discuss another example of it. So in this slide, the image shows an example of a supervised learning process used to produce a model which is capable of recognizing the ducks in the image. The training dataset is composed of labeled picture of ducks and non-ducks. The result of supervised learning process is a predictive model which is capable of associating a label duck or not duck to the new image presented to the model. Now once trained, the resulting predictive model can be deployed to the production environment. You can say a mobile app, for example. Once deployed, it is ready to recognize the new pictures. Right. Now you might be wondering why this category of machine learning is named as supervised learning. Well, it is called as supervised learning because the process of an algorithm learning from the training dataset can be thought of as a teacher supervising the learning process. We know the correct answers. The algorithm iteratively makes while predicting on the training data and is corrected by the teacher. The learning stops when the algorithm achieves an acceptable level of performance. Now let's move on and see some of the popular supervised learning algorithms. So we have linear regression, random forest, and support vector machines. These are just for your information. We'll discuss about these algorithms in our next video. Now let's see some of the popular use cases of supervised learning. So we have Cortana. Cortana or any other speech automation in your mobile phone trains using your voice. And once trained, it starts working based on that training. This is an application of supervised learning. Suppose you are telling, okay Google, call Sam, or you say, hey Siri, call Sam. You get an answer to it and the action is performed and automatically a call goes to Sam. So these are just an example of supervised learning. Next comes the weather app. Based on some of the prior knowledge, like when it is sunny, the temperature is higher. When it is cloudy, humidity is higher. Any kind of that, they predict the parameters for a given time. So this is also an example of supervised learning, as you are feeding the data to the machine and telling that whenever it is sunny, the temperature should be higher. Whenever it is cloudy, the humidity should be higher. So it's an example of supervised learning. Another example is biometric attendance, where you train the machine and after a couple of inputs of your biometric identity, be it your thumb, your iris, or your earlobe or anything, once trained, the machine can validate your future input and can identify you. Next comes in the field of banking sector. In banking sector, supervised learning is used to predict the credit worthiness of a credit card holder by building a machine learning model to look for faulty attributes by providing it with a data on delinquent and non-delinquent customers. Next comes the healthcare sector. In the healthcare sector, it is used to predict the patient's readmission rates by building a regression model by providing data on the patient's treatment administration and readmissions to show variables that best correlate with readmission. Next comes the retail sector. In retail sector, it is used to analyze the product that a customer buy together. It does this by building a supervised model to identify frequent item sets and association rule from the transactional data. Now let's learn about the next category of machine learning, the unsupervised part. Mathematically, unsupervised learning is where you only have input data X and no corresponding output variable. The goal for unsupervised learning is to model the underlying structure or distribution in the data in order to learn more about the data. So let me rephrase you this in simple terms. In unsupervised learning approach, the data instances of a training dataset do not have an expected output associated to them. Instead, unsupervised learning algorithm detects pattern based on innate characteristics of the input data. An example of machine learning task that applies unsupervised learning is clustering. In this task, similar data instances are grouped together in order to identify clusters of data. In this slide, you can see that initially we have different varieties of fruits as input. Now these set of fruits as input X are given to the model. Now once the model is trained using unsupervised learning algorithm, the model will create clusters on the basis of its training. It will group the similar fruits and make their cluster. Let me make things more clearer to you. Let's take another example of it. So in this slide, the image below shows an example of unsupervised learning process. This algorithm processes an unlabeled training dataset, and based on the characteristics, it groups the picture into 3 different clusters of data. Despite the ability of grouping similar data into clusters, the algorithm is not capable to add labels to the group. The algorithm only knows which data instances are similar, but it cannot identify the meaning of this group. So now you might be wondering why this category of machine learning is named as unsupervised learning. So these are called as unsupervised learning because unlike supervised learning, above there are no correct answers and there is no teacher. Algorithms are left on their own to discover and present the interesting structure in the data. Let's move on and see some of the popular unsupervised learning algorithm. So we have here K-means, Apriori algorithm, and hierarchical clustering. Again, these are just for your information's sake. We'll discuss about these algorithms in our next video. Now let's move on and see some of the examples of unsupervised learning. Suppose a friend invites you to his party and where you meet totally strangers. Now you'll classify them using unsupervised learning as you don't have any prior knowledge about them. And this classification can be done on the basis of gender, age group, dressing, educational qualification, or whatever way you might like. Now, why this learning is different from supervised learning? Since you didn't use any past or prior knowledge about the people, you kept on classifying them on the go. As they kept on coming, you kept on classifying them. Yeah, this category of people belong to this group, this category of people belong to that group, and so on. Okay, let's see one more example. Let's suppose you have never seen a football match before, and by chance you watch a video on the internet. Now you can easily classify the players on the basis of different criterion, like player wearing the same kind of jersey are in one class, player wearing a different kind of jersey are in different class. Or you can classify them on the basis of their playing style, like the guy is an attacker, so he's in one class, he's a defender, he's in another class. Or you can classify them whatever way you observe the things. So this was also an example of unsupervised learning. Let's move on and see how unsupervised learning is used in the sectors of banking, healthcare, and retail. So starting with banking sector. So in banking sector, it is used to segment customers by behavioral characteristic by surveying prospects and customers to develop multiple segments using clustering. In healthcare sector, it is used to categorize the MRI data by normal or abnormal images. It uses deep learning techniques to build a model that learns from different features of images to recognize a different pattern. Next is the retail sector. In retail sector, it is used to recommend the products to customer based on their past purchases. It does this by building a collaborative filtering model based on the past purchases by them. I assume you guys now have a proper idea of what unsupervised learning means. If you have any slightest doubt, don't hesitate and add your doubt to the comment section. So let's discuss the third and the last type of machine learning, that is reinforcement learning. So what is reinforcement learning? Well, reinforcement learning is a type of machine learning algorithm which allows software agents and machine to automatically determine the ideal behavior within a specific context to maximize its performance. The reinforcement learning is about interaction between two elements, the environment and the learning agent. The learning agent leverages two mechanisms, namely exploration and exploitation. When learning agent acts on trial and error basis, it is termed as exploration. And when it acts based on the knowledge gained from the environment, it is referred to as exploitation. Now, this environment rewards the agent for correct actions, which is reinforcement signal. Leveraging the rewards obtained, the agent improves its environment knowledge to select the next action. In this image, you can see that the machine is confused whether it is an apple or it's not an apple. Then the machine is trained using reinforcement learning. If it makes correct decision, it gets rewards point for it. And in case of wrong, it gets a penalty for that. Once the training is done, now the machine can easily identify which one of them is an apple. Let's see an example. Here we can see that we have an agent who has to judge from the environment to find out which of the two is a duck. The first task he did is to observe the environment. Next, he selects some action using some policy. It seems that the machine has made a wrong decision by choosing a bunny as a duck. So the machine will get penalty for it. For example, minus 50 point for a wrong answer. Right. Now the machine will update its policy, and this will continue till the machine gets an optimal policy. From the next time, machine will know that bunny is not a duck. Let's see some of the use cases of reinforcement learning. But before that, let's see how Pavlov trained his dog using reinforcement learning, or how he applied the reinforcement method to train his dog. Pavlov integrated learning in 4 stages. Initially, Pavlov gave meat to his dog, and in response to the meat, the dog started salivating. Next, what he did, he created a sound with the bell. For this, the dog did not respond anything. In the third part, he tried to condition the dog by using the bell and then giving him the food. Seeing the food, the dog started salivating. Eventually, a situation came when the dog started salivating just after hearing the bell, even if the food was not given to him, as the dog was reinforced that whenever the master will ring the bell, he will get the food. Now let's move on and see how reinforcement learning is applied in the field of banking, healthcare, and retail sector. So starting with the banking sector. In banking sector, reinforcement learning is used to create a next best offer model for a call center. By building a predictive model that learns over time as user accept or reject offer made by the sales staff. Fine. Now in healthcare sector, it is used to allocate the scarce medical resources to handle different type of ER cases by building a Markov decision process that learns treatment strategies for each type of ER case. Next and the last comes the retail sector. So let's see how reinforcement learning is applied to retail sector. In retail sector, it can be used to reduce excess stock with dynamic pricing by building a dynamic pricing model that adjusts the price based on customer response to the offers.
Machine learning is a branch of artificial intelligence that enables computers to learn patterns from data and make predictions or decisions without being explicitly programmed. So instead of following the rigid rules, ML models adapt and improve over time by analyzing vast amounts of data. From personalized recommendations on Netflix to fraud detection in banking, ML powers countless real-world applications. So now that we have a basic understanding of machine learning, right? Now let's explore different types of ML models. So not all data is structured the same way, and different problems require different approaches. So for example, predicting stock prices requires the models that learn from historical trends. And then identifying objects in images needs models that recognize patterns in visual data. Next, the chatbots and voice assistants rely on the models trained to understand and generate human language. So to tackle these challenges, as I discussed previously, that ML is divided into different learning models, such as supervised, unsupervised, and reinforcement learning. And each has its own strengths, and it is used depending on the problem at hand. Since we know why different ML models are needed, let's see how they play a crucial role in generative AI. Well, generative AI is one of the most exciting applications of machine learning. And unlike traditional ML models that make predictions or classifications, generative models create entirely new content. And here's how ML enables AI to generate. So first here we have text. A language models like GPT generate human-like text for chatbots, content writing, and coding. Next is the image. So AI-powered tools like DALL-E can create realistic images from textual descriptions. Next is videos. So advanced ML models synthesize lifelike video content, transforming media, marketing, and even filmmaking. So these advancements in generative AI are reshaping creativity and automation, proving that machine learning is not just about making decisions, it's about creating new possibilities. So now that we have seen how ML models enable AI to create new content, so now let us briefly understand the different types of machine learning models. So here, the first type of machine learning model is supervised learning. Supervised learning trains a model using labeled data, where each input has a corresponding correct output. And this makes it ideal for tasks where historical data can be used to predict future outcomes. For example, let's say spam detection. Email services like Gmail uses supervised learning to classify emails as spam or not spam by learning from past labeled examples. The next example is the price predictions. So real estate platforms use regression models to predict house prices based on the features like location, size, and amenities. Now, let us see some of the popular algorithms. So first, let's discuss on decision trees. These models break down the data into a tree-like structure, where each node represents a decision based on a feature. So they are easy to interpret and work well for both classification. For example, deciding if an email is a spam or not, and regression example predicting house price. However, they can become overly complex. Next is the support vector machines. So SVMs are powerful for classification tasks as they find the optimal boundary, also called a hyperplane, and that best separates different clauses in the data. They work well for high-dimensional spaces and cases where the distinction between categories is clear, such as handwriting, facial recognition, or medical diagnosis. So now that we have seen how labeled data is used, so now let's explore how unsupervised learning finds patterns without labels. Well, unsupervised learning works with unlabeled data, identifying hidden patterns and relationships without predefined categories. So here we have some of the popular algorithms. So first is the K-means clustering. This algorithm partitions data into a predefined number of clusters by grouping similar data points based on their attributes. It works well for tasks like customer segmentation, where businesses can group customers based on purchasing behavior. However, it assumes clusters are spherical and may struggle with irregular shaped data. Next, we have autoencoders. So these are specialized neural networks designed to learn efficient data representations by encoding and reconstructing input data. Let us see some of the examples. So first example here we have is customer segmentation, where e-commerce platforms group customer based on their shopping behavior to offer personalized recommendations. The next example is market analysis. Businesses analyze purchasing trends to find association, such as which products are frequently brought together. Now we have covered both labeled and unlabeled learning. So let's see how semi-supervised learning combines the best of both worlds. So, semi-supervised learning bridges the gap between the supervised and unsupervised learning by using a small amount of labeled data along with large amount of unlabeled data. So for example, let's say AI assistant medical diagnosis. Labeled medical images such as X-rays with diagnosis are scarce, but large amounts of unlabeled images exist. Semi-supervised learning helps AI learn patterns from both labeled and unlabeled data, improving accuracy in disease detection. Alright, now let's explore the reinforcement learning, where AI learns through trial and error. Well, reinforcement learning is inspired by the concept of learning through trial and error. So models interact with an environment, receive rewards or penalties for actions, and refine their strengths over time. For example, let's say gaming. Mario AI, developed using reinforcement learning, learns to navigate levels by optimizing actions through trial and error. The next example is robotics, where robots learn to walk, balance, or perform tasks through reinforcement learning by maximizing positive outcomes. Also, reinforcement learning uses agents, actions, and rewards to improve decision making, making it ideal for tasks requiring continuous learning and adaptation. So now that we have covered all the types of machine learning models, so let's go over some of the key tips to help you choose the right one for your needs. So here are the tips. When it comes to supervised learning, classifying emails as spam or not, and diagnosing diseases from patient data. Next is the unsupervised learning. So unsupervised learning is best when you're grouping shoppers by behavior and detecting fraud in banking. Next we have semi-supervised learning. And this is best when you're improving speech recognition with limited labeled data and identifying fake news. And finally, the reinforcement learning. This will be best when you're training self-driving cars to navigate, optimizing AI in video games like Mario. So whether it's supervised, unsupervised, semi-supervised, or reinforcement learning, each model plays a crucial role in shaping AI's future. So as generative AI continues to evolve, these models are driving innovation in text, images, and video generation. So which machine learning model do you find the most fascinating? Let me know in the comments below.
Why mathematics in machine learning? Aspiring machine learning engineers often tend to ask me, what is the use of mathematics in machine learning when we have computers to do it all? Well, that is true. Our computers have become capable enough to do the math in split seconds where we would take minutes or even hours to perform the calculations. But in reality, it is not the ability to solve the math. Rather, it is the eye of how the math needs to be applied. You need to analyze the data and infer information from it so that you can create a model that learns from the data. Math can help you in so many ways that it becomes mind-boggling that someone could hate this subject. Of course, doing math by hand is something I hate too, but knowing how I use math is enough to explain my love for math. So allow me to extend this love to you guys too, because I won't be teaching you just the mathematics for machine learning, but the various applications you can use it for in real life. So what math do we need to learn for machine learning? Here is a pie chart which comprises of all the needed math. Linear algebra covers a major part, followed by the multivariate calculus. Statistics and probability also play a big role, and you need to know the knowledge of algorithms and much more. This is the requirement that is needed to master machine learning. So now that we have developed this understanding, let's do some math. We shall kick off with linear algebra. Linear algebra is used most widely when it comes to machine learning. It covers so many aspects, making it unavoidable if you want to learn mathematics for machine learning. Linear algebra helps you in optimizing data, operations that can be performed on pixels such as sharing, rotation, and much more. you can understand why linear algebra is such an important aspect when it comes to mathematics for machine learning. So let's move over to the first topic in linear algebra, scalars. So what is a scalar? A scalar is basically a value. It represents something, right? So scalars are just values that represent something. Suppose we had a laptop on sale and it is priced at 50,000 rupees, right? So this 50,000 rupees is the scalar value of that laptop. What are the operations that can be performed on scalars? It is just basic arithmetic. So for example, we have addition, subtraction, multiplication, division. All of those operations can be applied on scalars. Okay. For example, over here, we are buying a laptop and the accessories. What is the total price? It will be the addition of both the prices. So 50,000 for the laptop and 5,000 for the accessories brings it up to 55,000 rupees. What happens if you're buying a laptop at a 50% discount? So it is half the price, right? It is 50,000 divided by 2. That becomes 25,000 rupees for the laptop. So this is just a brief introduction and all that is required from scalars. So once we are clear with this, let's move over to vectors. So vectors can get a bit complicated as they are different for different backgrounds. Let me tell you how. Computer science people can interpret vectors as a list of numbers that represent something. Physicists consider vectors to be a scalar with a direction and it is independent of the plane. Mathematicians take vectors to be a combination of both and try to generalize it for everybody. All of these standpoints are absolutely correct, and that's what makes it so confusing for anyone learning about linear algebra for mathematics for machine learning. In machine learning, we usually consider vectors in the standpoint of a computer scientist, where the data is in the tabular form consisting of rows and columns, right? And when our data is in the form of pixels or pictures, we consider them as vectors that are bound to the origin and transform them to matrices and perform operations that we shall discuss later. So now that you have a brief idea about vectors, let's jump over to the operations that you need to know when working with vectors. Operations on vectors can be applied only when you know what kind of data you're working with. Suppose you have pixel data and you want to apply rotations but end up doing something wholly different, your model will not work because it is doing all the wrong operations here. It's important that you make sure that you know what you're working with. Only then you will be able to apply the required operations. So the first operation that we have here is vector addition. So let's understand what vector addition does. So for example, vector addition is also called as dot product. Vector addition is something that is completely different from operations that we've been learning now for scalars. Okay, it's not simple arithmetic. It is actually the total work that is done by both the vectors in a quantified form. So for example, let me say that I want to walk forward by 50 meters and that is one vector. Okay. So me walking forward for 50 meters is one vector, and from there I go right for 25 meters, right? So that is the second vector. So what is the work that is completely done by both these vectors is me moving forward and then moving right. So let me say, for example, V1 is what I walked forward, okay? And then V2 is something that I moved right. So what is the addition of this? The addition is basically putting both the vectors point to point and then finding the displacement or the work that has been done. If you look at it over here, it is V1 plus V2's work that is in the quantified form of V1 plus V2. It is the displacement. So for example, V1 is a distance and V2 is a distance. V1 plus V2 is the displacement. So that is basically what is a dot product. I hope you've understood this. So let's move over to the next operation, that is scalar multiplication. So what is scalar multiplication? So whenever a vector is multiplied with a scalar value, it either grows or shrinks. What this means is that you have a particular value, a scalar value, which is either positive or it is negative. And it may be greater than 1 or lesser than 1. Whichever is lesser than 1 and it is negative, it will always make it shrink. Or else it will do the opposite. It will make it grow. So let me just show you an example over here. So let's say I have a vector called V1 Now, if I'm trying to multiply this with a positive scalar value, say k, positive scalar value into v1 will make the vector grow. Whereas if I am trying to multiply this particular vector with a negative scalar value, say minus k, it will be shrinking down. So it is minus k into v1 gives me a shrink vector. So as you can see, this was my normal vector. And if I multiplied it with a constant k, which was positive, it grew. And if it was negative, it shrank down. So that is basically what is scalar multiplication. So the next vector operation is a projection. So what does projection help us with? So for example, let's say I have two vectors, okay, v1 and v2. Now I do not know much about v1 and I just know more about v2. So if I can try to find a way in which I can project the vector v1 onto v2, I'll be able to obtain information about v1. So let me just show you. So for example, I have a vector v1 and I had another vector v2. So I know all about v2, but I do not know about v1 vector. So what happens over here is if I'm able to project the projection of vector v1 onto v2, I will be able to analyze and know the unknown features that vector v1 has. Okay. Actually, if you go with this into deep learning, right, you can be able to find unknown features of the vector, which can help you modify your one image into so many images that you can basically simplify and modify that image into something that it is not. Okay, that comes under deep learning, but we're not going to cover that. But this is a very important concept that you need to understand. It is basically like it's said over here. Projection is the shadow of a vector that it places on the other vector. So whatever information that v1 vector has, I'll be able to somehow extract it from the vector v2 because the projection falls onto v2. That basically brings us to the end of all the vector operations that you need to remember for machine learning. Let's move over to matrices. So what is a matrix? A matrix is the composition, or it is the mixture of numbers, symbols, expressions which are in a rectangular array. It can be rectangular, it can be square, it depends on the order. So what do we use matrices for? We use matrices to convert our equations into the form of arrays. For example, if you've got an equation, you cannot simply put that into your computer saying that, okay, solve this and give it to me. You need to convert it into a list or an array so that you will be able to perform your operations on it, right? That is the reason matrices are so much important to us. And that is the reason it is much more easier for us so that we can convert our equations into lists and arrays and then perform our operations on them. So suppose, for example, you have two equations over here. So how do you convert these two equations into matrices? So what does an equation tell you? If you have 2x plus 2y is equal to 10, what this basically is trying to convey the information to you is that you have two constants x and y. In these constants, if you keep giving different numbers, you will be able to find a different value for it. Let's say, for example, the scalar value is 10 and you have 2x plus 2y, which is basically a vector. I need to find the points of x and y. Find the points of x and y meaning that I'm trying to find the direction of the vector. And then if I'm able to substitute values and then find out how 2x plus 2y is equal to 10, I'm finding all the information I need from that vector so that I can basically find out what all the other information I need from it. That is how functions are very important. You need to understand what a function is trying to convey to you. Let's say, for example, you have the equation of a straight line. So what does a straight line be? It is y is equal to mx plus c. What does this mean? It means that the y coordinate is equal to some value m into x plus a constant. So I'm able to plot this. I'll be getting the y coordinate, the x coordinate, and I'll be able to get a straight line. So whatever numbers I put into these, I will always be getting a straight line. So that is the reason it is called the equation of a straight line. It is always going to be constant. So you have to understand what a function is trying to convey to you. Once we are done with that, let me just tell you how you convert equations into matrices. It's really simple. Take out all the numbers. So you have 2x plus 2y equal to 10, right? So 2x and 2y has two numbers, 2. So those two become one row. 4 and 1 in the second equation become one row. X and y becomes one column, and 10 and 18. So let me just show it to you. So as you can see, we have a matrix 2, 2, 4, 1. Then we have x and y is equal to 10 and 18. If you multiply it accordingly, you will be getting back the same equation that we had earlier. This is how matrices are used in linear algebra. So once you know how the equations are converted into matrices, let's move over to the matrix operations. So what is the first operation? Simple addition. What does addition help you with? It is just basically adding all the directions of two vectors. Why is it two vectors? Because I'm converting vectors into matrices, right? You are simply just going to add the corresponding elements of both the matrices. Simply add the corresponding elements of both the matrices. And you have to remember that if you are adding two matrices, it has to be of the same order. What do I mean by order? It is basically the number of rows into the number of columns. So for example, if I have the first matrix, that is 2, 2, 4 and 1, I have two rows and I have two columns. So that becomes a 2 cross 2 matrix. That is the order of the matrix. The next one also, 2, 3, 1, 4, it has two rows and two columns. That makes it an order of 2 cross 2. So if I had 3 rows and I had 2 columns, it would be 3 into 2. So I hope you've understood what order is. Let's say I had these two matrices and I want to add them. So what I do, it is 2 plus 2. So let's say I have 2 over here and I have 2 over here. So what is 2 plus 2? It becomes 4. What is 2 plus 3? It becomes 5. What is 4 plus 1? It becomes 5. What is 1 plus 4? It becomes 5. So it is adding the corresponding elements of the matrix. So I hope you've understood that. So let's move over to the next operation, matrix subtraction. It's the same thing as how you did it for addition. You just subtract the corresponding elements. If you had 2 minus 2, it becomes 0. 2 minus 3 becomes -1. 4 minus 1 becomes 3. 1 minus 4 becomes -3. Simple. You can understand this very easily. Moving ahead from matrix subtraction is matrix multiplication. What do you do with matrix multiplication? You are basically multiplying the rows with the columns. The matrix of row 1 with the columns of matrix 2. What happens? You have to remember that the number of rows in matrix 1 has to be equal to the number of columns in matrix 2. Only then will you be able to perform the matrix multiplication. So for example, if I had a 2 cross 2 matrix, it would be A11 into B11, A12 into B21, A11 into B12 plus the A12 into B22 accordingly. So let me show you an example for matrix multiplication so that you can understand how it works. Suppose I have a 2 cross 2 matrix that I've already been using for matrix addition and subtraction. Now how am I going to perform the matrix multiplication is basically I'm going to multiply the first row into both the columns of the matrix 2. So I have 2 into 2 plus 2 into 1. Then I have 2 into 3 plus 2 into 4. The same thing goes for the second row also. So what do I get? I get 4 plus 2, 6 plus 8, 8 plus 1 and 12 plus 4. That accordingly gives me 6, 14, 9 and 16. So this is the matrix multiplication. It's really simple to understand. So if you have any doubts, leave them in the comment section. We'll get back to you as soon as possible. So once we are done with matrix multiplication, let's move over to the transpose. So the transpose is a really simple operation. All you do is you convert the rows into columns. That's it. But why is it so important? Transpose is really important when you want to change the dimensionality of your data. Suppose all your data is in a row. You can reiterate through there, or all your data is in a column. You can do it accordingly. So it is really important when you work with transpose because it helps you to change the dimensionality. It helps you flip the dimension. So for example, if you're working with pixels, right, pictures, if you change the rows or the columns of your pictures data, You are basically changing the picture, and then you can, analyze it more, get more information from it. So transpose plays a very important role. You need to understand that. So for example, I have 2, 2, 4, and 1. What happens is the first column becomes the first row, and the second row becomes the second column. So as you can see here, it is 2, 2, 4, and 1. And that is all transpose is. So let's move over to the next operation. We have determinant of a matrix. By now, all we have been doing is having matrices being added, subtracted. So what is all of this? It is basically all the vectors being added, subtracted, multiplied, then flipped with their dimensions. You will understand this when you do all of this practically, because all of this is something that we do not do it in our daily lives. But when you're learning with machine learning, when you're performing machine learning, all of these operations come into picture. So all that you've learned by now is basically adding values of vectors, subtracting vectors, multiplying two vectors, then transpose, that is the flipping of vectors, and now you're going to learn about determinant. What is a determinant? All the matrices that we had till now, they are basically directions. They are basically directions and values of all the vectors. Now, all these vectors are definitely going to have a scalar value in them, so that you can understand the weight, you can understand the depth of that particular matrix. What is the determinant helping you with? The determinant helps you with understanding the weight or the sensitivity that it can provide on the data set. That is the reason determinant is really important. It is the scalar value of the matrix, and it can help you give the eigenvalues of the matrix. What do I mean by eigenvalues? I'll teach that to you in the next part, because we are going to understand in depth what are eigenvalues and eigenvectors. That is the reason determinants are so important. So let's say, for example, I had this particular matrix A, B, C, D, E, F, G, H, I. It would be A into E, F, H, I, and then it would be minus B into D, F, G, I plus C into D, E, G, H. So what happens now is I'm going to get this particular equation. So it's AEI plus BFG plus CDH minus AFH minus BDI minus CEG. This is basically what is going to give me the scalar value of the matrix. So I hope you've understood the importance and how determinants are important in machine learning. So next we will learn about the inverse of a matrix. So how do I explain inverse to you? It's a very simple example if you understand that. Suppose I am walking on a road and I walked straight for 50 meters. But then I remember that I had to get back something from the place I started. So I walked back 50 meters. What is the distance that I traveled? The distance that I traveled was 100 meters. Why? Because I went 50 meters forward and 50 meters backward. But what is the work that I have done? It is 0. Why is that? It is because I am at the same place that I started from. That is not the work done. If I move from one place to another place, that is the work done. That is some displacement that my body has achieved. But I have not achieved that over here. Why? It's because I have gone straight and come back straight for 50 meters, making my work done 0. So just the same way inverse of a matrix works. Suppose you have a vector that moves in the forward direction. You will have the inverse of that particular vector that comes in the negative direction, and it makes all the work done 0. Sometimes there is no inverse of a matrix that exists. That's because the vector does not have all the information that is required to obtain its inverse. So I hope you have understood what is an inverse. Let's see how do you find an inverse of it. Okay. For a 2 cross 2 matrix, this is how you're going to find it. It is finding the determinant into the transpose, or finding the inverse of the matrix. So it is A and D that is going to be switched over, and minus B and minus C. This gives you the inverse of the matrix. So for orders 3 and above, what do? You find the determinant of A, and then you accordingly find all the different determinants inside of it. So that is basically how you find the inverse of a matrix. Let's move over to how a vector can be used as a matrix. Okay. So by now that I've been telling that vectors can be easily translated into matrices, and I've already showed it to you. And why is it so important? It's because they help you apply operations on the data very easily. And then you have certain well-known operations such as scaling, rotation, sharing, and much more. All of this come under computer graphics, okay? Making these operations on your image or your vectors becomes really easy when you're working with matrices. So that's the reason matrices are so important. So for example, right now I've shown you that if there was an equation v1 as 3x plus 4, it would be 3 and 4. And then you had x and y, then you would have x plus 2y, which would become 1 and 2, and then x and y. That is how vector as a matrix works. What are some of the well-known operations, right? I'm assuming that there is going to be a 2 cross 2 matrix. Whenever you're scaling, it is basically increasing the size. So how do you increase the size? It is Sx and Sy, which are the scaling factors which you perform on your x and y coordinates. Then you have sharing, which is basically moving or reshaping your particular object that you're working with. So it can be m, which is the sharing factor. And then you have the rotation. So how do you rotate your particular object, in which direction? So all of that can be done using these particular matrices. So let's move over and understand how matrices can help you solve equations and obtain solutions much more easily. So that is basically vector as a matrix. We have two methods over here. They are the echelon method and the inverse method. For our tutorial, I've been taking the row echelon method because it's much more comfortable for me. If you are much more comfortable with column echelon method, you can go ahead with that. But because I am comfortable with row echelon methods, I've used row echelon method. And next we have the inverse method. So we are basically going to solve the equations. We are going to find the coordinates at which our points give us that particular value. So let's move over with the first method, which is the row echelon method. And I have some equations over here which go ahead like 2x plus y minus z equal to 2, x plus 3y plus 2z equal to 1, x plus y plus z equal to 2. So I'm going to convert all of this into a particular matrix. So let me show you how the matrix looks. It is 2, 1, minus 2 and 2, 1, 3, 2, 1, and 1, 1, 1, 1. So all the information about the equations have been put into the matrix form. And the answers that we are going to get are x is equal to 2, y is equal to minus 1, and z is equal to 1. So this is the reason I'm going to get all these particular values, that is 2, 1, and 2, which I'm getting from the equations. Whenever I put the x, y, and z values into them, I'm going to, get those particular coordinates. Now, let me just tell you why we are solving equations, okay? So if I am telling that there is this particular vector that goes like this or comes in this direction or something like that, I want to find the x, y, and z coordinates so that I can obtain the information, visualize it, and then learn more about that particular vector. Now, say for example, this is just 2x plus y minus z equal to 2. Let's say for example, what if it was a 2 boxes plus 1 candle minus 1 chocolate is equal to giving me a profit of 2 rupees. Okay. So as you can see, these are just simple equations, and these are the coordinates that we get. X is equal to 2, y is equal to minus 1, and z is equal to 1. But what is the importance of this? Okay. Let me just give you a simple example so that you can understand what we are actually trying to find out over here. Okay. Suppose I have a factory and I want to get a profit of 2 rupees. And I have boxes, I have candles, and I have chocolates. So if I take the first equation, I'm saying that if I have 2 boxes, 1 candle minus the chocolate, it is going to give me 2 rupees profit. So what is X, Y, and Z exactly? X, Y, and Z are the investment costs. How much do I need to invest into them so that I can get back what I really required? So for boxes, I need to invest 2 rupees. For chocolates, I need to invest nothing. For candles, I need to invest minus 1 or something like that. Okay. If I invest so much, I'm going to get 2 rupees profit. So this is like a real life example which is being converted into some equation, and then we just need to solve it. That is the reason vectors are so important and how they can be converted into matrices and then, solved very easily. How does the row echelon method work? I'm going to be taking the step 1, which is R1 divided by 2. R1, when we divide it by 2, we get 1, half, minus half, and 1. So what's the step 2? We will do R2 minus R1. So we have R2, which is the minus of R1. I'm going to get the particular equation, which is 1 half minus half and 1, 0, 5 by 2, 5 by 2 and 0, 1, 1, 1, 2. Simple enough, right? So what is the next step? It'll be R3 minus R1. So it is 1 half minus half 1, 0, 5 by 2, 5 by 2, 0 and 0 half 3 by 2 and 1. The next step is 2 by 5 by R2. So you get 1 half minus half 1, 0, 1, 1, 0 and 0, 1 by 2, 3 by 2 and 1. So what's the step 5? Step 5 is basically R1 minus half of R2. So I get 1, 0 minus 1 and 1, 0, 1, 1, 0 and 0, 1 by 2, 3 by 2 and 1. Step 6 is R3 is equal to R3 minus half of R2. So I have 1, 0 minus 1 and 1, 0, 1, 1, 0 and 0, 0, 1, 1. Step 7 is R1 plus R3. So I have 1, 0, 0, 2, 0, 1, 1, 0 and 0, 0, 1, 1. Step 8 is R2 is equal to R2 minus R3. So I have 1, 0, 0, 2, 0, 1, 0 minus 1 and 0, 0, 1, 1. If you put all of this back into the equation, you will find out that for the first row, 1, 0, 0, 2 is equal to x plus 0 is equal to 2. The value of x is equal to 2. The value of y is equal to minus 1 and the value of z is equal to 1. So this is how the row echelon method works. And what do you have to actually perform in row echelon? It is basically the first row has to start with the value 1. The second row has to have a 0 and then somewhere in the middle it has to have a value of 1. And then the third row should be starting with zeros and then getting some value where it starts with 1 only. So row echelon or column echelon, whatever method you use, you have to make sure that whichever element is the first starting element of the row, it has to have a 1 or it has to be preceding with zeros. So as you can see here, the first row has 1, 0, 0, 2 and then you have 0, 1, 0, minus 1 and then you have 0, 0, 1, 1. So that is how you are performing the row echelon method to solve your matrix. So if you remember, we had x is equal to 2, y is equal to minus 1 and z is equal to 1. Those were the answers that we wanted. Once we are done with row echelon method, let's move over to the inverse method. So suppose we have some equations, 4x plus 3y is equal to minus 13 and minus 10x minus 2y is equal to 5. What does the inverse method tell us? Let me show it to you. So this is the matrix that you come up with. So it is a 4, 3, minus 10 and minus 2. Then you have x and y and which is equal to minus 13 and 5. So what does the inverse method actually tell us? For example, we know that A into A inverse is equal to 0 work done, right? It is the identity matrix, I matrix. So if I have A into the A inverse, so it is like I'm doing the work and I don't do the work, is equal to no work done. So A into A inverse gives me the identity matrix. If A into B is equal to C, so A is my, all the numbers, then B is my x and y and C is the output value. If I do A into A inverse into B is equal to C into A inverse, I am going to get B is equal to C into A inverse. Because A into A inverse gets cancelled, so B is equal to C into the A inverse of it. So that's what I'm going to do. So what is the inverse of the 2 cross 2 matrix? The inverse is found by this formula, and the inverse is actually 1 by 22, minus 2, minus 3, 10 and 4. So that's the inverse of the matrix. So let me show you how it works. What happens is I'm having A into A inverse into B is equal to C into the A inverse. So A into A inverse is obviously going to get cancelled out because it's an identity matrix. So I'm just going to be left with x and y is equal to 1 by 22 into minus 13 and 5, minus 2, minus 3, 10 and 4. So what I do later, I'm going to just multiply and this is what I get. So it's basically 1 by 22 and 11 by minus 110. So if I do 1 by 22 into the particular matrix that I've found, it is going to be x is equal to half and y is equal to minus 5. So that is how I'm going to be using the inverse method to find or solve the equations. I hope that was simple to understand. So once we've done all of that, we are now capable enough to understand what an eigenvector is. Eigenvectors are really important when you're working with data. All of that, what vectors, matrices, what all we've been doing by now, think of it as the data you're working with in your machine learning algorithm, right? What is an eigenvector? Eigenvector does not change the direction even if a transformation is applied to it. What does a eigenvector really give us? So for example, I have a data. If I am trying to do any transformation on it, it should not change from what it was really. It should not change from what it was initially. It should not become something that is totally irrelevant to me. If I have such data that even if I apply transformations to it, it does not change what it was supposed to be, that is an eigenvector. What does an eigenvector give me? They are the most sensitive parts of my data set, and I can use them and I can trust them for my analysis purposes. So that is why eigenvectors are so important. Eigenvectors help you transform and make your data much more careful. So for example, let me show you what an eigenvector looks like. Okay, so I have a particular rectangle and I have a lot of vectors, but for my example I'm just going to be using two vectors. Okay, I have a v1 and v2. These vectors are basically trying to explain all the data that is there in the particular rectangle. What happens if I perform the sharing operation? When I perform the sharing operation, my v1 vector has changed its direction completely. It was at some other direction, and after sharing or after performing some operation, it has completely changed its dimensionality, its direction. All the information that it held initially has now completely been changed. Whereas my v2, it has not changed its direction. Yes, it has moved forward. It has multiplied. But it gives me the same information that it was giving me earlier also. So that becomes an eigenvector. Think of this now in the form of a matrix. If my matrix is changing so drastically, how will I be able to perform operations on it? It becomes really difficult. Okay, so for example, think of the vector v2 as a list, which is then just multiplied by 2. It does not make a difference. Why? It's because even if I multiply by 2, it's just going to double the value. But the operation that I want to do on it, the information that it is giving it to me, that's the same. So that's the reason eigenvectors are so important. And what are eigenvalues? The values that we perform on these eigenvectors are all that are eigenvalues. It's that simple to understand. So that is all you need to know about eigenvectors. All the data which is not transforming anything is basically the data that you should be learning with. What are the applications that linear algebra helps us with? You have the first and foremost, which is the principal component analysis, PCA. It is used for dimensionality reduction and it helps increase the quality of data. Then you are working with applying transformations. It helps in encoding. It helps in the single value decomposition, where it is again reducing the dimensionality of a single value data. And then it is used for natural language processing, for latent semantic analysis, optimization of your deep learning models. All of this can be achieved through linear algebra. So it is a very important aspect of machine learning. Once we are done with all of this, let's start our coding for PCA. We will now be coding for principal component analysis. Let me show you how it really works. So I am having all the programs already prepared for you guys, so we do not extend this big tutorial even more further. Let me go to the presentation mode. So what happens over here is I am having these important libraries, which are import NumPy as NP. Then I have the PyPlot as PLT. And then from sklearn.decomposition, import the PCA. So principal component analysis is already present. I'm just going to import it from sklearn. So I'm going to get a range of around 200, 300, how much ever it is. After I'm getting that particular range, I'm going to get data. I'm going to get all of that data and then I'm going to put it into my particular list. So what happens over here? I have np.dot and in the range of 2,2 and it is in the range of 2,200. So in the range of 2,200, whatever numbers that you can randomly generate, please give it to me. And then dot t. Why is it dot t? It's because all of this which I'm going to get is basically in the form of a column. I do not want it in the form of a column. I want it in the form of a row. So that is the reason I'm using .t. .t is used to transform it. So I'm just going to scatter that on the plot and then show it to you guys. That is what this particular function does. And then I am doing PCA is equal to PCA of n components is equal to 2. And then I'm going to fit the data into it. And then I have a function which is to draw the vector. So I'm going to do arrow props, dictionary style, all of that I've just given the styling over here. And then I'm going to annotate and draw it accordingly. So this is my draw vector function. And then I'm just going to scatter plot everything that I had. So I have the vector. How am I going to get a vector? It's using this particular formula, which is the vector and 3 and np.sqrt. So what is PCA explained variance and components? Okay. So if you remember, I had fit PCA with the data that I have generated, right? So explained variance is basically going to tell me how much is the variance between my data points and what are the components that are really required that I look at and perform my analysis on them. So these are what the required components are for me. And after I do all of that, I'm going to get another vector. I'll show that to you guys. And then what I'm going to do is I'm going to find one component only over here and I'm going to fit the data. Okay. And I'm going to transform and perform the inverse transform so that I am going to get a particular linear line which I can just look at and find all the important aspects of the data that I wanted to from it. Let me run the program and let me show you all the outputs. So as you can see here, this is all the data that I had generated using the dot function of the random generating thing. So this is all the random data that I have generated. Then what I did, I had to find out two components, right? Then what I had to do, I had to find out two components. What can I understand from this particular information? This one is a small vector. So this small vector means that this is the only amount of information that it can give. Whereas this vector is so long. What this means is that the longer the length of the vector is, the more information that it can pass to me. Simple enough, right? Longer the length of the vector, the more information that it can pass to me. So what all information I have through this particular vector, all of this is going to give me the best for my analysis. So that's what I'm going to do. I'm going to get all the data points that are according to this vector. So as you can see here, all of these data points are very, very important for my analysis. So this is how I converted such a big, huge data set into one particular line. And if I follow all these points, I'm going to get almost the same amount of information the whole data set is going to give it to me. As you can see, this was such a huge data set, but it's just come up to just one line. It's so easy. Think if you're working with tons and tons of data, it becomes really, really difficult when you're working with it. That's the reason use PCA. And it's just not use PCA. Make sure that you're able to reduce the data as much as you can so that you can get at least all the amount of information that you can from that particular data. You do not need all the data, but you need the information from that data. That is basically how PCA works. I hope it was clear to you guys. So basically, that was all we needed to learn from linear algebra, and I hope it was clear to you guys. So now that we know all about vectors, let's move over to multivariate calculus. Multivariate calculus is one of the most important parts of the mathematics in machine learning. It helps us solve the second most important problem that we are facing in developing machine learning models. The first problem is obviously the pre-processing of the data. The next is the optimization of the model. Multivariate calculus helps us to optimize and increase the performance of a model and give us the most reliable results. So how does something that almost half the class hated help us solve such a problem? So let's break all the ice that's surrounding this, but before that we need to understand the basics. So let's calculus. So the first topic in calculus is differentiation. Differentiation is basically breaking down the function into several parts so that you can understand every element and analyze it in depth. They are very helpful in finding the sensitivity of a function to the varying inputs. A good function gives you a good output, which can be described using a rather easy equation. The same cannot be said for a bad function. So for example, right here I have y is equal to e power x. It is really easy to tell that, okay, if it is e power x, this is going to be the graph for it. But look at y is equal to 1 by x. it is such a horrendous graph that I cannot explain it using a particular equation. Those are the types of equations. Those are the good functions and the bad functions. We know all of this, but what are we really after? So let's do all of that right now. Okay, so most of us already know all of this, but what are we really after? So let's understand that with a really simple example. So let's assume that we have a car moving in a single direction only and is already in motion. So if we plot a graph of its speed versus time, it communicates to us how the speed varies as the time keeps increasing and it halts after a certain point. Now if we want to know the rate at which the speed varies with respect to the time, it turns out to be that we are actually finding the acceleration. The acceleration of the car can be plotted as follows. So what this means is that acceleration is actually a derivative of speed, because the speed we have here is just the magnitude and does not hold any more factors, just for simplifying everything. So if there was no speed, there would be no acceleration. It's as simple as that. Now that we have the acceleration, we can justify whether the car had a varying or a constant change in its speed, whether it was moving or not, and much more. But in this case, that is all we need. Now think that you want to find the change in acceleration between a certain range in a time span. Okay, we mark 2 points, x and some variable which is a small portion more than x. We can denote this using x plus delta x. So let's denote this on the graph. So you can see it as it's shown over here. Now we know that this range has many values in between. But what if we want to know the rate of change only between one point and the next? We know that this is really kind of impossible, because between a range there are countless numbers as the function is continuous. Thus we approximate that the limit or the step between two input variables is 0. Remember that this 0 that we are assuming is only the smallest possible value that we can make up, and it is not the absolute 0. If we ever work with absolute 0, we would never have had any functions at all. So if you are still confused, this number is basically some value of 0.00000. It just keeps going and then some numbers ahead, but it is never really 0. That is the only way that we can put this as. Okay, so now that we have understood what we are really trying to find, let's make it a general equation. So let's derive the derivation formula. So the derivation formula is f dash of x is equal to limit delta x tends to 0, which is not exactly 0, but we are assuming it to be 0 point something. So we are just going to write 0. And then we have f of x plus delta x minus f of x divided by delta x. That is how the formula comes into existence. This helps us find the rate of change between one point to the other. It is such an important concept as it plays a huge role in the optimization of machine learning models. You need to understand that this is the first order of derivation only. If we differentiate the output of the first differentiation, it becomes the second order differentiation and so on. But that is all the introduction we need from differentiation. So now that we have the basic idea and formula of derivation, let's move over and understand some of the important rules that we need in differentiation. So the first rule that we will be talking about is the power rule. So whenever you have a function which has a variable with some power, you can basically use this formula and solve the equation much more faster. So for example, let's say that I had an equation called as f is equal to 3x square. So let me put this into the formula. So I have f dash of x is equal to limit x tends to 0, 3 of x plus delta x the whole square minus 3x whole square divided by delta x. So x plus delta x the whole square becomes a formula. Let me expand it. And then this is what I actually get. Plus x square and minus x square get cancelled, and then I have delta x which is being removed out of there. So delta x and delta x also get cancelled. Then I have 3 into delta x plus 2x. So I'm going to put the value of delta x is equal to 0 into the equation, which is not exactly 0, but it is so small that I can ignore it. So I have 3 into 2x, which becomes 6x. So that's how I had to solve the whole entire equation, right? So what about the power rule? Power rule is just 3 and whatever number I had, right? So if it is 3x square, let me take out 3 because 3 I am going to treat it as a constant. So x square. So x to the power of 2. So then what I do? I bring 2 down, which is n, and then I have x of n minus 1. So it is 2 minus 1. So it becomes 3 into 2x, which is equal to 6x. So I get the entire same answer, but I just had to do it in 3 steps. I can actually do it either in 1 step, but just for simplification, I've done it like this. The next rule that we are going to be studying is the rule of sum. So if you have a particular function which is the sum of 2 variables, their differentiation's sum also is the differentiation of the whole function. So if you have f of x1 plus x2, it will be x1 dash plus x2 dash. A simple example will be 3x square plus 5x. Okay, so I'm going to solve the equation right now. 3x square, I hope you remember, I just showed it to you before. And the same thing goes for 5x also. So 5x plus 5 delta x minus 5. And then I'm going to just, cancel out 5x's. And then I have delta x being cancelled out. And then I have x square minus x square being cancelled out. So the whole same process goes on. Then delta x gets cancelled. Then I have 6x plus 5. So I'm going to use the same rule that we learned earlier. That was the power rule. And then I have 3 into 2x plus 5. So I get 6x plus 5. This is basically how the sum rule works. Next, I have something called as the product rule. So if I have a function which is in the form of x into 2x or something like that, the differentiation is very simple. This is how the differentiation looks. If it is f dash of x1 into x2, that is equal to x1 dash into x2 plus x2 dash into x1. That is how you're going to find out the differentiation. And the next rule that we are going to look at is the chain rule. So basically, if I have f dash of g dash of x, it will be f dash of g into x dot g dash of x. This is a very simple example and it's really easy to understand. So if you want to learn more about the common functions, I have my blog which is also put up in the description, and you can go ahead, click over there and learn more about the common functions. Okay. So now that we have understood all the basics that we really needed from differentiation, we'll now be moving over to partial differentiation. Partial differentiation is an important concept that most of us have ignored throughout our academy. What has partial differentiation helped us achieve might be the question that most of you may be having right now. So let me give you an example so that you can understand its importance. Okay. Suppose you are a car designer who deals with the exterior of the car only. You have been given the task to maximize the performance of the car. So how do you do that? You do not go into the car, you do not take out the engine, you do not tune the engine. You are not supposed to do any of that. You just are going to change the particular exterior of the car. So what's happening over here? You know that even the engine and all the other tires and all that, all those are variables also that come to making the car better in its performance. But you are not going to do that. You're not supposed to do that because you are only going to deal with the exterior of the car. Those variables of the engine and all of that, those are kept constant. If those are kept constant, that means that those variables will be performed by somebody else. You are just going to look at your particular variable that you have to change. That is the exterior of the car. So this is how partial differentiation comes into play. You are just going to change one particular variable. All the other variables become a constant. Okay, it's that simple. So what do? You would change the windshields, change the body if necessary, air vents, and many more. I've just given whatever I could find. You are just changing what is necessary. That is basically what is partial differentiation. So what are the equations that partial differentiation goes according with? Now if you can see, it is the f dash of x, y, and z. If you remember the previous slides, we were just working on one variable, that is x, which is x1, x2, which may be x squared, 3x, 5x. It was all on x. Partial differentiation is not like that. It is x, y, z, whatever variables it can find. So that is what makes partial differentiation much more realistic, much more easier to understand. Because you are just going to change your factors, your variables. You're going to keep everything else constant. So let's say, for example, you have to find it with respect to y. So y and z become a constant, f dash of x. If you want to find it with respect to y, x and z become a constant, f dash of y. With respect to z, x and y become a constant, f dash of z. So what is the complete differentiation? It is the addition of all the three differentiations that we've just found out. So this is how partial differentiation works. Let's show you an example. So if I have a function which is x square plus 3y plus 4xz square, how am I going to find the differentiation of this? So with respect to x, y becomes a constant, so it is 0. And then you have 2x plus 4z square. So with respect to y, x square plus 4xz square become a constant, so I'll just have 3. So with respect to z, it will become x square becomes a constant, 3y becomes a constant, and then 4xz square is what I am going to differentiate. So I will have 8xz. So what is the total differentiation? It is a 2x plus 4z square plus 8xz plus 3. So I hope you've understood this really simple example of it. So this is how partial differentiation works. So what are the applications that multivariate calculus comes into play? We have something called as the Jacobian vector. Now what is the Jacobian vector? It is basically differentiating the vector once. Jacobian is basically differentiating the vector once and then putting it into the form of a matrix. That becomes the Jacobian vector. It helps in finding the global maximum of the data set. It is pointing to the maximum data that is there in the data set. And it also helps in linearizing a non-linear function to a linear at a particular point. So that's how the Jacobian helps. So differentiating the Jacobian or differentiating the actual vector twice gives us the Hessian. And it is used in minimizing the errors. It is used in deep learning models, gradient descent for optimizing all the weights and all of that. So that is how multivariate calculus helps us in real life. Let me show you how the gradient descent works. I already have code ready for you guys. Let me go back to the presentation mode. I have a particular import, which is the NumPy. And then I have the sigmoid function, which is basically 1 divided by 1 minus e to the power of minus SOP. So this is what I'm going to return back to it. And then I have the error, that is a predicted minus target whole square, or x to the power of 2. This is what the error is basically. And then I have the errors derivation, which I'm going to use over here. So that is basically 2x or 2 into predicted minus the target part. And then I have the actual function over here, which is sigmoid into 1 minus sigmoid, which is the activation function, which is basically trying to find if my particular model is working or not. And then I have the derivation of it, which is just basically x. And then I have the updating function of the weight. So I'm just going to get the weight, I'm going to get the gradient, and I'm going to get learning rate. And I'm going to basically keep trying to, find out the best way that I can find my weight. So here's my function. I have x is equal to 0.1, which is my input. And then I have the target, which is 0.3. And I'm going to have a learning rate of 0.01. And then I'm going to get a random number, which is the weight of it. And then this is the initial weight. What I'm going to do then is I'm going to find the value of y and x, and I'm going to find the errors also. And then I'm going to find all the gradients, and then I'm going to pass the gradient into it and then update the weight. Let me show you an example now how increasing the number of steps is going to make me reach my target much more better. So as you can see, my initial weight was 0.50 thing and all that, and I have just run this for 10 times, right? Let me change this to 1000. My input is 0.1 and this is 0.3. I have to make 0.1 as 0.3, right? So let me run this again. It is still at 0.50. Let me add another 0, which is 10,000 times. Let me run this. So as you can see, it has now become 0.47, which is much more better than what we were actually doing. Let me add another 0 over here. So this is going to take a lot of time because the amount of, steps to be performed are more. But as you can see over there, which was 0.5 previously has now come up to 0.36, which is much, much better than what we were actually getting. Let me add another 0. Let me run it again. 4.6, 4.4, 4.0. As you can see, it is reducing. It's just reducing. The input and our output is almost close enough. What we really needed, the target was 0.3. And as you can see here, we've already reached 0.30 and all the numbers that are succeeding it, right? If you remember, we had 10 steps, which would just give us 0.50 or 51 something. Now, for the amount of times it has learned, it has become much, much, much better than what we were previously getting. So now it is 0.300002 something. It's still reducing. It is still reducing. So this is how the gradient descent works. It keeps repeating, learning. This is the final output that we've achieved. 0.30000577, and it is much, much, much better than what we were already getting from the output. So this is how the gradient descent works. It uses differentiation. Where is the derivation over here? This is my derivation function. This is my derivation function. So these derivation functions are what are helping me to get my new error. And then put that into the gradient descent function, and then basically find and make my weight much more better so that I can get the output, which is from my input 0.1, I have to get the target of 0.3. So I hope you've understood how the gradient descent works. It keeps going in, and it uses differentiation a lot. So I hope that was very easy for you guys to understand. So with that, we have come to the end of all that was required from multivariate calculus. Let's move over to the next topic, which is probability. So what is probability? Probability is measuring how likely an event will occur. What this means is that how much are you sure, or how much quantity that you can give to your sureness that this particular event is going to happen. So that is what is probability. It is the ratio of the desired outcomes by the total outcome. So with that particular formula, you will be able to understand what is the probability. It is the desired outcomes by the total outcomes. So always remember that probabilities always come up to 1. So if you have 0.6, that means you have a 60% probability that this particular thing will happen. If you have 0.6 of something happening and 0.4 of something not happening, they always sum up to 1. Remember, probabilities always sum up to 1. So some examples that I've given over here are rolling a dice. There are 6 possibilities, right? So every possibility has 1 outcome out of the 6 outcomes. So for example, the probability of getting a number 2 is 1 by 6. So that is the probability of getting a number 2. This is basically what is probability. So what are the terminologies that you need to understand when it comes to probability? There are 3 things, okay? You need to understand what is a random experiment, what is a sample space, and what are the events. Let's understand all of these terminologies one by one now. So what is a random experiment? It is an experiment or a process for which the outcome cannot be predicted with certainty. So for example, if I give you a dice, okay, and I tell you to roll it and tell me the number that you're going to get it. You are not sure because that's a random experiment. You have this uncertainty whether this particular event will happen or not, okay? So that process where you roll a dice and all of that, that is a random experiment. So what is the sample space? The entire possible set of outcomes of a random experiment is the sample space of that experiment. It's really simple, right? I tell you to roll a dice, there are 6 outcomes. So it can be either 1, 2, 3, 4, 5, 6. That particular range of 1, 2, 3, 4, 5, 6 is the sample space. It is all the possible outcomes for the random experiment that you've been doing. Simple enough. So what is an event? An event is one or more outcomes of the experiment. So if I told you, roll the dice, you get a number 1, that is an event. You roll the dice again, you get a number 6, that is an event. So what outcome you get from your random experiment is called the event. There are 2 types of events. There are joint events and disjoint events. Let's understand both of these. So joint events have common outcomes, right? Joint events can be together. That is what is a joint event. For example, you have a student who can get 100 marks in statistics and 100 marks in probability. The outcome of a ball that can be delivered can be a no ball also, and it can be a 6 also. And it can be possible are called joint events. Disjoint events do not have common outcomes. So the outcome of a ball that is to be delivered cannot be a 6 and a hit wicket or something like that, okay? So a single card cannot be a king and a queen together, and a man cannot be alive and dead at the same time. So those are disjoint events. Those are not at all possible to happen. Now that we've understood all the types of events, we need to understand the distributions. So now we have three distributions that come under probability. We have the probability density function, we have the normal distribution, and central limit theorem. So let's understand all of these distributions one by one. So the first one is PDF, probability distribution function. So the probability now can be described using an equation. The equation that describes a continuous probability distribution is called the probability density function. I hope it's very clear to you. If it is not, let me just simplify it even more. You have a function which is going to describe the probability of something happening in the form of a graph. It's that simple enough to understand. You have a function which will give you the probability which you can plot a graph on. So that is the reason it is a continuous probability distribution. Okay. As you can see here, you have A and B. Between the range of A and B is the most likely that something is going to happen. So now that you've understood what a PDF is, let's understand the properties of the PDF. The graph of the PDF will always be continuous. It's simple enough to understand that. Then the area bounded by the curve of the density function and the x-axis is always going to be 1. And the probability that a random variable assumes a value between A and B is equal to the area under the PDF bounded by A and B. What this means is basically if you have any particular value or any particular probability that is between A and B, it is going to be equal to the area that is bounded by A and B, the probability value. So that is basically what a probability density function is. So next we have the normal distribution. So what is a normal distribution? It is a probability distribution that associates the normal random variable x with a cumulative probability. So how do you find this particular cumulative probability? It is using this formula, which is y is equal to 1 by sigma into the square root of 2 pi into e to the power of minus x minus mu into 2 divided by 2 sigma 2, where x is the normal random variable that we have just taken up, then mu is the mean and sigma is the standard deviation. And this is how the normal distribution looks like. The graph of the normal distribution depends on basically two factors, which is the mean and the standard deviation. So the mean determines the location of the center of the graph and the standard deviation determines the height of the graph. So if you have a very big deviation between, your variables, it becomes a very short graph and very wide graph. Whereas if you have a good deviation, which is, very less, you will have a tall graph. That is basically what's going to happen over here. That is all we have from normal distribution. Then the central limit theorem. So this is basically a theorem which is stating that the probability is always going to be in the center of the graph. Let me tell you the statement of this. The central limit theorem states that the sampling distribution of the mean of any independent random variable will be normal or nearly normal if the sample size is large enough. So what this basically means is that the distribution of your mean or your samples are always going to be near the center or always going to be near the mean of your graph if your sample size is much large enough. So what this means is that if your sample size is very big, it is going to be a normal distribution. It is as simple as that. So as you can see, if I have n is equal to 1 component, you can see the graph as it increases to 3, as it increases to 10, as it increases to 50. So as you can see, it almost becomes nearly identical to a normal distribution. So that is what the central limit theorem is. So once we are done with that, we will look at the types of probability. We have marginal probability, joint probability, and conditional probability. Let's understand each of this. So what is marginal probability? Marginal probability is the probability of occurrence of a single event. If I flip a coin, it is going to be either a head or a tail. That occurrence of that single event is called as a marginal probability. So for example, I have a deck of cards here and I randomly take out a card from there and I want it to be a heart card, right? So that will be the probability, which is 13 by 2, and it can be expressed by this particular formula. So once we are done with marginal probability, let's go to joint probability. What is joint probability? It is the measure of two events happening at the same time. So the same example over here, I have a deck of cards out of which I want to take out the ace, which is a hearts. So it has to be a ace card and it has to be a heart card, which will be the probability giving me 1 by 52. So now that we've understood what is joint probability, let's understand what is conditional probability. So the probability that depends on something already happened is called as the conditional probability. It is basically the outcome of the event is based on the occurrence of a previous event or an outcome. Conditional probability of an event B is the probability that an event will occur given that A event has already occurred. What are the two types of formula that we have in conditional probability? If A and B are dependent events, then the expression for the conditional probability is given by P of B by A is equal to P of A and B divided by P of A. If A and B are independent events, that means the expression will be P of B only. So it is just the probability of B occurring. Whereas if they are dependent events, means that if you want to find the probability of B, A already has to be occurred. So it is a probability of A and B divided by the probability of A. So that is basically all the introduction that was required from probability. We now have Bayes' theorem. So what is Bayes' theorem? It shows the relationship of one conditional probability and its inverse. What is Bayes' theorem? It shows the relation between one conditional probability and its inverse. So this is the formula, that is P of A by B is equal to P of B by A into P of A divided by the P of B. So what does this particular thing mean? So what we are trying to find out is the probability of the occurrence of A given that B has already occurred is equal to the probability of B occurring when A is already there and the P of A, which is the prior probability, which is something that we already think of, and then the probability of B occurring. So this is basically what the Bayes' theorem is. Let me give you an example for it, okay? Suppose you're a doctor and you're running a clinic where you test if a patient has a liver problem or not. All the previous patients that had come to you, out of them 10% of your patients had liver problems. Okay, so all the patients that had come before, they had around 15% probability that they were drinking. So now we have found out the probability of A and probability of B, the prior probability and the probability of B. So what was the probability that out of all of those patients, even though they had a liver problem, they were drinking? It is 5%, which is P of A by B. Hence, the Bayes' theorem says that the probability that a new patient, whoever is entering, will have a particular liver disease is calculated by 0.05 into 0.10 divided by 0.15 is equal to 3.33%. What this means is that if a new patient is going into the clinic, there is a chance of 3.33% that that particular person is also having a liver problem. This is basically how the Bayes' theorem works. So what are the applications of probability? Probability helps you to optimize your model. Classification of our algorithms also requires probability. The loss can also be calculated using a probability. Then models are built on probability. So let me show you how the naive Bayes classifier works over here. So let me go to naive Bayes. This is the naive Bayes classifier. So let me tell you what I have done over here. I have imported the data sets, the metrics, and all the required naive Bayes classifier, and I've imported the Gaussian naive Bayes classifier. The Gaussian is also another name for the normal distribution. Okay, so normal distributions are also called as the Gaussian naive Bayes classifiers. And why I have done this is because I had visualized it and I came to know that it was a normal distribution. Okay, so I load the iris, that is the load iris dataset, and I load a model. And then I'm just going to fit the model. Okay, then I'm going to get the predicted model of it, and then I'm just going to basically find all the metrics of it. So basically, let me show it to you. What is the precision, recall of all of that? So this is all the accuracy. Then my model has an accuracy of 96%, and this is the confusion matrix, which means that out of 50 it was able to classify all the 50 correctly. Then out of 50 it classified 47 correctly and 3 were wrong. And then out of 50 again over here, 3 were classified wrong and 47 were classified correct. So this is the naive Bayes classifier. So as you can see, probability is actually being used in all of this. The Gaussian naive Bayes classifier already does all of that, so we do not need to worry about it much more. So now that we have finished up everything that we needed to do from probability, let's move over to the last topic for today, statistics. What is statistics? Statistics is an area of applied mathematics concerned with data collection, analysis, interpretation, and presentation. What this means is that you are going to analyze, understand all the data that you've collected and how you're going to present it. So for example, your company has created a new drug that may cure cancer. How would you conduct a test to confirm the drug's effectiveness? What are you going to do? You are basically going to collect a large amount of people around. You're going to take all of those people. You're going to, give them basically the new drug that you have created, and then you're going to interpret all the results that you get from it, and then you're going to present that out of, let's say, 1,000 people, around 900 of them were cured or 950 were cured. So all of those parts come under statistics. Okay. So I hope you've understood that. What are the terminologies that you need to understand when you work with statistics? There is population and there is sample. So what is population? It is the collection or a set of individuals or objects whose properties are to be analyzed. All the data that you have collected is called as the population. So out of all the data that you've collected, you take out a set of data for your analysis. That set of data is called a sample. So what is a sample? A subset of the population is called as a sample. So a well-chosen sample will contain most of the information about the population parameter. So how do you choose the sample? The sample needs to be chosen such that all the data that the population is trying to convey can be conveyed through the sample itself. So that is what is population and sample. Now that we've understood the basic terminologies, let's look at some of the sampling techniques that we have in statistics. So sampling can be classified as probabilistic and non-probabilistic type of approaches. So in probabilistic sampling, we have random sampling, systematic sampling, and stratified sampling. In non-probabilistic one, we have snowball, quota, judgment, convenience, and all of that. Okay. So, but for machine learning, we do not need to take a look at the non-probabilistic approach. We just need the probabilistic approach. So we will be now covering about random sampling, systematic sampling, and stratified sampling. So let's go ahead with that. So what is random sampling? You take out a sample randomly out of the population. That is basically what is random sampling. Each member of the population has an equal chance of being selected in the sample. So that is what is random sampling. So what is systematic sampling? Systematic sampling is basically you follow a particular order out of which how the sample has to be taken. As you can see here, I have 6 particular groups. Now from this 6 particular groups, I'm going to take all the even ones, right? So that will be 2, 4, and 6. That is basically how the systematic sampling works. I follow a system. I follow an order of how I'm going to take the sample. So once we are done with that, what is stratified sampling? What is a stratum, first of all? A stratum is basically a subset of the population that shares at least one common characteristic, which is the gender, which I have taken over here. So as you can see here, I have the whole population, out of which I have found out one property that is common between all of them. That is gender. They are either male or female. So I'm going to break the whole population based on that. I'm going to break my population into the male subset and the female subset. So after that, I'm going to apply the random sampling and I am going to take out all the samples that I am going to be needing. Okay. So once I have now broken down my particular subsets, now I'm just going to be using random sampling and take out all the samples that are required by me. So this is what is stratified sampling. So what are the types of statistics that we need to infer from? We have descriptive statistics and inferential statistics. So let's understand each of these right now. Okay. So what is descriptive statistics? Descriptive statistics is mainly used to focus upon the main characteristics of the data. It provides the graphical summary of the data. So as you can see over there, descriptive statistics uses the data to provide descriptions of the population, either through numbers or calculations or graphs or tables. Okay. So as you can see here, I have my shirt and there can be either 3 particular sizes. There can be the most minimum one, the most average one, and the most maximum one. And all of that is based on the weight of the person. Suppose, for example, if a person weighs 60, he's going to get the maximum one. If the person weighs 40, he's going to get the average one. The person weighs 20, he's going to get the minimum one. So that is how I am describing my data and I'm going to infer data from it. So that is descriptive statistics. So what is inferential statistics? Inferential statistics makes inferences and predictions about a population based on the sample that is being taken from it. So what this means is basically I'm going to generalize a large data set and apply probability and draw a conclusion to it. So it allows me to, infer data parameters based on the statistical models which is using the sample data. I have a whole bunch of population out of which they can tell me they have either the large size or the medium size or the small size. So according to their sizes, I'm going to supply them the t-shirts. So this is basically what are the two types of statistics. There are descriptive statistics and inferential statistics. Descriptive statistics, what does it do? It describes the data. Whereas inferential statistics takes information from the data and then analyzes accordingly to however we want it to. So these are the two types of statistics. Let's go in depth with descriptive statistics. What is descriptive statistics? It is used to describe and understand the features of a specific set of data. So what is descriptive statistics? It is a method used to describe and understand the features of a specific data set by giving short summaries about the samples and measures of the data. In descriptive statistics, it is broken down into the measures of center and the measures of variability. So what does measures of center have? Measures of center has the mean, median and the mode. Whereas the measures of center have the range, interquartile range, variance and standard deviation. So let's understand all of this right now. So for example, here you can see that I have a data set of a car which contains the variables, the car, the mileage, the cylinder type, the displacement, the horsepower and the real axle ratio. So I'm going to find out the mean. So what is a mean? Mean is the average of all the samples. So for example, if I want to find the mean of the horsepower, I'm going to just add the values and divide it by the number of values. So I get 103.625. This is the mean of the horsepower. So what is the median? It is the measure of the central value of the sample set. That is what is a median. So let me show you how to find it for the miles per gallon. To find the order of the center value, you have to basically arrange it in the ascending order. Okay. So you have 21, 21, 21.3, 22.8, 23 and accordingly. Now I have to take the two middle values. Okay. So that will be 22.8 plus 23 divided by 2. That becomes 22.9. So that is the median of my sample. Next, let's move over to mode. The value which is most recurrent in the sample set is called as the mode. So let me find the mode for the cylinder type. What is most recurring? The 6-stroke or the 4-stroke? I can see here that there are 1, 2, 3, 4, 5. So there are 5 times that the cylinders type of 6-stroke has been repeated and 3 times cylinder type 4-stroke has been repeated. So 6 becomes the mode of the data. Okay. So now that we have understood all that is required from measures of center, let's move over to the measures of spread. So a measure of spread is also called as a measure of dispersion, is used to describe the variability in the sample or the population. Okay. So the first one is a range. Range is the given measure of how spread apart the values are in a data set. So it is the maximum value minus the minimum value, which gives us the range. So what is an interquartile range? Quartiles tell us about the spread of the data by breaking the data into many quarters, just like the median breaks itself. So for example, if I have 8 datas over here, I can break it down into 3 quarters where I have a 1, 2, then I have 3, 4, 5, 6 and 7, 8, which become different samples accordingly. Okay. How do I find what is the interquartile range? So how will I find the interquartile range of this? Okay. So the first quartile Q1 comes between the 25th and the 26th. So it'll be 45 plus 45 divided by 2. That becomes 45. The second one comes under 50 and 51st. And that will be 58 plus 59 by 2. That will be 58.5. And the next one comes at 75 and 76. That is 71 plus 71 divided by 2, which is always 71. So that is basically what is an interquartile range. It is the measure of variability based on the dividing set into the quartiles. So that is basically how you break down the interquartile range, and it is the measure of variability based on dividing the set into quartiles. So quartiles divide a rank ordered data set into 4 equal parts, which would be Q1, Q2 and Q3 respectively. And the interquartile range is measured by Q3 minus Q1. So if you can see this, you have the whole data which is 100% and you have broken down the data into 25% each. So the quartiles come in between the first Q1, Q2 and Q3. So those are the interquartile ranges. So now that we've understood that, let's move over to variance. So variance describes how much a random variable differs from its expected value. It entails the computing squares of the deviations. So that is how you find the variance, which is s square is equal to the summation of 1 to n is equal to 1, xi minus x bar the whole square divided by n. So xi is the value and x bar is the mean. I hope that's simple for you to understand. What does a variance mean? It means the difference between the data which it should have actually been. So what does the variance actually try to tell you? Okay, it basically means that the data which should have been something and what it really is, what is the difference between them, how much it differs from each other. So that is what is the variance. So what is a standard deviation? Deviation is the difference between each element from the mean. So I have xi and I have the mean. What is the difference between each of them is the deviation. So what is the population variance? The population variance is given by this particular formula, that is sigma square is equal to 1 by n. The whole summation of I is equal to 1 to n is equal to xi minus mu the whole square. Once we have found out the population variance, what is the sample variance? So it is s square is equal to 1 divided by n minus 1, the summation of I equal to 1 to n, and xi minus x bar the whole square. That is the sample variance. So what is the standard deviation? Standard deviation is the measure of the dispersion of a set of data from its mean. What the standard deviation is trying to tell you is basically that how much this data is trying to disperse from its actual data. So how is that given by? It is given by 1 divided by n, summation of I equal to 1 to n xi minus mu the whole square, which is basically the variance's square root. So that is standard deviation. So how do you find the standard deviation? I'm just going to give you an example over here. So say for example, Daenerys has 20 dragons and they have the numbers accordingly. So how do you work out the standard deviation? So the mean is given by adding all the numbers, dividing it by 20. So mu is equal to 7. And then what is the standard deviation? So it'll be xi minus mu the whole square. So it'll be 9 minus 7 the whole square is equal to 2 square is equal to 4. Then you have 2 minus 7, all accordingly. You keep on going and you get the following results, which is 4, 25, 4, 9, 25, 0 accordingly. Once you have done that, put that into the formula. So you have this formula accordingly. So we get the variance square is equal to 8.99 and the standard deviation will just be the square root of 8.9, which will be 2.983. What this means is that with a value of 2.983, the values are differing from the mean. So if you are trying to add 2.983 to all the other values, you will be getting something which is much more similar and much more realistic and much more, closer to the mean of the. So that is how standard deviation works. Now that we've understood all of that, we have a very classic example of information gain. So what does information gain help us with? This is an ideology that comes into picture for decision trees. So let's understand the basic concepts of what we require in information gain. So the first topic that we need to understand is entropy. So what is entropy? Entropy measures the impurity or uncertainty that is present in a data, and it is given by the formula h of s is equal to minus summation of minus 1 to the power of n p of I log base 2 p of I, where s is all the instances in the data set, n is the number of the distinct class values, and p of I is the event probability. Because entropy is the impurity that a data has. So what is information gain? Information gain is how much information a particular feature will give to the final outcome. So that is given by gain of a of s is equal to h of s, which is the entropy, minus summation of j is equal to 1 to v, s of j divided by j into h of s of j is equal to h of s minus h of a by s. H of s is the entropy of the whole data set. S of j is the number of instances with j and a value of attribute a. S is the total number of data sets. V is the distinct value of attribute a. H is the entropy of the data set with value a and entropy of attribute a. So these are all the requirements. So let me give you an example of information gain. You can see the data set over here, which is for 14 days and the particular, attributes that are given to it. So the forecast is to find out whether the match will be played or not according to the weather conditions. So this is what we are trying to find. Here we have 5 no's and 9 yeses. So we have the outlook, and then we have sunny, overcast, and rainy. So in sunny, we have 3 no's and 2 yeses. In overcast, we have 4 yeses and 0 no's. And in rainy, we have 3 yes and 2 no's. So how are we going to find out which particular node is going to, attribute the most to it? So let's find out the entropy first for the whole data, which is 9 instances say yes and 5 instances say no. So we have a minus 9 by 14 log base 2 of 9 by 14 minus 5 by 14 log 2 of 5 by 14 is equal to 0.940. So what this means is that the data that we have has 0.940 times bad data. Means it cannot give us much information. There is much more impurity in the data. So let's move over. The first step in information gain is to find the root variable. So how are we going to find the root variable? We are going to take all of the attributes and find the information gain from them. We have outlook, we have windy, humidity, and temperature. So let's find out the information gain. So for information gain of windy, we have 6 instances true and 8 instances false, right? So h of s is equal to 0.940 minus 8 into 14, and as you can see, all the other variables. So the gain that we have achieved from windy is 0.048, which is really less. So for outlook, the same thing happens over here. We have the information gain that is being passed by it is 0.247. Then we have the information gain from humidity, that is 0.15, which is also really good. And then we have temperature, which is 0.029. You can pause and look at the steps if you want to. Out of all the gains that we have, the variable with the highest information gain is used to split the data. So outlook has 0.247, windy has 0.048, gain has 0.151, and gain of temperature is equal to 0.029. So what are we going to choose? We are going to choose outlook. Why is that? It's because it has the highest information gain. So that becomes our root node. That is a simple example of how statistics is used in the information gain. Next, let's move over to the confusion matrix. So what is a confusion matrix? Confusion matrix is a table that is often used to describe the performance of a classification model. So it is a table that is used to describe the performance of a classification model on the set of test data. So how are you going to calculate the accuracy of this? It will be true positives plus true negatives divided by true positive, true negative, false positive, false negatives. So if you are confused with what is true positive, true negative, false positives, false negatives, let me explain that to you right now. Let's say, for example, there are 2 possible predictor classes which are yes or no. The classifier made a total of 165 predictions. That means 165 predictions were total. So out of the 165 cases, the classifier predicted yes 110 times and no 55 times. So in reality, 105 patients only had the disease and 60 patients did not. So how are we going to put this into the table? So as you can see here in the table, we have n is equal to 165. Then we have predicted no and predicted yes, actual no and actual yes. So if our classifier predicted it no and it was actually no, that is the correct output. If it predicted yes and it was actually yes, that is also the correct output. But it predicted it as yes and it was actually no, that means it has made a mistake. And it predicted no but it was actually yes, it has still made a mistake. What are the correct values over here? Which is 50 and 100. So 50 and 100 are the correct values and 10 and 5 are the wrong values. What is a true positive? True positive are which it was predicted as yes and they actually have the disease. True negatives are predicted no and they did not have the disease. False positives are classifier predicted it as yes but they did not have the disease, and false negatives we predicted no but they also had the disease. So this is basically what a confusion matrix is, and it is helpful in finding out the performance of the classifier that you are working with. So that is what is a confusion matrix. Next comes inferential statistics. It is a method where we infer and understand what the data is trying to communicate with us. So it is broken down into 2 points. It is a point estimation and interval estimation. So let's understand about point estimation. Point estimation is concerned with the use of a sample data to measure a single value which serves as an approximate value or the best estimate of an unknown population parameter. So you have such a huge population of India, right? Out of that, you're just going to randomly take out some sample of it. You're going to find out the sample mean, and this sample should be so good enough that it is going to estimate the whole mean of the population. So this is how you use point estimation and try to approximate it for the whole, population. So what are the different methods? We have methods of movement, methods of likelihood, Bayes estimator, and best unbiased estimators. So estimates are found out by equating the first k sample movements to the corresponding k population movements, which is the method of movements. And then we have the maximum of likelihood, which uses a model to maximize a likelihood function. Bayes estimator minimizes the average risk, and it is an expectation of all the random variables. And then we have the best unbiased estimators, which is used to find out the best depending parameter. So that is all that we require from point estimation. Let's move over to interval estimates. So an interval or a range of values is used to estimate the population parameters. So we have a point estimate and we have an interval which gives us the low confidence and the high confidence limit. How is this going to happen? There are three things that you need to remember. There is something called as the confidence interval, and it is the measure of your confidence that the interval estimate contains the population mean mu. So statisticians use a confidence interval to describe the amount of uncertainty associated with a sample. Technically, a range of values are so constructed that it is specified probability of including the true value of a parameter within it. So for example, let's take a sample where we have 10,000. So let's say that we have something called as a supermarket. So out in that supermarket, we have collected a lot of data. And in that data, I'm saying that this particular items, okay? So item 1 and item 2, if they both are kept together, they are going to be sold together. And I say that with 90% confidence. So that 90% confidence, okay, is what is my confidence interval. It can be in between this range. It can be between 90 to 95%. And between 90 to 95%, it is highly likely that that particular thing is going to happen. So that is my confidence interval. So what is the sampling error? It is the difference between the point estimate and the actual population parameter, which is the sampling error. Okay. So when mu is estimated, the sampling error is mu minus x bar. It is mean minus the point. What is the margin of error? So for a given level of confidence, it is the greatest possible distance between the point estimate and the value of the parameter it is estimating. What this basically means is that it is the greatest possible distance between what you have predicted and what it actually is, and what level of confidence you are giving to it. Okay, so that is the margin of error. How much error you can allow for the predicted model is what is the margin of error. So I hope you have understood that. So the level of confidence is the probability that the interval estimate contains the population parameter. So as you can see here, all the parameters that come under C, right, are what we are allowing. Okay, that is the margin of error that is allowed. But whatever comes in minus ZC and plus ZC, we are not going to take that. Those are the interval estimates. So finding these intervals is what is our probability. So finding these interval estimates is what is our work over here. Okay. So for example, if the level of confidence is 90%, this means that you are 90% confident that the interval contains the population mean. 0.05 and 0.05 of minus ZC and plus ZC is equal to plus 1.645 and minus 1.645. Those are the Z scores. Anything minus or plus of 1.645 is not allowed. So those are the values that we are concerned with when we are working with interval estimates. So now that we have understood everything we needed to from inferential statistics and descriptive statistics, let's move over to hypothesis testing. So what is a hypothesis first of all? It is some event that you have made up which may have the probability of happening or not happening. Testing that hypothesis is what is hypothesis testing. Is, formally checking whether this hypothesis is accepted or rejected. So how is the hypothesis testing conducted? You first state the hypothesis, and then you formulate an analysis plan of how you are going to test this particular hypothesis. Then you get all the output, you analyze the data that you've got from all of it. So then you understand whether this particular hypothesis has failed or it is a good hypothesis. Okay, suppose I have 4 boys over here, which are Nick, John, Bob and Harry. So they were caught doing mischief in the class and they have to now serve detention for almost 2 months. Okay, the detention is basically they have to clean the classrooms. So John over here comes up with an idea saying that I'm going to write all the names of ours into chits and then put them into a bowl. Whoever name comes out has to clean the classroom. So what happens here, that we are going to assume that the event is free of bias. So our hypothesis is, what is the probability of John not cheating? Let's find out what happens actually. The probability of John not being picked up for a day is 3/4. Now the probability just keeps increasing on and on if he is not picked up for 3 days. Okay, so it is 3/4 into 3/4 into 3/4 is equal to 0.42 approximately. And what is the probability of John not being picked up for 12 days? It is 3/4 into 12 is equal to 0.032, which is equal to 3.2%, which is less than 0.05, which is 5%. So what this means is that our hypothesis was that John is not cheating, but actually John is cheating over here because it has come down and it has come below the threshold value of 5%, which is 3.2%. So now all of us have come to know that John is cheating because he has not even written his name in the chits. So this is how the hypothesis works. So what is the null hypothesis? The hypothesis that we have created in the beginning, okay, that John was not cheating, that was a null hypothesis. It has no result which is different from the assumption. And we have an alternate hypothesis, which means that our results disapprove the assumption. We had a hypothesis that John is not cheating, but actually through our results we found out that John is cheating. So this is what is the hypothesis testing. And we have a threshold value. If the probability that we are testing goes below this threshold value, it means that the particular hypothesis has failed. So this is what is the hypothesis testing. So now we need to know something about the P and T values. Okay, what is the P and T values? The P value and the T value help us in our hypothesis testing. Okay, we want to find the height of students who are greater than 5 feet and 7 inches. Okay, so we take a sample of 100 students and find that the mean height was 5 feet and 9 inches. Okay, we make a hypothesis that out of all the 100 students, there is going to be at least 6 students who are greater than 5 feet and 9 inches. So this is our P value. It is the probability value that we are saying that this particular hypothesis is going to be correct. We say that at least out of 100 times, 6 students will at least have a height which is greater than 5 feet and 9 inches. Okay, so this is the P value. This is the probability value that we have given to a hypothesis. The T value is testing this particular hypothesis and finding the difference that we have found out from our assumption and what we have actually calculated from our results. So this is how the P value and the T value help in making the null and alternate hypothesis. You find the result of the null hypothesis and the alternate hypothesis. So this is how the P and the T values help in making and observing the results from the null and alternate hypothesis. Okay, let me show you a code where we are going to find the mean, median, mode accordingly and how that becomes helpful to us. Okay, so let me go back to the presentation mode. I have my data over here, which is this particular data. So I'm going to import statistics as S and I'm going to just find the mean, median, mode of it. So let me just run this program for now. So as you can see here, the mean is 33.43 and the median is 3 and the mode is 2. 2 has been repeated the most number of times, so that is the reason it is the mode. And the variance is 5124 and the standard deviation is 73. That is how the mean, median, mode is calculated. Let me run the program now so that you can understand what we are trying to do. So let me close this out. What's happening over here is I have the iris data, which is the load iris, and then I am creating it into a data frame. Okay, simple enough. After that, I am saying that the species is the target and the data of species is equal to, I am going to just apply all the lambda parts of it, okay? And then I am going to get the description of the data. And after that, what I'm going to do is I'm going to take this data and I'm going to pair plot it. And then I'm going to show the plot to you. So let me run the program. Let me show you the figure first. So I had 4 features over here, right? So that was the petal length, petal width, sepal length, and sepal width. So if you can take a look at this data, you can see that there is a normal distribution here. There's a normal distribution here. Also, there's a normal distribution over here with some exclusions over here. And there is a normal distribution here too, but with some exclusions here. So looking at this, I will be able to understand if I want to, apply the Gaussian naive-Bayes classifier or accordingly to however I wanted to. So this is how statistics has helped me to understand what is my data looking like. Now let me go back over here. So as you can see, this is the count of a 150, right? Simple enough. Then what is the mean? What is the standard deviation? What is the maximum length and maximum width that you can find over here? All of this is done using the describe part of it, okay? And describe is a function that is already available in Pandas. So that was a very simple example of how I was able to understand how I have to use the Gaussian naive-Bayes classifier for my iris data, which I showed in the probability part, right? Now we are done with this.
So what exactly is predictive analysis? Predictive analysis is the branch of data analysis which is mainly used to predict future events or outcomes. It is solely based on data-driven approaches and techniques to reach to conclusions or solutions. The analysis mainly makes use of analytical techniques and predictive modeling in order to find relevant patterns in large datasets. In turn, these patterns can be used to make various opportunities in the businesses by identifying risk and benefit points, etc. Predictive analysis is an anticipatory technique for forward-looking solutions and insights to assess any situation. Most of the processes in the predictive analysis incorporates the machine learning terminologies and algorithms for model building, especially to train the models. So it is significantly important to understand how to choose these predictive techniques for model building. And as a beginner, it can help you a lot along the way. So let us quickly take a look at why we do predictive analysis, and I'm sure most of us are aware of the significant increase in the generation of data all around us. It has seemingly become quite clear since we are seeing a lot of data-driven approaches. But humankind has been storing data since a very long time. Documenting every detail has been a prevalent practice. With the digital age, it has become to process the data a lot more easier as well. But it has also opened a lot of opportunities for the years and years of long and unprocessed data. To understand the relationship between various aspects of the data and make use of it in real life as well. We can use this data for various purposes. We have like risk and fraud detection, then there's market analysis, operational movements, operational improvements, campaigning, etc. And one simple example is to use the weather data to study the patterns and use predictive analysis based on the insights to predict the future events. So let's take a look at a few predictive analysis techniques as well. First of all, we have regression, guys. So the main goal of regression is the construction of an efficient model to predict the dependent attributes from a bunch of attribute variables. A regression problem is when the output variable is either real or a continuous variable. That can be weight or area or salary, etc. We can also define regression as a statistical means that is used in applications like housing, investing, etc. It is basically used to predict the relationship between a dependent variable and a bunch of independent variables. And simple linear regression is a regression technique in which the independent variable has a linear relationship with the dependent variable. It is basically a technique to analyze data set which has a dependent variable and one or more independent variables to predict the outcome in a binary variable, meaning it will have only two outcomes. And the dependent variable is categorical in nature. Dependent variable is also referred as target variable, and the independent variables are called as the predictors. Logistic regression is basically a special case of linear regression where we only predict the outcome in a categorical variable. It predicts the probability of the event using the log function. Next up, we have classification, guys. So classification is the process of categorizing a given set of data into classes, and it can be performed on both structured or unstructured data. The process starts with predicting the class of given data points, and the classes are often referred to as target, label, or categories. The classification predictive modeling is the task of approximating the mapping function from input variables to discrete output variables. And the main goal is to identify which class or the category the new data will fit into. Now let us try to understand this with a simple example, guys. So a heart disease detection can be identified as a classification problem, and it's a binary classification since there can only be two classes, which is basically has a heart disease or does not have a heart disease. So the classifier in this case needs training data to understand how the given input variables are related to the class. And once the classifier is trained accurately, it can be used to detect whether heart disease is there or not for a particular patient. Since classification is also a type of supervised learning, even the targets are also provided with the input data. And then we have clustering, guys. So clustering is basically, dividing data points into homogeneous classes or clusters. So the points in the same group are as similar as possible, and then the points in different groups are as dissimilar as possible. So when a collection of objects is given, we put the objects into group based on similarity. So that is what clustering is all about. And then we have another technique which is time series, guys. So the time series model comprises a sequence of data points captured using time as the input parameter. It uses the last year of data or the previous data to develop a numerical metric and predicts the data using that metric. It is basically a means of understanding a singular metric is developing over time with a level of accuracy beyond simple averages. So it also takes account seasons of the year or events that could impact the metric as well. And next up we have forecasting. So forecasting is nothing but using the historical data to make predictions or numeric predictions on a new data based on the learning from the previous data. Now that we know what these various techniques are, let us understand how to choose which one would be the best one for us while working on any data. So there are a few factors that you should consider while choosing a model. But before that, before talking about the deciding factors, let us go through the processes before predictive analysis before you start building the model. First up, we have the problem statement, guys. So problem statement tells a lot of things about the project or how you should approach it. If you're looking at the problem statement, you'll be able to know what kind of target you're looking at. So in a heart disease condition, guys, let's say for an example, we have a problem statement to decide or to analyze or predict if a patient has a heart condition or not. So with that said, we have already figured out the target variable, which is going to be categorical in nature, which means it basically will have only two values. That is, one has a heart disease or does not have a heart disease. So it becomes quite clear to us in the problem statement only. We're going to use the classification technique in this particular example. But then there are a few problems where you will not be able to figure out which kind of target variable you will be choosing or what are all the independent factors will be involved in your analysis. So you move on to the next one, which is extraction and loading. And you basically analyze all your data, and transform it and try to make use of all the information that you get from visualization and all these processes to understand what kind of variables you're looking at. And then comes the factors to consider before going for the model, which is what is the target variable. So if the target variable is continuous, you should go for the regression analysis. And if the target variable is categorical, you can go for the classification analysis. And if you're not able to find a target variable, don't worry guys, you can probably go for a clustering analysis. So you'll know which points are similar, which points are not similar, making it a classification or, making clusters. And then you can perform classification on those clusters as well. The next question you should be asking is your data linearly separable? And there is no direct way to actually determine it. So we can go ahead by choosing different models. I mean, you can compare different models to see if your data is actually linearly separable or not. Then the next factor would be the size of the data. You have to look for factors like the size of data to determine the possibility of overfitting and underfitting the model. Also, some models may not work efficiently with small data. So these are some deciding factors for choosing a model before you train the model with the training data. And let us take a look at a few machine learning models so that we can use for predictive analysis. The first one is linear regression. So linear regression is to be used when the target variable is continuous and the dependent variable or variables is continuous or a mixture of continuous and categorical. And the relationship between the independent variable and the dependent variable has to be linear. So that is when you know when you can use a linear regression. After that, we have logistic regression. So logistic regression does not require a linear relationship between the target variable and the dependent variables. The target variable is binary, assuming a value of either 1 or 0 or maybe true or false or something, or dichotomous as well. Then we have the k-means clustering model, guys. So k-means involves placing unlabeled data points in separate groups based on similarities, and this algorithm is used for the clustering model as well. After that, we have neural networks. So neural networks help to understand or help to cluster and classify the data, guys. So these algorithms are modeled loosely after the human brain and are designed to recognize patterns. Then we have decision tree. So a decision tree is a map of the possible outcomes of a series of related choices. It allows an individual or organization to weigh possible actions against one another based on their costs, probabilities, and benefits. As the name goes, it uses a tree-like model of decisions, and they can be used either to drive informal discussion or to map out an algorithm that predicts the best choice mathematically. After that, we have time series, guys. So the time series regression analysis is a method for predicting future responses based on response history. And the data for a time series should be a set of observations on the values that a variable takes at different points in time. So these are a few models that we have for predictive analysis, and these are only a few models, and there are other models also that we can use for predictive analysis. And with that said, let's also see a few applications of predictive analysis. So we can use it for finance, guys. So predictive analysis in finance can help in identifying the risk detection or the risk detection model to identify any fraudulent transactions or loans that you can detect using the predictive analysis. Then there is stock prediction as well. You can gather a lot of data in time and forecast a prediction that can be taken into account for different stocks. And there goes a lot of process behind this, but for as far as the application goes, stock prediction is a pretty good application of predictive analysis in finance. Then we have governments, guys. So governments are using predictive analysis for campaigning. They're using it for weather detection, weather prediction. There is disaster management. They're using predictive analysis for predicting the impact of policies, different policies that they're making, and they're making surveys, etc. We can use the predictive analysis in healthcare for early detection of diseases such as cancer, any heart ailments that may or may not be a part of your life several years later. So it helps in predicting all those diseases or conditions at an early stage. And we can also use predictive analysis in manufacturing. We can actually identify production failures and work on it using the prediction analysis. Then there is sport franchisees using predictive analysis to predict the outcome of certain events in the leagues or something like that. They're trying to make sense of what kind of match they have the best probability or the best prediction of winning, the chances of winning they have, or if they don't have any winning chances, what are the the basic points or basic insights that they're getting from the data that they should work on to win that particular game or a match or a league. And then we have telecom industries using predictive analysis for customer support. They're trying to segregate or segment the customers into groups that they are able to work on them based on their prediction. Let us understand what regression in machine learning is. So what exactly is regression? The main goal of regression is the construction of an efficient model to predict the dependent attributes from a bunch of attribute variables. A regression problem is where the output variable is either real or a continuous value like salary, weight, area, etc. We can also define regression as a statistical means that is used in applications like housing, investing, etc. to predict the relationship between a dependent variable and a bunch of independent variables. For example, let's say in the finance application or investing, we can actually predict the values of certain stock prices or those values depending on the independent variables, like how many years it takes for a stock to actually mature, or how many days will it take to grow, or those variables that you have in investing, and depending upon that we can make a possible outcome or a possible prediction of how our stock is going to be invested in a profit state or a loss state or all those things. Or we can take another example like housing. We can take different parameters like number of years it's been there, how many people have used it, or what is the area of the house. Depending on all these factors or how many rooms does a house have, we can predict the price of a house. So this is basically what regression really is. So let us take a look at the various types of regression techniques that we have. We have simple linear regression, then we have polynomial regression, support vector regression, decision tree regression, we have random forest regression, and we have logistic regression as well. That is also a type of regression that we have. But for now, we'll be focusing on simple linear regression. So let's talk about how or what exactly is simple linear regression first. So one of the most interesting and common regression technique is simple linear regression. In this, we predict the outcome of a dependent variable y based on the independent variables x. So the relationship between the variables is linear, hence the word linear regression. Then comes the polynomial regression. So in this regression technique, we transform the original features into a polynomial feature of a given degree and then perform regression on it. So this is basically polynomial regression. After this, we have support vector machine regression, or we can also call it SVR. We identify a hyperplane with maximum margin such that the maximum number of data points are within those margins. It is also quite similar to the support vector machine classification algorithm. Then we have decision tree regression. A decision tree can be used for both regression and classification. But in this case of regression, we use the ID3 algorithm, which is iterative dichotomizer 3, to identify the splitting node by reducing the standard deviation. After this, we have a random forest regression, which is basically an ensemble of predictions of several decision tree regressions. So this is all about the types of regressions. For now, we are going to focus on simple linear regression. So let's take a look at what exactly is a simple linear regression. Simple linear regression is a regression technique in which the independent variable has a linear relationship with the dependent variable. The straight line in the diagram is the best fit line, and the main goal of the simple linear regression is to consider the given data points and plot the best fit line to fit the model in the best way possible. So if we talk about a real life analogy to explain linear regression, we can take an example of a car resale value. So we have different parameters, when we are talking about a resale value of a car, like how many years the car has been there in the market and how many kilometers it has been ridden, the kind of mileage the car gives, and then we have different parameters we can focus upon, and all these independent variables somehow are linearly connected or interconnected to the price of the car. So that is one example to understand linear regression. We'll be doing that in the use case. I'll be telling you about how you can predict the price of car. Now talking about linear regression terminologies, there are a few terminologies you have to be thorough with to begin with linear regression. So first of all, we have to talk about cost function. So the best fit line can be based on the linear equation that is given here. So in this, the dependent variable that is to be predicted is denoted by y. A line that touches the y-axis is denoted by the intercept b0. The b1 is the slope of the line, and x represents the independent variables that determine the prediction of y. The error in the resultant prediction is denoted by e. Now talking about cost function, the cost function provides the best possible values for b0 and b1 to make the best fit line for the data points. We do this by converting this problem into a minimization problem to get the best values for b0 and b1. So with this, the error is minimized in this problem between the actual value and the predicted value, and we choose the function above to minimize. Now we square the error difference and sum the error over all the data points. The division between the total number of data points and the produced value provides the average square error for all the data points. It is also known as mean squared error, and we can change the values of b0 and b1 so that the MSE or the mean squared error value is settled at the minimum. So this is one terminology, that is cost function, that we use in linear regression. Then we have the gradient descent. So the next important terminology to understand linear regression is gradient descent, of course, and it is a method of updating b0 and b1 value to reduce the MSE, which is the mean squared error. The idea behind this is to keep iterating the b0 and b1 values until we reduce the MSE to the minimum. Now to update b0 and b1, we take the gradients from the cost function, and to find these gradients, we take partial derivatives with respect to b0 and b1. And these partial derivatives are the gradients and are used to update the values of b0 and b1. I'm sure guys this might be a little confusing for you guys if you are new to this, like gradient descent and cost function, but you don't have to worry about this, because in Python when we're using a linear regression, we're going to be using the sklearn or the scikit-learn library, so you don't have to worry about this. You just have to integrate your model with the linear regression module that we have already over there, and you will be done with it. And when I'm implementing the linear regression model, you'll see how easy it is to actually implement linear regression in Python. So after this, let's talk about a few advantages and disadvantages of linear regression. So talking about the advantages first, linear regression performs exceptionally well for linearly separable data. And it is actually very easy to implement, interpret, and very efficient to train as well. And even though the linear regression is prone to overfitting, it handles it pretty well using dimensionally reduction techniques, regularization, and cross-validation. And one more advantage is that the extrapolation beyond a specific data set. So these are all the advantages that we have with linear regression. Let's talk about a few disadvantages as well. So one of the most common disadvantage with linear regression is that it takes the assumption of linearity between dependent and independent variables. The next disadvantage is it is often very prone to noise and overfitting as well, which is not a very good sign for any model if you are doing regression or classification in machine learning. The next disadvantage is it is very quite sensitive to outliers as well. And the last one is that it is very prone to multicollinearity. So these are all the advantages and disadvantages of linear regression.
What is the least squares regression method? Now, the least squares regression method is a technique which is used in regression analysis. Now guys, regression is a very common type of machine learning problem. So regression analysis usually falls under the category of supervised machine learning. And the least squares regression method is a mathematical method that is used to find the best fit line which can represent the relationship between two variables, right? One is an independent variable and the other is a dependent variable. That's what regression is all about. Linear regression is about finding your relationship between two variables in which one is a dependent variable and the other is an independent variable. To understand the least squares regression method, let's get familiar with the concept involved in formulating the line of best fit, right? Let's understand what exactly do you mean by line of best fit, because this is the most important part of the least square regression method, right? So first let's understand that and you'll finally understand what exactly we mean by least square regression method. So the line of best fit is basically drawn across a scatter plot of data points in order to represent a relationship between these data points, between two or more variables basically. So to be more specific, a line of best fit will basically represent a relationship between two or more variables. So basically regression analysis makes use of mathematical methods such as least square regression in order to get a definite relationship between your predictor variable and your target variable. So guys, I'm assuming you all have a prior knowledge of regression analysis because that is required for you to understand this whole concept of least square regression. So I'm assuming you guys have a good knowledge about regression, and if you don't, I'll leave a couple of links in the description box. You can go through those videos and then maybe come back to this one. Now, the least squares method is one of the best and one of the most effective ways in which you can draw a line of best fit. It is based on the idea that the square of the errors that are obtained must be minimized to the most possible extent, and that's why it has a name least square regression. So let's say that if I were to plot the best fit line that shows the relationship between the sales of a company over a period of time, it would look something like this. I'm drawing the time on the x-axis, so which represents your independent variable. Your price is across the y-axis, which represents your dependent variable. Now this line that you see is known as the line of best fit. How do you obtain this line of best fit is you use methods such as the least square regression method. By using least square regression method, you can make sure that this line is as accurate as possible, meaning that it most accurately depicts the relationship between your price variable and your time variable. That's what least square regression is all about. Now, these data points on the graph should be as close to the line of best fit as possible. That is the idea behind the least square regression method. Now, the farther these points are from the line of best fit, the more the error is going to be. So in order to minimize the error, we make use of the least square regression method. Okay, here we basically try to draw a line across these data points in such a way that the square of the errors between the line and the data points are as minimized as possible, right? So basically you need to minimize your error, right? That's the whole point of least square regression method. Now, again, if you notice the line, it is very close to the scattered data points, right? This is what an ideal best fit line will look like. Now, to better understand the whole process, let's see how to calculate the line using the least square regression method. So to start drawing the line that best shows your relationship between your variables, we first need to understand the basics. Now take a look at the equation here, y is equal to mx plus c. Surely all of you have come across this equation before, right? It's a simple equation that represents a straight line along two-dimensional data, which is x-axis and y-axis. Right here, I'm assuming that we have two-dimensional data and not more than that. So to better understand this, let's understand what each of these values denote in this formula, right? Y is basically your dependent variable. If we look at the example that I showed previously, wherein we had price and time drawn out as a relationship. So Y will basically be your price variable. M will be your slope of the line. It can be either positive or negative depending on the relationship between your X and your Y. X is again the independent variable that is used to predict the dependent variable. So X is commonly known as your predictor variable because it can help you predict your Y variable, and Y is known as the target variable. So X is used to predict the value of Y, right? So guys, these are all basics of linear regression. And only if you know the basics of linear regression, you'll fully understand the least square regression method. Now, similarly, we have something known as C, right? C is basically your y-intercept, and y-intercept is basically the point in your line which meets the y-axis. Now, don't worry if you haven't understood this fully. We'll move ahead and understand each step in performing this. So guys, the basic aim here is to calculate the values of your slope, your y-intercept, and substitute the corresponding x values in the equation. So by doing that, you'll get the value of your dependent variable, which is y. Now let's see how this can be done. Now we're assuming that there are n data points. Okay, let's say that the total number of data points that are there in your data set are n. Okay, so your first step is to calculate the slope by using this formula, right? X and y values, all you have to do is just substitute the x and y values, and n, which basically stands for your total number of data points, right? Once you substitute the values in this, you'll get your slope of the line. Next, what you'll do is you'll compute the y-intercept. Now look at the figure on this screen. Y-intercept is basically the point on the line that meets the y-axis, right? Like you can see in the figure, the point on the line that meets the y-axis is known as your y-intercept. Now the slope of your line will basically tell you whether your x and y are directly proportional or indirectly proportional. That's what the slope of line will depict. Now you can see that each of these data points have a distance between them and the line of best fit. Now this is basically your error. This error is also known as residual, right? This is the error that we're trying to minimize when we use your least square regression method. So to compute your y-intercept, you just exchange the main equation. Instead of y equal to mx plus c, you just put c is equals to y minus mx. So it's as simple as that. It's a basic mathematical equation. Your final step will be to substitute all the values in your final equation. So this is quite simple. So now to better understand this, let's look at an example and see how you can use the least square regression method to compute the line of best fit. Now consider an example. Let's say that there's this guy known as Tom, and he's the owner of a retail shop, and he found the price of different t-shirts versus the number of t-shirts that are sold at his shop over a period of 1 week. Right? So basically the price of your t-shirt versus the number of t-shirts that are sold. So let's use a concept of least square regression to find the line of best fit for this data set. So like I mentioned, your first step is to calculate the slope m. So you substitute your values into this. I've already given you x and y values in this table, and all you have to do is you have to substitute these values here, right? N here will basically be your total number of data points, which is 5. So 5 data points, and just substitute x and y values, and you should get a slope of approximately 1.5. So next you'll do is you'll compute the y-intercept value. So again, what you have to do is you just have to substitute the values. Okay. Once you substitute, you should get a value of around 0.3. So your last step is to just substitute the values in the final equation. Okay, now let's say that what Tom can do is he can use this equation to estimate how many t-shirts of, let's say, price $8 can he sell at the retail shop. Let's say your X value is $8. So if you substitute X as 8, you should get an answer of around 12.45, which is basically 13 t-shirts. So if you start selling a new t-shirt of around $8, which costs $8, then he'll sell around 13 of those t-shirts, right, which is pretty profitable. So that's how you can, predict new values by using linear regression. All you have to do is you have to substitute all these values, find out your slope, your y-intercept, and finally substitute the values in your final equation. So that's how simple it is to make predictions by using linear regression. Now let's sum up the entire thing. So like I said, the least squares regression method works by minimizing the sum of the square of the errors as small as possible. Okay, hence that's why it has the name least squares. So basically the distance between the line of best fit and the error must be minimized as much as possible, right? This is the basic idea behind least squares regression method. Now, a few things to keep in mind before implementing the least square regression method is that the data has to be free of outliers, right? If the data is not free of outliers, then your final output is going to be biased, right? Or it's going to be very wrong, because outliers are basically data points which are, calculated because of a few mistakes, which make no sense at all. So you have to make sure that your data is free from outliers. Another thing is that the line of best fit can be drawn iteratively until you get a line with the minimal possible squares of errors, right? So basically you can iteratively keep drawing this, and if you use Python code or if you use a coding language to do this, then it's quite simple. It'll figure out everything on its own, right? There are a lot of packages in your scikit-learn library that will do this entire thing for you, right? It's a small function, linear regression function. All you have to do is you have to call that function and it'll fit your data accordingly. Now, this method works very well on non-linear data as well. It does not have to be linear data, right? So a least square regression is one of the known methods which can reduce your error even on non-linear data sets. Finally, the difference between your actual value of y and the predicted value of y is called your residual. Now, this is basically your error value, right? So your residual is your error, and this has to be minimized as much as possible, right? That's what least square regression is all about. Now let's move on and take a look at the last section, which is performing regression analysis by using Python. Right, in this section, we'll be running a simple demo to understand the working of regression analysis by using the least square regression method. So guys, a short disclaimer is that I'll be using Python for this demo. So if you're not familiar with the language, you can go through the links. I'll post a couple of links in the description box. So go through those links and then come back to this. So our problem statement today is we're going to apply linear regression and we're going to build a model that studies the relationship between the head size and the brain weight of an individual, right? So it's going to study the relationship between these two factors. Now our data set is basically contains around 4 variables. There is gender, which depicts whether a person is a male or a female. Then we have age variable. After that, we have head size in centimeter cube and brain weight in grams, right? That's pretty understandable. So these variables need to be analyzed in order to build a model that will study the relationship between the head size and the brain weight of an individual. So when we look at the variables itself, we know that there is a dependency between head size and brain weight. So this is quite easy to understand if we use linear regression. So we know that regression will be the perfect method in order to solve this problem. So let's open up our Python code. So we'll be using linear regression like I mentioned, and we'll evaluate the models by using your least square regression method, where RMSE and R squared will be the model evaluation parameters. Now don't worry if you don't know what that is, we'll discuss that in a couple of minutes. Right, so guys, I'm assuming you have a good understanding of Python. So I'm just going to brush you through the entire code. So your first step is you're going to import the required packages. After that, you're going to read your data set. Is basically you're going to import your data set. And if you look at the data shape, let's look at the output here. So our output shows that we have around 237 rows, basically 237 observations or data points, and we have 4 variables. And if we take a look at the first 5 observations in our data set, We see that we have gender variable, age variable, we have the head size and the brain weight. Now gender variable and your age range is already being scaled in order to avoid any biasness in your output. Next, what we'll do is we'll collect your X and Y values, which is your head size will be your X and your brain weight will be your Y variable, right? We're going to collect them and store them in different data frames, X and Y respectively. After that, we'll calculate the mean, and then we'll finally calculate a slope and your y-intercept values. Right now, this entire code is used to calculate your slope, which is your m, and c, which is your y-intercept. Right? These are the exact formulas that I showed you in the slide earlier. Right? So I'm just substituting that formula in Python code and getting the answer here. Now, if you want to see the coefficients, coefficients are basically your m value and c value, your y-intercept and your slope value. Right? This is the value that I'm getting for our coefficients. After that, we're going to plot a regression line. After that, we're just plotting our values here, and then we'll finally create a final plot, a scatter plot that will show us the relationship between x and y. Right? So let's run this code and I'll show you what our graph looks like. So guys, this is our line of best fit, the line that you can see on green, right? Green in color, this is your line of best fit. And these are all your data points. Now this line is drawn in such a way that it minimizes the square error. Okay, that's what least square is all about. So it's basically minimizing that error as much as possible. We're trying to fit the data with this perfect line, right? That's what line of best fit means. Now followed by this, in order to perform model evaluation, we're going to calculate your root mean squares error value, right? Basically, this is where your least square regression comes into the picture, right? We're just making sure that your square of your errors is as minimized as possible. And RMSE is basically the root of your least square errors. Now, the model that we built is quite good, right? If we take a look at the graph, it is pretty good because our data set is quite small. Right? So if you want to train a machine in a better way, then you need to make sure that you're feeding it enough data. But since here I'm just trying to make you understand the math behind all of this, I feel like this data set is perfect. Now, mathematically speaking, your root mean square error is nothing but the square root of the sum of all errors divided by the total number of values, right? That's all your root mean square error is. It's nothing but the square root of the sum of all the errors divided by the total number of values or the total number of data points that you have. So basically, you're taking the square root of sum of all the errors. So that's all you're doing here. This is what your least square regression method is all about. Right here, we're only rooting the whole value. Another parameter to evaluate your model efficiency is your R squared parameter. Now, this is something that is out of scope for discussion here, but I'll just give you a basic definition. It's simple. It's just that the R squared value will measure how close the data are to the line of your best fit. Right? Basically, this is also an error calculation parameter. Now, if we look at our RMSE value, it is 72. Now, this is quite good for our data set, meaning that we do not have a lot of error. But if we increase the size of the data set and if we use a different problem statement, then we need to make sure that RMSE value is reduced. Right? That's what will build a line of best fit. Now, coming to your R squared value, your R squared value usually ranges between 0 and 1. Now, a negative R squared value will denote that the model is very weak and the prediction usually is wrong and biased. Right? So if you have a negative value, it means that your model is extremely weak and your prediction is probably wrong. In such situations, it's very important that you understand all your predictor variables and you look for a variable that has a higher correlation with your output variable. Now, this usually falls under your EDA or exploratory data analysis, which is out of the scope for this session. So as you can see, our R squared value here is 0.6, approximately quite close to 1. And this denotes that our model is doing good and it can be further used for making predictions. Right? So our model is actually quite good. We do not have a negative value here. In fact, it's close to 1. So guys, this basically shows that our model is quite effective.
So let's understand the what and why of logistic regression. Now this algorithm is most widely used when the dependent variable, or you can say the output, is in the binary format. So here you need to predict the outcome of a categorical dependent variable. So the outcome should be always discrete or categorical in nature. Now by discrete, I mean the value should be binary, or you can say you just have two values. It can either be 0 or 1. It can either be yes or a no, either be true or false, or high or low. So only these can be the outcomes. So the value which you need to predict should be discrete, or you can say categorical in nature. Whereas in linear regression, we have the value of y, or you can say the value you need to predict is in a range. So that is how there is a difference between linear regression and logistic regression. Now you must be having a question, why not linear regression? Now guys, in linear regression, the value of y or the value which you need to predict is in a range. But in our case, as in the logistic regression, we just have two values. It can be either 0 or it can be 1. It should not entertain the values which is below 0 or above 1. But in linear regression, we have the value of y in the range. So here, in order to implement logistic regression, we need to clip this part. So we don't need the value that is below 0, or we don't need the value which is above 1. So since the value of y will be between only 0 and 1, that is the main rule of logistic regression, the linear line has to be clipped at 0 and 1. Now once we clip this graph, it would look somewhat like this. So here you are getting a curve which is nothing but three different straight lines. So here we need to make a new way to solve this problem. So this has to be formulated into an equation, and hence we come up with logistic regression. So here the outcome is either 0 or 1, which is the main rule of logistic regression. So with this, our resulting curve cannot be formulated. So hence our main aim to bring the values to 0 and 1 is fulfilled. So that is how we came up with logistic regression. Now here, once it gets formulated into an equation, it looks somewhat like this. So guys, this is nothing but a S curve, or you can say the sigmoid curve or sigmoid function curve. So this sigmoid function basically converts any value from minus infinity to infinity to your discrete values, which a logistic regression wants, or you can say the values which are in binary format, either 0 or 1. So if you see here, the values are either 0 or 1, and this is nothing but just the transition of it. But guys, there's a catch over here. So let's say I have a data point that is 0.8. Now how can you decide whether your value is 0 or 1? Now here you have the concept of threshold, which basically divides your line. So here threshold value basically indicates the probability of either winning or losing. So here by winning, I mean the value is equals to 1, and by losing, I mean the value is equals to 0. But how does it do that? Let's say I have a data point which is over here. Let's say my cursor is at 0.8. So here I'll check whether this value is less than my threshold value or not. Let's say if it is more than my threshold value, it should give me the result as 1. If it is less than that, then it should give me the result as 0. So here my threshold value is 0.5. Now I need to define that if my value, let's say 0.8, it is more than 0.5, then the value shall be rounded off to 1. And let's say if it is less than 0.5, let's say I have a value 0.2, then should reduce it to 0. So here you can use the concept of threshold value to find your output. So here it should be discrete, it should be either 0 or it should be 1. So I hope you caught this curve of logistic regression. So guys, this is the sigmoid S curve. So to make this curve, we need to make an equation. So let me address that part as well. So let's see how an equation is formed to imitate this functionality. So over here we have an equation of a straight line, which is y is equals to mx plus c. So in this case, I just have only one independent variable. But let's say if we have many independent variables, then the equation becomes m1x1 plus m2x2 plus m3x3 and so on till mnxn. Now let us put in b and x. So here the equation becomes y is equals to b1x1 plus b2x2 plus b3x3 and so on till bnxn plus c. So guys, your equation of the straight line has a range from minus infinity to infinity. But in our case, or you can say in logistic equation, the value which we need to predict, or you can say the y value, it can have the range only from 0 to 1. So in that case, we need to transform this equation. So to do that, what we had done, we have just divided the equation by 1 minus y. So now if y is equals to 0, so 0 over 1 minus 0 which is equals to 1. So 0 over 1 is again 0. And if we take y is equals to 1, then 1 over 1 minus 1 which is 0. So 1 over 0 is infinity. So here my range is now between 0 to infinity. But again we want the range from minus infinity to infinity. So for that what we'll do, we'll have the log of this equation. So let's go ahead and have the logarithmic of this equation. So here we have just transform it further to get the range between minus infinity to infinity. So over here we have log of y over 1 minus 1, and this is your final logistic regression equation. So guys, don't worry, you don't have to write this formula or memorize this formula. In Python, you just need to call this function which is logistic regression and everything will be automatically for you. So I don't want to scare you with the maths and the formulas behind it, but it's always good to know how this formula was generated. Moving ahead, let us see the various use cases wherein logistic regression is implemented in real life. So the very first is weather prediction. Now, logistic regression helps you to predict your weather. For example, it is used to predict whether it is raining or not, whether it is sunny, is it cloudy or not. So, all these things can be predicted using logistic regression. Whereas you need to keep in mind that both linear regression and logistic regression can be used in predicting the weather. So, in that case, linear regression helps you to predict what will be the temperature tomorrow, whereas logistic regression will only tell you whether it's going to rain or not, or whether it's cloudy or not, whether it's going to snow or not. So these values are discrete. Whereas if you apply linear regression, you'll be predicting things like what is the temperature tomorrow or what is the temperature day after tomorrow and all those things. So these are the slight differences between linear regression and logistic regression. Now moving ahead, we have classification problem. So Python performs multi-class classification. So here it can help you tell whether it's a bird or it's not a bird. Then you can classify different kind of mammals. Let's say whether it's a dog or it's not a dog. Similarly, you can check it for reptile, whether it's a reptile or not a reptile. So in logistic regression, it can perform multi-class classification. So this point I have already discussed that it is used in classification problems. Next, it also helps you to determine the illness as well. So let me take an example. Let's say a patient goes for a routine checkup in a hospital. So what doctor will do, it will perform various tests on the patient and will check whether the patient is actually ill or not. So what will be the features? So doctor can check the sugar level, the blood pressure, then what is the age of the patient, is it very small or is it an old person, then what is the previous medical history of that patient, and all of these features will be recorded by the doctor. And finally, doctor checks the patient data and determines the outcome of an illness and the severity of illness. So using all the data, a doctor can identify whether a patient is ill or not. So these are the various use cases in which you can use logistic regression. Now I guess enough of theory part, so let's move ahead and see some of the practical implementation of logistic regression. So over here I'll be implementing two projects wherein I have the data set of a Titanic. So over here we'll predict what factors made people more likely to survive the sinking of the Titanic ship. And in my second project, we'll see the data analysis on the SUV cars. So over here we have the data of the SUV cars, who can purchase it, and what factors made people more interested in buying SUV. So these will be the major questions as to why you should implement logistic regression and what output will you get by it. So let's start by the very first project, that is Titanic data analysis. So some of you might know that there was a ship called as Titanic which basically hit an iceberg and it sunk to the bottom of the ocean. And it was a big disaster at that time because it was the first voyage of the ship and it was supposed to be really strongly built and one of the best ships of that time. So it was a big disaster of that time, and of course there's a movie about this as well. So many of you might have watched it. So what we have data of the passengers, those who survived and those who did not survive in this particular tragedy. So what you have to do, you have to look at this data and analyze which factors would have been contributed the most to the chances of a person's survival on the ship or not. So using the logistic regression, we can predict whether the person survived or the person died. Now, apart from this, we'll also have a look with the various features along with that. So first, let us explore the data set. So over here, we have the index value. Then the first column is passenger ID. Then my next column is survived. So over here, we have two values, a 0 and a 1. So 0 stands for did not survive and 1 stands for survive. So this column is categorical where the values are discrete. Next, we have passenger class. So over here, we have three values, 1, 2, and 3. So this basically tells you that whether a passenger is traveling in the first class, second class, or third class. Then we have the name of the passenger, we have the sex, or you can say the gender of the passenger, whether passenger is a male or female. Then we have the age, we have the SIB-SP. So this basically means the number of siblings or the spouses aboard the Titanic. So over here we have values such as 1, 0, and so on. Then we have patch. So patch is basically the number of parents or children aboard the Titanic. So over here we also have some values. Then we have the ticket number, we have the fare, we have the cabin number, and we have the embarked column. So in my embarked column, we have three values. We have S, C, and Q. So S basically stands for Southampton, C stands for Cherbourg, and Q stands for Queenstown. So these are the features that we'll be applying our model on. So here we'll perform various steps and then we'll be implementing logistic regression. So now these are the various steps which are required to implement any algorithm. So now in our case, we are implementing logistic regression. So our very first step is to collect your data or to import the libraries that are used for collecting your data and then taking it forward. Then my second step is to analyze your data. So over here, I can go to the various fields and then I can analyze the data. I can check, did the females or children survive better than the males, or did the rich passenger survive more than the poor passenger, or did the money matter, as in who paid more to get into the ship, were they evacuated first, and what about the workers, does the worker survived, or what is the survival rate if you were the worker in the ship and not just a traveling passenger. So all of these are very very interesting questions, and you would be going through all of them one by one. So in this stage, you need to analyze your data and explore your data as much as you can. Then my third step is to wrangle your data. Now data wrangling basically means cleaning your data. So over here you can simply remove the unnecessary items, or if you have a null values in the data set, you can just clear that data and then you can take it forward. So in this step you can build your model using the trained data set and then you can test it using the test. So over here you will be performing a split, which basically split your data set into training and testing data set. And finally you will check the accuracy so as to ensure how much accurate your values are. So I hope you guys got these 5 steps that we're going to implement in logistic regression. So now let's go into all these steps in detail. So number one, we have to collect your data, or you can say import the libraries. So let me just show you the implementation part as well. So I'll just open my Jupyter notebook and I'll just implement all of these steps side by side. So guys, this is my Jupyter notebook. So first let me just rename the Jupyter notebook to, let's say, Titanic Data Analysis. Now our first step was to import all the libraries and collect the data. So let me just import all the libraries first. So first of all, I'll import Pandas. So Pandas is used for data analysis. So I'll say import Pandas as PD. Then I'll be importing NumPy. So I'll say import NumPy as NP. So NumPy is a library in Python which basically stands for numerical Python, and it is widely used to perform any scientific computation. Next, we'll be importing 𝐶born. So 𝐶born is a library for statistical plotting. So I'll say import 𝐶born as SNS. I'll also import Matplotlib. So Matplotlib library is again for plotting. So I'll say import matplotlib.pyplot as PLT. Now to run this library in Jupyter Notebook, all I have to write in is %matplotlib inline. Next, I'll be importing one module as well, so as to calculate the basic mathematical functions. So I'll say import maths. So these are the libraries that I'll be needing in this Titanic data analysis. So now let me just import my data set. So I'll take a variable, let's say Titanic data, and using the pandas, I will just read my CSV, or you can say the data set. I'll write the name of my data set, that is titanic.csv. Now I have already showed you the data set. So over here, let me just print the top 10 rows. So for that, I'll just say, I'll take the variable Titanic data dot head and I'll say the top 10 rows. So now I'll just run this. So to run this, so I just have to press Shift plus Enter, or else you can just directly click on this cell. So over here, I have the index, we have the passenger ID, which is nothing but again the index which is starting from 1. Then we have the survived column, which has the categorical values, or you can say the discrete values, which is in the form of 0 or 1. Then we have the passenger class, we have the name of the passenger, sex, age, and so on. So this is the dataset that I'll be going forward with. Next, let us print the number of passengers which are there in this original dataset. So for that, I'll just simply type in print. I'll say number of passengers. And using the length function, I can calculate the total length. So I'll say length, and inside this, I'll be passing this variable, which is Titanic data. So I'll just copy it from here. I'll just paste it, dot index. And next, so let me just print this one. So here the number of passengers which are there in the original data set we have is 891. So around this number were traveling in the Titanic ship. So over here my first step is done, where you have just collected data, imported all the libraries, and find out the total number of passengers which are traveling in Titanic. So now let me just go back to presentation and let's see what is my next step. So we're done with the collecting data. Next step is to analyze your data. So over here we'll be creating different plots to check the relationship between variables, as in how one variable is affecting the other. So you can simply explore your dataset by making use of various columns, and then you can plot a graph between them. So you can either plot a correlation graph, you can plot a distribution graph. It's up to you guys. So let me just go back to my Jupyter notebook and let me analyze some of the data. Over here, my second part is to analyze data. So I just put this in header 2. Now to put this in header 2, I just have to go on code, click on markdown, and I just run this. So first let us plot a count plot where you compare between the passengers who survived and who did not survive. So for that I'll be using the 𝐶born library. So over here I have imported 𝐶born as SNS. So I don't have to write the whole name. I'll simply say sns.countplot. I'll say X is who survived, and the data that I'll be using is the Titanic data, or you can say the name of variable in which you have stored your data set. So now let me just run this. So over here, as you can see, I have survived column on my x-axis, and on the y-axis I have the count. So 0 basically stands for did not survive, and 1 stands for the passengers who did survive. So over here you can see that around 550 of the passengers who did not survive, and there were around 350 passengers who only survived. So here you can basically conclude that there are very less survivors than non-survivors. So this was the very first plot. Now let us plot another plot to compare the sex as to whether out of all the passengers who survived and who did not survive, how many were men and how many were female. So to do that, I'll simply say sns.countplot. I'll add the hue as sex. So I want to know how many females and how many males survived. Then I'll be specifying the data. So I'm using Titanic data set. And let me just run this. Okay, I've done a mistake over here. So over here you can see I have survived column on the x-axis and I have the count on the y. Now, so here your blue color stands for your male passengers and orange stands for your female. So as you can see here, the passengers who did not survive, that has a value 0. So we can see that majority of males did not survive. And if we see the people who survived, here we can see the majority of females survived. So this basically concludes the gender of the survival rate. So it appears on average women were more than 3 times more likely to survive than men. Next, let us plot another plot where we have the hue as the passenger class. So over here we can see which class that the passenger was traveling in, whether it was traveling in class 1, 2 or 3. So for that, I'll just write the same command. I'll say sns.countplot. I'll keep my x-axis as subject only. I'll change my hue to passenger class. So my variable is named as P class. And the data set that I'll be using is Titanic data. So this is my result. So over here you can see I have blue for first class, orange for second class and green for the third class. So here the passengers who did not survive were majorly of the third class, or you can say the lowest class or the cheapest class to get into the Titanic. And the people who did survive majorly belong to the higher classes. So here 1 and 2 has more rise than the passenger who were traveling in the third class. So here we have concluded that the passengers who did not survive were majorly of third class, or you can say the lowest class. And the passengers who were traveling in first and second class would tend to survive more. Next, let us plot a graph for the age distribution. Over here, I can simply use my data. So we'll be using Pandas library for this. I'll declare an array and I'll pass in the column that is age. So I plot and I want a histogram. So I'll say plot.hist. So you can notice over here that we have more of young passengers, or you can say the children between the ages 0 to 10. And then we have the average age people. And if you go ahead, lesser would be the population. So this is the analysis on the age column. So we saw that we have more young passengers and more mediocre age passengers which are traveling in the Titanic. So next, let me plot a graph for fare as well. So I'll say Titanic data. I'll say fare. And again, I'll plot a histogram. So I'll say hist. So here you can see the fare size is between 0 to 100. Now let me add the bin size so as to make it more clear. So over here I'll say bin is equals to, let's say 20, and I'll increase the figure size as well. So I'll say fig size. Let's say I'll give the dimensions as 10 by 5. Okay, so it is bins. So this is more clear now. Next, let us analyze the other columns as well. So I'll just type in Titanic data and I want the information as to what all columns are left. So here we have passenger ID, which I guess it's of no use. Then we have see how many passengers survived and how many did not. We also see the analysis on the gender basis. We saw whether female tend to survive more or the men tend to survive more. Then we saw the passenger class, whether passenger is traveling in the first class, second class or third class. Then we have the name. So in name we cannot do any analysis. We saw the sex, we saw the age as well. Then we have 𝐶𝐵. So this stands for the number of siblings or the spouses which are aboard the Titanic. So let us do this as well. So I'll say sns.countplot. I'll mention x as 𝐶𝐵 and I'll be using the Titanic data. So you can see the plot over here. So over here you can conclude that it has the maximum value on 0. So you can conclude that neither a children nor a spouse was on board the Titanic. Now second most highest value is 1. And then we have very less values for 2, 3, 4 and so on. Next, if I go above, we saw this column as well. Similarly, you can do for Parj. So next we have Parj, or you can say the number of parents or children which were aboard the Titanic. So similarly, you can do this as well. Then we have the ticket number. So I don't think so any analysis is required for ticket. Then we have fare. So fare we have already discussed. As in the people who tend to travel in the first class usually pay the highest fare. Then we have the cabin number and we have embarked. So these are the columns that we'll be doing data wrangling on. So we have analyzed the data and we have seen quite a few graphs in which we can conclude which variable is better than the another, or what is the relationship they hold. So third step is my data wrangling. So data wrangling basically means cleaning your data. So if you have a large data set, you might be having some null values, or you can say NaN values. So it's very important that you remove all the unnecessary items that are present in your data set. So removing this directly affects your accuracy. So I'll just go ahead and clean my data by removing all the NaN values and unnecessary columns which has a null value in the data set. So next I'll be performing data wrangling. So first of all, I'll check whether my data set is null or not. So I'll say Titanic data, which is the name of my data set, and I'll say is null. So this will basically tell me what all values are null and it will return me a Boolean result. So this basically checks the missing data and your result will be in Boolean format, as in the result will be true or false. So false means if it is not null and true means if it is null. So let me just run this. Over here you can see the values as false or true. So false is where the value is not null and true is where the value is null. So over here you can see in the cabin column we have the very first value which is null. So we have to do something on this. So you can see that we have a large data set. So the counting does not stop. And we can actually see the sum of it. We can actually print the number of passengers who have the NaN value in each column. So I'll say Titanic underscore data is null and I want the sum of it. So I'll say dot sum. So this will basically print the number of passengers who have the NaN values in each column. So we can see that we have missing values in each column, that is 177. Then we have the maximum value in the cabin column. And we have very less in the embarked column, that is 2. So here if you don't want to see these numbers, you can also plot a heat map and then you can visually analyze it. So let me just do that as well. So I'll say sns.heatmap. I'll say y tick labels to false. So I'll just run this. So as we have already seen that there were 3 columns in which missing data value was present. So this might be age. So over here almost 20% of age column has a missing value. Then we have the cabin columns. So this is quite a large value. And then we have 2 values for embarked column as well. Add a CMap for color coding. So I'll say CMap. So if I do this, so the graph becomes more attractive. So over here your yellow stands for true, or you can say the values are null. So here we have concluded that we have the missing value of age. We have a lot of missing values in the cabin column and we have very less value which is not even visible in the embarked column as well. So to remove these missing values, you can either replace the values and you can put in some dummy values to it, or you can simply drop the column. So here let us first pick the age column. So first let me just plot a box plot and they will analyze with having a column as age. So I'll say sns.boxplot. I'll say X is equals to passenger class. So it's P class. I'll say Y is equals to age. And the data set that I'll be using is Titanic set. So I'll say data is equals to Titanic data. You can see the age in first class and second class tends to be more older rather than we have it in the third class. Well, that depends on the experience, how much you earn, or might be there n number of reasons. So here we concluded that passengers who were traveling in class 1 and class 2 tend to be older than what we have in the class 3. So we have found that we have some missing values in M. Now one way is to either just drop the column or you can just simply fill in some values to that. So this method is called as imputation. Now to perform data wrangling or cleaning, let us first print the head of the data set. So I'll say Titanic.head, it's Titanic underscore data. Let's say I just want the 5 rows. So here we have survive, which is again categorical. So in this particular column, I can apply logistic regression. So this can be my Y value or the value that I need to predict. Then we have the passenger class, we have the name. Then we have ticket number, fare, cabin. So over here we have seen that in cabin we have a lot of null values, or you can say the NaN values, which is quite visible as well. So first of all, we'll just drop this column. So for dropping it, I'll just say Titanic underscore data, and I'll simply type in drop and the column which I need to drop. So I have to drop the cabin column. I'll mention the axis equals to 1, and I'll say in place also to true. So now again, I'll just print the head and let us see whether this column has been removed from the data set or not. So I'll say Titanic.head. So as you can see here, we don't have cabin column anymore. Now you can also drop the NA values. So I'll say Titanic data dot drop all the NA values, or you can say NaN, which is not a number. And I'll say in place is equals to true. It's Titanic. So over here, let me again plot the heat map, and let's say what the values which were before showing a lot of null values, has it been removed or not. So I'll say sns.heatmap, I'll pass in the data set. I'll check it is null. I'll say white tick labels is equals to false. And I don't want color coding, so again I'll say false. So this will basically help me to check whether my values has been removed from the data set or not. So as you can see here, I don't have any null values. So it's entirely black. Now you can actually know the sum as well. So I'll just go above. So I'll just copy this part and I'll just use the sum function to calculate the sum. So here that tells me that data set is clean, as in the data set does not contain any null value or any NaN value. So now we have wrangled our data, you can say clean our data. So here we have done just one step in data wrangling, that is just removing one column out of it. Now you can do a lot of things. You can actually fill in the values with some other values, or you can just calculate the mean and then you can just fit in the null values. But now if I see my data set, so I'll say Titanic data.head. But now if I see over here, I have a lot of string values. So this has to be converted to categorical variables in order to implement logistic regression. So what we will do, we will convert this to categorical variable into some dummy variables, and this can be done using pandas, because logistic regression just take two values. So whenever you apply machine learning, you need to make sure that there are no string values present, because it won't be taking these as your input variables. So using string, you don't have to predict anything. But in my case, I have the survived column, so I need to predict how many people tend to survive and how many did not. So 0 stands for did not survive and 1 stands for survive. So now let me just convert these variables into dummy variables. So I'll just use pandas and I'll say pd.getDummies. You can simply press tab to autocomplete. I'll say Titanic data and I'll pass the sex. So you can just simply click on shift plus tab to get more information on this. So here we have the type data frame and we have the passenger ID, survived, and the passenger class. So if you run this, you'll see that 0 basically stands for not a female and 1 stands for it is a female. Similarly for male, 0 stands for it's not male and 1 stands for male. Now we don't require both these columns, because one column itself is enough to tell us whether it's male or you can say female or not. So let's say if I want to keep only male, now I'll say if the value of male is 1, so it is definitely a male and it is not a female. So that is how you don't need both of these values. So for that, I'll just remove the first column, let's say female. So I'll say drop first and true. So over here it has given me just one column which is male and has the value 0 and 1. Now let me just set this as a variable, let's say sex. So over here I can say sex.head. I just want to see the first 5 rows. Sorry, it's dot. So this is how my data looks like. Now here we have done it for sex. Then we have the numerical values in age, we have the numerical values in spouses, then we have the ticket number, we have the fare, and we have embarked as well. So in embarked, the values are in S, C, and Q. So here also we can apply this get dummy function. So let's say I'll take a variable, let's say embark. I'll use the pandas library. I'll enter the column name, that is embarked. So let me just print the head of it. So I'll say embark.head. So over here we have C, Q, and S. Now here also we can drop the first column, because these two values are enough whether the passenger is either traveling for Q, that is Queenstown, S for Southampton, and if both the values are 0, then definitely the passenger is from Cherbourg, that is the third value. So you can again drop the first value. So I'll say drop and true. Let me just run this. So this is how my output looks like. Now similarly you can do it for passenger class as well. So here also we have 3 classes, 1, 2, and 3. So I'll just copy the whole statement. So let's say I want the variable name, let's say PCL. I'll pass in the column name, that is P class, and I'll just drop the first column. So here also the values would be 1, 2 or 3, and I'll just remove the first column. So here we just left with 2 and 3. So if both the values are 0, then definitely the passenger is traveling in the first class. Now we have made the values as categorical. Now my next step would be to concatenate all these new rows into a data set. Or you can say Titanic data. Using the pandas, we'll just concatenate all these columns. So I'll say p.concat, and I'll say we have to concatenate sex, we have to concatenate embark and PCL. And then I'll mention the access to 1. I'll just run this. Okay, I need to print the head. So over here you can see that these columns have been added over here. So we have the male column, which basically tells whether a person is male or it's a female. Then we have the embark, which is basically Q and S. So if it's traveling from 𝐂𝐝𝐻, the value would be 1, else it would be 0. And if both of these values are 0, it is definitely traveling from 𝐶hERBOG. Then we have the passenger class as 2 and 3. So if the value of both these is 0, then the passenger is traveling in class 1. So I hope you got this till now. Now these are the irrelevant columns that we have it over here. So we can just drop these columns. We'll dropping P class, the embarked column, and the sex column. So I'll just type in Titanic data dot drop, and I'll mention the columns that I want to drop. So I'll say I'll even delete the passenger ID because it's nothing but just the index value which is starting from 1. So I'll drop this as well. Then I don't want name as well, so I'll delete name as well. Then what else we can drop? We can drop the ticket as well. And then I'll just mention the access, and I'll say in place is equals to true. Okay, so my column name starts from uppercase. So these has been dropped. Now let me just print my data set again. So this is my final data set, guys. We have the survived column which has the value 0 and 1. Then we have the passenger class. Oh, we forgot to drop this as well. So no worries, I'll drop this again. So now let me just run this. So over here we have the survived, we have the age, we have the 𝐶hERBOG, we have the parch, we have fair, male, and these we have just converted. So here we have just performed data wrangling, or you can say clean the data, and then we have just converted the values of gender to male, then embark to Q and S, and the passenger class to 2 and 3. So this was all about my data wrangling or just cleaning the data. Then my next step is training and testing your data. So here we will split the dataset into train subset and test subset. And then what we'll do, we'll build a model on the trained data and then predict the output on your test dataset. So let me just go back to Jupyter and let us implement this as well. Over here, I need to train my dataset. So I'll just put this in heading 3. So over here, you need to define your dependent variable and independent variable. So here, my y is the output, or you can say the value that I need to predict. So over here, I'll write Titanic data. I'll take the column which is survived. So basically, I have to predict this column whether the passenger survived or not. And as you can see, we have the discrete outcome, which is in the form of 0 and 1. And rest all the things, we can take it as a features, or you can say independent variable. So I'll say Titanic data dot drop. So we'll just simply drop this survived, and all the other columns will be my independent variable. So everything else are the features which leads to the survival rate. So once we have defined the independent variable and the dependent variable, next step is to split your data into training and testing subset. So for that, we'll be using sklearn. I just type in from sklearn.cross-validation, import train test split. Now here, if you just click on shift and tab, you can go to the documentation and you can just see the examples over here. I'll click on plus to open it, and then I just go to examples and see how you can split your data. So over here you have xtrain, xtest, ytrain, ytest. And then using this train test split, you can just pass in your independent variable and dependent variable and just define a size and a random state to it. So let me just copy this and I'll just paste it over here. Over here we'll train, test, then we have the dependent variable train and test, and using the split function we'll pass in the independent and dependent variable, and then we'll set a split size. So let's say I'll put it as 0.3. So this basically means that your data set is divided in 0.3. That is in 70-30 ratio. And then I can add any random state to it. So let's say I'm applying 1. This is not necessary. If you want the same result as that of mine, you can add the random state. So this will basically take exactly the same sample every time. Next, I have to train and predict by creating a model. So here logistic regression will grab from the linear regression. So next I'll just type in from sklearn.linear model import logistic regression. Next I'll just create the instance of this logistic regression model. So I'll say log model is equals to logistic regression. Now I just need to fit my model, so I'll say log model dot fit, and I'll just pass in my x train and y train. Alright, so here it gives me all the details of logistic regression. So here it gives me the class weight, dual, fit, intercept, and all those things. Then what I need to do, I need to make prediction. So I'll take a variable, let's say predictions, and I'll pass on the model to it. So I'll say log model dot predict, and I'll pass in the value that is x test. So here we have just created a model, fit that model, and then we had made predictions. So now to evaluate how my model has been performing, so you can simply calculate the accuracy, or you can also calculate a classification report. So don't worry guys, I'll be showing both of these methods. So I'll say from sklearn.metrics import classification report. So over here I'll use classification report, and inside this I'll be passing in y test and the predictions. So guys, this is my classification report. So over here I have the precision, I have the recall, we have the F1 score, and then we have support. So here we have the value of precision as 75, 72, and 73, which is not that bad. Now, in order to calculate the accuracy as well, you can also use the concept of confusion matrix. So if you want to print the confusion matrix, I'll simply say from sklearn.metrics import confusion matrix first of all, and then we'll just print this. So here my function has been imported successfully. So I'll say confusion matrix, and I'll again pass in the same variables, which is y test and predictions. So I hope you guys already know the concept of confusion matrix. So can you guys give me a quick confirmation as to whether you guys remember this confusion matrix concept or not? So if not, I can just quickly summarize this as well. Okay, Jagriti says a yes. Okay, Swati is not clear with this. So I'll just tell you in a brief what confusion matrix is all about. So confusion matrix is nothing but a 2 by 2 matrix which has 4 outcomes. This basically tells us that how accurate your values are. So here we have the column as predicted no, predicted y, and we have actual no and an actual yes. So this is the concept of confusion matrix. So here let me just feed in these values which we have just calculated. So here we have 105, 21, 25, and 63. So as you can see here, we have got 4 outcomes. Now 105 is the value where a model has predicted no, and in reality it was also a no. So here we have predicted no and an actual no. Similarly, we have 63 as a predicted yes. So here the model predicted yes, and actually also it was a yes. So in order to calculate the accuracy, you just need to add the sum of these two values and just divide the whole by the sum. So here these two values tells me where the model has actually predicted the correct output. So this value is also called as true negative. This is called as false positive. This is called as true positive, and this is called as false negative. Now in order to calculate the accuracy, you don't have to do it manually. So in Python, you can just import accuracy score function and you can get the results from that. So I'll just do that as well. So I'll say from sklearn.metrics import accuracy score, and I'll simply print the accuracy. And I'll pass in the same variables, that is y test and predictions. So over here it tells me the accuracy as 78, which is quite good. So over here, if you want to do it manually, you have to plus these two numbers, which is 105 plus 63. So this comes out to almost 168, and then you have to divide it by the sum of all the 4 numbers. So 105 plus 63 plus 21 plus 25. So this gives me a result of 214. So now if you divide these two numbers, you'll get the same accuracy, that is 78%, or you can say 0.78. So that is how you can calculate the accuracy. So now let me just go back to my presentation and let's see what all we have covered till now. So here we have first split our data into train and test subset. Then we have built our model on the trained data and then predicted the output on the test data set. And then my fifth step is to check the accuracy. So here we have calculated accuracy to almost 78%, which is quite good. You cannot say that accuracy is bad. So here it tells me how accurate your results are. So here my accuracy score defines that, and hence we got a good accuracy. So now moving ahead, let us see the second project, that is SUV data analysis. So in this, a car company has released new SUV in the market, and using the previous data about the sales of their SUV, they want to predict the category of people who might be interested in buying this. So using the logistic regression, you need to find what factors made people more interested in buying this SUV. So for this, let us see a data set where I have user ID, I have gender as male and female, then we have the age, we have the estimated salary, and then we have the purchased column. So this is my discrete column, or you can say the categorical column. So here we just have the value that is 0 and 1. And this column we need to predict whether a person can actually purchase a SUV or not. So based on these factors, we will be deciding whether a person can actually purchase a SUV or not. So we know the salary of a person, we know the age. And using these, we can predict whether a person can actually purchase a SUV or not. So let me just go to my Jupyter notebook and let us implement logistic regression. So guys, I will not be going through all the details of data cleaning and analyzing the part. So that part, I'll just leave it on you. So just go ahead and practice as much as you can. Alright. So my second project is SUV predictions. Alright. So first of all, I have to import all the libraries. So I say import NumPy as NP. And similarly, I'll do the rest of it. Alright. So now let me just print the head of this data set. So this we've already seen that we have columns as user ID, we have gender, we have the age, we have the salary, and then we have to calculate whether the person can actually purchase a SUV or not. So now let us just simply go on to the algorithm part. So we'll directly start off with the logistic regression, or how you can train a model. So for doing all those things, we first need to define your independent variable and a dependent variable. So in this case, I want my x that is an independent variable. I say dataset.ilog. So here I'll be specifying all the rows. So colon basically stands for that. And in the columns, I want only 2 and 3 dot values. So here it should fetch me all the rows and only the second and third column, which is age and estimated salary. So these are the factors which will be used to predict the dependent variable, that is purchase. So here my dependent variable is purchase. And your dependent variable is of age and salary. So I'll say dataset.ilog. I'll have all the rows and I just want fourth column, that is my purchased column, dot values. Alright, so I've just forgot one square bracket over here. Alright. So over here I have defined my independent variable and dependent variable. So here my independent variable is age and salary, and dependent variable is the column purchase. Now you must be wondering, what is this ilog function? So ilog function is basically an indexer for Pandas data frame, and it is used for integer based indexing, or you can also say selection by index. Now let me just print these independent variables and dependent variable. So if I print the independent variable, I have the age as well as the salary. Next, let me print the dependent variable as well. So over here you can see I just have the values in 0 and 1. So 0 stands for did not purchase. Next, let me just divide my dataset into training and test subset. So I'll simply write in from sklearn.crosssplit.crossvalidation import train test. Next, I'll just press shift and tab, and over here I'll go to the examples and just copy the same line. So I'll just copy this. I'll remove the points. Now I want the text size to be, let's say, 25. So I have divided the train and test split in 75-25 ratio. Now let's say I'll take the random state as 0. So random state basically ensures the same result, or you can say the same samples taken whenever you run the code. So let me just run this. Now you can also scale your input values for better performing, and this can be done using standard scaler. So let me do that as well. So I'll say from sklearn.preprocessing import standard scaler. Now why do we scale it? Now if you see our data set, we are dealing with large numbers. Well, although we are using a very small data set, so whenever you're working in a prod environment, you'll be working with large data set where you'll be using thousands and hundred thousands of tuples. So their scaling down will definitely affect the performance by a large extent. So here let me just show you how you can scale down these input values. And then the pre-processing contains all your methods and functionality which is required to transform your data. So now let us scale down for test as well as a training data set. So I'll first make an instance of it. So I'll say standard scalar. Then I'll have xtrain. I'll say sc.fit, fit underscore transform. And I'll pass in my xtrain variable. And similarly, I can do it for test, wherein I'll pass the xtest. Alright. Now my next step is to import logistic regression. So I'll simply apply logistic regression by first importing it. So I'll say from sklearn.linear model import logistic regression. Now over here I'll be using classifier. So I'll say classifier dot is equals to logistic regression. So over here I'll just make an instance of it. So I'll say logistic regression. And over here I'll just pass in the random state, which is 0. And now I'll simply fit the model. And I'll simply pass in xtrain and ytrain. So here it tells me all the details of logistic regression. Then I have to predict the value. So I'll say ypred is equals to classifier, then predict function, and then I'll just pass in xtest. So now we have created the model, we have scaled down our input values, then we have applied logistic regression, we have predicted the values, and now we want to know the accuracy. So to know the accuracy, first we need to import accuracy score. So I'll say from sklearn.metrics import accuracy score, and using this function we can calculate the accuracy, or you can manually do that by creating a confusion matrix. So I'll just pass in my y test and my y predicted. Alright, so over here I get the accuracy as 89%. So if we want to know the accuracy in percentage, so I just have to multiply it by 100, and if I run this, so it gives me 89%. So I hope you guys are clear with whatever I have taught you today. So here I have taken my independent variables as age and salary, and then we have calculated that how many people can purchase the SUV, and then we have calculated our model by checking the accuracy. So over here we get the accuracy as 89, which is great.
What is classification? And if I have to tell you about classification, like for example, what happens is like we have two type of, when we talk about machine learning is nothing but, you know, like a series of instructions you give it to the computer so that it can learn the patterns from your data set, right? To give you an example, imagine that there is a trending topic. For example, you want to find it out whether Prime Minister Modi will be the second Prime Minister, once again the Prime Minister for the country or not. Okay, so now what you will do is you will collect the data set from multiple different sources, and you will actually build it like a algorithm where you will get a label as yes or no. Yes, he will continue as a next prime minister, or no, he will not continue as a next prime minister. So you will collect the data set and you will feed this data set to the computer, and this process is called as a machine learning, right? So now in this case, what happens is so this is about the classification, right? So now machine learning is basically of two types. One is called as a supervised machine learning, another is called as a unsupervised machine learning, and the third one is a reinforcement machine learning. So when we speak about supervised machine learning, as the name suggests, it provides some supervision, right? For example, the teacher teaching the kid, it's a supervised machine learning, right? So we will give the trained examples, we will give the trained data set with the pure label on top of that. This is called as a supervised machine learning. So if I draw in front of you, this type of machine learning look like this, supervised machine learning, where what happens is like you would have the data set, which is a structured data set, and you would have one column which is called as a label, what you want to predict. Okay, and you would have a various predictors by which you want to predict. To give you an example, imagine that you want to predict a pricing of a community. Okay, you want to predict what would be the pricing of apartment in a particular community, right? Now these can be the variable, like you can see that what would be the number of how many floors it has. You can have a variable like what is a pollution level, how many educational institutions are nearby, right? So based upon that, the pricing will change. But this type of supervised machine learning, why it is called supervised machine learning? Because we provide the independent variable, or we provide the predictors, also we provide the label data set. Okay, now this supervised machine learning is basically of two types. So this supervised machine learning, first is called as the, regression based supervised machine learning. Okay, and the second one is called as a classification based supervised machine learning. Now, what is the difference between regression based and a classification based supervised machine learning? Regression based supervised machine learning is that machine learning where what you want to predict is continuous in nature. Okay, imagine you want to predict the community prices, right, which is a continuous value. If it is a continuous value, then we will go ahead with regression based supervised machine learning. Okay, whereas if you want to predict something which is the discrete outcome, to give you an example, you want to predict that whether I will win the match or not. Okay, I want to predict whether the particular employee will churn out from the company or not. You want to predict, like whether the person will have a cancer or not. You're getting my point, right? So if you have the output which you want to predict is in the form of yes or no or true or false, right, this is called as the supervised machine learning, but a classification based supervised machine learning. Okay, so classifications based supervised machine learning is the process of dividing the data set into different categories or group by adding a label. Okay, so always remember that whenever you guys want to predict the classes in the data set, whenever you want to predict, like whether this will happen or not, whether a person will do a credit card fraud or not. You're getting my point, right? Whether the employee will churn out from the company or not, right? Whether the particular person will have a diabetes as a disease or not. All these questions, wherever you want to find it out, yes or no, or true or false, or you want to predict classes in the data set, this is called as a classification based supervised machine learning. Okay, so this is what is called as a classification based supervised machine learning. And today I will teach you, I will tell you about various form of classification based supervised machine learning, although we will do a deep dive into decision tree. Right now you will be able to understand that decision tree, how decision tree is connected to the network, what we are learning today with classification based supervised machine learning. Okay, so now we have various algorithms. Algorithm is nothing but a set of mathematical equations for classification based supervised machine learning. We first of all we have something called as decision tree, then we would have something called as random forest, then knife base, and then KNN, which is called as a k nearest neighbors. Okay, so let me give you few statements about this algorithm, and we have many others, but today we will focus on one of them, which is decision tree. So now first let's start with decision tree. Now what is a decision tree? What I was telling you is, believe me or not, decision tree is something you use every day in your daily life. For example, you take decisions, and today also you took a decision to attend this webinar, right? But how do you decide a decision? Based on various further decisions, right? For example, for today joining the webinar, you have seen that, okay, when this webinar is about, okay, so you said it is weekday or weekend, then you might have said check it out, right? What is the time of the webinar? Then you might have checked it out, what is the topic of the webinar, right? So, and who is conducting this webinar? So based upon this, you took a decision, shall I go ahead or not go ahead? You're getting my point, right? So this is what is called as a decision tree. We call it as decision tree because it is a graphical representation of all the possible solution to a decision. It's like a tree. Like decision tree is like a tree. Why? Because a tree also start with a root and then it emerge into various branches. Similarly, you have a decision tree, which I'm showing to you here as a simplest algorithm, which is being used for machine learning purposes. Now it is something like this. Imagine that you want to find it out that, like, do you want to go to a restaurant or do you want to buy an hamburger? Okay, so you have two choices. Either you can go for a restaurant or either you can buy a hamburger. Now, how would you decide which one you would follow? So you will start with what is called as a root node. You will start with the root node that whether I am hungry or not, right? If I am hungry, right, then only I will go for all these activity. If I am not hungry at all, then simply go and sleep. You got my point, right? So this is how you will start with the first node, which is to find it out whether I'm feeling hungry or not. If I'm feeling hungry, then I will decide that, well, do I have money which is around $25 worth? If I have money, then I will go for a restaurant. If I don't have a money, then I will buy an hamburger. You understood this? This is simplest representation of decision tree. Basically, you decide something on the basis of the previous outcomes. And you can imagine any sort of example here. Imagine that you want to find it out whether the person will do a credit card fraud or not. Again, it will depend upon the previous circumstances that, for example, it will depend upon how much is the salary of the person. It will depend upon what is the job profile of the person. It will depend upon the fact that, like, for example, how many fraud or how many cards this person have, right? So on basis of, you will decide that whether this will do a credit card fraud or not. So this is the simplest form of classification based algorithm. Then we have the next algorithm, which is called as a random forest. Now, what is a random forest? As the name suggests, you built one decision tree in the last example, right? But one decision tree can sometimes be overfitting as a case, right? So people said that, like, why should I only trust one decision tree? For example, whenever you take a bold decision in your life, you don't trust only a single voice, right? You want to hear it from multiple different people to make your decision more stronger, right? Go to a doctor. If the doctor says to you that you have this type of a disease, you don't believe in that. What you do is you also talk to second doctor, third doctor, fourth doctor to confirm that this is true or not. Okay, so this is what is called as a random forest. As the name suggests, why it is called random forest? It is called random forest because now you're building the various number of decision trees here. It's like a forest of all the trees, right? It is no longer a single tree, it is a forest of complete trees. So for example, you can imagine that if it is my training data set, I will split my training data set into multiple examples, multiple decision trees will be built, and then based upon the majority, I will decide whether should I do this or not. Okay, so it is also called as a bagging sort of methodology where we bring the outcome of various models or we bring the outcome of various trees all together to make our powerful decision. Okay, so this is another example. This is another algorithm which is called as a random forest. Then after random forest, we have something called as naive Bayes. Okay, now what is a naive Bayes algorithm? Naive Bayes is also a simplest algorithm, but naive Bayes is basically based on the Bayes theorem. Okay, so this algorithm is basically based on the Bayes theorem, and Bayes theorem is based on the conditional probability, right? So it is based on the conditional probability, which is your naive Bayes. Now in naive Bayes, what happens is, like, we decide that whether something will happen or not on the basis of probability. So let me illustrate you with this example. Imagine that you want to find it out whether I would have a disease or not. Okay, so first of all, the probability of having a disease is 0.10 and the probability of not having a disease is 0.90. Okay, so if there is a probability of having a disease is 0.10, you will further find it out that what is the probability that my test will be positive given I am diseased. What is the probability that my test to diagnose the disease is negative given I have a disease, right? Similarly, if you go into this direction, if there is a probability of not having a disease is 0.90, you will find it out that what is the probability of having a disease, test being positive with no disease, and what is the probability of no disease given I don't have the disease, which is 0.90. So basically here you check the outcomes. Here you check the outcome of all the possible combinations. This is what is called as the naive Bayes algorithm or Bayes theorem, or conditional probability based theorem. Okay, then we also have something which is called as a key nearest neighbor, which is the one of the finest algorithm, which also helps you in deciding the classification, right? Now, what is k nearest neighbor? K nearest neighbor, as the name suggests, what happens in this case is we try to build, basically it's like a neighbor. So it's something like this. Like if I give you the data set, say I give you the customer data set, okay, and it is a transaction data set. So customer number one has bought a product number 1, right, from a particular vendor at a particular rate, and this is a profit this customer has given to us, and this is the revenues. Okay, this is my customer number 1. Similarly, you would have customer number 2, customer number 3, customer number 4, right? Now if I ask you that which customer profiling is nearby same, right? So what you can do is you can group your customers, or you will get to know that which customer behave in the similar way. So you can say that customer 1, customer 3, and customer 4, they behave in a similar way because they are giving us the high profit and high revenue margins. You understood? So this is what happens in the case of k nearest neighbor. So k nearest neighbor, what you generally do is you find it out that what I would be able to, find it out who is my nearest neighbor, like what are the similarities in the patterns we have, right? This is what we use for k nearest neighbors. And this you can see that, for example, the algorithm based on the distance based mechanism find it out that how many people or what type of audience is similar to the outcomes, right? So then moving further here, with the second topic, let's go into detail about what is decision tree all about, right? So far I have touched base on classification based algorithm, right? And I was teaching you different type of classification based algorithm, but since the focus of today's class is decision tree, let's take a deep dive into the decision tree. Okay, so let's get started with decision tree. A decision tree is a graphical representation of all possible solutions to a decision based on a certain condition. What does it mean? It means that it is as simple as that. Imagine that this is a tree, right? So it is like a tree where you have a problem statement that should I accept a job offer or not? Imagine that you want to find it out that should I accept a job offer or not? This is a problem statement which is there in your mind. Now, how would you solve this problem statement with the help of a decision tree? First of all, you will start with what we call as a root node. We will start with a root node, starting with, to find it out, what is a salary? Okay, what is the salary I'm getting? So if my salary is equal to or greater than equal to 50,000, I'll go here. If my salary is not greater than equal to 50,000, I will say I will not accept this offer. Okay, now imagine that you say that your salary is greater than 50,000, then you will check another variable here. You will check it out whether I have to commute more than 1 hour. If I have to commute more than 1 hour, I will decline the offer. You're getting my point, right? Then you will, if you don't have to commute more than 1 hour, then you will still consider this option, and then you will check it out. For example, in this case, we are checking it out whether you are getting the free offers also, like coffee or some snacks or other things like that. If yes, then you will accept finally the offer. Otherwise, you will decline the offer. You got my point? This is how our decision tree works. Basically, decision tree will keep on splitting unless and until you are able to find it out your decision. Okay, so here the decision was, shall I accept this or not? Right? So it will keep on splitting unless and until you get your decision whether you do this or not. Like this example which I have explained you. Okay. Now, with this, what happens is, like, if I go further and explain you further on this decision tree, let's understand this more importantly, right? Let's understand this one by one. So imagine that this is my data set. Okay. Now, in my data set, you can see that I have various colors given to you. It's like a green color, yellow color, red color, and a yellow color. I am saying if there is a green color fruit with a diameter of 3, right? And I can say it is a mango. Whereas I'm saying if it is a yellow color and a diameter 3, still will be called as a mango. If it is a red color with 1 diameter, then it is a grape. And it can be a red color with a diameter of 1, still can be a grape, but even a yellow with a diameter of 3 can be lemon. Now, what is happening in this case is, if you have this type of a data set where you want to predict the label of the fruit, right? You want to predict whether a fruit will be mango, whether a fruit will be lemon, right? Or whether a fruit in this case is mango and lemon or grape. I have to build a classifier, which is a decision tree classifier on the basis of this data set. Imagine this is a problem statement given to you. Now, first of all, what you will do here is you will take this data set, right? You will take this data set and you will start with a root node. Root node, imagine here is like, is my diameter of the fruit greater than equal to 3 or not? Okay, is my diameter of the fruit greater than equal to 3 or not? If it is greater than equal to 3, right? Now, if it is greater than equal to 3, you can see that you have 3 fruits here, 3 rows of the data set here. One is green with 3 mango, yellow with 3 lemon, yellow with 3 mango. And wherever it fails, if the diameter is greater than equal to 3, then it can be a mango or it can be a lemon. I'm not sure on my decision. So what I will do here is I will split it further. So I have to split this further. Here the splitting is not required, but if I split this further, I may check it out now. Is the color equal to yellow or not? Now, if the color is equal to yellow, then I have two fruit, which is your this row, which is your mango or lemon. And if the color is not equal to yellow, then you will have the another row of the data set, which is which you are left with, right? So this is how you have done this work in the case of your decision tree. Okay, and how you will find it out at which type of the criteria or which type of the algorithm I should, or which type of criteria or variable I should choose here to split the tree is on the basis of Gini index and the information gain, which I will illustrate and show you in the few slides from now. Okay, so I hope with this you understand the how your decision tree works, basically on the basis of the condition. And if you get a pure subset, then no need to split it further. If there is no pure subset, you will keep on splitting unless and until you get a pure subset. Okay, so in this case, what has happened is you got 100% mango. Here you got 50% mango and 50% lemon. Okay, so now this is what I have told you in the previous slide, like how does it work, right? Now this all depend upon the Gini index basis, right? Now in the next subsequent slide, let me tell you and explain you about Gini index and information gain. How does it work, right? How does that something works on the basis of your Gini index? So imagine that, imagine that I have a feature here, is the color green or not, right? Basis of whether the feature, whether you have a color green or not, what would happen here is if the color is green, you will get this row here. If it is not, you will get these two rows here, right? In the next, it may decide on the other basis, right? It can be, is the diameter which is greater than equal to 3 or not, and many other things. Okay. Now let's go ahead the example and the questions which is coming to your mind, which is related to decision tree terminologies. I'm pretty sure you would have these questions in your mind and you would be thinking that how should I decide that which feature I should use and which feature shouldn't I be using? This is the question which you had. And this is an excellent question for understanding the decision tree. But before I go on to that, I have to tell you about some of the terminologies which we commonly use while we build the decision tree. So first of all, decision tree looks like this type of a tree-based structure. Okay, so every decision tree will have its root node. So root node is where the decision tree will start. So it represents the entire population or sample, and it is further get divided or into two or more homogeneous sets. So as you know that this will be the first feature on the basis of your tree will start. Like tree start with a root, your in this case your decision tree will also start with a root node. Okay, now once you have the root, after that in a tree what happens is you will start getting the branches, right? I hope you understand what is branches. In this case we will keep on splitting unless and until we get a decision whether this will happen or not. So it's like a branches. Okay, then we would also have a parent or a child node. So child node is nothing but when you have a branches, then the branches can also have the outcomes. So in the previous example, like for example, we have whether the diameter is greater than equal to 3 or not. You remember whether the diameter is greater than equal to 3 or not. If it is true, what is happening? If it is a false, what is happening? So this is a child or child node. Basically, this is an intermediate node. This is not the final decision which is being made. So this is called as a parent or the child node. Then we also have other terminology here, which is splitting, which you know that we will keep on splitting unless and until you get a desired node. And finally, the tree end with the leaf node. So always remember one thing, you will start your tree with a root node. Root node is a node with which you will start the decision tree, and you will end your decision as decision tree at a leaf node where you will get a decision that you should do this or not. Okay, and now pruning is the activity where you will cut down the decision tree if it is pruned lot amount of times. I will even explain you this. It is a case of overfitting. You shouldn't build shouldn't build 1,000 branches of the tree when it is not even required. So I'll explain you this point. Now let's move further here and let's see this with the help of an example, which was your Gini index and your information gain, right? So this is where you were asking me that which question to ask and when, right? How would you decide that which feature has to be taken first, right? Let's take up an example here, and I would encourage every one of you to hear me really fine here, because this is on the basis how would you decide or how the algorithm decide to break this further. And I'm explaining you with the help of one simplest example, and we will do some maths over it. So imagine that there is a data set where I want to find it out whether I will play the match or not. Okay, there is a cricket match or there is a football match or whatever it is. I want to find it out whether I will play the match or not. Okay, now how do the decision tree look like? Decision tree look like this. If the outlook is humid, if the outlook is humid and if the outlook is humid and humidity is very high, then I will not play the match. On the other hand, if the outlook is humid and humidity is normal, I may play the match. Okay. If the outlook is absolutely clear, then I will always play. On the other hand, if outlook is windy and the winds are very strong, I may not play the match. On the other hand, if the outlook is windy and the wind are weak, I may play the match. So now what is happening again is that you are not sure how you decided with outlook, how you decided with these nodes here, how you decided with these features here. Let me try to show you this entire data set. So this entire data set look like this. Okay, so this is basically your 14 days data set, and this exactly happens in the case of your classification based algorithm. You will get a data set like this. So you can imagine that you want to find it out, I would like whether I will play or not, right? This is what you want to essentially find it out whether I would play or not. On basis of what? On basis of 4 different variables you have. 4 different variables or features in the data set is outlook, temperature, humidity, and wind, right? So now it can be like if the outlook is sunny, temperature is hot, humidity is high, wind is not there, I will not play the match. This is how you will read this one data point, right? Similarly, I have multiple data point. Now I have to decide how can I build a decision tree, and out of these 4 features, which feature should I use first as my root node, right? So this is what I have to decide, and let's do it accordingly, right? So now what I'll do from here is I will illustrate you what is Gini index, what is information gain, and how does this happens, right? And this is basically used to build your decision tree. So before I make you understand about Gini index or information gain, one thing which you should always remember is to understand the concept of impurity. What is impurity? Impurity is nothing but, you can see there is a basket where you have apples, right? Now, if you have a basket which is of apple and another tray, it is written the label as apple. Now, in this case, you will never make a mistake. You will never make a mistake because here you have an apple, here you have only one label. So everything will be perfect. It will be 100%. Basically, there is no impurity, there is no problem in your data set, right? On the other hand, let me flip the story. In this case, imagine that I have different fruits in the basket, which is like apple, you have a banana, you have a grapes, you have a, cherries and many other things, right? And you have many apples, many labels here. In this case, try imagining you have to match each fruit with its label, right? Now, in this case, the impurity cannot be equal to 0. The impurity will not be equal to 0 in this case, because what would happen here is that you have a chances of misclassification, right? This is a very important concept, right? When you have perfect thing, the misclassification will not happen. But whereas if you have a multiple labels with multiple fruit, misclassification or impurities will not be equal to 0, right? So this is associated with a term called as entropy. Maybe in your childhood days you have learned about entropy in your chemistry class. In a simple sense, what is entropy? Entropy is a randomness of the space, sample space. Whenever you are not sure on your decision, then entropy will be more. Imagine that I'm giving you the data set where it is like 51% of doing this thing, 49% of not doing this thing. 51% chance that the employee may leave the organization, 49% chance that employee may not leave the organization. So basically you are not sure on your decision. If you are not sure on your decision, then the entropy will be very high. On the other hand, if you are very sure on your decision, then the entropy will be very low. So basically we need that feature which can provide us lowest entropy rather than the highest entropy to select as that as a good feature. So we generally find it out entropy by the help of this formula. What we simply do is don't get scared with this formula because everything happens automatically in R or Python, right? Imagine, just look at this formula. What is this formula? This formula says that what is the probability that something will happen, multiply by log base 2 probability that something will happen, subtract this with probability that something will not happen, into log base 2 probability that something will not happen. Okay, let's take up an example. Don't worry about it. Let's take up an example that probability that I will win the match you will apply here, and probability that I will not play the match or win the match you will apply here, and then you will calculate the entropy. Let's take an example how you can do this in our case. So in our case, let me show you. Yeah, how we will build the decision tree in our case. In our case, you just see here what is happening is that we have 14 instances or 14 rows of the data set, where 9 times if you see it, I will play the match, and 5 times I will not play the match. Okay, so if you see carefully, there are 9 labels where I'm playing the match, and there are 5 labels where I'm not playing the match, right? So first of all, I have to find it out the total entropy. How I will find the total entropy? This is being determined by probability that I will play the match, multiply this with log base power 2 probability that I will play the match. What are the chances that I will play the match? 9 out of 14. All of you will be with me, right? This is 9 out of 14. Multiply with log base 2, 9 out of 14. Subtract this with what is the probability that I will not play the match? 5 out of 14. Multiply this with log base 2, 5 out of 14. So once you calculate this, you will find it out the entropy of this entire system. Entropy of this entire system is 0.94. Okay, so this is the entropy of your entire sample space. This is the first thing. Now, how this entropy will help you in selecting which features you will take or not? So let's go further. So now we will take each feature one by one, whether I should take outlook, whether I should take temperature, whether I should pick up humidity, or whether should I pick up windy, right? Let's go one by one. Now, first I'm plotting for outlook. Imagine for outlook, how many times, so what are the distinct value of outlook? Outlook can be sunny, outlook can be overcast, or outlook can be rainy, right? These are the 3 different combinations you can have for outlook. Now, if the outlook is sunny, 2 times I'm playing, 3 times I'm not playing the match. If the outlook is overcast, I'm always playing the match. If the outlook is rainy, 3 times I'm playing, 2 times I'm not playing the match, right? This is how I have bifurcated it. What I will do in the next iteration is, let me find it out the entropy of outlook. Okay, so if we start with outlook, remember this formula, which is, probability that I will play, multiply with the probability that I will play, right? And subtract with probability which I will not play, and log base 2 of not playing. So 2 by 5 is the chances that I will play, into log base 2 by 5. This is a subtraction here, right? With I will play and log 3 by 5 I will play, right? So you will calculate this entropy when outlook is sunny. Yeah, so you got this entropy when the outlook is sunny is 0.971. Accordingly, you will proceed with calculating the entropy when the outlook is overcast. Outlook is overcast, always you are playing, right? If the outlook is overcast every time you are playing, so it means that you will get a probability of 0. If you apply in that formula, you will get 0. And third, what would happen if the outlook is sunny? In that case, you will again multiply and you will put the formula and you will get it out 0.971, right? So you will find it out entropy for each and every distinct combination of your feature. You got my point, right? Outlook being sunny, outlook being overcast, outlook being sunny, overcast, sunny, and rainy. This should be replaced here, right? And then what you will do is you will finally calculate the information gain. Information gain is nothing but what you will do is you will pick it up the chances, you will pick it up the entire chances when you are playing, right? Which is 5 out of 14. You remember 5 out of 14 were the total chances that I will play, into if it is sunny, plus 4 out of 14 if it is overcast, 5 out of 14 if it is rainy, right? And you will calculate the information from this outlook. And once you calculate the information, you will subtract this information from your total entropy, which I found it out in the last slide, which was 0.94. You will subtract this and you will get the information gain, or this is also called as a information gain from a particular feature. So basically, these type of a calculation, first of all, don't get scared away that you have to do this calculation. But what I'm trying to explain you is this is how your algorithm will work. For each and every feature, it will calculate the information gain from your feature, right? If you have the more information gain, it means that this variable is of very, very important in predicting that something will happen or not. Okay, so for outlook, I got the information gain as 0.247 with all the calculation. Remember, then we will proceed with wind, if the wind is there or not, right? And then I will proceed with wind and I will calculate the information gain and say information gain I found it out is 0.048, right? Similarly, we will calculate for all the 4 of them. Let me put it together for all of you. So this is what happens here. Now, if I put in front of all of you, these were the 4 different variable I have: outlook, temperature, humidity, and wind, right? I am calculating the information gain for each one of them, and the information gain I got for outlook is 0.247. So if the information gain is highest in a particular feature, that feature will become your root node. You got my point. So therefore, we will pick it up outlook as our root node. Similarly, for when the tree gets started later on as a branch node also, your information gain will be calculated, and whichever feature is giving you more information gain, that will be picked up later in the your tree also. So this is how you will build your decision tree, and you will finally get a decision tree like this. Okay. So now what I will do is, I will quickly show you how do we do the decision tree in your Python. Okay, so I'll show you how do you do this in Python, and then I will summarize for all of you that why decision trees or tree-based algorithms are better than your other algorithm. Okay, so how do you choose? Basically, that which algorithm you will select and when. Okay, so I'll describe you this, but before, let's jump on to Python and go there. So what I have done here is, I had built the decision tree in front, already. So quickly, I will walk you through the commands. Okay. So what happens here is that in Python, as you would be well versed with this, that we generally import packages in Python. So I'm importing NumPy, I'm importing Matplotlib for plotting the chart. I'm importing various packages from your sklearn, which is for machine learning purposes, right? So I am importing your label encoder, your decision tree classifier, classification report, and I'm importing your tree, right? So we have all this which I am importing, right? After I import, what I will do is I'm reading my data set. So I'm showing you this with the help of our iris data set, which is one of the very popular data set for building the a decision tree, right? For any particular source. So imagine that this is my data set, and I'm just showing you 6 rows of the data set where, like, I want to find it out whether a particular flower species will be Setosa, versicolor, or virginica. I have 3 different flowers which I want to predict, and on the basis of sepal length, sepal width, and petal width. So basically, I have different dimensions of flowers length and width, and based on that, I want to find it out whether the particular species will be Setosa, versicolor, or virginica. You got my point, right? So this is a data set. So what I will do is, as you know, with every machine learning data set, we play with the data set. So I'm checking the information here, what type of the data type it is. So sepal length, it is a float, petal length, it is a float, and species is a object. Why object? Because this is a categorical column. So after this, I'm also checking whether there is any null value present in the data set or not, because if there is any null value, then we have to get rid of that null value, or we have to replace that null value with some imputed value, right? This is what I'm checking here. Once I do that, I'm also plotting this because we usually do visualization, right, to understand the data set better. So what I'm doing here with the help of SNS, which is your SNS.pair plot, I'm plotting all the possible plots. So basically sepal length with sepal width, what type of the combination look like. So Setosa, versicolor, and virginica, there are 3 different species you can see in the data set. And this is what I'm getting a trend between your sepal length and sepal width. Similarly, this is basically from sepal width to petal length, right? So this is how I'm understanding the patterns, or I'm understanding the relationship between the variables in the data set. So this is what I'm understanding here. I'm also checking whether there's a correlation or not. Higher the shade, it means there will be a strong correlation. So all of these things is being done as a part of exploratory data analysis before even you start your machine learning model, right? Once you do this, after that, what I have to do is, after that, what I'm trying to do is I am taking your species column, what I want to predict, as my target variable, which is your dependent variable. And so this is the dependent variable, and with the help of what I want to predict will be my independent variable. So I'm calling X all my independent variable, and I'm calling target as my dependent variable. Once I do this, then you will also think about it that the variable which I want to predict is the flower species, right? But I want to convert this into 0 and 1 class, 0, 1, 2 class, because your computer cannot understand text, right? Computer can only understand the numbers. So what I'm doing here is I'm changing it to the class, right? So what I'm trying to do here is I'm saying wherever it is Setosa, it will become 0. Wherever it is Virginica, it will become 1. And it is versicolor as a third category, it will become 2. So now imagine my data set, my label to predict becomes 0, 1, or 2 instead of 3 flower, which was Setosa, versicolor, and Virginica. This is what I'm doing with the encoder here. Once I convert this and this become my target, what I will do is, as I told you, that I will split this data set into training and test data set. So basically 80% of the data is going into the training data set, and remaining 20% I'm taking as a test data set. Okay. Now I will call decision tree classifier. Like I want to make a decision tree and I want to fit this on my training data set and the test data set. And I will start building the decision tree, and with the help of so here is when I have created the decision tree, and here is when I'm checking the prediction, how accurate my decision tree is. So I got my precision, which is good. I got my recall, I got my F1 score, and I also get the support, right? So all these matrices are being used to calculate your how accurate your predictions are. So higher the precision, better the results would be, right? And finally, I am showing to you that how does the tree look like. So I had tried to plot this decision tree in front of you. So basically it starts with petal length, and you can see the Gini index coming up here, or the information gain, which is information gain and Gini index are reciprocal to each other. If you want to use information gain, you will get that score. If you don't want to use information gain, you will get Gini index. So they are both reciprocal of each other. It is one and the same thing. You use Gini index or you use information gain. They are the two different metrics to build your decision tree. So you can see that based on a petal length, the tree gets splitted like this. Then based on the petal length of different dimensions, your tree further split, then it further split, then it further split, and finally you get to know that whether the particular species will be versicolor or virginica. Okay, so this is how your entire decision tree is built in Python. Okay, so this is how it's so simple. I know it takes time to build this thing, but once you are a good data scientist and you understand all these things, it is very simple to build all these things very easily in Python or R. Right? So now, finally, going back, how would you decide? How would you decide that which algorithm, which algorithm will be taken when? So what happens is, this is on the basis of scikit-learn. So it starts something like this. Okay, so it is on the basis of like this, that first of all you see here that whether how many samples you have, how many data points you have in the data set, right? If you have more than 50 samples, then you will go here. If you have less than 50 data point, then you will go here. So you will get more data set, right? So if you have more data, if you have greater than 50 data point, then you will go further, you split your data set. If it is not, then you just the kind advice it, get more data set. Okay, so then you will decide at what you want to predict. If you have a labeled data set, then you will go here, right, and do clustering. If you don't have the labeled data set, then you will see whether you want to predict a quantity. If yes, you will go in regression. If you want to predict, if you just want to do exploratory analysis, you can do dimensional reduction. If you have a labeled data set, for classification, you can do all this classification. So basically, this is a cheat sheet which we generally use to decide that what we have to do with the data set and when.
Let's understand what is a random forest. So random forest is constructed by using multiple decision trees, and the final decision is obtained by majority votes of these decision trees. So let me make things very simple for you by taking an example. Now suppose we have got 3 independent decision trees. Here we are just taking 3 decision trees, and I've got an unknown fruit, and I want that these trees would give me a result of what exactly this fruit is. So I pass this fruit to the first decision tree, the second decision tree, and the third decision tree. Now a random forest is nothing but a combination of these decision trees. So the results are being fed into the random forest algorithm. So what it sees is that, okay, the first decision tree classifies it as peach. The second decision tree says that it is an apple. And the third one says that it is a peach. So random forest classifier says that, okay, I've got the result as 2 peach and 1 for an apple. So I would say that the unknown fruit is an peach. All right. So this is based on the majority voting of the decision trees. And that is how a random forest classifier comes to a decision of predicting the unknown value. Okay, so this was a classification problem, so it took the majority vote. Now suppose if it was a regression problem, it would have taken mean of it. Okay, so now let's move on further to understanding what is a decision tree. But before that, we should understand that random forest, the building blocks are decision trees. And that's why studying decision tree becomes important, because if we understand one decision tree, we can apply the same concept to random forest. Okay. So now let's move on forward and understand the important terms in random forest. And this will also help us consolidate whatever we have learned so far. So we've taken the same small decision tree of the previous example, and let's understand these are also the important terms which will be relevant to random forest also. So the first is the root node. Now here what happens is that the entire training data is being fed to the root node. And then we've got here that each node will ask either true or false question with respect to one of the feature. And then in response to that question, it will partition the data set into different subsets. That's what it is doing here based on the condition that if the body mass is greater than or equal to 3500, it asks a question either yes or no. And based on that, again, further partition is done. And if not, then it just classifies the species. And then again, what happens is that the splitting. Now, this is very important here. The splitting takes place either with the help of a Gini or entropy methods. And these helps to decide the optimal split. And we will be discussing about splitting methods very soon, right? Okay. And then we've got the decision nodes, which provide the link to the leaf nodes. And these are really important because then only the leaf nodes would tell us what actually the real predictions or to which class does this species belong. So now coming to the leaf node, and these are the endpoints where no further division will take place and we will obtain our predictions. Okay. So now coming up to another important thing here is working of random forest. So now for working of random forest, we will have to understand a few important concepts like random sampling with replacement, feature selection, and also the ensemble technique, which is used in random forest, and that is bootstrap aggregation, which is also known as bagging. So we will understand this with the help of an example, which will be very simple. And then we will go on understanding how feature selection is done in both the classification and the regression problem. Actually, how random forest select features for the construction of decision trees. Well, in random forest, the best split is chosen based on Gini impurity or information gain methods. So this also we will understand. Now let us first understand random sampling with replacement. Now what happens here is that we have got a small subset of the same penguin dataset, wherein we have got some 6 rows and 4 features, that means 4 columns. And the arrows that you can see is that now we will be creating 3 subsets from this small subset, right? And these 3 subsets will become our decision trees. And then we'll be constructing decision trees from these subsets. So let us create our first subset. And you can see here that the subset is randomly being created. And for convenience sake, let me just also show you the different subsets here. Okay, so now for better understanding, let us understand this, that in the first subset, if we focus, we've got certain random rows here and we've got certain feature, but we do not know how this feature has been selected. We got island and we got body mass, but in the second subset, we got island and flipper length. And in the third subset, we got body mass and flipper length, right? Now let's look at the rows. Now, when I am talking about these features, I will say this is feature selection. And remember this term. Now coming to the second concept, that is random sampling. Now random sampling is nothing but selecting randomly from your subset. So I'm selecting randomly certain rows from my subset and creating further subset. Okay. So what is replacement here? Replacement can be seen here and can be understood with this second subset. We see here that the 𝐤𝐴 species, this row is being repeated again. And this is replacement. That means that when we are working with repeated rows and this row can be repeated again in the second or the third subset, then this is random sampling with replacement. That means my random forest can use a row multiple times in multiple decision trees, right? So this is the basic concept of random sampling with replacement and feature selection in random forest. Another important term which I would like to bring into the notice is that when we are working with these type of small subsets, these are also known as a bootstrap datasets. And when we aggregate the results of all these datasets, it becomes bootstrap aggregation. So just filling in the gaps so that later on the concepts become more clear. So now let's move on to drawing decision trees of these subsets. Okay. So let's draw the decision tree of the first subset. Again, we are taking body mass as the first root node, and then based on a decision like if the mass is greater than or equal to 3500, then take a decision either yes or no. If it is no, then the species is 𝐂𝐚𝐬𝐿, and if it is yes, then again you partition based on island, and if it is 𝐷𝐸𝐺, then it is Edureka, and if it is 𝐵𝐸𝐿, then it is 𝐵𝐸𝐿 species. Okay. So this is how we will construct 2 more decision trees of the remaining subsets. So on the second subset, let us just again create decision tree. And here now we are taking flipper length, and then based on a condition that if the flipper length is greater than equal to 190, then make a split. If it is yes, then the species become 𝐵2. And if it is no, that means again make a decision based on island, and if it is Togresen, it is Adelie, and if the island is Dream Island, then it is a chinstrap species. So this is how the decision tree of the second subset has been created, and this is how it will take decisions, right, based on the tree length, depth, and also the features it is selecting. Okay, so now let's create the third decision tree of the third subset, and we get a decision tree something like this, wherein body mass, if it is greater than 4000, and if it is yes, then clearly it is a 𝐵2 species, and if it is no, then again make a partition with respect to flipper length, another feature here, and then if it is again greater than equal to 190, then the species would be Adelie, else it would be chinstrap. So this is how decision tree 3 will make a decision. Now let's just keep these decision trees with us, okay? And we will make sense of these trees just in a while, okay? But before that, let us understand how feature selection is done in a random forest. How am I selecting the columns? So for classification, by default, the feature selection is taken as the square root of total number of all the features. Now suppose I've got here 4 features. So it is a classification problem. I will take the square root of these 4 features, which becomes 2. So decision tree would be constructed based on 2 features each. If suppose I had 16 features, then it would be square root of 16. That would be 4. So 4 features would be taken in each decision tree. All right. And suppose if this would have been a regression problem, then by default, what would happen? The features would be selected by taking the total number of features and dividing them by 3. Okay. So this is how by default the feature selection is being done by a random forest. Okay. Now let us move on forward to consolidating our learning. So now we are coming to ensemble techniques, that is also known as bootstrap aggregation. Random forest uses ensemble techniques. And what is ensembling? It just means that you are aggregating the result of the decision trees and taking the majority vote in case of classification and the mean in case of regression problems and giving the output. Okay. So now we have again plotted all our decision trees here. And below we can see that there's an unknown data and I want to predict the species of this data. So what will happen is that again, let us just feed this problem to each of the decision tree and let's see what each decision tree makes the prediction. So I just feed this unknown data to decision tree 1 and it says that, okay, the species seems to be chinstrap. Okay. And then decision tree 2 says that based on the data, it has been found that the species is Adelie. And then decision tree 3 says that, no, with my decision tree, this species is chinstrap. Okay. Now, all these data is being fed to random forest classifier. And it says that, okay, for chinstrap, I've got 2 votes. For Adelie, it's got 1 vote. So the new species would be chinstrap, right? So this is how the bootstrap aggregation is done based on the majority voting and the decisions taken by different decision trees. They have been combined together, aggregated, and we get an ensembled result in the random forest. Okay, so this was a very simple concept of ensemble techniques which has been used in random forest. Okay, so now let's move on forward to splitting methods. So what are the splitting methods that we use in random forest? So splitting methods are many, like Gini impurity, information gain, or chi-square. So let's discuss about Gini impurity. So Gini impurity is nothing but it is used to predict the likelihood that a randomly selected example would be incorrectly classified by a specific node. And it is called impurity metric because it shows how the model differs from a pure division, right? And another interesting fact about Gini impurity is that the impurity ranges from 0 to 1, with 0 indicating that all of the elements belong to a single class and 1 indicates that only one class exists. Now value, which is like 0.5, this indicates that the elements, they are uniformly distributed across some classes, right? Now moving on forward to information gain. Now this is another splitting method which random forest can use, and information gain utilizes entropy. So entropy is nothing but it is a measure of uncertainty. So information gain, let's talk about that first. So the features they are selected that provide most of the information about a class, right? And this utilizes the entropy concept. So let's see what is entropy. This is a measure of randomness or uncertainty in the data, right? So we will understand this entropy with the help of a small example. So don't worry about it. So let's understand this entropy. Now suppose there's a fruit tray with 4 different fruits, right? And what do you feel about the entropy here? That means the randomness of the data. Is it really easy to classify these fruits into the respective class? So this becomes really uncertain and the data looks messy here. But what if we just split here these into 2 trays, wherein the first tray would have peaches and oranges, and in the second tray will have apples and lemons. So now this becomes a little more certain. We get low randomness here, and this is called as low entropy. So when we move down from tree, that means from root node to the leaf nodes, the entropy reduces. And we can also calculate information gained from this entropy. That is the difference in entropy before and after the split. That is known as information gain. Okay. So once we move down the tree and start reducing the randomness from the data, the entropy becomes lower. And that is what we want in our data. If there's low entropy, that means we are likely that the predictions would be more accurate and we can make predictions very easily as compared to very messy data which has high entropy. Okay, so that was about entropy. And now let us just move on to the practical demonstration or a hands-on on random forest. Okay, so now it's time for a hands-on on random forest. So let us just import a few basic libraries of Python in our Jupyter notebook. And we will run this. We will import pandas as PD, NumPy as NP, and 𝐶born as SNS. Now 𝐶born is needed here because we want to load a data set, that is a penguins data set, with the help of 𝐶born. And this is already been preloaded in 𝐶born. This is already loaded data set, and 𝐶born has got multiple data sets, for practice for beginners. So it is a good way to practice for data sets. Now we can see this asterisk sign, that means it is telling us to wait. So let us just let it get loaded. So we got our data in an object called df, and we can see the first 5 entries here. And this data frame is shown in the form of a table, rows and columns. And we see here some species, island, bill length, bill depth, flipper length, body mass, and the sex of the penguin. So our task is to specify or to classify these species of penguins into the respective correct species, right? So we see the shape of our data, and we see that it is like 344 rows and 7 columns. And we will see the info. So we see df.info, and this gives us, along with the non-null count, we also get the data type of the values. So we have got species island as the object data type, whereas the bill length, bill depth, triple length, and body mass are in floating point, or you can say floating data type, and the sex is in object data type. Right? So now moving on forward to calculating how many null values are there with the help of df.isNull.sum. So we get certain some around 2 null values in all these columns, as you can say the features like bill length, bill depth, flipper length, and body mass, whereas there are 11 null values in sex feature. Right? So what we do is, since they are very small null values, we can just drop it, or you can also ignore them. So here in this data frame, what I'm doing is I'm just dropping these null values, and let us just check whether they are being dropped or not with the help of, again, the same function .isNull.sum, and then we see that yes, they are being dropped from our data frame. Now let us do some feature engineering with our data. Now we have seen that we have got some object data type in our data frame. And before feeding it into algorithm, that is random forest, we have to transform the categorical data or the object data type into the numeric. So we are using here one-hot encoding to convert the categorical data into numeric. Now there are various ways in Python which we can do that, like one-hot encoding, or you can also use a mapping function in Python. But here we are using one-hot encoding. So let us just do that. And we find here, first of all, let us apply it on the sex column. And here we see that we have got 2 unique values in sex, that is male and female. And we use pandas here to get dummies. That is how we will apply this one-hot encoding, because this is how get dummies work. So what happens is here is that the new unique values are converted into the respective columns in the data frame. So we see here we have got 2 unique values, males and female, and they are being converted into the columns. Okay, so one thing to note here is that we also get a problem of dummy trap, because here we see only 2 unique values. Now suppose if I had 6 or 7 unique values and I do this one hot encoding, I would have lots of features in my data frame, and that would lead to several complexities. So what I do is, to keep things simple, I can use one hot encoding when my data frame or my unique counts are low, when my unique values are less. So since I had just 2 or 3, I can use it. So I'm using here. So what I do is, again, now one row, one column, as we can see here, that it is redundant, giving me extra information. So I will just drop it. So I drop this first column, and what I get in this data frame is only male. So let us just infer whether I can also infer females from this or not. So if the value is 1, that means the penguin is a male. And if the value is 0, that means the penguin is a female. Okay, so only one column is needed for this data frame. So I just kept one and dropped the another one. Okay, now apply again one hot encoding to the island feature. So in island, if we check the unique values, we've got 3 unique values here: 𝐓𝐫𝐶, 𝐵ISCO, and Dream Island. And the object is the data type, right? So again, we will use pandas, pd.getDummies, and we will apply it on the feature island, and let's get the head of it. So we get here, again, the unique values were converted into columns, and we get here respective 3 columns. And then again, we will just drop the first column to get the remaining 2 columns. So here also we can infer that if the island is 𝐓𝐷, if it is 1, then it is not Dream, neither 𝐵ISCO, right? So this is how we can read it from the data frame and understand that. Now remember this thing, that these 2, island and here sex, these are 2 independent data frames. These are not yet included in the main data frame. So what we will do now is we will concatenate the above 2 data frames into the original data frame. So what we do, we again create a new data frame, that is new data, and let us just concat with the help of pd.concat function, and we will concat what? df, island, and sex. And access is 1, that means in the column. Okay. So when we will run this, let's see the head of it. So everything gets concatenated in a single data frame, which is good for the feeding this data into, or splitting the data into test and train data. So now we have this new data frame, and we've got some repeated columns here which needs to be deleted. So what we do is we will delete sex and island here, which are just repeating, because we've got here male, and we have also got here Dream and 𝐓𝐷. So we do not require this island column, neither this sex. So we just drop it with the help of new data.drop and the column names x is 1 in place equals to true, right? And let's see the head of this data frame. Head of the data frame gives me 5 unique values, right? And now it is time to create a separate target variable. And what we'll do is we will store in a variable called y only species. So what we do is from this new data.species, we will just store the species in this y. And we see this y.head, that is the first 5 species. And we got the values here. That means another target variable is being created now. So, and you can also see the y.unique values as Edureka, 𝐁𝐚𝐬𝐞, and 𝐁𝐚𝐬𝐞. So now we see here 3 unique values of the penguin, that is 𝐁𝐚𝐬𝐞, Edureka, and 𝐁𝐚𝐬𝐞, and the data type is object here. So again, we need to convert this object into the numeric data type. So now what we are doing is we are using the map function in Python, and what we do is we map Edureka to 0, 𝐁𝐚𝐬𝐞 to 1, and 𝐁𝐚𝐬 to 2. So this is how we see then all the values are being mapped to numeric. This is another way to convert a categorical value into a numeric value in Python. Now what we do is, let us just drop the target value species from our main data frame. So we just drop it, and let's see our new data frame. So we see that we don't have any target species here, right? Okay. So in X, let's store this new data and perform the splitting of the data. So what we do is from sklearn.model selection, we will import our train test split, and we will split our training data into 70% and 30%. So test data becomes 30% and training data is some 70%. And this random state is 0, which means that I'm not fixing any random state. And this is also used for the code reproducibility. Now suppose if I again run this code, I will get the same result. It will not change. You can set this random state to any of the random number as per your choice, and the result would differ. Okay. So now let us print the shape of xtrain, bytrain, xtest, and bytest. So we see here that it has been split into 70 and 30%, and we get xtrain as 233 values here and 7 features, and X test has 100 values and 7 features. Similarly, Y train, you can see 233 values and Y test has 100 values. That means the species. Okay. So that has been perfectly splitted into 70 and 30%. Now what we do is we will train the random forest classifier on the training set. How do we do it? We will import the random forest classifier from sklearn.ensemble. So we've already dealt with what is ensemble. And then in classifier, we will store this random forest, and this n estimator is nothing but decision trees. So we are creating some 5 decision trees here, and the criteria is entropy. And again, random state is set to 0. So let's see. And then we will fit this X train and Y train. So this has been fitted and the criteria is entropy here. All right. So now let's make some predictions and let's create a variable called yPredict, and we will just predict it on X test. And we have also printed this Y prediction. And now let's print the confusion matrix to check the accuracy of random forest algorithm. And what we do is from matrices, sklearn matrices, we will import classification report and confusion matrix and also the accuracy score. So we will just import them, and then in CM variable, we will print the confusion matrix of Y test and Y predictions. So we will print it, and we see here the accuracy score also, which is 98%. So our random forest classifier is giving us a very good accuracy of 98%. And you can see a confusion matrix that only 2 cases have been misclassified. Rest all the cases have been correctly classified by random forest classifier. Okay, so now let's move on to printing the classification report of Y test and Y prediction. Let's see. And we get the precision as 96%. That means the true predictions by the algorithm is 96%. The recall or the true prediction rate is 100%, which is very nice. And F1 score is also good, which is 98%. So this is giving us a good result. But what if we change the criteria from entropy to Gini? So let's just experiment with that too. So let's try this with the different number of trees and change the criteria to Gini coefficient. So now again from sklearn.ensemble, we will import random forest classifier and fit it. Okay. And here what we are doing is just we are using 7 trees. Previously we used 5. And now in the criteria, we will use Gini coefficient and random state is 0. So let's run this and see whether there is a change in accuracy or not. And let's predict this. And let's check the accuracy score. What is the accuracy score for this random forest classifier with 7 trees? So we get 99% accuracy with changing the criteria and changing the number of trees. So you can just experiment with different number of trees and different number of decision trees. Let's just experiment with, 12 decision trees and see what happens. So you can see the accuracy reduced to 98%. Okay. With 7, we were getting 99. So let's just keep 7 because it is giving us really good accuracy. So this is about random forest classifier and how it works with several trees and different criteria to give us very good accuracy on our training and test data.
The case that we are discussing is basically the KNN algorithm, which is an algorithm which we used for mostly supervised machine learning, which is where you have labeled data. Okay, so what is KNN algorithm? So as we said, KNN algorithm is K nearest neighbors algorithm, and it is an example of supervised learning algorithm where basically you try to classify a new data point based on the neighbors of that data point, which is basically which data points are closer to it. For example, here, as you can see, you have on one side couple of cats, and on the other side you have on one side you have dogs, and on the other side you have cats, right? Now, if a new data point is given to us, there is a picture of a new animal, and if it is lying somewhere here, right, then we know that it is nearer to the cats, right? And therefore we will classify it as cat. Whereas if it is sort of nearer to the dogs, then we classify it as dog, right? So that's the neighborhood for the dog, and therefore we sort of classify it, that new animal or the new picture, as being or that of a dog. And this is quite this is something which is we even see in our regular day-to-day life, right? we have had examples where our parents keep telling us, okay, don't play with those kinds of children or something, because they are not good in their studies, or probably they are not so good in their behavior, because you would become like them, right? So it's again an example from real life of classifying a particular person based on the company that they keep, right? Or from the with the kind of people that they are. So that's sort of the example. And now let me actually go back. Okay, what are the features of k-nearest neighbors algorithm? Okay, so let's talk about the features of KNN. So as I said, KNN is a supervised learning algorithm. Typically, it is used for supervised learning kind of problems. It's very simple, as we mentioned. Intuitively, you can it's about what kind of neighbors do you have. So your class is predicted based on your nearest neighbors, as the name suggests. And then it's a non-parametric technique. So I would like to spend a couple of minutes here to discuss about what we mean by non-parametric. So typically, the supervised machine learning algorithms are of two kinds, right? One is the parametric types, and the second one is the non-parametric type. When we say parametric, what we mean is basically that the machine or the algorithm assumes that there is an underlying function or a distribution that is known of the particular data set. Like, for example, the linear regression would assume that the relationship between two things x and y is linear in nature, right? And similarly, for a distribution, a Gaussian distribution, it would assume a normal distribution of the data points, and so on. So a lot of the supervised machine learning algorithms, they assume some kind of function association between the predictor, which is basically the root causes which help you in predicting, and the variable that you are trying to predict. Whereas there are certain algorithms like the KNN or the Parson window or the linear discriminant analysis, which is of the kind which is called non-parametric, because it does not assume any particular kind of distribution or any particular kind of functional relationship of the data that you are trying to predict, or you're trying to learn the pattern of. So KNN is one of the kind. As I said, Parson window is another one, which is basically where you in Parson window, essentially the volume of the data set or the area that the data set covers is known, whereas you're trying to find the k there, which is the number of data points within that area or the volume, right? Whereas in case of non-parametric technique like KNN, it's the opposite, where the k is known, which is basically you would like to associate the class of the data point that you are trying to predict based on the k number of neighbors around it. Now k can be 3, 4, 5, whatever, right? 10, 20, and so on. Essentially, the difference between Parson window and KNN is that in KNN, you already know the k, and then from the k you try to find out the volume, and therefore then you try to find the probability or the density underlying distribution. And then there is the discriminant analysis, which is of again two kinds, linear discriminant and multiple discriminant analysis, where basically what you do is you transform the underlying data, the features, into a higher dimension, and in such a way that in the new feature space, after you have transformed the data, you now try to apply a parametric approach. Like, for example, you will try to project the features onto a line, or if it is on a subspace which is higher dimension than a line, then essentially it becomes multiple discriminant analysis. So basically, those are the three kinds of non-parametric techniques. So even if you were not able to sort of get the full hang of what these three types are, what you need to keep in mind is that non-parametric technique does not assume any kind of distribution or any kind of functional relationship of the underlying data, and therefore it gives us a lot of flexibility. Whereas the parametric techniques, they basically assume some kind of functional relationship between the data points, or they assume some kind of distribution. So where would you use a non-parametric versus a parametric technique, right? So basically you would use non-parametric technique, where you do not know about the functional relationship. That is one. Second is that, there is maybe, let's say, large amount of data and so on. And thirdly, non-parametric technique like KNN does not work in a very high dimensional data. So you would also use parametric techniques in that case. Whereas if you have, smaller data sets, you would use, typically non-parametric techniques. And then also, if you understand that the relationship between the data points might be, for example, linear or something like that, you would use a parametric technique. So you're assuming that there is some kind of relationship, like a linear relationship or something like that between the data point. So that's where you will use the parametric technique. So again, just to summarize, basically non-parametric is an approach where you do not assume any kind of distribution or functional relationship, whereas parametric assumes a functional relationship or basically a distribution between the data points. The other feature of KNN is that it is a lazy algorithm. So what do we mean by lazy algorithm? Actually, in most of the supervised learning algorithms, you basically train your model on the training data set, then you have your model, and then you apply this particular model to the test data set to then classify or predict. For example, whether a new image is that of a cat or a dog, right? So this can be, some kind of algorithm like support vector machine or regression or logistic regression or whatever, right? So you run this logistic regression or you run this regression or support vector machine on the training data set, and it learns the features or it learns the parameters of the model from that data set, and then applies this learned model on the test data set. Whereas in case of KNN, actually there is no training step at all. That's why it's called a lazy algorithm, because what it does is, at the time that you are actually now want to predict, at that point in time, actually it will go and it will do all the calculations of the distance of the new data point, like for example the new image of the cat or dog, from all the other data points that you have. So it will calculate all the distances, and then we'll check for those data points which are, or the k data points which are nearest to this. So that's why it's called lazy algorithm, because nothing happens till the point, or no calculations happen till the point you are actually trying to predict something. So there is no training step involved. Okay, and then it's used for both classification and regression, as we just mentioned. So it can be used to predict the values as well as be able to classify something like, okay, whether it is a cat or dog, or if you're trying to, let's say, predict some value, some forecast or something, that for that also you can use it. And then it is based on feature similarity, which is basically, what do we mean by feature similarity? So feature can be things like, if for example, you are looking at classifying cats versus dog, right? So is the eyes like a dog? That can be one of the features. How do the ears look? That can be one of the features. What about the tongue, the face, and so on? So there can be multiple such features, and how similar these features are between two data points, which is used basically by the KNN algorithm. And then, as I said, there is no training step involved. So these are the features of KNN algorithm. And therefore, now let's look at actually just some simple examples of how it works. So as you can see here in this slide, we have two classes of data. So one is all these blue data points, and there is another one which is the orange data points. Now, if you have a new data point, which is this pink one here, which class should it belong to? Should it belong to class A or should it belong to class B? So what you would do is, you would actually start calculating the distance of this pink data point from every square or blue triangle data point. And then you will decide, you will have to assume a particular k. Let's say k is 3, right? Which is, I'm looking at the nearest 3 data points. And in that case, basically, as you can see, if we draw this circle, right, then we see that 2 of the nearest data points within that circle is of the square orange kind. So basically, we will predict that this particular new data point belongs to class A. Whereas k value was 7, right? As in this particular example now, you would see that 4 out of the 7 is actually of the blue triangle kind, and therefore we will now classify it as belonging to class B. So essentially this prediction changes, as you can see here, depending on what is the k value. So therefore the question is, what should be the value of k, right? And typically what happens is you run a trial and error, and basically you come up with, okay, what is the best k value? But essentially what one needs to understand is that as the value of k increases, basically the partition line starts moving towards becoming more and more linear. So it starts becoming less flexible, and it starts assuming some kind of a linear dividing line or something like that. So what happens is that in that, as you increase the k, your bias basically increases, but your variation reduces. So we know that in classification problems or in machine learning problems, bias and variance are two things that we are trying to manage, right? Bias is basically how close you are to the actual class or to the actual value, whereas variation is how much variability is there in your prediction. So as the k increases, the bias sort of increases, but the variance reduces, and then it is vice versa. So if your k decreases, let's say at k is equal to 1, where you are only looking at just one nearest neighbor and then predicting based on that, actually the bias is the least, which means it is the most flexible. K is equal to 1 is the will give you the most flexible sort of demarcating line or function, whereas the variability will be the maximum. So that's the sort of the trade-off, and that's how we actually determine k. So we have to get a k value in such a way based on trial and error that sort of maximizes our sort of or reduces the bias as well as the variance, and that's the kind of optimization we are trying to do. Okay, so how do we calculate the distance itself, right? And distance typically can be of many kinds. So the example here is of the Euclidean distance, but you can have other kinds of distances like Manhattan distance or Mahalanobis distance, and you can look up references for other kinds of distances. Now Euclidean distance is calculated for the point P1 and P2 as given here. Essentially Euclidean distance is nothing but the square root of sum of the x coordinates of these 2 points P1 and P2, and then y coordinate square of these 2 points P1 and P2. And this is just an example of one kind of distance, and other kinds of distances like Manhattan or Mahalanobis are also there. And then this calculating this distance becomes quite challenging, especially in cases where you are trying to, for example, calculate, let's say, how close two LinkedIn profiles are, right? Or trying to classify the category of electrocardiogram and so on and so forth. So there we have to bring in more creativity to just decide what kind of distance to use. Okay, now let's move ahead. We will now talk of some use cases where KNN can be used, and this is an example of how KNN can be used for book recommendation. So if you have purchased books on Amazon or wherever, right, some of these recommendations are based on KNN algorithm. And then as we said, KNN is like based on features, right? So maybe let's say what will be the nearest neighbors of a particular book. It can be based on who is the author, what is the topic, and so on and so forth. And then there are other use cases like I mentioned, so for classifying satellite images, for classifying handwritten digits on image analytics, or for classifying electrocardiograms, etc. Typically KNN can be used. Okay, so now actually we will get into some hands-on. Okay, so to start the hands-on session, I'll go to this Jupyter notebook that I already have installed on my system, and I have a certain code written which we will take two examples. Both the examples are based on data sets which are available in the open source, so you can easily get access to that data. So what we do is we start by importing the necessary libraries. So we import Pandas, Seaborn, NumPy, and Matplotlib. Basically, Pandas and NumPy are there for doing the data manipulation and also for storing data as matrices or as arrays and be able to perform some mathematical procedures on them. And then Seaborn is basically used for plotting and Matplotlib for plotting as well. And this line here, get IPython, just helps us to run the images that we'll be creating in line with Jupyter Notebook instead of opening up a new window. So let's run this. And what it will do is it will import all these packages for us, which we are going to use. And then we will first import the breast cancer data that is available in your scikit-learn datasets. So we import that, and then let's just initialize that data into a variable here called cancer. So cancer here represents all the load, the breast cancer data. And now let's actually look at what this data is. It's a bunch of attributes in this dictionary here. So you have data, the target, which is basically nothing but whether it is a cancer or not. So whether it is malignant or benign. Malignant means it's a bad cancer, and benign means, well, it's just a tumor, it's not cancerous. Target's name, description, feature names, which is basically the features that will tell us whether a particular case belongs to cancerous or non-cancer, or malignant or benign. And then actually let's just print the description of this particular data here. So as you can see, we can use this command to print the description here. And then we see that there are 569 data points with about 30 attributes. And these attributes are radius, texture, parameter, etc. And the max and min values of those are given here. And then now let's look at some of the feature names. So these are the feature names, radius, texture, and so on. And now let's actually set up a data frame of this particular data here using Pandas, this function here. So there are 569 data points, and all these are basically your features as we talked about. And let's look at the target variable, which is nothing but whether it is telling us whether a particular data point belongs to malignant or benign. So 0 is cancerous and 1 is non-cancerous. And then we convert the target into a data frame as well. And then let's look at the couple of examples of how the data points look like. This is one row of the data points with all the several feature values that we have. So basically we use this package called standard scalar from scikit-learn for pre-processing and for standardizing the variables. And we initialize this standard scalar into a variable called scalar. So standardizing is nothing but basically bringing all the samples to essentially the same range, right? Because what might happen is some of the data point, like for example, temperature might be from 0 to 100, and some price might be from, let's say, 1,000 to 100,000 or whatever, right? So the absolute values can lead to some issues with respect to the prediction. Therefore, we have to standardize it or bring it between, let's say, -1 and 1. So, and then a mean of 0, right? So we have to bring everything to the same scale to be able to compare the samples. So we first of all, we fit this standardization or normalization on the data set we have. And that is, we calculate the variance and the means, and then we actually apply it on the data set to transform it to the actual values. And then if we look at the scaled values now, so let's look at the scaled values. And this will give an example of the top 5 rows here. So we can see now the values are between -1 and 1, or rather it is standardized essentially with a normal distribution. And then we divide this data into test and train. So basically we will train the model and then we will test it on a separate data set. If you use the same random state, you should be able to get the same result. Otherwise, you may get a different result here. And essentially, we are keeping the testing size to 30, which means that we are dividing the entire data set into 2 parts. the train part, which is having 70% of the data, and the test part, which is having 30% of the data. And again, we are using this package called train test split from the scikit-learn package. So we get the x and the y's, which are basically nothing but your train, and the x's are your predictors and y is your predicted variable, whether it is cancerous or not. And then now let's import the k nearest neighbors classifier. This is the actual algorithm which we are importing from scikit-learn package. And now we initialize this particular algorithm, and then we fit it on the data. And some of the parameters, as you can see, is basically what is the leaf size and so on and so forth. The nearest n neighbors we are taking. So we are taking k is equal to 1 here, basically, as of now. We will see the results based on that, and then we will change it and see how the results vary. And we now run it on the, we now try to predict it. And then we will now try to evaluate what the results look like. So we have imported the classification report and confusion matrix, which is basically trying to see whether we were able to correctly classify the cancerous as cancerous and non-cancerous as non-cancerous as or not. So we can see that this is the actual and this is the predicted. So basically some data points here, 5 and 4, are classified wrongly, otherwise all the others are classified well. So if we look at the accuracy, calculated accuracy actually, so we see that the precision, which is true alarm, right, which is basically from the cancerous samples, how many were you able to actually predict as cancerous? If you see, the accuracy is quite high, almost 94-95%. And then the recall, which is from all of the cancerous samples, how many were you able to actually predict accurately, is about, again, 94-95%. And F1 score is nothing but a combination of both precision as well as recall, and that's quite good as well. So with k is equal to 1, we are able to get already some good results. Now let's try to see how to choose the k value, right? So this is basically nothing but a bunch of code that actually runs the k value from 1 to 40 and then tries to check the accuracy. And this is just like doing a trial and error to see where we get the best results so that we can then use the best k value. So if you can see this particular plot here, after we plot the result from the running the trial and error from 1 to 40, we see that the error actually starts decreasing, and somewhere around this k is equal to 21, we get the minimum value of error. So for us, the best k value is 21. So now if we compare the results between k is equal to 1 and k is equal to 21, we should be able to see the prediction result. So as you can say, this was the result with k is equal to 1, which is we get about 94-95% accuracy. And then with k is equal to 21, we will see whether the accuracy improves, right? So we see that, yes, the accuracy has now gone up to almost 99%, which is, we earlier had 9 misclassified data points out of all of the points. And then here we have just 2 data points which are misclassified from the test data set. So now this was one example of applying KNN on the cancer data set, which is available freely. And now let's look at another example, which is the iris data set, and again available freely as well. So iris is a type of flower, and we will see what flower is it. So just give me a moment here. So we again start by importing the necessary libraries, and then we'll look at what this iris data set is. So the iris data set comprises of 50 samples of 3 species of iris flower, which is iris setosa, iris virginica, and iris versicolor. These are the 3 types of iris flowers. And if you run this, basically we will find that, okay, sorry, we did not copy the entire code here, so it was giving an issue. Let's just run it again. Okay, so we see that it is this particular flower, which is iris setosa. So the iris setosa you can see. And now let's look at the other 2 kinds of flowers here. So which is iris versicolor. So this is iris versicolor. And then you have the iris virginica. So we see that this one is 𝐬𝐧𝐥𝐞. So essentially we now will import the sort of data set. We have already done that, and we will now use the Seaborn package to actually plot some of this data and see how it looks like, which is basically do some kind of exploratory data analysis. So if we look at the data itself, so this is the top 5 rows from the data, right? So essentially the data consists of basically what is the sepal length, sepal width, petal length, and petal width. And this is nothing but basically your petal is your this colored part of the flower, and the sepal is basically your green part here, right? So it is talking about what is the sepal length, sepal width, and petal width of each of the species, whether it is Setosa, Virginica, or versicolor. And we will see whether we can use KNN to actually classify these flowers into the data points into these categories of flowers. So let's do some quick exploratory data analysis on this. So we are running a pair plot on the data set, and in the meantime, I'll just copy another part of the code here. Okay, so now the plot has come up. So as we can see that the green is basically your Setosa flower, and we can see that this pair plot actually just plots the sepal length, sepal width, and the petal length, petal width of each of the samples of Setosa, versicolor, and Virginica. And we see that the green dots, which are the Setosa flower, is actually quite separable from the others. It's when you plot, let's say for example, sepal length and petal length, right? We see that this is quite separate from the other data points. So let's see whether we can actually be able to classify it using KNN or not. And here we are running a kernel density estimation function on the Setosa flower to check what kind of distribution it has. So this is the kernel density estimation plot using the SNS package. So only for the Setosa flower. So if we plot the sepal length and sepal width, we get something distribution like this. So essentially we see that the maximum centered around here, and then there is a distribution, as you can see here. So there's some kind of a linear relationship here. Okay, so now we will again do the same standardization of the variables that we had done in the cancer dataset case. So we are importing the standard scalar function from the scikit-learn preprocessing. So we will initialize that. So we are again basically doing the standardization or normalization of the data. And we will do the standardization on everything except the species, which is a categorical value, right? So it's categorical whether it is which kind of flower it is. So we have removed that, and then we have done the standardization or normalization on rest of the data. So we now convert this into a data frame, a Pandas data frame. And if we look at the top 5 rows, now it's all converted or transformed. So the values are now normally distributed basically. Okay, so now we divide the data again into train and test. And we again have a training of about 70% and test data set of about 30%. So we are dividing that entire data set into these 2 buckets, and we will now use KNN to see if we can use KNN to classify them. Again, the same k is equal to 1, and we will check the results, and then we will do a trial and error to check what is the best value of k. So here k is equal to 1, and now we are going to predict on the test data set and look at the results. So we are now importing the classification report and the confusion matrix. So if we look at the confusion matrix, we see that kind of already we are getting quite good prediction. So just 2 misclassified points. And if we look at the accuracy, we see that the accuracy is quite high, around 96% already. Now we have to see what is the best value of k. So essentially we will again run k is equal to 1 to 40 and check which is the best value. So let's plot the errors when we vary the k from 1 to 40, and we see that actually the error decreases and then increases. So basically the error is minimum with k is equal to, let's say, 3 or even 5 or maybe 11. So let's choose one of these values. So let's say k is equal to 3, and let's see how the results look like. Does it improve the accuracy or not? So we now see that even the two data points which are misclassified earlier is now classified properly. So the accuracy improves to 100%. So that's the example of how you can choose k.
What is naive Bayes? Let us understand naive Bayes with an example. Here, I just cannot seem to figure out which are the best days to play football with my friend. Can you please help us out? All possible conditions are given to us. There is summer, monsoon, and winter, which is nothing but the outlook. Am I correct in saying that? Summer, monsoon, and winter is nothing but the outlook. Then we have sunny or not sunny. So that basically is the humidity, right? And then we have windy or no windy. That speaks about the winds. How are the winds, right? So if you look at these combinations, okay, we will look at this using navy Bayes on how do we decide whether we can play or not. So if I have noted down all the days it was good, bad to play football and the combination of weather matrices on that day, that will be perfect, right? That is perfect, and we will be able to do navy Bayes classifiers using that. Now, navy Bayes classifier comes from the navy Bayes theorem, and navy Bayes theorem is purely and purely based on the assumption of independence. So what does it mean? When I say independence, what it means is that this variable has no relationship, no association with this variable. Now, when I talk about this in a linear context, obviously in summer, you will see that we have more sunny days. Yes. So if you look at it from the correlation area, from the linear algebra concepts, linearly, these two are correlated to each other. Am I correct in saying that? Obviously, in monsoon, we have less sunny days. In winter, we further have less sunny days. Yeah. So, although there is a relation, navy Bayes theorem says that all these variables are independent of each other. What does that mean? If this is causing any kind of an effect, if this is causing any kind of an impact, this should not matter. Okay, there is going to be no relationship. Summer, monsoon, winter, it has its own weightage. Okay, and it has nothing to do with the other conditions. Every condition is equally significant. All right. So what happens in navy Bayes is we estimate the posterior probability of every event happening. Here we calculate the posterior probability of an event happening. Okay. So here if you see, if you look at the sunny conditions, what we have done, sunny conditions, we have this distribution that there is no play happening in summer, there is play happening in monsoon, there is play happening in winter, right? So base of the season, we are figuring that out. Similarly, for windy conditions, we are doing that, right? Again, then we do it for a combination, right? Whether when windy conditions are yes and no, what happens to play? Okay. So here, what at the end of the day, what gets selected is the one which has a posterior probability of greater than 5. Now, when I talk about posterior probability, what do I mean by posterior probability? Let me have a blank slide. Here you go. Actually, it's given, so I need not show you that. What is the simplistic probabilistic classifier here? What is the probability of an event A happening given B? So if you look at our problem context, what is it that we are trying to figure out? We are trying to figure out what is the probability of play happening given the outlook is sunny, comma, the winds are normal and there is no rain. On any given day, when there is no rain, there is no wind, and the outlook is sunny, whether play will happen or not. So what we end up doing is we calculate the posterior probability of play happening given these conditions. We also calculate the posterior probability of play not happening given these conditions, and then we normalize these probabilities. Mathematically, we do all of these calculations to figure out Navy bias. Okay. Now here, see, here we are talking about one event. Here we have three events. We have outlook, we have winds, and we have rains. So what this becomes is probability of three independent events. So what we will do, we figure out what is the probability of play happening given outlook is sunny. We also figure out what is the probability of play happening, multiply this with the probability of wind as no, given no, then probability of play happening given rain is no. We figure out all the three independent probabilities, multiply it. All right, this is what we do mathematically. This is what is done mathematically in Navy bias theorem. Ultimately, the posterior probability of an event A happening given B conditions is calculated by first calculating the class probability. What is the class probability here? Probability of it raining given play was happening in that day. This is multiplied by the total probability of play happening and divided by the total probability of sunny conditions. Here, as you see, this is the posterior probability. This is the class probability. Here is the predictor's probability. This is the outlook. X is the outlook. C is what we are trying to predict, right? And here is the likelihood. So how is this formulated into our table? Now, if you correlate this to our graph, what will be the likelihood? What will be the likelihood of sunny conditions given play happens? Sunny conditions, play happens. 2 divided by 3 out of, sorry, how many sunny conditions do we have? 6 conditions. In 6 conditions, how many days does play happen? 2 days. 2 by 6, 1 by 3. What is the class probability? So of all the events that are given to us, how many days does play happen? Okay, this is how this is calculated. So here you see what we have done is, let me go back to the previous slide. Here you go. Okay, here what we have done is we have calculated this table. Now it speaks about a data set. Where can you get this data set? You can look for golf play days data set online. You can look for golf play days data set. Okay, in this data set you will find all the data which is required for this particular example to be done. So what I will be doing is I will be doing this example, this Navy bias classification with you in Python. All right, so whatever calculations are being done here, okay, I will do the same activity in Python with pen and paper, and instead of doing this in a numeric way where I'm doing a lot of probabilistic calculations, I will achieve this simply in very limited lines of code, with Python. Once I have done that, I will come and explain this probability table to all of us. I'm going to use some basic libraries Alright, so here what I will be doing is using some very basic libraries for this activity. Alright. Done. Now let me quickly go and read the data set. So for that, what I will do is quickly change my working directory. And now let me quickly go and read my data. So my data frame is pd dot. Here you go. This is my data set, right? So if you look at this data set, in this data set, you have 14 days. In these 14 days, you have the outlook, overcast, rainy and sunny. You have temperature. Temperature is hot, cool and mild. You have humidity, you have wind, and you have play, right? So I will not be using okay, let us use all four. In this example, they are using only 3 variables, but in our hands-on, okay, in this hands-on, what I will be doing is I will be using all 4 variables. Let us do that. Okay, so before I do that, let me convert everything into a category. If you look at your data frame right now, it's not, everything is not into a categorical variable. Here you go, see. Okay, so let me quickly go and convert everything into a category. And once I have done this, let me create a new data frame in which I have everything as a category code, so that I have numbers. I'll show you what do I mean by this. So let me execute this. Here you go. See, now I have 2 data frames. In the first data frame, I have all these values. These are now categorical variables. But in the second data frame, I have all ones and zeros. So wherever you see there is sunny conditions, now I have a code 2. Rainy conditions, code 1. Similarly, when play happens, I have a 1. When play does not happen, I have a 0. This is what I have done. This data frame is available online. Okay, you can get this data frame online. All right, now my data frame is ready. So now what I'm going to do is I'm going to divide my data frame into training and testing. I have 14 records. So let's take 10 records for training. I will give 10 records as an input, and I will give 4 records, last 4 records, as my test data frame. All right. So now I will need to create my X and my Y. So how I will do that is I'll say Y underscore train is equal to from train. I don't want the play variable. That play variable should be my Y. As simple as that. And I will say X underscore train is equal to train. Okay, and I will do the same thing for my test data frame also. Now those who are new to Python will find this a little bit strange. Please bear with me. But these are the only calculations, only steps which need to be performed every time you are trying to achieve Navy bias algorithm or any kind of an algorithm. Right? So here now you see this is my training data frame in which play variable is not there. Play variable is not there. This is my Y in which only play variable is there. This is my training data set. So both of them have 10 records with the matching index. Similarly, test data frame, 4 records with the matching index, right? So that we know which data frame is where. Now, Navy bias. Very simple, 3 lines of code and my model will be done. Okay, first I initialize my model. Here you go, I have initialized my model. In this model, I fit my data. In this model, I will fit my data. So to do that, what I say is fit X underscore train comma Y underscore train. Done. Your model object is now ready. And now you can simply get the classification outcomes. So we have in our test data frame, if you look at our test data frame, this is our test data frame. We have 4 conditions. All 4 are sunny, high temperature, low humidity, and windy, right? And if you look at their outcomes, these are their outcomes. On the first 2 days, play is not happening. On the next 2 days, play is happening. Let us look at what is the prediction of our model for this. So to do that, what I simply do is X out is equal to model.predict. To this, I give my X underscore test. Here you go. Okay. Now you have your y out variable. So this is the prediction for all the 4 inputs that you give, and this is the prediction. First day, we say play does not happen. Let us match it. Let us try to match it with our here. See, out of 4 records, 3 records we are predicting correctly. 3 records we are predicting correctly. If you want to check the accuracy, what is the accuracy of your model? What you can simply do is print. Let us print the accuracy on both training and testing. Training accuracy. How do I get the training accuracy? Very simple. Model.score. And here I give my X underscore train, comma Y underscore train. And then we do the testing accuracy also. Here you go. So here you can see for our model training we have 80% accuracy, and for testing we have 75% accuracy. Okay, the advantage of doing this activity in Python. But what is happening in the backend? Now let us go and also understand that in terms of naive Bayes classifier. We have successfully implemented the naive Bayes classifier in Python programming language. But here, let us try to understand Bayes theorem, what is happening. So from this data set, all the tabulated data, frequency tables are calculated. Once the frequency tables are calculated, they are substituted in our formula to calculate the probabilistic scores. So what is the probability of summer given it is playing conditions. Total, how many playing conditions are there? Total, there are 9 playing conditions. 9 days play happened. That becomes our denominator. Out of those days, how many days was summer is our numerator. That is how for this we get a probability of 0.33. Then we calculate the class probability where we look at how many days was it summer. Out of total 14 days, 5 days was summer. So that's the probability. Probability is 0.64. Put everything into our equation. And this is what we get. Okay. So we do this for each. So here we calculated for winter. All right. Once we have done it for all 3 days, winter, sunny and windy days, we substitute those here, and that gives us the probability which is more than 0.5. Thus now we can say that if it is winter, sunny and conditions are sunny and there are winds, conditions are not sunny and there are winds, play can happen. Look at another example. If a single card is drawn from a standard deck of playing cards, the probability that card is a king is 4 by 52, since there are 4 kings in a standard deck. King is the event. This card is a king. This is the event. The prior probability of this is 1 by 13. If evidence is provided, for instance, someone looks at the card, that the single card is a face card, then the posterior probability can be calculated using Bayes theorem. Okay, since every king is also a face card, the probability of face happening given you getting a face card given it's a king is 1. Since there are 3 face cards in each suit, all right, it's actually 4. Ace is also a face card, so it's jack, king, queen and ace. The probability of the face card is 4 by 13. Okay, so if you combine these 3 likelihoods, what you get is 13 by 4. So using Bayes theorem, this is the probability that you get.
How does an SVM work? So the main objective of our support vector machine is to segregate the given data in the best possible way. So when the segregation is done, the distance between the nearest points is known as the margin. The approach is to select a hyperplane with the maximum possible margin between the support vectors in the given data set. Now, to select the maximum hyperplane in the given sets, the support vector machine follows the following. It generates a hyperplane which segregates the classes in the best possible way, and then it selects the right hyperplane with the maximum segregation from either nearest data points. Now let me tell you how we can deal with inseparable and nonlinear planes as well. So in some cases, hyperplanes cannot be very efficient, and in those cases, the support vector machine uses a kernel trick to transform the input into a higher dimensional space. So with this, it becomes easier to segregate the points. Now let us talk about the SVM kernels. So an SVM kernel is basically used to add more dimensions to a low dimensional space to make it easier to segregate the data. It converts the inseparable problem to a separable problem by adding more dimensions using the kernel trick. A support vector machine or SVM is always implemented in practice by a kernel. The kernel trick helps to make a more accurate classifier. Let me talk about the different type of kernels that we have in support vector machine. First of all, we have linear kernel. A linear kernel can be used as a normal dot product between any 2 given observations. So the product between the 2 vectors is the sum of the multiplication of each pair of input values. And then we have the polynomial kernel. So it is rather generalized form of the linear kernel. It can distinguish curved and nonlinear input space as well. Now talking about the next kernel that we have, that is a radial basis function kernel. So the radial basis function or RBF kernel is commonly used in SVM classification. It can map the space in infinite dimensions. That is the advantage that we have with RBF kernel. So these are the kernels that we have in SVM, guys. Now I'm going to talk about a few support vector machine use cases. So these are a few use cases I have listed down here. We can use SVM for, which is face detection. We can use SVM for face detection. Then we can use it for text and hypertext categorization. Then we can use it for classification of images. We can use it for bioinformatics, protein fold and remote homology detection. We can use it for handwriting recognition, and we can use it for generalized predictive control as well. So these are the use cases that we can use SVM for. Now that we are done with the SVM use cases, let me tell you how we can implement SVM. So there are a few steps that we have to follow to implement support vector machine in machine learning. In any machine learning model, we have to follow specific steps. So first of all, we have to load the data in which we are going to perform the classification of data. After that, we are going to explore the data. We're going to see how many labels, what are the target variables there. And then we are going to split the data into train and test data. And then we'll generate the model by implementing the support vector machine. And after that, we are going to evaluate the model as well. So I'm going to show you this when we are going to work on the PyCharm. After this, I'm going to show you a simple use case, which is a character recognition using support vector machine. So in this, we are going to get image recognition, something like this. So let's take it up to PyCharm, guys, and I'll show you how you can implement support vector machine in Python. So we are in PyCharm, guys. Let me go to the presentation mode for better visibility. So first of all, you have to make sure you have all these libraries installed in your system, that is scikit-learn, sklearn. And then you have to import all these modules like SVM metrics, train test split from model selection, and datasets to load the data. So first of all, we have that cancer data over here in which we are going to load the dataset, which is the breast cancer dataset. So this is a simple example, or this is the way we can load the data. I'll just write a comment over here. Loading the data. This is where we are going to load the data. After this, we can check for what all are there inside the data, like how many images or what all is there. So I'm just going to remove all this for now. And let's see what we have in the data. So I'm just going to print cancer data. Let's see what we have. It's going to take a while because it's loading the data set from the internet. You can see these all points are there inside the data set. So we have data. Then we have target also over here, which is an NP array. This is the data that we have over here. Now I'll just check the shape of the data as well. Let's see the target variable also. So this is our target variable, guys, which is in a binomial form, which is 0 and 1. So we have only two possibilities over here. Now that we are done exploring the data also, let me show you how you can start splitting the data into test and train sets. So I'll just remove this again and print the previous code. So this is my training and testing variables, that is xtrain, xtest. Then we have ytrain, ytest. And inside this, I have used train test split to train my data over here. And as you can see, I'm using the data as cancer data. Then we have the target variable. We are using the test size as 0.4. We can use it at 0.3 as well. We'll be using like 30% for the testing and the other one for training. And we have random state as 209. After this, I am going to generate the model, that is my classifier, using the SVM over here. And I'm going to use the SVC with the kernel linear. We are using the linear kernel over here. So I'll just write generating the model. After this, we are going to train the model. For training the model, we are going to use the fit method over here. Inside this, we are passing the xtrain method and ytrain method to train the data. So basically, fit method is used to train the data. After this, we are going to predict the response using the predict method over here. Inside this, we are going to pass the variable, that is xtest. So we are taking the xtest separately for this purpose only, to predict the outcome over here. So now that we are done with the training and testing over here, we are going to print the accuracy. I'll just write one more C over here to make it correct. For this, we are using the metrics from the sklearn module, which is going to give us the accuracy score. In this, we have ytest and yprediction. So it's going to give us the accuracy report. After this, we are going to get precision score using the precision score method in metrics. And then we have recall as well. And to make it easier, I'm also using a classification report. So let's just run this program, guys, and we'll see what happens. We'll get the total report, how efficient our model is actually. So as you can see, we have the accuracy as 0.92, which is close to 92%. And then we have precision of 93% and recall as 94%. And after that, we have a classification report. Inside this, we have also given the accuracy, the FN score, and the recall as well. So this is a simple example to implement your support vector machine, guys. Now moving on, let me show you one more example. Before that, let me just exit the presentation mode. Now I'm going to show you a use case for character recognition using support vector machine. So for this also we are using one more library, that is Matplotlib, to plot the graph or to plot the image as well. So we have data sets which we are going to import from sklearn only. We have SVM and metrics, which we are not going to use in this one for accuracy, which I'll tell you later, guys. So first of all, we are loading the data sets over here. This is the load digits. So we have a data set with a bunch of digits, the handwritten digits, and now we are generating the model directly. After this, we have X and Y variables, which is going to take the test data and the target data as well. So we are taking all the data until -10 over here for training, and for target variable we are also taking the same number. And after this, we are going to fit the model to train it, and we are predicting the models with the digit data that is over here. After this, I'm just going to show our image, or instead of 9 we can use any other number. We have taken interpolation that is nearest, and I'm using the IAMShow method from the Matplotlib. And if you are not familiar with Matplotlib or how you can plot graphs, you can check out other tutorials on Edureka on Matplotlib to get better insight about this. So let's just run this program, guys. Let me exit the presentation mode, and we are getting a figure something like this. So it looks like 9, but it's quite distorted right now because we have taken the gamma as 0.01 and the C value is 100. So if I increase or decrease this value, the output is going to change. The accuracy is going to be much larger, but the speed is going to become a little slower. So this is the reason. And instead of 9, I can just write, let's say 6 over here. So the prediction is actually right, but the image is a little distorted because the accuracy is not quite accurate the way how we want it. But this is a very simple example to make a character recognition model using support vector machine. Also, to increase the accuracy, we can change the gamma values or C values in the SVC parameter, but it will hinder the speed too. So if we increase the gamma values, the accuracy will decrease, but the speed will increase, and vice versa.
So what is a clustering technique? Clustering technique is something that we will use it for grouping purpose. So especially there is a very easy way to understand what is clustering technique. You would have seen such a while we are going through an COVID-19 situation, the government has came up with creating some containment zones, as all of you must be knowing. So how, on what criteria government has taken that, okay, which area is supposed to be a containment zone, or which area is supposed to be applied with some restrictions, and which areas can be considered as normal, on what criteria that they have created. So that's what using clustering technique. Which means the governments, or when I say government, means that the people who will be taking the final decision in such criteria, either prime minister, either the chief ministers of that particular state will be taking decisions whether to go for a lockdown, whether to not to go for lockdown, or which areas has to be considered as containment zones or non-containment zones. So those high-level decisions are something which will be taken based on the clustering technique output which is generated by these algorithms, based on a number of inputs. Okay, what is the population in a particular area? How many number of people are affected? How many number of hospitals which are present? How many number of people who are been recovered? So likewise, based on these multiple criteria, people will do some clustering technique on top of the data, and according to that, people will be segregated, or the areas will be segregated. So that saying that, okay, these are the observations which belong to one cluster, these are the observations which belong to one cluster, like that, so that people can cluster them, which can make organizations to take decisions on a very high level. Okay, that's what is our clustering technique. Which clustering technique output will contain the different groups. It itself will group the different components based on whatever the number of clusters that you want to generate. That may not give the direct output. On top of the generated output, people will be taking business related decisions. That's what is all about clustering techniques. Okay, so now what we will do, let's take an example of within clustering techniques, what are the different types of clustering techniques we have. So what are the different types of clustering that we have? So there are multiple types of ways based on the type of output that we want to produce. There are multiple different types of clustering techniques we have, but out of which let's try to understand about what are the very famous and most widely used clustering technique algorithm, out of which we have something called K-means clustering algorithm is one of the very famous and most widely used. More than 90% of the people will end up with using K-means clustering algorithm, which is very famous in clustering techniques. right? Which is very, very famous in clustering techniques. So what are these clustering techniques? As I said, how this clustering technique will work. So K-means clustering is nothing but, always remember one thing, if any one of you are going to work in machine learning or anywhere, wherever you see a notation called K, by default K is nothing but you are supposed to, as a user, you are supposed to provide what is the input of K, which means wherever you see there are multiple techniques that we have in machine learning, like K-means clustering technique, K nearest neighbor is one of the algorithm, K-fold cross validation. Likewise, wherever you see a notation called K, what does a K means? It's an input that you are supposed to provide. Always remember this. It's an input that you are supposed to provide to your algorithm. Your algorithm cannot identify that K value. Of course, everything else will be taken care by your algorithm. But whenever you see K, which means in K-means clustering, what is the meaning of K-means clustering? How many number of clusters that you want to provide? That is something that you have to input it to your algorithm. That is something that you have to input to your algorithm, right? Here, the meaning of K is how many clusters that you want to generate. So how many clusters that you want to generate? Okay, when you have 1,000 observations which are present, when you have 1,000 input records which are present in your historical data, how many number of clusters that you want to produce? Do you want to go for one cluster? Obviously, one cluster means that the entire data set will be considered as is. Do you want to create 2 clusters out of the data? Do you want to create 3 clusters out of the data, 4 clusters, 5 clusters, or 10 clusters? So how this can be done? There are multiple steps that are involved in generating K-means clustering algorithm. So you can see, choose the number of clusters. This is what is nothing but your first step. It means you need to decide what is your K is nothing but number of clusters that you want to produce. And then there is an initialization of centroids will happen as a one-time activity. Right, so there is an initialization of centroids which will be declared, that will be used as your initial step for your machine, and then assign the clusters, move the centroids, and optimization, and then converge all the clusters into one component. Yes, I know it will be very difficult to understand by looking at this thing. So let me show you a very simple example how exactly it will be done. Maybe let me take a simple diagram for you to show how exactly that's going to work. Okay. So let's say, for example, I'm going to take some historical data just to explain you on how exactly the K-means clustering algorithm will work. So what is that it is written in the first step? What is that it is written in the first step? So the choose number of clusters. Choose number of clusters. Now, which means, say for example, we need to take some historical data. I'm considering some historical data here. Let's assume this is the historical data. Let's assume this is the historical data that we have. So as you could see, there are multiple historical data points. So as you could see, the first step, choose number of clusters, which means, let's assume, to make this thing simple, I'm going to choose that we want to have 2 clusters generated. Okay, so this is, which means we want to have 2 clusters created. So because my number of clusters that I want to generate is 2, I'm going to consider that there are 2 centroids which are present. This is my first step. How this algorithm will do? How algorithm will come with the number of clusters? So this is how it will happen. So first step is to choose the number of centroid and then initialize your centroid. That's the second step. So now what is the third step? Let's assume this is observation number 1. This is our data point 1. So now what is the next step? We will take the distance from every observation to every centroid and every observation to every centroid, which means, now tell me which observation, for this observation number 1, which centroid is more closer? Is the green color centroid is more closer, or the red color centroid is more closer for this? Centroid means that data points, the one which I have highlighted, that's what we call a centroid, data points. We have chosen 2 centroids only because that is as a user, you are supposed to input what's supposed to be your K. What's supposed to be your K value, that's what I said. You need to know what is your K is nothing but how many number of clusters that you want to provide. Usually your business users are going to provide that. In case if you are going to work in this kind of algorithms, they will provide that. Or else there are some methods available like elbow method or other things. We will talk about that. Now this observation is more closer to red color. So now what happens? What is the next step? The algorithm will assign this particular observation 1 as a red color for now, as considering that this belongs to red color. Likewise for the second observation, when the second observation appears, what is the distance from the second observation to both the centroids? Now which one is more closer? I see green color is more closer. So now I'll mark this as green color. If the distance is same equal, so then the algorithm will force any of the observation to get into any of the centroid. So number of clusters, number of centroids that you will choose based on the K value, as I said. Now you're going to likewise you will repeat the same process, and whatever the observation which is more closer to whatever the centroid it is, you will mark them as with their so called mark like this. Now you are going to initially mark them as observations into either into green color, either into red color. So now these observations are now considered as green color observations, and these observations are now considered as red color observations. This is step number 1. What is the step number 2? Step number 2 is segregate all these red color observations and take the average value of x and y coordinates, and repeat the same process for calculating average coordinates of x and y coordinates for the green color observations. Take the average of all these observations, calculate average, and take all these observations, take the average. You end up with getting a new centroid positions called xy, which means now you ended up with getting a new centroids. In the initial step that we have taken random centroid, now you got the centroids that you can use based on the previous iteration. Now you ended up with getting a new centroids. You repeat the same process again. You repeat the same process. Take the distance from every observation to every centroid and assign the observation based on the nearest distance, and continue to mark every observation either into red color or either green color or whatever it is. And you repeat the process until you will be able to see there will be no change applicable for your clusters. You repeat the process, which means in every step you might end up with changing your centroid. Every step will continue to change your centroid. Now the centroid might become like this, then later your centroid will become like this. Likewise, your centroids will be keep on moving. Initially you are taken it like this, but it might continue to move like this. Somewhere it will be fixed, and after that there will be no change that you will notice if you are repeating the same process. At this particular stage, whatever the observations which are marked into, which are grouped into green color, you will say like these are the green color observations. Whatever the observations which are marked into red color, you will mark them as okay, these are the observations which belong to red color. These are the observations which belong to red color. Likewise, you will segregate all these observations either into red color or green color. Right? So that's how we can generate these clustering technique. That's how the K-means clustering algorithm will generate these algorithms output of using this algorithm. Okay, so that's how K-means clustering algorithm will work. Okay. So now, likewise, there are multiple algorithms that we have. So like when we talk about machine learning, so there are multiple types of algorithms that we have. So like how we have how does the k value will occur, as you can see on the PPTs which are also mentioned. So you're going to choose some randomly generated k value, and you will be choosing the number of k's over here, and you can see that it will assign them based on the number of this most nearest distances, and according to that you will change your centroids. Once you change your centroids, you will repeat the same process until you are able to change that your centroids don't move further, and then once it has been finalized, you will say like this is the final centroid and final cluster output that we can generate out of this. Right. So likewise, we also have different types of clustering technique, and the second type of clustering technique that we have is fuzzy or C-means clustering. So what is fuzzy or C-means clustering? The output will remain same. So C-means clustering means that there are places that one or two observations can belong to one or two different clusters, right? One or two different clusters, which means usually the primary difference between your C-means and K-means clustering technique is, in case if there are any observations which are having equal amount of distance, usually in K-means clustering what we will do, we will force this observation to be part of any of the cluster. But in C-means clustering, based on the distance that we see, there are chances that an observation can go to or can belong to one or two clusters. So it purely depends on the business use case, who is going to decide to either to go for K-means clustering or C-means clustering based on the business use case, based on our business outcome. So if people are going to decide whether to go for C-means clustering or K-means clustering. So there are a number of observations which might, it's not mandatory, which can belong to one or more clusters that can happen. So the third is agglomerated clustering, so which is the third type of clustering technique that we have. Okay, so which is also one of the clustering technique that we have. Okay, so now which can also be used here. Okay, so now what is this agglomerative clustering? So this is what we also call it as hierarchical clustering. So in times you'll also call them as hierarchical clustering. These clustering techniques are built using H clustering. In short, we call it as H clustering. And also people will also call it as hierarchical clustering technique. So what are this? So based on the type of algorithm, they will try to, there is a mathematical expressions which are involved in it, but considering that the limited time that we have, I'm not going to take you through all the in detailed depth of it. So considering the way how the data points have been segregated, it will build a kind of dendrogram. So on top of this dendrogram, your observations can be classified here like this, as you can see on the screen. Is K-means clustering sensitive to outlier? You need to understand one thing. When we are talking about unsupervised learning algorithms, as I said, you may or may not have clarity on the data, which means your assumption is that at the least level, you don't have clarity on the data. Then if you don't, when you don't have clarity on the data, how can you say this is an outlier or this is not an outlier? When you have clarity on the data, especially when you're working on supervised learning algorithms, you can. But you don't have output column also. How you will be able to evaluate how the so called output column can be evaluated, because this is not been classified properly, this is not been clustered properly based on the historical data, because there is no output column. So those type of concepts are something which you don't need to worry about when you are working on unsupervised learning. They will be constrained when you are working on supervised learning algorithms. And of course, in case if you see that there are outliers which are present, obviously it will be considered as one of the clustering any of the cluster, it belongs to the data. But anyhow, that's the characteristic of the data. You don't need to you don't be taking care, because you might be killing the actual original values which are present in the data, but you cannot expect that outlier can be recognized for all the cases that you have in unsupervised learning. So the next type of clustering technique that we have is division clustering. So what is this division clustering? As the division clustering is also creates the data in a form of dendrogram, but the difference is you can see that it starts with all data points in one cluster, splits the root into child recursively based on the dendrogram, and stops when there is a singleton clusters which are created, which means that for every cluster there will be one observation which belongs to. So likewise, the clustering technique will work. Now there is one more technique that we have in terms of building a clustering technique. That's what we call the mean shift clustering. So what we will do, we'll take an average of every cluster that we have. What we will do, we'll end up with reducing their means into a single density of items, and then we'll continue to repeat the process to see to that which observations mean will belong to the same cluster, and according to that we'll continue to identify which observation will belong to a particular cluster. So likewise, we can apply different types of clustering technique that can help us to cluster the data which is part of unsupervised learning, right? So now let's jump into something called a small hands-on. Okay, let's take a small Python example, and we will see how do we build that particular clustering technique on top of the data using one of the simple data that we have. Jupyter notebook. Let me open how we can use scikit-learn using one of the example. So meanwhile, let me show you some of the data set also. Let me show you a data set that I'm going to use as well. So what I'm going to do is I'm going to take this movie metadata information. Let me open this data set. I'm going to take this example of movie metadata information where this data set has got a number of observations which are present. Okay, let me open this. Okay, you can see that there are a number of movies related information. As you can see, the movie names. So Avatar, Pirates of the Caribbean, Spectre, The Dark Knight, Star Wars, etc., etc., John Carter, Spider-Man 3, Tangled, or etc., etc. We have a lot of movies, and about every movie we got a lot of information which is present, like who is the director, who is the actor, what are the director Facebook likes, what are the actor Facebook likes. Likewise, we got a lot of information which is present as part of these particular every observation. So now what we will do, we will try to cluster these data points. You can see a lot of observations which are given. What is the gross of the movie? What is the number of reviewers? What is the IMDb rating? What is the so and so called IMDb score? What is the movie span? What is the gross? What is the budget and everything? So now what I'll be doing, I'll be reading this data set using one of the Pandas library that we have. Okay, so I'll be reading this data set. Let me open the Jupyter notebook. I'll be using something called Pandas. As you can see, read.pandas.csv. I'll be reading this data set where you can see that this is the data set that I am able to read. I got a number of observations that are present. I can see that director Facebook likes and actor 3 Facebook likes. So now what is that I want to do is, instead of building this clustering technique on top of every observation, so what I will do is I will take these columns called number of Facebook likes on director and number of actor Facebook likes versus director Facebook likes. So where you can see that if I want to select a director Facebook likes alone, I'll be able to choose this director Facebook likes alone. You can see for every movie you got the number of director Facebook likes which are present. So if there are more number of Facebook likes, what does it mean? The director is famous person, correct? Or either if there are more number of famous Facebook likes that the actor has got, which means that the person is, or the actor is very famous person. So that's what you can understand. So now we can see that I'll try to extract these independent components that we're talking about. I will extract all the records in all the director Facebook likes versus actor Facebook likes, where I'm just going to form an object called new data by applying some I location as a filter. I locations, ILOC stands for index location, where I can filter out what are the records that I wanted to, what are the columns that I wanted to, using this I location function. Now I got all the so-and-so called number of director Facebook likes versus actor Facebook likes, which are present as part of this. Okay, so this has been loaded into an object called new data. So now what is that I'll be doing? After that, I'm importing something called sklearn k-means cluster. So this algorithm is available as part of this scikit-learn algorithm. Whatever the number of steps that we have discussed, you're not supposed to execute all these steps manually. And of course, if you want, you can also write such a program as well. But what is that we'll be doing? In scikit-learn library, there is a Python library called scikit-learn, which has got most of the algorithms present, and we will be importing this k-means clustering algorithm. And for this k-means clustering, I'm providing the c is equal to number of clusters is equal to 5. So here, if you are aware of object-oriented programming using Python, you'll be able to correlate. I'm importing this k-means clustering, which is implemented as a class here, where I'm creating an object called k-means clustering by providing an input called n number scores clusters is equal to 5, which means that what is the meaning of 5? I want to build 5 clusters out of this. So where once you create an object using k-means, I'm calling this method called fit method by providing new data as my independent variables. I'm calling this fit method, which means fit is a method that's going to invoke what's supposed to be the process that needs to be executed. That's going to build my clustering technique algorithm by taking number of clusters is equal to 5. So now I'm able to generate my algorithm where by looking at my model, I'll be able to extract what are the centroids that I got, final centroids, because initially you'll be taking some random centroids, but at the end you'll end up with getting a final centroid position somewhere fixed to it. That is nothing but a center point for every cluster that we got. These are the final centroid that we got. Even if I want to print what is the labels which are generated, labels is nothing but it will extract the outcome. You can see that these are the label numbers which are added here. Out of 5,000 movies, we got the labels which are added as an array, but we won't be able to see it like that. What is it I'm trying to do? I'm trying to get all the unique values present in these labels with respect to counts. Now you can see that my data is now clustered into 5 different, all the movies are clustered into 5 different clusters. As you see, cluster number 0 has got 4,700. Most of the observations are moved into cluster number 0. 104 movies went into observation number 1. 11 movies are moved into cluster number 2. And 87 movies are moved into cluster number 3 and 67 into cluster number 4. So the data properties are being distributed, and that's how the clustering technique has divided the data into 5 clusters. Now you can see what is that I'm trying to do. I'm trying to put this into a new data of cluster, which means whatever the labels that are generated here. This is my output column. I'm going to create this into as a new column in my new data, where I'm using this lm plot that will print whatever the column that I have called director Facebook likes versus actor Facebook likes. And I'm choosing this data is equal to new data that will help me to identify what column can be considered as hue, so that I'll be printing it in a cool warm type chart. You can see that palette type is equal to cool warm type, which will help me to identify based on the cluster that you have created. Now if I print this, you can see that pretty much every observation is now categorized into individual cluster. You can see these are the movies which are now graphical representation. This is the graphical representation that we are using to see how these movies are being segregated. I can see these movies are nothing but cluster number 0. You can see there are a few more movies which are extracted over here. This is nothing but based on the color indication. This is cluster number 3. And these movies are created as a cluster number 1, cluster number 2. These movies are something which are created as cluster number 1. And these movies are created as cluster number 4. 0, 1, this is nothing but 2, cluster number 3, cluster number 3, and cluster number 4, like this. Now you can clearly see that how the k-means clustering has came up. The movies which are made by new people with new directors, new actors are making films with new directors, or new directors are making film with new actors. These are all, you will see more number of movies will fall into this category, because you will end up with getting new people into the film industry most of the cases. A lot of movies are being made with new directors with new actors. And you can see that these movies are the clusters which are being segregated very clearly. The famous actors are making films with new directors. Very famous actors are making films with new directors. And these movies are something where very famous directors are average fame directors are making films with some new actors. You can see these movies are nothing but very famous directors are making films with very new actors. You can see very famous directors are making films with very famous actors. Like Spielberg might be making a film with Tom Cruise or something like that. So likewise, you can clearly see that where instead of if you do this activity manually, it might take a little longer time for you to segregate each and every component. But within 5 minutes, we're able to cluster this activity, right? So that's what the beauty with algorithms. You don't need to manually do this activity, where you can provide your data automatically based on the properties of the data. Your algorithm itself will build this clustering output out of the data. All right. So that's how we will be able to build a clustering technique on top of the given data. So that's what we have as part of one of the hands-on example.
What is hierarchical clustering? So hierarchical clustering, it is also known as HCA or hierarchical cluster analysis. And this is a method of cluster analysis as we have seen. So what happens here is that this clustering allows us to build the tree structure from data similarities, like we have built X and Y, and we have created trees, and these trees are actually called known as dendrograms. So the way you represent a hierarchical cluster or hierarchical clustering is through dendrograms. So we actually drew a dendrogram. Okay. So this is how the clustering is being formed, and this is how the clusters are being made, and this is how the relationship among the clusters is being shown by a dendrogram. So based on these things, now we will go on further to understanding what is agglomerative clustering. So when this hierarchical clustering follows a bottom-up approach, this is called agglomerative clustering. And when this is following up a top-down approach, this is used in divisive clustering. So now let us understand what is agglomerative clustering. So the types of hierarchical clustering are two, that is agglomerative and divisive. So now moving on further, what is agglomerative clustering? So agglomerative hierarchical clustering, this is also known as AGNES, which means agglomerative nesting hierarchical clustering. And it follows a bottom-up approach, which means that clustering or clusters, they are formed from the bottom and are again clustered till a complete single cluster is formed. And what happens then is that the clustering continues until we obtain a single cluster, and we will see how we obtain a single cluster, and we also represent it. So individual data points are clustered based on similarity, and we go on clustering until there's only one single cluster left. So let us just plot this agglomerative clustering and make things really simple for us. Now suppose I have got these data points scattered here, A to G, and these data points have to be clustered. So another important thing is that now we will form clusters. So how clusters are formed? So we can see that based on some similarity, like because of the distance, nearby distance, A and B can be grouped together in a single cluster. So I am just doing that. C and D, I form another cluster because they are near. So I just club them. And again, I would just club E and F based on their distance. And G is separate, so I will just form a separate cluster. Now what happens in agglomerative clustering is that I have to plot all these data points like A, B, C, right, D, E, F, and G. So these are separate clusters. The clustering starts from the bottom, and each data point is treated as a single cluster, which we will also understand with the help of an example further. But now for simplicity, let's take A, B, C, D. So then what happens is that since A and B are grouped as one cluster, so this is how I just group them, all right? And C and D is grouped as one cluster. This is how I group them. E and F are grouped in one single cluster. This is how I group them. Now remains G, which is not being grouped into any of the cluster. So now clustering, I said that it continues until a single cluster is left. So now I would have to have another level of clustering. That means that E, F, G, since G is very close to E, F, I will cluster it in one single cluster. Okay. And since I can see that both these A, B, and C, D pairs, these clusters are again together, so I will just cross this line and I will make one single cluster of these 4 points, right? So what I do is, since these two are connected, I connect them with the help of this line figure, that is tree structure dendrogram, and this G, E, and F, they are connected somehow. I connect them. All right. Now what happens is that I have got two big clusters, and clustering continues until a single cluster is obtained. So in the end, I will have to cluster everything into a single cluster. And this is how I do that. And to join it, I will again join this entire graph. So this is when it follows a bottom to up approach. This is called as agglomerative hierarchical clustering. Okay, so now we will go and see an example of this hierarchical agglomerative clustering, right? Okay, so let us understand what is agglomerative clustering with this example. Now we see that here the clustering takes place from bottom to up, and we have taken an example of population wherein we go on clustering until we get population. So here from the bottom, the individual professions are being plotted, and we see that let's take for a convenience the left hand side, and on the left hand side the red dots, as you see, this is individual profession in public sector, and on the another side which we see in the brown circles is the private sector employment. So somehow there's similarity between private sector, so they are being clustered as one single cluster, and the private sector as another cluster. These again are being clustered into one single cluster, and that is employment cluster. Whereas on the another side, we can see another cluster which is different, and that is unemployed section of cluster of people. Now, they again share one similarity, and that is that they all belong to a single gender, that is male. So everything is being clustered into one single cluster, that is male. And then again, male and female clusters are being clustered together to form one single cluster, that is population. Similarly, we also divide on the right hand side the individual professions of women clubbed into private and public sector, and then again we have separate clusters of employed and unemployed women, and they have been grouped into one single cluster, and that is women. Again, we merge the two big clusters into one single cluster, that is population. So this is how the clustering is taking place. The levels are being increasing from bottom to up. So when we are using this bottom up approach, this is agglomerative clustering.
Now, many of us have visited retail shops such as Walmart or Target for our household needs. Or let's say that we are planning to buy the new iPhone from Target. What we would typically do is search for the model by visiting the mobile section of the store and then select the product and head towards the billing counter. But in today's world, the goal of the organization is to increase the revenue. Can this be done by just pitching one product at a time to the customer? Now the answer to this is clearly no. Hence, organization began mining data relating to frequently bought items. So market basket analysis is one of the key techniques used by large retailers to uncover associations between items. Now, examples could be the customers who purchase bread have a 60% likelihood to also purchase jam. Customers who purchase laptops are more likely to purchase laptop bags as well. They try to find out associations between different items and products that can be sold together, which gives assisting in the right product placement. Typically, it figures out what products are being bought together, and organizations can place products in a similar manner. For example, people who buy bread also tend to buy butter, right? And the marketing team at retail stores should target customers who buy bread and butter and provide an offer to them so that they buy a third item, suppose eggs. So if a customer buys bread and butter and sees a discount offer on eggs, he will be encouraged to spend more and buy the eggs. And this is what market basket analysis is all about. This is what we are going to talk about in this session, which is association rule mining and the Apriori algorithm. Now, association rule can be thought of as an if-then relationship. Just to elaborate on that, we have come up with a rule. Suppose if an item A is being bought by the customer, then the chances of item B being picked by the customer too under the same transaction ID is found out. You need to understand here that it's not a causality, rather it's a co-occurrence pattern that comes to the force. Now there are two elements to this rule. First is the if and second is the then. Now if is also known as antecedent. This is an item or a group of items that are typically found in the item set. And the later one is called the consequent. This comes along as an item with an antecedent group, or the group of antecedents are purchased. Now, if we look at the image here, A arrow B, it means that if a person buys an item A, then he will also buy an item B, or he will most probably buy an item B. Now, the simple example that I gave you about the bread and butter and the eggs is just a small example. But what if you have thousands and thousands of items? If you go to any professional data scientist with that data, you can just imagine how much of profit you can make if the data scientist provides you with the right examples and the right placement of the items which you can do. And you can get a lot of insights. That is why association rule mining is a very good algorithm which helps the business make profit. So let's see how this algorithm works. So association rule mining is all about building the rules. And we have just seen one rule, that if you buy A, then there's a slight possibility or there's a chance that you might buy B also. This type of a relationship in which we can find the relationship between these two items is known as single cardinality. But what if the customer who bought A and B also wants to buy C? Or if a customer who bought A, B, and C also wants to buy D? Then in these cases, the cardinality usually increases, and we can have a lot of combination around these data. And if you have around 10,000 or more than 10,000 data or items, just imagine how many rules you're going to create for each product. That is why association rule mining has such measures so that we do not end up creating tens of thousands of rules. Now, that is where the Apriori algorithm comes in. But before we get into the Apriori algorithm, let's understand what's the maths behind it. Now, there are three types of matrices which help to measure the association. We have support, confidence, and lift. So support is the frequency of item A or the combination of item A or B. It's basically the frequency of the items which we have bought and what are the combination of the frequency of the item we have bought. So with this, what we can do is filter out the items which have been bought less frequently. This is one of the measures, which is support. Now, what confidence tells us? So confidence gives us how often the items A and B occur together, given the number of times A occur. Now, this also helps us solve a lot of other problems, because if somebody is buying A and B together and not buying C, we can just rule out C at that point of time. So this solves another problem, is that we obviously do not need to analyze the products which people just buy barely. So what we can do is, according to the sales, we can define our minimum support and confidence. And when you have set these values, we can put these values in the algorithm and we can filter out the data and we can create different rules. And suppose even after filtering, you have like 5,000 rules. And for every item, we create these 5,000 rules. So that's practically impossible. So for that, we need the third calculation, which is the lift. So lift is basically the strength of any rule. Now let's have a look at the denominator of the formula given here. And if you see here, we have the independent support values of A and B. So this gives us the independent occurrence probability of A and B. And obviously, there's a lot of difference between the random occurrence and association. And if the denominator of the lift is more, what it means is that the occurrence of randomness is more rather than the occurrence because of any association. So lift is the final verdict where we know whether we have to spend time on this particular rule, what we have got here or not. Now, let's have a look at a simple example of association rule mining. So suppose we have a set of items A, B, C, D, and E, and a set of transactions T1, T2, T3, T4, and T5. And as you can see here, we have the transactions T1 in which we have A, B, C, T2, A, C, D, T3, B, C, D, T4, A, D, E, and T5, B, C, E. Now what we generally do is create some rules or association rules, such as A gives D or C gives A gives C, B and C gives A. What this basically means is that if a person buys A, then he's most likely to buy D. And if a person buys C, then he's most likely to buy A. And if you have a look at the last one, if a person buys B and C, he's most likely to buy the item A as well. Now, if we calculate the support, confidence, and lift using these rules, as you can see here in the table, we have the rule and the support, confidence, and the lift values. Now let's discuss about Apriori. So Apriori algorithm uses the frequent item sets to generate the association rule. And it is based on the concept that a subset of a frequent item set must also be a frequent item set itself. Now this raises the question, what exactly is a frequent item set? So a frequent item set is an item set whose support value is greater than the threshold value. Just now we discussed that the marketing team, according to the sales, have a minimum threshold value for the confidence as well as the support. So frequent item set is that item set whose support value is greater than the threshold value already specified. For example, if A and B is a frequent item set, then A and B should also be frequent item sets individually. Now let's consider the following transaction to make the things a little easier. Suppose we have transactions 1, 2, 3, 4, 5 and these items are there. So T1 has 1, 3 and 4, T2 has 2, 3 and 5, T3 has 1, 2, 3, 5, T4, 2, 5 and T5, 1, 3 and 5. Now the first step is to build a list of item sets of size 1 by using this transactional data. And one thing to note here is that the minimum support count which is given here is 2. Let's suppose it's 2. So the first step is to create item sets of size 1 and calculate their support values. So as you can see here, we have the table C1 in which we have the item sets 1, 2, 3, 4, 5 and the support values. If you remember the formula of support, it was frequency divided by the total number of occurrence. So as you can see here, for the item set 1, the support is 3. As you can see here, the item set 1 appears in T1, T3 and T5. So as you can see, its frequency is 1, 2 and 3. Now as you can see here, the item set 4 has a support of 1 as it occurs only once in transaction 1. But the minimum support value is 2, that's why it's going to be eliminated. So we have the final table, which is the table F1, in which we have the item sets 1, 2, 3 and 5 and we have the support values 3, 3, 4 and 4. Now the next step is to create item sets of size 2 and calculate their support values. Now all the combination of the item sets in the F1, which is the final table in which we discarded the 4, are going to be used for this iteration. So we get the table C2. So as you can see here, we have 1, 2, 1, 3, 1, 5, 2, 3, 2, 5 and 3, 5. Now if you calculate this support here again, we can see that the item set 1, 2 has a support of 1, which is again less than the specified threshold. So we're going to discard that. So if we have a look at the table F2, we have 1, 3, 1, 5, 2, 3, 2, 5 and 3, 5. Again, we're going to move forward and create the item set of size 3 and calculate their support values. Now all the combinations are going to be used from the item set F2 for this particular iterations. Now before calculating support values, let's perform pruning on the dataset. Now what is pruning? Now after the combinations are being made, we divide C3 item sets to check if there is another subset whose support is less than the minimum support value. That is what frequent item set means. So if you have a look here, the item sets we have is 1, 2, 3, 1, 2, 1, 3, 2, 3 for the first one. Because as you can see here, if we have a look at the subsets of 1, 2, 3, we have 1, 2 as well. So we are going to discard this whole item set. Same goes for the second one. We have 1, 2, 5. We have 1, 2 in that, which was discarded in the previous set or the previous step. That's why we're going to discard that also. Which leaves us with only 2 factors, which is 1, 3, 5 item set and the 2, 3, 5. And the support for this is 2 and 2 as well. Now, if we create the table C4 using 4 elements, we're going to have only one item set, which is 1, 2, 3 and 5. And if we have a look at the table here, the transaction table, 1, 2, 3 and 5 appears only 1. So the support is 1. And since C4, the support of the whole table C4 is less than 2, so we're going to stop here and return to the previous item set, that is C3. So the frequent item sets are 1, 3, 5 and 2, 3, 5. Now let's assume our minimum confidence value is 60%. For that, we're going to generate all the non-empty subsets for each frequent item sets. Now for I equals 1, 3, 5, which is the item set, we get the subset 1, 3, 1, 5, 3, 5, 1, 3 and 5. Similarly for 2, 3, 5, we get 2, 3, 2, 5, 3, 5, 2, 3 and 5. Now this rule states that for every subset S of I, the output of the rule gives something like S gives I to S. That implies S recommends I of S. And this is only possible if the support of I divided by the support of S is greater than or equal to the minimum confidence value. Now applying these rules to the item set of F3, we get rule 1, which is 1, 3 gives 1, 3, 5 and 1, 3. It means 1 and 3 gives 5. So the confidence is equal to the support of 1, 3, 5 divided by the support of 1, 3. That equals 2 by 3, which is 66% and which is greater than the 60%. So the rule 1 is selected. Now if we come to rule 2, which is 1, 5, it gives 1, 3, 5 and 1, 5. It means if we have 1 and 5, it implies we're also going to have 3. Now if we calculate the confidence of this one, we're going to have support 135 divided by support 15, which gives us 100%, which means rule 2 is selected as well. But again, if we have a look at rule 5 and rule 6 over here, similarly, if we select 3 gives 135 and 3, it means if we have 3, we also get 1 and 5. So the confidence for this comes at 50%, which is less than the given 60% target. So we're going to reject this rule. And same goes for the rule number 6. Now, one thing to keep in mind here is that although the rule 1 and rule 5 look a lot similar, they are not. So it really depends what's on the left hand side of the arrow and what's on the right hand side of the arrow. It's the if-then possibility. I'm sure you guys can understand what exactly these rules are and how to proceed with these rules. So let's see how we can implement the same in Python, right? So for that, what I'm going to do is create a new Python file, and I'm going to use the Jupyter Notebook. You're free to use any sort of IDE. I'm going to name it as Apriori. So the first thing what we're going to do is we'll be using the online transactional data of a retail store for generating association rules. So firstly, what we need to do is get the Pandas and MLXtend libraries imported and read the file. So as you can see here, we are using the online retail.xlss format file. And from MLXtend, we're going to import Apriori and association rules. It all comes under MLXtend. So as you can see here, we have the invoice, the stock code, the description, the quantity, the invoice data, unit price, customer ID, and the country. Now next in this step, what we're going to do is do data cleanup, which includes removing the spaces from some of the descriptions and drop the rows that do not have invoice numbers and remove the credit card transactions, because that is of no use to us. So as you can see here, the output in which we have like 532,000 rows with 8 columns. So after the cleanup, we need to consolidate the items into one transaction per row with each product. For the sake of keeping the data set small, we are only looking at the sales for France. So as you can see here, we have excluded all the other sales. We are just looking at the sales for France. Now there are a lot of zeros in the data, but we also need to make sure any positive values are converted to 1 and anything less than 0 is set to 0. So as you can see here, we have still 392 rows. We're going to encode it and see. Check again. Now that you have structured the data properly, in this step what we're going to do is generate frequent item sets that have support at least 7%. Now this number is chosen so that you can get close enough and generate the rules with the corresponding support, confidence, and lift. So guys, as you can see here, the minimum support is 0.7. Now what if we add another constraint on the rules, such as the lift is greater than 6 and the confidence is greater than 0.8. So as you can see here, we have the left hand side and the right hand side of the association rule, which is the antecedent and the consequence. We have the support, we have the confidence, the lift, the leverage, and the conviction. So guys, that's it for this session. That is how you create association rules using the Apriori algorithm, which helps a lot in the marketing business. It runs on the principle of market basket analysis, which is exactly what big companies like Walmart, you have Reliance and Target do. Even IKEA does it.
Let's start with the core interview questions. First thing, how will you explain machine learning to a school-going kid? So in this case, the interviewer is interested to see how you can explain the concepts in machine learning in a very simple manner so that even a school-going kid can understand. you can give an example to a kid saying that, okay, your friend has invited you to a party and you meet completely strangers there. So you have not seen them previously. They are just completely strangers to, and you're going to meet them. Since you have no idea about them previously, so you will try to classify them based on the available things that you can visualize. That is like, what is the gender, what is the age group, so how are they dressed, how do they behave with you, like what is their attitude. So he will try to classify them based on those features. So this is a pure example of unsupervised learning. So in this case, we don't have any prior knowledge. So in this case, they are completely totally strangers. How is it different from the supervised learning? So in supervised learning, the benefit will be you will have some prior knowledge, and based on that, you will try to go. So you can explain to the kid that as you already got identified to those kids, in future you know their names, so you will try to classify them whenever you see them. So that will be the example of supervised learning. So let's move on to the next thing. What are various types of machine learning? So first of all, you have to say that the machine learning is categorized into majorly three components. First is the supervised learning, second is the unsupervised learning, and third is the reinforcement learning. So in the supervised learning, it is like learning with a teacher. So training data set is like a teacher is giving you like training the machine. So teacher is trying to train based on the whatever teacher knows. So model is like trained on this predefined data which you have, and it start to make decisions based on the, again based on this rule that it has identified from the existing data. It will try to make some predictions and decisions on the new data. You can give some examples as we have here. In this case, when we have apples and bananas, we feed machine apples and bananas with the label saying that, okay, this is the apple, this is how it looks, this is the set of bananas, and this is how they look. So when you feed it to the machine learning supervised algorithm, so what it does is it tries to identify the patterns which are there with each category. So it will set the rule that, okay, apple looks like this, banana looks like this. So this is the training data that we have provided based on which our supervised learning learns it. And we use this model on the new data set. So for example, in this case, we are using this green apple, and based on the structure which is already there, the green apple is still going to be predicted as an apple based on the shape it has. Okay, so that is the example of supervised learning. Let's move to the next thing, which is unsupervised learning. So in this case, it is like learning without a teacher. So model learns through the observations which are there, and it tries to identify some patterns and structure which will be hidden within the data. So in this case, we are not labeling the data. So model is given a data, and model is left on itself to learn the patterns and relationships out of the data by creating clusters. So clustering is one of the major techniques which are used in the unsupervised learning. There are many, but it is the most popularly used within the unsupervised. So for example, when we feed the apples, bananas, and the mangoes here again, but in this case, we are not labeling them. We are not telling the machine that, okay, these are the apples, these are the bananas. We're just giving it the data, saying, okay, this is what it is. We don't know anything about it. So when we feed it to the algorithm tries to learn the patterns out of it and tries to classify them. It won't say this is apple, this is banana, but it will say, okay, these are similar. So apples are similar, and it'll try to cluster them together. Bananas are similar, it will try to separate them in a different cluster. And mangoes are similar, it will try to cluster them in a separate cluster. So it will try to understand the patterns which are there within the data and give you the clusters out of it. So that is the unsupervised learning. Third part is reinforcement learning. So in this case, model learns with hit and trial method. So assume that we are playing the Mario game, and in the Mario game, the player is called as the agent in the reinforcement learning. We have an environment which is nothing but a game. There will be some predefined actions which agent can take. For example, in the game of Mario, it will be he can move forward, he can jump, he can go into the tunnels, he can fire the bombs. So those are the steps. And based on the steps, your environment will try to reward you. Either it will reward you or it will penalize you. Based on that, your model will get created, which will say, okay, these are the best actions, where when you do these actions, you will get your score more, which is like a reward. And when you don't, you do this kind of action, your score will get penalized. So based on this environment, your reinforcement learning will try to learn those things.
So that is one example, and you can also give some examples related to the AlphaGo, which is a Go playing game which recently was developed by a Google-based company. And you can also say that chess-based games can be automated with the reinforcement learning. So there is one more category within machine learning which is not much talked about, which is the semi-supervised algorithm. So which are basically combination of supervised plus unsupervised. So in this case, what happens is you have a data set which is half of it is labeled and half of it is not labeled. So in this case, both supervised plus semi-supervised are used to create your models. So you can also give this so that there will be more confident on you. Okay, so let's move on to the next thing. What's your favorite algorithm and can you explain it in a minute? In this case, interview is trying to understand as how you can explain some complicated techniques and technologies in a very simple and simplistic manner to some higher up people or the clients or those kind of things. So make sure you have some choice and you can explain different algorithms in a simple manner. You keep for every example, try to keep some simple examples so that you can effectively and you can easily explain it so that even a small kid can understand as how you're explaining those things. So how deep learning is different from machine learning? In this case, first thing is you have to know that deep learning is not completely different from machine learning. You have to say that, okay, deep learning is a small part of machine learning. And in the core machine learning, based on the input, first you have to do the feature extractions. You have to classify the features which are the good, which are trying to explain your model better based on some exploratory data analysis, and based on that you will feed it to the algorithms, and those algorithms will try to identify the patterns within those and give you the output. In deep learning, it is a bit simplified. What happens is based on the input, the model will try to extract the features on itself and will try to create a model based on those. So it is trying to combine both the things of feature extraction and classification into a single thing, and it will give you the output. So that's why it is recently being very popular. So that is one thing. And deep learning is basically, if you know, the deep learning is constructed most of the neural networks. So and neural networks are basically borrowed from the idea of the human brain. So how the human brain works and how the neurons within the brain really works in a very complicated and effective manner. So those are the things which have been taken and being implemented in the deep learning. And machine learning is about the algorithms that basically parses and learns the data and tries to identify the patterns within the data, apply whatever pattern learned from the data to the new data whichever is coming. So that is the most of the thing which was related with the machine learning, but deep learning has come a bit more advanced to it. Okay, so explain classification and regression. So classification and regression is part of supervised learning. So you have to say this first, that this is part of the supervised learning. Supervised learning is broadly categorized into these two parts, and regression is mostly dealing with the continuous variable. So in continuous variable, it's like you're trying to predict the sales, you're trying to predict the stock market values. So wherever there are continuous predictions, you're trying to do the regression of your data. So classification is like you're trying to predict the different classes which are there within the data. So for example, the classes could be like, is the student going to pass or not? Is my customer going to buy my product or not? And is my salary is within like high, medium, low? So those are the different classes. And when we're dealing with the classes, we say it is classification. And we're dealing with the continuous values, we say it is regression. So in this case, if you see, the regression is like size of your house, area, and the location which are there. And classification is like when you're trying to give it a classes. So very cheap, affordable. So you're creating a 5 classes here, and that becomes the classification. What do you understand by selection bias? In the statistical term, sampling is basically trying to sample some data from your population. So you are trying to take some portion of the data from the population, and when you have some bias to some specific set of data. So let's assume we want to take a population of all the data scientists within India. When you're talking about India, you have to take data from all parts of India. But let's assume you just take the sample from the Gurgaon. So when you just take the sample from the Gurgaon, you're getting a selection bias. You're getting bias to the Gurgaon and you're just selecting the data from there. So in this case, you're getting bias to those conclusions of your inaccurate conclusions of yours, and you're not making the accurate decisions based for the population. Okay, so that is the selection bias. So what do you understand by precision and recall? So in this case, let's go on with the example. So let's imagine that your girlfriend keep on giving you surprises from last 10 years of your birthdays, and one sudden day she comes to you and asks you, do you remember all birthday surprises from me? And you just get shocked. And in this case, to extend your life, what you do is you try to recall all the 10 surprising events that you had in your previous birthdays, and this recall that you're doing is nothing but the number of events you actually correctly trying to recall it and the actual events which have happened. So this is the ratio that you're trying to capture of all the recalls that you're doing correctly and the number of the correct events which happened. So for example, if you are trying to recall out of 10 all the 10 correctly, then your recall ratio is nothing but 1. So which is again 100%. But if you're trying to recall only 7 events correctly, so as per the ratio, what will happen is the number of events you can correctly recall is 7, and the total number of events which are there is 10. So in this case, your ratio will be 0.7, which will be 70%. But let's assume you might be wrong in some answers. So for example, you answered you remember 15 times, but out of this only 10 were correct and 5 events were actually wrong. So you remembered from some another events. So in this case, so you recall all the events which are there, but it's not completely precise. So in this case, the precision is the ratio that the number of events you are recalling correctly to the number of events you recall. So which is like out of 15, you are trying to recall the 10 as a correctly. So that is the precision which we have. So 10 real events and 15 answers. So the ratio is the 66% in this case, which is 10 divided by 15. Okay. In the formulas, you can represent all those things in a simple formula. So number of events you can correctly recall are called as the true positive. So which you said as true, you said as a positive, you are able to recall them correctly and they're actually there. So number of all correct events. So this is also again the true positive which you recall correctly plus the false negative which you didn't recall. Okay, and the next thing is the number of events you recall. So which is true positives plus the false positives. In this case, what's happening is the correct recall that you did, all the events that you correctly remembered, and some which are not correct. So you said, okay, I recall them. So for example, when we had it 15, so in that case, there were some like 10 were correct and 5 were the false positive, which was you didn't recall them correctly. So based on all this above, recall is true positive divided by true positive plus false negative. So true positive plus false negative is nothing but the number of correct events, as we already saw that. So number of events you can correctly recall divided by number of correct events. And precision is true positive divided by true positive plus false positive, which is the number of events you can correctly recall divided by number of all events you recall. Okay. So the next question is explain false negative, false positive, true negative, and true positive with a simple example. So previously we just saw the example where we had an example of the birthday surprises. So you can also go with the example where it will be more realistic as it will give some impact to it. So for example, the true positive. So in this case, we can take some real example where what the model that we are trying to build, what it does is based on the fire is there or not, it will try to raise an alarm. So in the first case, it's true positive. So in true positive, what will happen is you said you have to do the alarm and there is actually a fire. So there is actual fire and you try to do it. It is the right condition. So that is the true positive. Second is the false positive. In this case, you raise an alarm, but there is no fire. So in this case, what will happen when you raise the alarm? There is no fire, but still people are running. So that is not a good thing, and that is called the false positive. Third example is false negative. So false negative if you're not raising an alarm even when there is a fire. This is the worst condition that we have in all the situations. So your aim is to raise an alarm when there is actual fire. But this condition says when there is still a fire, you're not raising any alarm. So this is the most harmful thing which can be there and where your model is not working. So you have to be very careful with this thing one. And true negative is something where there is no fire and you have not raised any alarm, which is still good. Okay. What is confusion matrix? So to explain this confusion matrix to your interview, you can take some simple examples such as you want to create a model where what you are trying to look is you have a bank and that bank wants to identify who are the customers I should be giving loan to so that they won't default me. So I have a training data where I know that okay, these are the customers who were good, who didn't default, and these are the customers to whom I gave loan but they defaulted. So that data is used in making these predictions, and you have a model which has done this also. So assume that we have 165 people in the training set, and after doing the prediction, so in the training set, what we have got is in actual 105 people can be given loan who didn't defaulted, and 60 people who bank gave loan they defaulted. So what your model is predicting in this case is it says 110 people can be given loan who will not default and 55 people can be rejected so as they are going to default. But this is on a higher level. But when you look at a confusion matrix, what will happen is you will try to see, okay, how my model is performing and where are the true positives, true negatives, and how should I take care, not take care, but how is it performing at the part of the false positive and the false negative. So assume we have a true positive. So in actual, there are 105 people who the bank's training data says can be given loan who didn't default, but out of that model has identified 100 people, so which is a good thing. And for the no case, for the rejection case, out of 60 people the model says 50, which is again a good thing. But your model says for 10 people who are actually defaulters, but model says you should give them loan. So those are the things which can be looked into the future, but confusion matrix will help you to understand how your model is performing based on the predicted, the model output and the actual data which you have. So what is the difference between inductive and deductive learning? So to help this concept, you can give some good examples such as a father want to explain his son how the fire can burn him. So there are two ways that he can teach his kid as how he can get impacted from the fire. So first thing is he will show him some examples, like he will show him some videos or he will show some demo as how the fire will get him burned. So based on the observations, the kid will learn and make some conclusions out of it. So that is the example for inductive learning where he will do the observation and see how the things are going to be and make some conclusions out of it. And for the deductive learning, it is like father is letting the kid play with the fire. So the father will wait till kid will get burned and try to make some conclusions out of it and have the observations after it. Like he will get himself burned and then he will say that okay, fire makes us burn. So that is the deductive learning where what happens is first you will make some conclusions and then you draw the observations. Similarly, in the field of machine learning, it is like out of the data you will try to do some observations and these observations are stored as a model, which is like you have observed all the things and kept it as a model. And the deductive learning is like you are giving it a data and based on the previous inductive learning that it has already done, it will try to deduce the output of it. So how is KNN different from K-means clustering? One important thing happens is people are really confused with what is KNN. Sometimes like is KNN clustering or is K-means a clustering? In this question, the clustering is given to you as K-means clustering, but sometimes the interview will just ask you how is KNN different from K-means. First thing you have to do is you have to understand the difference as K-means is an unsupervised technical algorithm and KNN is a supervised technique. In KNN is used as a supervised algorithm, KNN is used for classification and regression, and K-means is used for clustering. As it's a clustering algorithm, it is used to create the clusters of your data. K within KNN basically means it tries to observe the K neighbors. So in the case of regression, it will try to identify the surrounding k neighbors and take the average and give you the output. And in the case of classification, what it will do is it will try to see the surrounding neighbors, k neighbors, and whatever the majority of the class is there, it will assign the class to that. So in this case, k is your neighbors based on which your regression and classification will be done. In the case of k means, it is the k clusters that you're going to create out of your data. So k in the both cases is different, and you have to give this differences to the interviewer. So one thing is, once you know that okay, k means is an unsupervised and KNN is a supervised, you can further go on top of that. Okay. Can you explain me what is ROC curve and what does it represent? So in this case, interviewer is interested to know how good you understand the ROC curve and how you can use it to understand your model's output. So interviewer is very much interested as how you are trying to use this in your model performance. So as ROC is also one of the performance parameters for your model, and this is used in the cases of binary classification. The full form for the ROC is Receiver Operating Characteristics Curve, and its fundamental use started with the diagnostic test evaluations. So in the medical field, its application started and it is used in the machine learning field to do the classification related algorithms performance evaluation. So in simplistic term, it is the plot of true positive rates, which is also called as the sensitivity, against the false positive rate. So what happens is once you get the output in the probabilities, you can use the different cutoffs, and you can use the cutoffs to distinguish as what is going to be the true cases and what is going to go for a false cases. And you can plot the ROC curve, and ROC curve says when your curve is having 1, your model is good. And the plot with the 50% like 0.5, which is nothing but this blue line, which is the worst case. It's like your model is saying you have a 50% chance in the prediction. It's just saying it's just a normal guessing work. So you're either guessing 1 or 2 with a 50% probability. The more closer to this and more area this curve is trying to cover, the better is the algorithm. So better you're trying to predict the true positive rates than the false negative rates. Your true positive rates should increase faster than the false positive rates in this case. So first we saw like what actually ROC curve does, and we will see like how you can interpret it now. So you can give the interviewer some idea about what is really ROC curve, give some details about it, and you can give the technical details like how you can interpret it. So first of all, it is like trade-off. There is always a trade-off between sensitivity and specificity, and one will increase in one will create a decrease in another. So it is really important with the ROC curve, you will see these differences as how they are getting impacted. The closer the curve follows to the true positive rate line and the more area it covers, such as the yellow one, as it is covering the highest area, that is more better than the pink one, and pink one is more better than the blue one. The blue one is, as we already said, is like just a random guessing with a 50% of probability. And the slope of the tangent line at the cut points gives you the likelihood ratio as how likelihood your model is. What's the difference between type 1 and type 2 error? So this is one of the very important concepts which you interviewers trying to understand as how you try to distinguish between the type of errors, or do you understand as how this type 1 and type 2 errors are impacting the performance of your model. So interviews trying to understand those things, so you can give some good examples to say how these are going to impact. So first thing is type 1 error is false positives. So when something is not true, which in actuality is not true, but your model is saying it is true. So as we have the example, if a doctor says to a male person that he is pregnant, so it is like something is not true, but you are saying it is true. So which is the false positive and is an example for the type 1 error. And the type 2 is a false negative. So when something you are saying is not there, but in actuality it is there. So when you're saying negative, so you are saying it is not there, but in actuality it is false. So that is the false positive. Similar example comes to where female is pregnant and the doctor says she is not pregnant. So this is like your model says something is not true, which is in the negative case, but in reality it is there. Is it better to have too many false positives or too many false negatives? This case really depends on the domain and the type of problem that you're solving. So based on the different problems and the different business requirements, you have to decide on what to have. So there is always a trade-off. You have to maintain the trade-off between these false positives and false negatives, and you have to decide which one we can keep as a more. As we already saw in the previous case, where you can imagine that where a doctor says a male person that he is a pregnant person. So these kind of model is always going to be a problem, and you have to decide like how many of these cases you can manage. So is it like out of 100, can you say that you can manage 10 false positives, or how many you can consider for those, and you can move on with the model. So similarly, there is example wherein the spam filtering. So can you say a good mail as a spam or not? So that trade-off you have to manage, and based on that it will go. So this you have to define beforehand which one you can go on with, and you have to create a model as per that. So these kind of questions are mostly related with the domain specific questions. So you cannot just select any one of it and just give example. So beforehand, just try to understand what domain you're trying to explain, and before that, try to first be clear with what is false positives and what is false negatives. After that, select some specific domains and give the examples. So for example, in the medical testing, negatives may provide a false reassuring messages to the patients and physicians that some disease is absent, but you're actually saying it is present. So what will happen in this case is you are trying to give inadequate treatments to both the patients and the disease, which is not required. And these things will cost patients to the medical and the medical agencies, and these kind of things has to be managed. So it is desirable to have many false positives in this case. The other example could be the spam filtering. So in this case, a false positive occurs when spam filtering is blocking or wrongly classifying the legitimate emails. So you can't have that as many times. So users will get irritated when your actual mails are getting into the spam. So in this case, we prefer to many false negatives over the many false positives. So based on the domain, it differs, and you have to give the example specific to those domains. Okay. So which is more important to you, the model accuracy or the model performance? This question, the interviewer is trying to understand how better you know these terms. So do you really know the differences between these terms? So first thing, try to understand what these terms are. In actually, the model accuracy is part of model performance. It is subset of the model performance. There are different model performance measures, and model accuracy is one of them. So for example, let's consider the case of fraud detection. So in this case, what will happen is you will have millions of rows, and within those only very less percentage of rows will have actual frauds. So in those cases, if you look for the model accuracy, your model accuracy will mostly be higher, and it won't give you a complete picture of your model performance. So model accuracy is just a subset of the model performance, and there are more metrics that you have to look to understand the model performance. So now we are done with the core machine learning, so which were mostly related to the theoretical aspects of the machine learning. Now we will start with the Python related questions with the machine learning. As machine learning can be done with different languages like R, Python, SAS, but currently we are more focusing on the Python, and we will start with our practical questions which are there with the machine learning. So first question is, name a few libraries in Python used for data analysis and scientific computations. In this case, interview is trying to understand. So in the initial level, he will try to ask you these questions to gauge you if you really know about the core libraries which are used for the data analysis in the Python or not. So the core libraries which are there within Python are NumPy, SciPy, Pandas, and Scikit. So first of all, NumPy. NumPy is a numerical library to deal with the data. So as the name suggests, it's a numerical pie. So it tries to deal with the numbers. So all the core libraries such as the SciPy, Pandas, Scikit uses NumPy to store the data. So those are the core storage format for all the data in data analysis. So SciPy, its full form is basically scientific Python. So It basically gives you a library to deal with all the different kind of mathematical functions. So you can do Fourier transforms for the audio related data. You can go with the optimizations. You can go with the interpolation. So these are just a few examples, but all the mathematical related tasks you can go with the SciPy, and SciPy uses, as we already discussed, in a core NumPy to store the data. So Pandas is a data analysis library again where you can store the data in a tabular manner, which is called as a data frames, and data frames are very powerful function within Pandas. So data frames gives you a data manipulation access. You can access the CSVs, you can load the databases, you can load the Excel files, and you can do your operations on top of it. You can do the aggregations, merging, and all those kind of analysis related to the data you can do with the Pandas. Scikit is purely a machine learning library. What it gives you is access to the different machine learning models you can use. So it contains a different components. It contains a pre-processing component where you can do the pre-processing of your data. It provides a library for that, and it also provides you a different modeling library where you can access all the core machine learning models. So on top of that, we have Matplotlib, which is a purely a data visualization tool. So with the Matplotlib, you can visualize your data in a very efficient manner and in a faster manner. And Seaborn is something which is built on top of Matplotlib and gives you a more better visualization of the data and gives you different new kinds of visualizations which are not there within the Matplotlib. So you just can give this detail to the interviewer, just list them all and give a bit of the description about each of them. So that would be enough in this case. Which library would you prefer for plotting in Python language? Seaborn or Matplotlib or Bouquet? So all these three have their own applications. So preference is something that would come based on the thing that you are currently performing with the data analysis stage. So for example, when you're doing a quick analysis within your data, so you want to have a quick access to the charts, then you can use the Matplotlib. For example, Matplotlib provides you a quick access to the bar charts, pie charts, histogram, line charts, scatter plot. So for the quick analysis and your data exploration, you can go with the Matplotlib. Seaborn is something which is built on top of the Matplotlib. And you can use this when you want to do a bit in-depth analysis of your data. For example, when you want to have a statistical analysis within the data, and Seaborn gives you a bit more types of graphs which are not there within the Matplotlib. So for example, when you want to have a distribution charts with a more detail, so Seaborn provides you charts such as the violin plots, it gives you a KD plots. So for the detailed explanation of your data, you can go with the Seaborn. Bouquet is something which is an interactive visualization. Bouquet you go when you want to present your data to something of the outside world, when you want to publish it on a web and you want your user to interact with the data, then you use Bouquet. So when you go to the outside and you want to publish your visualization to the outside public, you use Bouquet for that purpose. So how are NumPy and SciPy related to each other? So this thing you can give a bit of detail as what is really NumPy first and what is really SciPy. And the thing is SciPy is a bigger library and NumPy is part of it. So NumPy is a smaller part of SciPy. NumPy helps you to define arrays and you can perform some operations on top of those arrays using the NumPy libraries. So different types of operations are like indexing, sorting. You can change the shape of it. You can change the matrices. You can create a splits within your data. You can merge different arrays together. So NumPy will help you with all those. SciPy, you can go to a next level when you using on top of those NumPy arrays when you want to create some mathematical formulation. You can go with the SciPy. So when you want to do the optimization, you want to do the Fourier transform if you have audio data. For those kind of applications, you can go with the SciPy. So what is the main difference between a Pandas series and a single column data frame in Python? So interviewer, he would like to really understand if you know the core concepts within the Python or not. And Pandas is something which is the core of the data analysis, as all your data is stored within Pandas and you're dealing with Pandas most of the time. So in this case, interviewer will try to gauge you as you know the basic terms which are there within the Pandas or not. So first thing, data frame is something which can store multiple columns, but a series cannot store multiple columns. So series is just a single column. But with the data frame, even if it's a single column, you can go with the multiple columns, you can add the columns to it. And there are some limited functions which are there with the series, and data frame has additional functions on top of series. So for example, LOC is a function which is there on top of this. So data frame is the upper level layer on top of series and gives you more control to the data. But the basic difference is with the series, you just have a single column, but with the data frame, you still can add more columns to the data. How can you handle duplicate values in data set for a variable in Python? So in this case, you may have to write a code and show to the interviewer that how you can really achieve this thing. So you can just import the pandas library, show that you're just reading a random file using the pd.read_csv, and you use the build data frame.duplicated to get the list of all the duplicate values which are there within the data, and just show that you can also drop those columns if sometimes we want to drop those. They are by some mistake created by the collector. So the duplicate values can be removed using the drop_duplicate columns. So these two functions you can try to show and explain them what they do. That would help you in that. Write a basic machine learning program to check the accuracy of the data set, importing any data set using any classifier. So in this case, you're not limited with what data set you're loading, what data classifier. The important thing which you have to show is how you are loading your performance parameters, and things that the interviewer will gauge is how you are trying to use the performance metrics. Are you trying to use it on the test set or the training set? Or you're trying to use it on the trained data or just the test data? So you have to be very sure, as you don't have the computer to do the output, you just want to write it. So you have to be sure that you are using a test set to show the accuracy parameter, and you have to use both training Y and test Y in this case. So you have to start with the complete program. You have to show all the steps which are involved within the accuracy part. So you have to start importing your data. Just take some random data. You can just show that you are reading some data and try to separate your data into the X and Y, the target data and the predictor data, and try to create a split within the data of train and test validations. You can use whatever ratio you want to use. You can use 80%, 70%, 50% as you like, but you need to give some justification to that also if your interviewer asks for it. Once we have split our data into train and test set, the next task is to use the classifiers to train the data and create a model out of it. So you can use any classifiers here, but choose something which you already know better, because interviewer will ask you whatever model you're going to use in the next step. So you have to be sure whatever you're using, you know it better. So once you have created an instance, you can use it to fit it on the training data. So use the X train data and the Y train data, create a model. Once you have done that, you use it to make predictions on top of the test data. So you use the X test and create a predictions out of it. And accuracy tries to compare your data, like your original data and whatever predictions you have done, and give you a score out of it. So you will load the metric accuracy score from the sklearn matrix. Once you have done that, you use the print to use the accuracy score, and accuracy score will take two parameters. One is the original matrix, which is the Y test, comma the predictions which you have currently made. So once you get that, it will create an accuracy measure for that. So accuracy will be nothing but the true positive plus true negative upon the all data. So it will calculate that and give you. The interviewer in the next step may ask you, like, how can you improve the accuracy score? So once you put the accuracy score, the next thing the interviewer may ask you is, how can you improve the accuracy score? So you can go for three simple steps where you can try to increase the accuracy of your model. First simple step would be try to see if you can make some tweaking into your probability cutoff. So the default probability cutoff is 50%. So the ones which are above the 50% is tagged as 1, and the ones below the 50% probabilities are tagged as 0. So if you are changing it to something like 0.8 and then checking the accuracy, if it makes changes to your model, it is still good. If it doesn't, the next step would be try to see if you can find out some better features using some feature importance algorithms, such as random forest, and different tree models are available which will give you the better features as per the target. So you can use those features and train a model so that you will have your accuracy increased. And next step would be create some new features and see if your model makes any improvement in your accuracy. You can make some new features or you can add some more data so that it will help your model to generalize better. For this part, we have completed with the Python related interview questions of the machine learning. So this was more of a technical part of it where we saw how we can code, how we can show the interviewer that interview is more interested to see how you can code the things and how confident you are with those things. Okay, so now we are done with that. We will now move on to the scenario based questions, where we will see some puzzle kind of things and the other are real problems where the interview is related to understand as how you try to solve those problems. Let's start with those. So you are given a data set consisting of variables having more than 30% of missing values. Let's say out of 50 variables, 8 variables have missing values higher than 30%. How will you deal with them? So missing values could be of any reasons. So something like your data got corrupted while storing and you got a missing data. The person who collected the data may have done some mistakes and that data is treated as a missing data. Or it could be like there is nothing for those kind of values. So it's like it is supposed to be blank and it's supposed to be missing. So there are different conditions for those. So let's see how we can try to handle those things. First, we can create a new feature which will say, okay, this much of the part is non-missing and this much of the part is missing. So we can assign it 1 and 0. We can create a new binary variable. It's possible that this thing is trying to give you some idea about the data and there will be some hidden pattern within your data because of this some missing values. So it's possible that creating this new feature will help your model to give the better accuracy and give the better performance. Second thing, we can remove that completely. If you have a high count of data, so for example, if you have a very good amount of data and you can say that, okay, I can leave with removing this 30% of the data, then you can blindly remove this. If it is not giving any value to you and you can't spend much time on trying to improve it or trying to impute it, then you can blindly remove it. Or you can check the distribution. So for example, there are different ways to check how your missing values are to the similar cluster. So some examples are, you can see your missing values are clustered on some other values. So can we give those cluster values to those missing values? So it's like identifying clusters and based on those clusters, we give values to the missing data. Or the second thing is we use the distribution. So if they are continuous in nature, we can use the distribution to assign some data to them. So write an SQL query that makes recommendations using pages that your friends like. So assume you have two tables. First table is a column table of users and their friends. Second table is a two column table of users and the pages they like. It should not recommend pages you already like. So why would interviewer ask an SQL question in this case? So it is like he's trying to understand how better you know the recommendation engines from the database point of view. So it is like he's trying to understand your knowledge in a different term. So first thing, you have these two tables. So first table is including, you can assume, you have to make some assumptions and draw the picture of this two tables first. So first table will include a user ID and a friend ID. Second table will include a user ID, the page ID they have liked. And then once you have this structure of these two tables ready, the next step is to merge them together based on the friends. So as we are interested to know as which friends are liking which pages, and based on that we want to recommend it to the original user. So first thing is we have to combine these two tables using a unique key, which is the friends ID. So we join these two in the SQL using the friends ID. That is one condition. Second condition says it should not recommend pages you already like. So what you do, you have to have a way where you can exclude the pages which were already liked by that user. So this can be done by an inner query, which you can use here to select the pages which that user has already selected. And in the where condition, you can say the page should not include this. So if you look at the whole query again, we are first selecting the first table user ID, the friends table user ID, and the likes table page ID from friends F join like L. So we are trying to join them together on friend ID and the user ID. Second is, as we mentioned, that was the first thing. And the second thing is we try to remove the recommendations, the pages which he has already liked. So which we'll do by page ID, not in the pages which he has already liked. So this is the condition which is trying to do this. And this is how you can explain this thing to the interviewer. So there is a game where you are asked to roll two fair six-sided dice. If the sum of the values on the dice equals 7, then you win $21. However, you must pay $5 to play each time you roll both dice. Do you play this game? And in follow-up, what is the probability of making money from this game if you're playing it for 6 times? So the first condition says if the sum of the values on the dice equals 7, then you win $21. But for all other cases, you have to pay $5. So in this case, if we first assume all the possible cases, as we have fair six-sided dice and we have two of them. So there is 6 multiplied by 6. We have 36 different cases. And out of it, having two dices equal to 7 is like we have 1 and 6, we have 2 and 5, we have 3 and 4, we have 4 and 3, we have 5 and 2, and we have 1 and 6 again. So those are nothing but 6 possible chances are there out of 36. If we take a ratio, 6 by 36 will give us 1 by 6 ratio. So this says we have a chance of winning $21 1 in 6 games. So assume that we are playing 6 games and out of it we win 1 game of $21 and 5 games we lose. So in this case for 5 games we have to pay $5 and this will be $25 and we are winning one time which is $21. In this case if you see there is a loss. So we are paying $25 and we are winning $21 in this case. So for the first question, do you play this game? This is no, as we are getting a loss as per the probability. The second question says what is the probability of making money from this game when you are playing it for 6 times? If you assume in this case we are making 6 games and out of that the winning probability, if we just have a win in one case it be a loss. If we win 2 games out of 6 we are going to win. If we win 3 games it will be profitable again. So 2, 3, 4, 5, 6 are the cases where we will see a profit. So this case can be simulated with the binomial distribution. So binomial distribution takes 3 parameters. First is your probability of winning and losing. So that is in our case nothing but 1 by 6. The second is the number of plays which is 6. And the third is the number of cases that we want to identify. So for example, in our case, we want to have a condition where the number of wins is greater than 2. So we want to identify. The first case is a failure where in the first case we are always losing. But in the second, if we win 2, 3, 4, 5, 6 times, we will always be winning. We will have a extra money. We have to find a probability where we will have more than 2 wins. So that can be simulated with the probability to get the answer for the second question. So the next question, we have 2 options for serving ads with newsfeed. So first is out of every 25 stories, one will be an ad. Second is every story has a 4% chance of being an ad. The question says for each option, what is the expected number of ads shown in 100 news stories? If we go with the option 2, what is the chance a user will be shown only a single ad in 100 stories? What about no ads at all? So in this question, if we look at the first part, which says for each option, what is the expected number of ads shown in 100 news stories? So let's check it for the first one. So for the first one, out of every 25 stories, one will be an ad. So this is like 1 out of 25. In the second case, every story has 4% chance of being an ad. So this is like 4 out of 100 and which is again nothing but when we divide 4 by 100, we will have 1 by 25. So for the first question, the answer is both are similar. So both the cases have expected number of ads in 100 similar, which is 1 by 25 or 4%. Both are equivalent to each other. For the second question, you have to see is the question asks what is the chance a user will be shown only a single ad in 100 stories. If you see this question, it is an example of binomial distribution. So as we just saw in the question 3, binomial distribution takes 3 parameters. First is the probability of success and failure, which is in our case is 4%. Second is the number of total cases, which as the question says 100 stories. Last is the case that we want to identify, means probability that we want to find out. So the question says, what is the chance a user will be shown only a single ad in 100 stories? So we want to have the three parameters as 4%, 100 stories as our n, and single ad as our probability chance. So if you see, the probability can be calculated as 0.96 is basically not getting selected, which is 1 minus 0.96 raised to 99. So 99 cases are not going to selected, multiply the chance of selecting, which is 0.04 raised to 1. So we are calculating a probability of not getting selected of 99 samples and getting selected of one sample. So this is the binomial distribution for selecting one ad out of 100 stories. The second question just says, what is the probability of no ad at all? So in that case, 0 and 99 would become 100. So 100 multiplied by probability of one case. So it will become 7.03%. The only thing is you have to identify like which distribution is highlighted from your question. So sometimes you will see that normal distribution kind of questions will be there where you have mean, standard deviation, and based on that you have to identify different things. In this case it was binomial, so based on the parameters which are there in your question, you have to identify which distribution you can use for that and try to solve it. How would you predict who will renew their subscription next month? What data would you need to solve this? What analysis would you do? Would you build predictive models? If so, which algorithms? This question is very generic, and interviewer is really trying to understand how you try to approach your problem. So when you are given a problem, how you try to identify different components which are there within your problem, how you try to solve each of those confidently, as how much of your knowledge is there within each of it. So what you have to do is, let's assume something as first thing, how would you predict who will renew the subscription next month? Let's assume we are trying to predict the subscription for Dish TV subscription. So who is going to renew the subscription next month for the Dish TV? So that is the problem statement first, we define it. What data would you need to solve this? So in the case of Dish TV subscription, we would like to identify how many number of hours for that household the channels are active, how many number of kids are there in the home, how many number of adults are there in the home, which are the different channels they use, for how much time, and from previous month, how much increase or decrease has happened in this month. So this all variables would help you to understand if in the next month again that customer is going to buy or not. So if there are kids in the home, there are chances that because of kids, whenever there are kids, they will look for the TV, and kids will always help you in understanding if there will be subscription or not. And if the subscription has either increased or decreased from the previous month, will also help you to understand if that user usage has increased or decreased. So that will help you to understand the trend and make your prediction better. So what analysis would you do? So we would like to do the classification analysis in this case. We want to identify, okay, this customer is going to subscribe next month, this customer is not going to subscribe. So this is a pure classification related problem. Would you build predictive models? Yes. So for the classification related problem, we would like to build a predictive model. So we would already have a historical data. We will gather the data which is already existing and use that to train our model. So we can use any algorithm. So we can use any classification related algorithms in this case. So we can use random forest, we can use logistic regression, we can use neural networks, whichever. We can try different models and see which one performs better. And based on that, we can continue with the model which performs better and tune it further. So you have to start with this step by step and show that, okay, this is the next step, this is the next step till the end of your model. So even in this case, if so, which algorithm would not end the problem? Algorithm you have selected, after that you have to validate your algorithm. It will even go that in production, and within production you will also validate again and see in real life how it's working, make again changes to the model. So those things may change again as the interviewer may keep on asking you the further things, and you have to be ready for those things. Interviewer may start with few questions, But as you keep on solving the problem, interviewer would keep on digging further as what would you do next. So you have to be ready for all those things. So be prepared for those things. How do you map nicknames Pete, Andy, Nick, Rob, etc. to real names? So this is like understanding how you try to solve a problem where there is not much of data is there. So this example is just you have just a nicknames and you want to identify the real names to them. So this can have different answers. It is not related to a single answer and there is no generic fixed answer. But interview would be interested to know as how you are trying to approach the problem and solve it. So few things could be like, as you don't have any data, first you try to gather as to which components these things are related. So for example, if you are trying to understand these nicknames from a Twitter tweets, try to see who is trying to refer to who, and based on these nicknames, see the relation as which person is trying to talk with which person, and you can try to identify based on the NLP algorithms as what is the real names for those people. So similarly, you can try to identify in the Facebook, or if you have some customer feedbacks and within those customer feedbacks you want to understand this, you can do it that way. But this would be more like you have to understand in the context. So in which context people are talking to whom, and based on that, you can try to identify the real names. So this is just a one example, but it is not related to just single one. You can create your own. As I said, there is no single answer to this problem, but it mostly depends on how you are trying to approach that problem and solve it. A jar has 1,000 coins, of which 999 are fair and one is double-headed. Pick a coin at random and toss it 10 times. Given that you see 10 heads, what is the probability that the next toss of that coin is also a head? So let's first try to split the problem statement that we have. So the different components are, we have 1,000 coins, of which 999 are fair. So for the fair case, we can say that, okay, there is 0.5% probability that it could be head or it could be tail. And one is double-headed. So it is not having probability and it is just 100% probability that it's a head. We pick a coin at random out of this 1,000 and toss it 10 times. So each time we select a coin, we toss it. We select a coin, we toss it. So we try to do it 10 times. Given that you see 10 heads, what is the probability that the next toss of that coin is also a head? So let's see what we can do in this case. So basically we have two types of coin which can be chosen in a two different ways basically, and there are probabilities associated with each and they are different. So for the first type of coin, which is fair, we have 999 out of 1,000, so which is 0.999. And the chances of selecting the second coin, which is unfair in nature, is 1 out of 1,000. So these are the probabilities that we have got first. Now, as the question says, we have already chosen 10 heads. We have already done some experiment and we have got 10 heads. So what is the probability of selecting those? So selecting 10 heads in a row is equal to the chances of selecting fair coin multiplied by getting 10 heads plus selecting an unfair coin. So if we see that, first thing is selecting 10 coins from the 999 fair coins is, we have the probability 0.999 multiplied by the fairness is basically probability 0.5 raised to 10, which will give us 0.999 multiplied by 1 by 1024. So when we multiply this, we will get a chance of selecting coin A, which is nothing but selecting the 10 coins from the fair coins. The second part is the probability of selecting the second coin, unfair coin, multiplied by 1, which is basically everything is head there, as we don't have anything, everything is head, so it is 1. So probability of here is 0.001. Probability of A says selecting the 10 coins from the fair coins. Probability of B says selecting the 10 coins from the double-headed ones. Now the second question says, given probability of fair coins, what is the chance of selecting the coin from that? It is like a conditional probability, and in this conditional probability, what we are doing is we are dividing the probability of A given probability of A and B. So given both of them, what is the probability of selecting the coins from the fair coins? This is the probability. And the second part basically says, given double-headed sided coins, what is the probability of selecting from that. So these are the two individual cases. Once we have got that, we have to create a combined probability, which will include the chances of selecting the coin from the fair coins multiplied by 0.5 plus the chances of selecting the coin given it is the double-headed multiplied by 1, and this would create a combined probability and give you the output as 0.7531. So for this case, we have to go step by step, divide the problem into smaller parts and get to the answer of it. Suppose you are given a data set which has missing values spread along one standard deviation from the median. What percentage of data would remain unaffected and why? In this case, there is not much details about how is the distribution of data. It is just said that there is a one standard deviation from the mean which is missing data. So we have to make some assumptions. So as most of the data follows a normal distribution, we would assume that this data is also following a normal distribution. And we would say that, okay, a normal distribution has within one standard deviation 68% of the values. So as per the normal distribution, within one standard deviation, around the mean, median and mode. As for the normal distribution, all are equal. All mean, median, mode are at the same location. And from the mean, around one standard deviation, we would have 68% of the values. And as the question says, missing values are spread along one standard deviation. So 68% of the values are basically missing, and question asks what percentage of data would remain unaffected and why. So everything left after the 68% would remain unaffected. So we would say 100 minus 68, that would be 32. So 32% of the values would remain unaffected by missing values. You are given a cancer detection data set. Let's suppose when you build a classification model, you achieved an accuracy of 96%. Why shouldn't you be happy with your model performance? What can you do about it? So first thing is, as this thing is mostly related to the domain of cancer detection, interview is trying to gauge you as how better you know as so how the accuracy of the models works in a different data distributions. So if we look at the cancer detection domain, in the cancer detection domain, very few of your data points would have actual cancer. So for example, if you have a 1 million patients data, out of that you would have like around 1,000 of them would be having cancer. So it's like a very small set of data is having actual cancer. So let's assume we are creating a confusion matrix. So when we create a confusion matrix, we see that in the true positive, which is just 1,000 values. So even if our model tries to identify like 500 of them, so we'll get in the true positive 500. And let's assume in the true negative, we are getting all the negative values, which is 1 million minus 500, which went into the positives, and everything remaining will go into negative. So if you create the accuracy, it is like 500 divided by whatever is there in the remaining parts. So 500 is what you got the true positive values, and something you will get in the true negative. And when you divide it, you'll have a bigger accuracy. So your model give like 98%, 96%. As your true positive is actually very small, your true negative would be very large, and small components will be there in the false positive and false negative. So when you try to divide them, you will have a bigger accuracy always. So accuracy is not used in those cases where your distribution of positive cases is very less. So in this case, accuracy won't be helpful for us to evaluate the performance of our model. So we have to go with other performance metrics which are available. So for example, we have recall, we have precision. Recall is again called as the sensitivity. Again, we have another as the specificity and F1 score. So this different performance metrics will try to identify the model performance based on different components. So accuracy is mostly useful when you have the classes which have some similar count. When you have some similar count but not very smaller classes, then your accuracy will be helpful. But when you have very small positive class, such as the cancer detection or the anomaly detection. So again, anomaly detection is a similar case where fraud detection basically. So fraud detection is again a case of this case where we have very small number of values. So we can't use accuracy in that case, and we have to use the different performance metrics. You are working on a time series data set. Your manager has asked you to build a high accuracy model. You start with the decision tree algorithm since you know it works fairly well on all kinds of data. Later, you tried a time series regression model and got higher accuracies on the decision tree model. Can this happen? Why? So first thing, as it is a time series data are mostly linear in nature. So as the next value would be related with the previous value. So let's assume we want to look at the stock prices. So stock prices which are today are related with the yesterday. So whatever value was there yesterday, it is the either higher or lower as compared to what was there in the yesterday. So as compared to this, what decision models would do, decision models would just try to identify some rules within your data. So they would just do some rules which is very non-linear in nature. If there is actually some proper patterns within rule, the decision tree would really helpful. But what the time series related regression should do it, they would try to regress it based on the historic value. As they are linearly correlated with the previous values, the time series regressions would work by regressing it on the historic values. So that's why time series regressions would be more accurate than the decision trees because we have a linearity available within the time series data. Suppose you found that your model is suffering from low bias and high variance. Which algorithm you think could tackle this situation and why? So first thing, so low bias and high variance. So bias and variance are the term mostly used when, so bias basically means you're getting bias to a specific set. So when you have a higher bias, your model is getting underfit. It's not preferring anything and it's just underfitting your data. And high variance is something where your model is very much overfitting to your data. So in our case, it says there is low bias and there is a high variance. So our model is doing a overfit. So first thing is we can use some kind of bagging algorithms. So what these bagging algorithms do is they try to divide your data into multiple samples. So those are samples with the replacement and each sample is trained with a decision tree. So now what happens, we are creating multiple trees which are trying to understand different patterns within the data set. Whatever data you are feeding, whichever sample you are feeding, whatever the patterns available within that sample, each model is learning those things. So now you have a weak learners and when you combine those weak learners, you create a strong learner which will also try to reduce your overfitting. And how it reduces the overfitting is as you're creating more and more models, if some of them is trying to overfit, the others will try to help to get balanced variance in this case. The other technique that we have is we can use the regularization technique. So regularization, there are two types of regularization. There is L1 regularization and there is L2 regularization. Those techniques we can use to penalize the model. So what happens, those try to penalize whenever your model goes for a higher variance, it tries to penalize it by some parameters that we provided. So based on those parameters, it tries to restrict your model for going beyond the limited threshold of the overfitting. So the regularization is the second technique. And third is we can use the feature importance. So we can use the different tree based techniques like we can use the random forest like feature importance techniques to select top features and we can use those to create a model so that our model will try to fit with those important features. So when we try to add all the features, some features may make our model very much overfitted and when we have a newer data, it may not generalize well. So when we try to identify which are the important features, then our model will try to generalize well to the actual patterns which are there within the data. So it's always better to go with feature importance, try to select the features which are important, then create our model on top of it. So these are the three techniques that we can use to reduce the variance. You are given a data set. The data set contains many variables, some of which are highly correlated and you know about it. Your manager has asked you to run PCA. Would you remove correlated variable first and why? So most of the people would say that, okay, PCA we are using to reduce the multicollinearity. So removing the collinear variables, we won't use the PCA. But what happens is with the PCA, we are not just interested with the multicollinearity of the variables. Sometimes we are also interested with the variance which is available within the data. So what happens is PCA tries to explain a complete variance available within your data. So variance is something which says like the distributions within your data. So once you know that, PC also gives you the eigenvector through this variance, and you can use this variance to reduce the features which are available to you even when there is no multicollinearity. Even if you have some 1,000 features, there is no collinearity within the variables. When you use the PCA, still in this case also, you will be able to reduce the size of your features to a lesser number. So PCA doesn't just has to be with the correlated variables. We can use it also just to reduce the column's length using the variances which are explained in the model. So you're asked to build a multiple regression model, but your model R-square isn't as good as you wanted. For improvement, you remove the intercept term. Now your model R-square becomes 0.8 from 0.3. Is it possible, and how? So first thing, what is R-square? So R-square says how your linear regression model, how much of the variance out of the data it's trying to explain. So your data contains a variance and what percentage of variance your model is trying to explain. The more the variance it is trying to explain, the better is your model trying to represent your data. So the formula if we see for the R square is R square is equal to 1 minus summation of y minus y hat, which is the predicted values, square upon y minus y mean square. So intercept basically refers to the y mean. So in actual, the intercepts are representing the y mean and they're helping the model to maintain based on the y mean. So in the presence of it, we are creating a R square, which is something different. And when we are removing the y mean, so when we are removing the intercept, we are removing the y mean. In our case, as a denominator becomes small, our R square would become big. So as we remove the y mean, our denominator would become small. And as we are dividing by that, our R square would become big. But one thing that you have to be very sure in this case is this: both the models are different. You cannot compare the model without the intercept and the model with the intercept. So both the models are different and you have to tune them separately and you have to measure them separately. They cannot be compared as the one with the intercept and without the intercept are completely different in nature. You are asked to build a random forest model with 10,000 trees. So during its training, you got training error as 0.0, but on testing, the validation error was 34.23. What is going on in this case? Haven't you trained your model perfectly? So this was very good. That right got a 0.00, like 100% accuracy with the training data. But when we try on the validation data set, we say that there is an error of 34.23 of some metric. What this case basically says is you are getting very much good performance on the training data, but when you check it on the unseen data, this unseen data is showing some different performance. So this is a pure example of complete overfitting. So what you are doing is your model is trying to mimic actual data within the training set. It's just learning every pattern, every corner of your data, and it's trying to make actual and accurate predictions out of it. But when we go for a newer data, as it has got very much mimicking the training data, so newer data may get the outer bounds and may not get a better prediction. So we have to reduce the overfitting and try to make a model generalize. So we can use these things that we have discussed earlier to reduce the overfitting within the data. So we can use different techniques that we've already discussed, such as we can provide more data or we can reduce the number of trees which are there. So as we are using more and more trees, our model is getting overfitted to the data. So in our case, we have to use the lesser number of trees and see if our model gets generalized or not. So people who brought this also brought recommendations seen on Amazon is based on which algorithm. So we have all seen on Amazon that when we are looking at some product, we get that, okay, people have also brought this kind of product. What basically this means is, whatever you are currently looking, people who have brought that product or who have already viewed that product have also looked at the different products. So based on those, you are getting recommendations. So there are two types of recommendation systems. First is the collaborative filtering and second is the content-based filtering. In content-based filtering, what happens is whatever you have rated previously, so based on that, you will get a future recommendations. So for example, let's take an example of Netflix. In Netflix, you have watched some genre movie. You have watched romantic movie for 2 to 3 times and you have given a better rating. So what Netflix would do, based on whatever you have done, whatever the content we have viewed earlier, it will create a new recommendation for you. So based on whatever you have done previously, you will get a newer recommendations. So that is the content-based recommendation. What we are seeing currently for this example, it is collaborative filtering. In collaborative filtering, what happens is whatever you are doing or whatever you have done previously, based on that, you will be checked with the other users who have done similar activity, and it will also check what are all different activities they have done and you have not done that. It will try to recommend those things to you. So if you see the example which is here, it says that the user who's on bicycle has brought pizza and pasta. Similarly, he is trying to be compared with the user who has done similar activity. So in our case, there is this user who has brought pizza, pasta plus a Coke. So as this user has not brought Coke, he will be recommended this Coke. So this is the core of collaborative filtering. So this is the technique which all the major e-commerce related companies use to recommend products to the users. So even Netflix is just uses the content-based filtering for recommending the products based on the history that he have done, but also he'll be recommended based on the collaborative filtering as what all other users have done similarly and what they have done as additional things. So that's how the recommendation systems works. Just to summarize what we have done today, so basically we have started with the three types of interview questions. We started with the core machine learning components, which involved more of a theoretical components in the machine learning. The second was we looked into the Python related questions on machine learning. We saw some practical aspects. What are the different components within Python? How we can write some Python code. How interviewer will try to gauge you. How you can write the code and those things. And the last part was scenario based questions. So in that case, we were trying to understand how, based on the scenario which is given, how would we choose different models? How would we do the machine learning related tasks based on the scenario which is available to us?
And with this, we have come to an end to this full course on machine learning with Python. If you enjoyed listening to this full course, please be kind enough to like it, and you can comment on any of your doubts and queries. We will reply to them at the earliest. And do look up for more videos and playlists, and subscribe to Edureka's YouTube channel to learn more. Thank you for watching and happy learning.